measured curvature, because we have all the metrics, as you may or may not know. They're made public to everybody, so we can pull those up and we know what they are. So what I'm saying is that it's a fruitless endeavor that you're on right now, this quest to actually try to prove the thing that you're actually trying to prove, but without proving it directly, but indirectly. And so maybe to you that makes sense, but to everybody here, knowledge works. I know, but I'm saying, but to everybody here, it makes more sense to directly measure the thing in question, and that hasn't been done.
Can you directly measure something that is as large as the Earth?
Yes, absolutely. With the variable. Listen, because I'm going to tell you.
Can you do it the same as a basketball in your hand?
Yes, absolutely.
No, you can't. You can't, because you're big, and you can have bigger things to use as measuring tools for that Earth, right? For that basketball, sorry. But for the Earth, you can only measure a small patch of the Earth at a time.
No, that's the thing, though. How did we do it in the first place? Because we have these metrics.
Transcontinental arc, the parallel.
Okay, so is that how we derive the metrics of the Earth? Yes or no?
Well, no. What we did is we have tested it many different ways. Some haven't been exclusive to a globe Earth. Some could be experienced on a flat Earth. But we have then done some that are conclusively for a globe Earth over a flat Earth. Did you hear what I just said, or did you start talking after you'd rambled for like 4 minutes?
We have the metrics. You don't want to look at the metrics.
Do you hear what I just said? Do you hear what I just said, buddy?
No, because it's not the actual direct measurement of the Earth's curvature by which we have.
Do you have a direct measurement of flat Earth? Yes or no?
I don't need to directly measure something.
Exactly. You're a fucking hypocrite.
Okay, so now you're resulting to insults because you're losing. You don't know how to provide evidence for the direct measurement of the Earth's curvature, so you want to spiral.
Transcontinental arc of the parallel. What's wrong with that?
Is this your out? Because it's not directly measuring the surface curvature. That's why.
It
and
is.
I asked you, is it? You said no. You conceded. That's great.
No, it is. Transcontinental arc the parallel directly measures the curvature of the Earth.
No, it doesn't.
It does.
Does it do we derive the metrics of the Earth's size from that?
Yes.
Show me where.
Great. I will link you the document.
It's a document that you didn't read.
Yeah, the one I did read that you didn't understand. You thought that,
dude, you can listen.
That they listed as direct measurements. You thought they'd already applied some form of transformation.
They
did. Read page 47 this time.
They did.
They didn't, Indio. Remember, you linked it to me and you read it, and it said that they had put the data in, and then they put the calculation.
Sorry,
it's called a horizontal reduction.
So,
right?
like, listen, I asked him for direct measurement. He said no. Now he's saying yes. He's going back and contradicting himself. But what he's going to post, because we've all seen this document, right? This PDF. I think is it page 19? Is it on the 4th paragraph? He's going to be astounded to know that it's not. They didn't directly measure anything. They actually pulled it off the Clark spheroid model. That's what they're using. So they didn't measure the curvature of the Earth.
He's denying that that's what they did.
Right, but that's what it directly says on the PDF that he's probably going to post if he hasn't posted it already.
He's denying it means that.
This dude is infamous, though.
In his own meaning.
He's infamous for denying his own references. That's all he does here.
So the thing that I asked him were 2 questions. Can we know if the Earth is measured to have curvature? He's for 100%. Like, can we know that? He said no. Second one was that has it ever been directly measured? And the answer was still no. It was because he's trying to use all these derivative topics to ruffle feathers and try to make it seem like he has a point when he does not. And he starts to get angry and starts to put out insults because he doesn't have an answer. But that's all I wanted to say, just to expose him that he doesn't have an answer, and he wants to dance around and that's all he knows. And that's all I have to say. I yield the floor.
I did notice he had a lot of direct, pointed personal insults. Now, I did swear at him to say shut up because he was constantly over-talking and through-talking.
Okay, can I talk about Mickey for a second? And how he started off with a genetic fallacy?
We'll talk about him? Or do you want to talk about the arguments?
No, his argument. His argument was a genetic fallacy. His argument was, I didn't know who did the measurement, so therefore the measurement is wrong.
That's not a genetic fallacy.
No, he was talking about you. He wasn't talking about the argument.
I don't know who measured the transcontinental.
No, he's pointing out that you have a belief. That's what he's pointing out.
Yeah, you just have a belief.
That's exactly how he started his argument. Is that how you started your argument? Because I wrote it down.
Yeah, that's okay. If you think about his first question,
I said no because we can't be sure of anything. It's basic epistemology. If you knew anything about knowledge, you'd know that.
Oh my goodness, dude!
You said that because I don't know who did it, I'm lacking some knowledge that makes that an actual like a good argument. When that's
that was your interpretation, but he never said any of those words.
He specifically said I was lacking some fundamental.
Yeah, that's right, but he didn't
sources that would make my sources incorrect.
No, you're adding that yourself. The incorrect part, you're adding that. He never said that part.
Okay, so for everything I've argued so far, what have I done that have made my arguments incorrect?
Okay. He wasn't arguing against your arguments. He was illustrating the fact that you have a belief.
He was using a genetic fallacy, yeah.
No, dude, what don't you understand? He was just illustrating the fact that your claims about whatever measurements exist out there, the results of which that you don't actually know are just a belief. Oh my God, dude.
Anyway,
it's about you, dude. This isn't about the measurements. It's about you. Are you like some weird narcissist?
Page 19 of the Arc of the Parallel. Isn't that great?
Dude, listen, before you read that, you need to specifically rebut the claim that they pulled that stuff off of that model.
Well, how about this? I can get right to the heart of this. Why do they use a reference ellipsoid? Why do they use a reference ellipsoid in the first place? Why is this even used? They're just measuring curvature.
We have previous information that tells us the Earth is a sphere. So based on that previous information, people now assume it because it makes sense to do so.
But why is it used in anywhere in any calculation ever? Why do they need it? Why is it necessary?
We have previous evidence that the Earth is a globe.
Okay, that's awesome. But why do they need it? You're not answering the question. Why do they need it in the equations? Why does it exist?
For the
why not just use the raw measurements, right, and then just come up with it like that? Why use the measurements and reduce them to an ellipsoid? Why are they doing that?
They have the raw measurements and they have the ellipsoid measurements.
Okay, so why are they reducing their raw measurements to the ellipsoid surface, the sea level? Why are they doing that?
Because they want to fit the measurements that they've made onto one larger, grander set of maps or measurements.
Okay, that are based upon old measurements. Were they reduced to another ellipsoid?
No idea what you're talking about.
So you just said the ellipsoid is based upon measurement. Dude, don't overtalk me. Don't overtalk me because you know you're fucked now. You're fucked and you know it, dude. Yep, that's right. You're fucked and you know it. You're fucked and you know it, dude. Sorry. You know you're fucked. That's why you're trying to fucking rabble-rouse right now. Listen, you said the ellipsoid's based upon some previous measurements. So these new measurements, arc of the triangulation, they reduce the measurements to the horizontal directions to the surface of this Clark ellipsoid. Where'd they get the Clark ellipsoid from? And when they took those measurements, did they reduce it to some other ellipsoid? How far back does it go?
Assumption upon assumption upon assumption.
To the first measurement of the radius of the Earth, you fucking moron.
When was that? When was that?
How stupid you are?
When was that?
I don't know. Maybe I don't.
Oh, you don't know. That's
probably prior to Eratosthenes, but Eratosthenes did the first one, and then we worked out.
Sorry, I missed that. I missed
actually
that.
Correct, using different styles
of measurement. Is he going to talk about Alberuni?
We've done it dozens of different ways. How do you guys not understand?
When was this measurement, dude?
Hey, the radius of the Earth's never been measured and can't even be measured in your paradigm.
His whole argument is based on he doesn't know. That's it. I've been saying I don't know this whole time, dogs.
You blow your father with
That's embarrassing, bro.
Look, you know what the answer is.
Look. Should we just
It's embarrassing. It's embarrassing. You're embarrassing yourself, dogs.
Yeah, you're so emotional, man. What you talking about? AI's emotions?
Go back and learn some more.
Let's have a good cry.
Oh,
yeah, I got a shoulder you can cry on. Go on. Go back to McToon and go get some more information from him because you're not up to date, bro. This is weak sauce, bro.
You guys haven't given a single argument for flat Earth.
Bro. You don't know about
Eratosthenes.
I don't know. Are you 100% sure? No, we can never be. Well, you don't know anything, bro.
Dude, it's not.
Anyone that knows about epistemology knows you can't be 100% sure about anything except.
Well, then you don't know the Earth. Thank you for admitting that.
Yeah,
And
that's nonsense.
fallibilism. It's provisional knowledge. It's knowledge that isn't 100% complete, but is still knowledge. You have two competing hypotheses, and one has over 50% probability of being correct based on predictive evidence, then you should go with the hypothesis that has a greater predictive evidence. This is Epistemology 101. It's fallibilism.
Dude, you just don't know.
That's your lack of fundamental knowledge about knowledge is the problem. That's why you're all fucking flat earthers, because you're too dumb to understand.
You don't know anything, dude. I love it. I love that you don't know. Please.
Hold on. What he basically said is that
tell me why fallibilism is incorrect.
If something has a greater than 50% probability and you have no other alternatives, you should accept it as true until something new comes along. Then it becomes false. Hooray.
Great. That's great. So give me something new that comes along that disproves the globe.
You don't know. That's all.
Nothing's come along that proves the globe.
That's all, folks.
I just gave you like 4 different things, didn't I?
No. Yeah, 4 different things that don't prove.
Yeah, 4 different things that you don't understand.
From towers is one. Yeah.
No, it isn't. No, it isn't, dude. Towers are not evidence of curvature. You're a clown, dude.
Go try to make.
We need to find some way to disprove these things instead of just saying.
You haven't proved it in the first instance, you weirdo.
I didn't add in this specific number.
You haven't proved it in the first instance, dogs. So don't even be saying that you got all this evidence. You got shit, bro. You ain't proved nothing.
Can you tell me what's
you're over here saying that I don't know. I don't know. That's what you said, bro.
We got to do that again.
Jesus. If you read that document, there's not enough information in that document to make an evaluation. And
but
you
that
claim
that it's wrong, does it? The experts, the people that built it, say
the experts. Exactly. Exactly. You just said it all. Your actual true epistemology. The experts.
Oh, by the way,
you talk all highfalutin.
By the way, that's a genetic fallacy. The experts. It comes from the experts, therefore it's true. It's a genetic fallacy.
A genetic fallacy would be because they are the people that did it, it must be correct. But the problem is that they did it correctly using the methodology that they chose.
Are you keep saying I don't know, dogs? We're used to you saying that already in here, so just keep saying I don't know. That'll win an argument anytime.
What's the correct methodology? How do you know the methodology is correct? Give us the methodology then.
I don't have to. The toe tank works.
Okay, so you don't know the methodology, but you know it's the correct methodology. How does that work?
The same fallacy. This is crazy.
The methodology is correct. It works, dude.
The toe tank works.
And because the experts worked on it, and it works.
Because the rail and the...
So nothing to do with their methodology, just the experts, exactly like these guys just said. Cool.
No, the thing itself, the toe tank works. That's evidence that the engineering works.
Yes.
Works because the thing works. That's how engineers work, you idiots. Do you not understand this?
Yeah. So I got a PDF from an engineer from Australia that says just because it... Oh, do you want me to... Okay. Now, hold on.
I read your last PDF. Do you remember what happened there?
No, I don't. Well, you read what PDF?
Big failure in them not calculating refraction across a body of water?
Yeah, they don't. They don't need to because it's an unproven quantity. Gee, that's why I asked you. Let's actually go back to that.
Wait, is this a YouTube video?
Let's go back to that
video. This is the calculus they won't teach.
Listen, don't mute him anymore. Let him talk. Right? Don't interrupt me. We're gonna have a real interchange. Fucking interrupt me, I'm just gonna kick you the fuck out of here. Okay? It's gonna be like that. So check this out. I asked you, what model for refraction should we use to make predictions? You are aware that there are probably a dozen to maybe 24 models of refraction going back 150 years. Which model should we use that makes predictions?
Snell's law.
Which one?
Snell's law.
Snell's law doesn't work.
Why?
Because it doesn't preserve the angles.
It doesn't preserve the angles. That's the whole point of refraction. Refraction is the angles changing.
Okay, so in a gradient index medium, you can't use Snell's law because the angles are not preserved. Okay, so hold on, I'm
The
describing.
angles are not preserved. Can you explain what that means? Because the angles aren't meant to be preserved. The angle is meant to go from A medium to B medium. The angle is to change, the inference angle.
Yes,
and then
that's
from
right.
C medium is meant to change again. Then from C to D, it's meant to change again. Then from D to E, it's meant to change again. So at what point
Sine
should
theta is a conserved quantity in Snell's law.
Say again?
Right.
I didn't hear
Sine theta, the angle is a conserved quantity. Okay? So the angle of incidence and the angle of refraction have to sum to 180 degrees. Right? Because they have to be normal.
Sine theta has to be 180 degrees.
The sum of the angles. The sum of the angle of incidence to the medium's interface, right?
Yeah.
And the angle of refraction have to sum to 180 degrees.
Okay, and?
Okay, so in a gradient index medium, that's not the case. If you apply Fermat's principle, I just posted a PDF that runs through the mathematics. I don't expect you to go through it now.
Live stream text?
Yes, right? I even posted the PDF, right? So it says sine theta conserved along the light path. And it goes on. Snell's law states that the quantity sine theta is unchanged in the refraction of light passing from one medium to the other. We inquire whether this is true in a general case where the speed of light varies continuously within a medium. That is a gradient index medium. Right? So you have to apply Fermat's principle, right? The principle of least time. So you understand that. Final result of these exercises is that, contrary to initial expectations, the answer to the question in the title is negative. So there's problems with using Snell's law and a freaking on like some gradient index medium, because you would end up having weird ducting, weird reflections, right? So if you modeled, right, so a medium with n number of indexes of refraction mediums, how many freaking layers are you going to use, right? So what you could end up happening is the light being trapped within one of these layers and never exiting, especially if the light ever ends up going horizontal. So if it ever ends up going horizontal, it's never going to transition some barrier, right? Some interface. So if you look at Andrew Thomas Young's website, he admits this, that it results in a singularity if you use Snell's law, right? If you use Snell's law and the Earth is flat, right, and you have a medium at that level, so 6 feet, right, and you even have a gradient, right, you can even have a temperature gradient, that light, if it's horizontal, will never transition into any other refractive index medium, because it's horizontal over a flat plane. So if you model out mathematically, yeah, it'll just go on forever, right? The only reason you all say there's bending light, right, is because you have a curving gradient. I'm not gish galloping. Like, no, just because you can't comprehend what's being said, because this is above your pay grade, ain't my problem. That's your problem.
Well, I'm reading through this, and I'm not seeing the part where they conclude. So what page is it where they conclude?
The conclusion? Scroll down.
Yeah.
The conclusion is literally in the abstract. You don't even have to read the conclusion. You can scroll down to it.
So in the introduction.
So you see, you've never read actually any scientific material, so this is just like fucking Chinese to you.
Well, the conclusion is usually...
So I've been reading this shit for 20 years.
It's in the abstract.
The conclusion is in the abstract. The answer to the question in the title is negative. Is sine theta conserved along the light path? That means, says, Snell's law states that the quantity and sine theta is unchanged in the refraction of light. Is sine theta conserved along the light path? The answer to the title is negative. The answer is in the abstract. They don't use Snell's law to model in physics, gradient index medium. Abstract, I posted it literally in the chat.
It also provides...
Look.
The final results of the exercise is that, contrary to an initial expectation...
Let me ask you this. Does Walter Bisgund's simulator use Snell's law?
Yeah.
No, it doesn't. It uses Fermat's principle.
Okay, if he uses Fermat's principle, who cares?
Okay, so does Mick West.
What's the difference? What's the applicable difference between the two?
Is that there's no boundary.
In Fermat's principle?
Yeah, there's no boundary. You integrate over the light path, basically.
No. Yeah.
It's you use the calculus of variations of integrate over the light path. Whereas one is just simply algebraic or trigonometric, if you want.
And?
That they're not mathematically equivalent, dude.
They are
you understand?
The outcomes are still generally the same.
No, Snell's law is a special case of Fermat's principle.
They're still...
Where you have a well-defined medium. No, they're not.
Yes.
Snell's law is a special case, right? Snell's law is a special case where you have two well-defined mediums with a well-defined boundary.
Snell's law and Fermat's principle, would they be roughly equivalent?
In one case, where you have a medium where you have two mediums with different refractive index that are homogeneous, isotropic, and have a well-defined boundary. That special case, that's what it models. Which is great for designing lenses. Right? You can use the thin lens equation, no problem. Easy peasy. Then you still get to the engineering.
Fermat's principle, which states the light travels the path which takes the least time. By taking the derivative of the optical path length, the stationary point is found giving the path taken by the light. And there are situations of light violating Fermat's principle by not taking the least time path, as in reflection or a spherical mirror. In a classic analogy, the area of lower refractive index is replaced by a beach, the area of higher refractive index by the sea. And the fastest way for a rescuer on the beach to get to the drowning person in the sea is to run along the path that follows Snell's law.
Yeah, because you have a well-defined boundary. Sand in the water. You go one speed over the sand and another speed over the water. So you want to find the path which is the most efficient to reach the person. Well, the principle of least time. Which one takes you the least time? Should you run through the sand more? Should you freaking swim more? Which one should you do?
Great. So they both use the principle of least time.
Fermat's principle, or Snell's law, is a special case of Fermat's principle.
Right? Okay, great. So why doesn't Snell's law work?
I told you, because it's a gradient. So now you have the sand, right? So the sand is continuously varying. In the water, your speed through the water is also continuously varying. Actually, there is no sand in no water because there's no well-defined boundary. It's just all sand. And your velocity through any given point in the sand, like at point, there's 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, but there's a continuum. It's a continuous change. It's a continuous change, right? It's not a discrete change, like at a boundary, which is Snell's law.
Why is that a problem? So think about it like this time. You have X speed on sand, X and Y speed on water, and then you replace that water, and you have the speed across just sand being equivalent to the average speed between X and Y. And all it is just...
I don't know how to explain this to you. If you don't understand basic mathematics, I just don't know how to explain it to you.
Well, I just explained to you what Snell and Fermat's law, the difference in the principles. One says you go from X to Y, and the other one says there is a gradual change between X and Y. But if they both end up with very, very similar end results based on, the different optical...
Do they end up with similar results?
Of the mediums. Yeah.
Yeah, where's your evidence for that, dude? Like, seriously.
The paper you cited. They only found very, very small deviations using different calculations. In your paper that you cited.
Well,
every FLIRF paper disagrees with them.
What did you say?
Every FLIRF citation disagrees with
Dude,
them.
okay, you just said that there's a difference. Previously you said they were the same. Okay? It doesn't disagree with me, it disagrees with you. That's a crazy projection. Now it's close enough. Before you were saying it was the same.
I'm waiting for evidence that it isn't. Can you tell me why Snell's law wouldn't work across a lake?
Because it's not a well-defined boundary. It's a single medium, so they have to
You can take all the different mediums, and it's not a single medium because optical density changes depending on the temperature and the amount of air, the amount of water in the air, and the density of the air and the pressure in the air. So you can.
So tell me, how, in reality, how would you model this out? How would you model this out? This gradient, right? This air gradient. How would you model this out?
I don't know. I don't have enough knowledge in maths for that, but I understand the concept.
Yeah. So you would have to use an infinite, like an infinite amount of
to B density, or X density to Y density.
How many layers
do you need? Is that there is a gradual change between A density and B density. That's all it is.
How many layers until you approximate Fermat's law?
I don't know. I don't care. But that doesn't matter.
I know you don't care.
And this is amazing. This is amazing. You're doing a reification.
Yeah, now you're going to talk about me again. How predictable.
You're doing a reification fallacy.
No one is reifying it.
You know
I'm asking you. You say refraction exists. I'm looking for the evidence that it exists. I'm looking for the model that makes
mathematical
so that we can.
Is it something that exists in reality?
Refraction as a general phenomenon exists. Refraction bending light around the curve of the Earth. Does that exist? That's what we want to determine. Does that exist? What is the evidence for it?
What is the boundary in Snell's law? Does that reference something actual, like an actual boundary, or does it reference a mathematical?
Yes, it's an actual fucking boundary. Yes.
No,
it's where one medium becomes another medium. The atoms on one side is.
I've ever heard. It doesn't.
Oh, so water. No, Elijah, please don't. Please, I'm asking you, please. I want to finish this. He's going to try and get off it. I'm not letting him get off of it.
Snell's law calculates the optical density of A and the optical density of B, and then it arbitrarily pops in a boundary between them.
Where do you think they would pop in that boundary?
What?
At the end of A, at the spatial end of A, and at the spatial beginning of B? Do you think that's where the boundary is? So if you have two substances, one's water and one's glass, the water's not the glass, and the glass is not the water, and where they meet is what we call the boundary.
They can both be water with two different optical densities.
So water can be water, and glass can be water and glass at the same time?
No. Indio, listen to me, okay? You can have air, just air, but if the optical density of air is different at 2 points, in Snell's law, you'll take those 2 points of measured optical density, so the different temperature and pressure, and you will put a boundary in the middle of that calculation. And that boundary calculates the deviation, the refraction.
That's why I asked you how many layers.
Going from A to B. Whereas in Fermat, it will be a gradual change. It won't be a defined boundary they put into the calculation. It will be between A and B, there is this amount of change, not it changes at a defined boundary, okay? It's all abstract, it's all mathematical, and it's called a reification fallacy when you say that there's an actual boundary in spatial reality.
No, what I said was there is a continuous change in Fermat's principle, and you just made my argument. Thanks you very much. Snell's law. Snell's law has a boundary. Snell's law has a boundary.
I've ever.
Dude. Snell's law. Oh my God, the fucking spiral. Snell's law has a boundary. You said that you can make an arbitrary boundary. Where do we make that boundary? How many boundaries? That's why I asked you how many layers. You didn't even understand what that was talking about. Like, how would you model this? How many layers do you have to do? If I take six feet of freaking air, right? How many layers of Snell's law of different refraction index to model this gradient do I use? Do I use 10,000? Do I use 1,000,000? Do I use 1,000,000,000,000? Do I use an infinite amount? Right? When we use an infinite amount, well, oh my God, that's fucking calculus. And we use a continuum. And look, the continuum's more accurate than the so-called simulation of boundaries. I don't know why you don't understand this. Oh, because you don't know anything about mathematics. But your whole idea of refraction is based upon mathematical models, which don't work in reality, which make no predictions in reality. That's why I'm going to ask you again. I know someone muted you. Give me the model of refraction that makes accurate predictions that we can test, so that we know which one to use, so that when we make our post hoc claim, we can be using a model which has some predictive power. You even said We need predictive power to tell us what's likely true. Give us the model with predictive power.
Both.
Give me the exact model with predictive power.
Both.
Okay, so those are models. How are they tested?
I can find some journal articles if you'd like me to.
Yeah, I'm sure I've read them all.
Awesome. But are you willing to admit that the boundary is just what they put in? Like it's the maths that they add in to say that there is a defined...
They don't use Snell's law for a gradient, you clown.
A defined point between the refractive index of A and the refractive index of B, right? So all they've done is they've said there has to be a boundary here instead of it being a gradual change.
Okay.
No. Are you saying that exists in reality is bullshit?
No, when they model it, listen, when they model it in reality, right? Like if they model it between glass and water, they'll use Snell's law. But if they have a gradient, they're not going to use Snell's law. So when I say the Snell's law is an actual boundary, that's what they're modeling. They're modeling an actual boundary. They're not going to use it in a situation you're talking about. They're not going to use it for a gradient index medium. They're just not going to use it. So it's like,
why not use it? If it's easier, because Snell's law is
because it's inaccurate.
Principle, isn't it?
Because it's inaccurate.
To what percentage? To what percentage?
It probably depends on the application.
Oh, okay. So we can use Snell's law if we want, say, a couple of percentage points of accuracy. And then Fermat's if we want, say, a couple more points of accuracy. It's the same with Newton's and Einstein's, isn't it?
Well, it depends on the distance, right? So it depends on how long the light is within the medium, right? So that's the defining factor. How long the light is inside the gradient versus, or how many layers you model. So there's all different, depends on your model, right? So that you could probably make a situational Snell's law model and use Fermat's principle and get them fairly correct, probably for good enough for practical purposes and make it quote unquote work, right? But it's not what's used in the common practice. They just use Fermat's principle because it's more accurate. That's just what they do.
So they both would work. One's just more accurate.
But the fact of the matter is, you can use Snell's law. You can use whatever the fuck you want.
You thought that this boundary was a physical boundary, you fucking goose.
No, listen, in the use that they model it, it is. Yeah, in the use that they model it, it is. Where they actually use Snell's law to model something,
it's real. When they model it, it's an actual boundary.
No, listen, they don't model gradients using Snell's law. Only dumbass fucking anti-flat earthers use it for that. That's what I'm trying to tell you. Only you fuck clowns use it for that. Nobody uses this. If you go read all the literature, no one uses Snell's law for this shit. Nobody. Not a fucking person. Only Dunning-Kruger anti-flat earthers use this shit.
Does it still work? Does it still work?
No!
Why? What's the percentage difference? How many decimal points are different?
I just told you. I already answered that question. Depends on the application.
You don't know Reification fallacy, and you don't know, and you're trying to lecture me about the maths. At least I'm big enough.
No. Listen, I told you the situation. It depends. It depends on the situation. It depends on what you're modeling. The error depends on what you're modeling. If you're modeling how long light's in fucking 1 millimeter of a gradient, dude. Yeah, they're going to be almost identical. But if you're modeling how far, like if it's going through fucking 1 trillion miles of air, that's something else. You're going to it depends. It depends on the application.
I think we're done with this now.
No, you're going to give me the predictive model. Dude. You're just going to give it to me because we want to know when we do our post hoc, ad hoc bullshit at the end, right? So we can't falsify the globe. I want to know what model we have to apply.
You're obviously
I want to know what model, dude. I want the evidence. No, I want the evidence for your foregone conclusion. I just want the evidence. That's all I'm asking for. What's the evidence, dude? What's the evidence? What's the evidence that any of these models work? What's the evidence that that light is bending around the curve? What model predicts that? And then that model has been validated by observation.
Great. I'm looking up
really simple.
Theoretical and experimental study of refractive indices of water, acids, and nitrile and salt systems.
Yeah, so I'm talking about terrestrial refraction.
They calculated the refraction.
I'm talking about terrestrial refraction. This thing that's supposed to be like bending around the curve, making everything look flat.
If you apply it to the surface of the Earth. No, these are physical constants, buddy. Do you know what a physical constant is?
Dude. Okay.
Dude.
That's a cool story. physical constants, yada, yada, yada. Cool story, bro. I'm asking for the model that makes predictions that we can apply in real life.
I propose a simple theoretical formula for describing the refractive indices in binary liquid mixtures containing salt ions. Our theory is based on the Clausius-Massotti equation. It gives the refraction index of the mixture in terms of the refractive indices of the pure liquid and the polarizability of the ionic species by properly accounting for the volume change upon mixing. The theoretical predictions are tested by extensive experimental measurements of the refractive indices of water, acetonitrile salt systems for several liquid compositions, different salt species, and a range of salt concentrations. Excellent agreement is obtained in all cases, especially in low salt concentrations with no.
Are you almost done? Like doing nothing?
Expression of the refractive index for low salt concentration is also given, which can be a theoretical basis for determination of salt concentration using refractive index measurements. So it seems like they've come up with a very, very simple equation for refraction based on this one specific liquid, and it's been correct. They tested it, and it was correct.
Yeah, awesome.
Okay.
Yeah.
So now we're going to apply that to the air. What model is used for the air?
Just a second.
It doesn't matter. There's not a big deviation.
It doesn't matter.
What I love is they're using a tank and a solution and allowing it to set so it becomes homogeneous and isotropic.
Are they?
Yeah.
Are they? Because what I just read out.
Because when you stir the solution, I've seen many demonstrations of this. Okay. When you stir the solution, you see no deviation.
Look, I'm just looking for the justification for claiming that there's terrestrial refraction fucking up all our measurements with a laser. I want the justification for that. And you can't seem to come up with one. Other than because I said so.
Experimental determination of the refractive index of Snell's law. This experiment uses a narrow beam of light passing from air into glass and then into air. The experiment is practically easier using a hemi-cylindrical prism of glass with a beam entering the curve.
But these are inapplicable to what we're talking about.
Why?
You're just Googling random shit on refraction, dude. Terrestrial refraction. Google that, brother.
There's literally
you think I don't know you didn't look for this?
An experiment showing refraction works, but you don't like it because you don't seem to understand that Snell's law, being a model, means that there has to exist things in real life.
You can claim it works in different applications that have nothing to do with. We want to see it works in this application.
In what application? Through air?
The application of a laser or a ray of light through air, dude.
Great. Refraction over water experiment. Have you never typed these things in?
Look, dude.
No, you haven't, have you?
What are you talking about?
It's much easier to just sit here and go around in circles about things that you don't understand rather than just go,
yeah, talking about me again. The old standby.
Hey, so, anyway.
No, we're going to finish this point. I don't care how long it fucking takes, dude. I don't. So, we're going to finish this. I want the predictive model for refraction so we know that there's a justification for saying that it exists. We need a justification. We can't just say, hey, willy-nilly, we're just going to throw in this phenomenon that we say exists. We need a justification for saying it exists, right? And one justification would be a model that's been tested and makes predictions. But that model doesn't exist, and you know it doesn't exist. That's why you're bringing up all this ancillary bullshit. And you know what? By bringing up ancillary bullshit and
predicting atmospheric refraction with weather modeling and machine learning.
Yeah. Okay. I've read that.
Would you like to read this?
I've already read it.
Have you?
Yes, I have. I read it about 2 years ago.
Oh, okay. What do they do in it?
I think they're looking at the side of a mountain, if I remember right. It's in Arizona. It's like in the desert.
White Sands, New Mexico?
Yeah, I got a pretty good memory. Seeing I only freaking skimmed it freaking goddamn 2 years ago, 3 years ago maybe. Yeah, but even if listen, so check this out. I'm pretty sure the AI successfully made predictions, but AIs are black boxes, so we don't know how they actually make predictions.
So you've read something that confirms that
no, it doesn't confirm anything. They just
weather model data results were computed for 10-minute intervals and ray tracing procedure was applied. The data is interpolated in time to align with the time-lapse image frames. Shows results of the experiment as a function of time of day, blah, 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 blah. Where is it? Measurements are only available for daytime. General downward drift through daytime hours is an effect we commonly observe in clear weather, and this corresponds to a reduction in the average refractive index gradient of the atmosphere along our line of sight.
Yeah, claiming something and showing the actual mathematics to support it are two different things.
Well, they've got the mathematics in this.
Not for that specifically. That the specific claim you just made, they do not have the mathematics.
I'm looking at it right now.
So what model do they use?
They have a machine learning model.
Well, you said it just matches the gradient of listen, you just said it matches the gradient of the refractive index.
Uh-huh.
What is it matching? What is the machine learning matching? What model is that?
So the machine learning takes the image and then the ray tracing, whatever it is, and adds that into the known distances, and then takes all of the weather data and then calculates a refractive index based off that. Okay.
So what model is it comparing it against?
I mean, I can just link the paper. It's got all the maths for it here.
What model does it compare it against? So what you have is you have a model, and the machine learning looks at the images, right? And then the machine learning goes, if this model existed, how would this image match that model? And now I'm going to make predictions. When I take an image, how does this image fit this model?
It doesn't matter. It works.
What's the model, dude?
Refraction exists, and it's between Fermat's, Snell's, and this model, they would have similar outcomes, right?
No.
And the deviation doesn't matter because the deviation can be changed by any of the variables changing. So the refractive index should actually just be like a range, okay? So if you have like the black swan image and then you apply refraction to that, you don't just add a set refractive index. You can make that range of refractive indexes based off the measurements you have and the variables that could change. That's how science and data works. And then from that, you can see whether that image can fit the predictions based off refraction, which would be the range of refraction.
What predictions? That's what I'm asking you. How do we make the predictions? What model do we use to make the predictions?
It doesn't matter. For math, this machine learning,
I'm going to use chicken bones.
Be fairly similar, right?
No, not really.
Not really. Okay, so what's
depends on what model you use. They'd actually. They've tested models, in the literature, they've tested these models against each other, Well, then so you actually don't know anything about this topic. I'm asking you this for a very specific...
literature, champ?
Because they're so... Dude, do you want me to link hundreds of PDFs that say, dude, we don't know?
I want you to link one.
Hold on.
Here, look, I'll add this in showing that machine learning can predict refraction.
So what? Machine learning is black boxes. We don't even know how it's doing the prediction. If you knew anything about machine learning, no.
That's genetic.
The machine learning is at modeling anything. You don't understand how machine learning works. So let's not talk about it. Until you know how machine learning works, then there's nothing to talk about.
It's a genetic fallacy.
No,
isn't machine learning where the machine takes in multiple sources of data and then it comes up with an algorithm based off that data that would predict any two sets of data outcomes further on?
Okay.
Let's look. Machine learning, subfield of artificial intelligence that deals with systems that are able to acquire their own knowledge by extracting patterns. There we go. Extracting patterns to get new data. Great. So, have you found that study yet?
Yeah, I'll just read you a whole bunch. How about that?
No, just link one.
Where should I pick?
Have you linked one? Have you dropped one in voice chat yet?
Yeah, I'm going to link to like 10.
Well, I just want one, so link your best one. I'm going to just look at the top one anyway. Top one's going to be your best one.
So what? Just so I get the right thing, and I give you the right thing. What exactly do you want?
Show the difference that an observation using Snell's law refractive index versus Fermat's law refractive index.
I already did that.
Deviation.
I'm not doing it again. They don't use Snell's law, and they don't use Snell's law in any type of surveying, anything to do with
they use Fermat.
terrestrial refraction. They don't use it.
Why'd you ask which one's best?
No, oh my God, dude!
This is law, so why would you ask?
This is what you don't understand. There's models for terrestrial refraction. They involve temperature, humidity, CO2, yada yada yada. I
explained all this to you, you fucking idiot.
Listen, no, dude.
Yes,
there's
I did.
multiple models.
10 minutes ago, I went through all the things that can impact refraction.
That's right. That's awesome. Yeah. That's awesome.
I explained it to you already. So every single image you guys have of a flat Earth can be explained using refraction. We know to exist.
Okay, cool.
Is that true? Yes or no?
Yeah, cool. No, it's not true. Okay.
Great. Give me one image that shows that the Earth is flat that can't be explained using refraction.
Using assumption, you mean?
No,
refraction. Okay. I just went through machine learning.
You just have assumption. You have no evidence that there is refraction happening on those days.
Machine learning was able to calculate a refractive index.
They're not calculating anything.
Yes, it did.
No, they're not.
You're just assuming things. You have no values, so you're just assuming things. There's more values in the laser test.
Data goes in, it calculates, it comes up with an equation.
It doesn't calculate, it does. It doesn't come up with a fucking equation. You don't know what you're talking about.
When you get data and you run data
dude, machine learning is basically a lookup table, dude. That's basically what it is. It's a lookup table.
It
you have no idea what you're talking about. Dude, I got a degree in computer science. You don't know what the fuck you're talking about.
X equals C, depending on some variable.
It's not. They use gradient descent, dude. In this machine learning model, they use something called gradient descent. You have no idea what the fuck you're talking about. Stay like you don't know what you're talking about with refraction. You really don't know what you're talking about with machine learning.
Even if I don't know what I'm talking about,
I'm not going to explain it to you.
I can understand.
Look, I want to go back to these variables.
Someone who's been doing this for years.
I want to go back to these variables, right? So these variables that you say exist, it's cause refraction. Right? You think they exist because there's models that exist that use these variables to make predictions about refraction. Well, none of these models actually makes accurate predictions.
They do.
No, okay, where is that?
The Fermat's law. You just explained yourself that surveyors use it. Surveyors get accurate data over land masses, don't they?
I'm not talking about. So listen. Okay, so to apply Fermat's principle, you have to know the refractive index at any given point. How do you calculate that?
No, you can average
temperature, humidity.
Snell's law assumes that there's some set boundary, but Fermat's law can say that given like the known variables, you can average it out over a distance.
Well, they don't do averaging, but whatever. That's
what Fermat's law is. It may not be an average, but what it is it's going from A to B using a function rather than going from A to B.
Right. And so there's different variables that they use in these different models to model terrestrial refraction.
So
none are accurate. That's what I'm trying to tell you. None are accurate.
As a function, it would be centimeter 1 is 9 from 1, centimeter 8 is bloody 2, centimeter 2 is 8 from 1, centimeter 3 is 7 from 1. That's how the function would work.
Yeah. Great. Fantastic. How do they figure out what the refractive index is at any given
maths. I don't know much advanced maths, and I was able to explain to you how that would be.
You don't have to explain it to me. You're just you're trying to convince yourself of something, dude. You're not understanding what I'm saying, or you're deliberately being obtuse. There's a model. There's a model that uses these variables. So you're starting to talk over me again. There's a model that uses these variables, and none of those models make accurate predictions. These variables that you say exist, which cause refraction, to validate whether these models cause refraction, you need a model that makes predictions which are tested and known to be accurate. You don't have that. You're putting the cart before the horse. Where's the fucking horse? Where's the model of refraction that makes predictions so that we know these are the variables that matter? These are the variables that cause uncertainty in our observation. These are the variables that we need to account for so that we can come up with a refractive index or a change in the refractive index from which we can make predictions with. That doesn't exist. And do you know what? It's been tested. So there was an experiment, this laser experiment across the Hawaiian Islands, and they took 3 lasers. And they went from one Hawaiian island to the other. And they did this experiment. They were measuring turbulence in the air. They picked up all 3 of these laser frequencies through their telescope. Then what did they do? So there was other research students there. So for his master's degree, he tried to model it. And when he applied the model of refraction, right? Gradient, standard US temperature, when he modeled it across this same distance using the same laser frequencies, he found out the experiment should not have worked at all. Because the divergence, because refractive index is wavelength dependent, right? You have, what the hell do they call it? Can't remember the name of it. Dispersion of light. That's where the wavelengths separate.
Why are you still talking? Have you linked a PDF about it?
Oh, I will if you want.
Yeah, of course.
It's going to make you fucking spiral into oblivion, but whatever. So, So what happens is the spread of the wavelengths of the laser are greater than the width of the telescope. So when you model it, right, when you model it in this refractive index air, the spread, so you have 3 frequencies of lasers all starting at the same point, they spread out because not all of them refract the same. They refract differently. It's wavelength dependent. So they're spread out by some spatial distance. That spatial distance is greater than the width of the telescope. But somehow they picked up all 3 beams in the telescope at the same time. The only way that can happen is if there's no refraction.
How do I find this? How do I find this?
Hold on, I'm gonna post.
How do I
want the underlying experiment? Yeah, hold on. So I'll find the underlying experiment. So this was there's experiments based upon, it's done by the Air Force. So the person that wrote this master's thesis, he tried to model what the results were. And when he modeled the standard, terrestrial refraction, using the same shit Bisgan uses, using the same shit Mick West uses, found out that, like it says, I'll read it to you. For the 150 kilometer path simulated, the rays are misaligned by about 4 meters.
Okay.
With respect to the point, the telescope's 3.4 meters wide.
And?
That means they should not have, if the refraction model was correct, they could not have picked up all 3 lasers simultaneously in the telescope. But they did.
What did they say about it?
I mean, what did they say about it?
What was their conclusion? What was their conclusion?
Well, see, they did the test first, and then after the fact, they applied the model, and then realized our test should not have worked. If they would have applied the model before the test, they probably would have never did it. They would have probably designed a different test.
Okay, so they came up with there is some variable or phenomena that we cannot explain. Is that what they came up with?
What they were testing was... Okay, so was it test
was their answer? The presented experimental results on intensity scintillation characteristics reveal complexity of the observed phenomena that cannot be fully explained based on the existing atmospheric turbulent models.
Yeah, so there's turbulence models, there's refractive index models, and he tried to use a mixed turbulence refraction model. None of those models worked, but the turbulence model, called a non-Kolmosov model or some shit. Can't remember the name of it because there's actually 2 of them. There's the non one and there's just a regular one. Anyway, so the turbulence model fit more closely than the so-called terrestrial refraction model. The terrestrial refraction model says that the experiment should not even have been completed because you can look at the simulation. He simulates it the same way Walter Bisgan simulates it, using the same methodology. So the fact that, and I have more stuff, right? So I have more. They've done terrestrial laser measurements using 2-frequency LiDAR. I can post that. And what they measured was the deviation.
What's that going to prove? What's that going to show? What's that going to show?
It shows that when they so-called measured the refractive index, right? They measured the angle of arrival of a beam of light of 2 different frequencies of light. And then they measure the angle, like how much deflection they are measuring, right?
Yes, but the argument.
And they're measuring 5 they're measuring a max 4 Mgon deflection, which is equivalent to 0.009 degrees. So if you extrapolate out to 29 miles, 25 miles, that's 8 feet.
And?
That's an 8 feet deflection at the max.
And?
The laser, like ISO laser test, would have to be a 420 foot deflection. A 440 foot deflection.
And?
You don't understand that the observation at Lake ISO is 2 orders of magnitude off the prediction, right? Even if you, say you use 7.6R, it's 2 orders of magnitude off that prediction.
What was that conclusion?
Bruh. Dude, for FE core? Yeah, that does not fit the WGS84 model.
Oh, you're talking about FE core again. They didn't add in any refraction, you fucking idiot.
Bruh. And I'm trying to justify adding it in. So don't you get it? We're trying to justify adding it in. We're not just saying, yeah, it exists.
The surveys use refraction.
Let's say we use 7.6R.
Surveys use refraction.
Surveys use refraction. How much refraction
do they accurately measure the surface of the Earth in distances?
For practical purposes, yes.
Great. Do they use optical measurements?
Yes.
Great. So why didn't FE core do the fucking same?
We can do the same. We can use 7.6R.
Then do it.
We can use. So if you look, so I'll give you an example. We in the United States, different states build roads. If you look at the surveying manuals for the transportation departments in different states, they all use different refractive index ratios. They use different values for terrestrial fraction. So, for instance, in Massachusetts, they use 0.17. In Washington State, they use 0.13. In Europe, they use 0.13. So different places use different values. Listen, the point is, the largest value anyone uses is 7.6R, which is 0.166, right? So you take this 0.16 that they use in surveying, right? It only takes 5 meters off. You have to, and the value is 137 meters off. The measured value is 137 meters off, dude. So, okay, we'll give you refraction. We'll give you terrestrial refraction model. We'll go 7.6R. Yeah, now you have to make up another 132 meters.
I didn't say this FE.
Now we can go, okay, there is even extra special refraction. We'll multiply it times 10.
Drop in the FE laser measurement link again. I'll look at it again using the highest and lowest refractive indexes.
What does that even mean? First of all, you just quoted surveying.
If I'm right,
they use a 7.6R value.
Stupid rambling way. If we were to add in the standard refractive indexes into the FE core measurement, it still would.
Yeah, the ones you just appealed to, surveying. Those are the ones you just appealed to. You said surveying, they use refraction. That's what they use. They use 7.6R.
Big fella, if you add those into the FE core data, it still won't explain the data. Is that what you're trying to say?
I'm saying, if you add that value listen, I'm explaining it to you. If you add that value into the data, it only moves the laser down 5 meters.
Okay, great.
You have to move it down 137 meters.
The FE core thing again. I'm gonna download it. I'm gonna go away. I'm gonna do the maths. I'm gonna come back. Okay.
Yeah. Okay. Fine with me. I want you to keep in mind that they didn't this isn't a one-off. They did it 3 weeks apart. So make sure that you read the dates.
Don't care if they didn't add refraction. I don't give a fuck.
You don't even know why they should be adding it, other than somebody told you they should add it.
No, I know why they have to add it. They have to add it because as light moves through a medium, if there's any change to that medium, then the angle of incidence changes.
And that means what?
And that means that the light can make things look further up or further down.
Okay. Yeah, you're claiming that. But you're claiming that. But what's the evidence? Dude, that's what you don't understand. You don't understand there's a difference between claims in
You
evidence.
open the fridge, mate? Have you ever opened the fucking fridge and looked at it? You cold air when it hits the warm air and things get all goofy behind it.
Well, that would be evidence.
There's experiments where there's one where some dude like pours cold water over, or I think it's liquid natural gas over a propane tank, and you can see some, I don't know, colours that you couldn't see before, some bands of colour.
Thank you for proving. Thanks, you just proved flat Earth. Thank you very much.
Affecting what you see.
Yeah, that's great, dude. Do you know what that proves? Because you have to use it's butane. Listen to me. Because that proves that you're applying refraction. Listen, you don't get it, dude. Butane has a refraction. Okay, can I finish? Can I finish? Can I finish? Can I finish? Okay, so the refractive index is butane, by the way. And the refractive index of butane is 1.33. Right.
I don't care. I don't care.
So check it out. The fact that you have to use, listen, the fact that you have to use an extreme, non-physical, unequivalent demonstration to simulate what you say is happening all the time demonstrates that it's not happening all the time. The fact you have to use butane to show it to happen demonstrates that it's not happening all the time.
It happens with cold air. It happens with cold air.
Yeah, with cold air, but that has a temperature gradient of something like 70 degrees per centimeter. Is that physical? Do we experience that in the real world? Do you ever have your feet get frostbite while your knees were burning off? I didn't think so. The fact you have to use extreme examples of demonstrations, non-physical to what we experience in everyday life, proves that it's not happening.
Oh my God, that's because the demonstrations are done in people's houses, you fucking moron. You fucking idiot. If you're going to demonstrate something in your house, a very small area, then you have to use extreme refractive conditions because you can't have the massive change over a long area. It's numbers, you dumb cunt. It's numbers.
Oh,
what numbers?
The language on you. You blow your father with that mouth?
Oh my God. So we have, say, I want to test something in a very small area. Okay, and I want to test some variable that usually happens over a very long area. I have to make that variable much bigger in the small area to make sure that I can observe that variable in action. Because over the very, very, very long area, that variable can have very insignificant changes, but because it's such a long area, those insignificant changes can cause a massive change over that long area. I'm explaining this to you like a child because so far you've shown that you may be a child.
This is actually pretty humorous. So what you're saying is,
look, here's a video.
We have to scale down the experiment to demonstrate that the phenomenon, which should be happening all the time in the air, is actually possible. And to do this, we need extreme conditions. But the underlying phenomenon, you can't actually demonstrate is happening.
Extreme conditions, just people show that it's possible using extreme conditions because they're doing it in their little house.
But they're not equivalent.
Of course they're equivalent. It's just scale, mate.
Okay.
If I want to make a square, I can make a square 1 centimetre by 1 centimetre or 1 mile by 1 mile, but those fucking squares will still be square.
Okay. It's not equivalent, and the scale's not equivalent, okay, because the refractive index of air, I'm going to explain to you why. I'm trying to explain to you why the emotional child.
Fucking trains are
irony of you calling me a child with your spasming, dude. That's hilarious. Anyway, so the refractive index of butane is nowhere near equivalent to air. Air's refractive index changes. Yeah, you don't give a. I thought it was math, dude. I thought it was numbers, but now you don't give a fuck.
Past butane onto air, but you're stuck on.
Oh yeah. No, I'm going to cover them both.
You consider anything that goes against your biases.
So I'm going to cover them both. See, don't presuppose what I'm going to say, dude.
Well, I'm going to cover them both. Don't talk about butane because I don't give a fuck.
No, you don't give a fuck. Okay, so let's talk about the air. The temperature, the extreme temperature gradient, right? That you're demonstrating. So I've seen the dry ice demonstration. The refractive index of CO2 is not the same as air. And then I've seen, I think they use a cold plate or something like that, or ice. I think it was Mick West used ice. Was it Weiss? What did he use to make everything cold? Was it turbulent air?
No, he didn't use Barry Weiss.
What was used to make the temperature gradient?
I don't know, because I'm not obsessed with people that do these experiments like you retards are.
So you cited an experiment that you don't even know what happened. Great. Let's go with that.
I've watched. I cited an experiment that I've watched, but I don't remember the people that did it because I don't give a fuck. Look, I found.
So what if they use dry ice?
Let's look at the Mick West.
What if they use dry ice?
I found the one you wanted. You wanted me to talk about Mick West, didn't you? Because you have pre-prepared.
No, I don't care about Mick West. He already got smashed in here. You can fucking listen to the video on the YouTube channel.
Yeah, there's Mick West. I finally found the thing you were talking about that I wasn't.
I don't care about Mick West. I'm asking you, if you don't know the details, if you don't know the details of the experiment, you don't know if they use CO2, if they use some equivalent. You claim they're equivalent, they're just different scale, but you don't actually even know that. I'm asking you, if they use CO2, why did they change the air? I'm trying to figure out the iron. See, you make claims that there's no evidence for. That's the hilarious part. You just keep,
What claim?
You claimed that these demonstrations are equivalent and they're just a change in scale. So I'm asking you details about them and you don't know the details. So you're just talking out your ass.
What detail do you want? The guy put up
what did they use to cool the air? What did they use to
laser changed it?
What did they use to cool the air? What substance? How did they create this temperature gradient?
Nothing. They warmed up the air using an iron.
They warmed up the air using an iron? What?
Are you just going to repeat back with a dumbfounded?
I don't understand what you're. I don't understand what you mean by they warmed up the air using an iron, like an iron for ironing clothes. Iron, like
you what? Don't seem to understand anything. I linked the video.
Because you suck at explaining yourself.
You know, an iron, like you iron your clothes. Yeah, it heats up the air. Look, here's one of nice wavy air patterns in front of a heater. Why would that happen?
Turbulence. It's called sensible heat flux.
Amazing.
Yeah, it's called sensible heat flux. Yeah. So, like when air gets hot, it goes up, right? Right? It tries to equilibrate and it moves around. It's like why you don't survey in the wind. So there's something called the Fresnel effect, where a medium that's in motion will deflect light in the direction of the motion.
Oh, okay. So there is refraction, deflection.
That's not refraction. It's a completely different thing.
So did they look at what the wind speed was over the water in the FE core experiment?
Yeah, I'm pretty sure they did. I mean, it sounded like they took pictures of the meteorological station.
Anyway, I'm out of here. My earbuds are about to die, and you seem to be thicker than a brick, my son.
Yeah,
hypothesis in science, buddy.
Oh, does that qualify as a wig, bro? I'm sorry to everyone that I cut off, but I do not want to let him out of that. Otherwise, we're going to be looping on that shit forever. I'm sick of this guy. I'm sick of looping with this guy.
That counts as a wig with the earbud still attached.
Ew. How about the ear still attached? How much glue did you use on that wig? Listen, this is, to me, these refraction claims, like, I'm so sick of it just being like a foregone conclusion. You didn't include refraction. You didn't account for refraction. Why should we? Give us a reason why we should. Oh, because everybody else is doing it. That's not an argument. Surveyors do it. Yeah, so what? And? They're measuring 50 meters at a time. The uncertainty is like 2 millimeters. Do you think that like if they don't use refraction, it's like, oh my God, now the fucking road's all fucked up. It's a 1,000-mile road and now it's messed up because we didn't account for refraction. I mean, come on, man.
Dude.
Get serious.
Did they account for refraction when they used the microscope on that fishing line?
Dude, that's somebody that's like, have you ever done asphalt AI?
Not really, no.
I
Cement,
have,
though.
when I was a kid. So I've done asphalt. I wish Mike was here. Like, you're precise, but you're not that precise. It's fucking asphalt, dude. It's like,
yeah, exactly.
fucking not measuring to like, oh my God, we didn't account for refraction of the road, man. Oh my God, like, no, the road doesn't work. I mean, get real.
I've done sidewalks and stuff and foundations, but yeah, same principle.
So they only use the geodetic surveying so-called techniques for practical purposes in road work. They don't use them. And it depends. It depends on whether it's an interstate highway versus, state road versus a city road, right? Depends on whether they're going to use a state plane system versus like the geodetic system. And the geodetic system is going to has to be long. And like any error of not using refraction is going to be so negligible, it isn't going to matter. They never like built roads and were like, fuck, we built this whole road and didn't account for refraction. No wonder why it's messed up. No one has ever done that. That's never happened.
Yeah, you were trying to tell me. I thought that the point that I wanted to jump in that was annoying was that he was trying to say boundary wasn't like the part he was missing was that to Snell's law it's two mediums.
Yeah, well, I went over that.
That's the boundary.
He denied that.
And I posted. It's like because I would have pointed into the screenshots of Snell's law. I'm like, what's that?
Look, I really didn't want to go into these rabbit holes with him. I just wanted to point out that there was, like, I was laser focused on one thing. Point out that he has no justification for including refraction in any calculation of anything, ever. That there's no actual justification for it. There's no, like, oh, we have a model, and this model requires refraction to make it unfalsifiable, but other than that, there's no reason to have it.
Yeah. Well, there you go. That's the rationale.
Oh, you got him so hard, AI, dude. You got him to admit we're making our model all falsifiable. Like, that's pretty much what he admitted. That is just perfect.
It's like that day when me and Kiwi were going through, and I was teaching him how to use the Bislins, and you know the refraction slider. I thought it went up to 60 million radius, but it actually goes up to 60 billion radius.
Oh shit!
He's like, "Oh, dude, what's these extra 3 zeros here?" And I'm like, "Hold on a second." I resized my screen, because sometimes it cuts it off if you have like 20%, 70%, whatever.
Yeah.
And then I saw the rest of the numbers, the rest of the zeros. I'm like, "Damn!"
Oh my God, Earth's the size of the solar system. Actually,
well, one of our
galaxy, right?
Yeah, so one of our friends asked a question, which is, how does he explain the Canigou shot? Well, lo and behold, this is what me and Kiwi were looking at. So we went and we did the slider, right? And we did this calculation for how much we would need to get to the Canigou shot. Now, check this out. The number of that value was only like 0.003 different than the category that you can click that just pre-calculates what's called extreme refraction. So let that sink in. And Walter Bislin's calculator, when we did it, and by the way, it's recorded, so if it was changed, there's proof still there. He literally labeled extreme refraction the exact amount of refraction needed to defeat the Canigou shot, proving the point that it's just an unfalsifiable ex post hoc excuse.
Yeah, that's the same thing he did with the Black Swan. That's why I brought it up, right? So he created this piece of software, and then he manipulates the variables until the piece of software looks similar to the image, and it doesn't matter what the values say. The values can be non-physical. It doesn't matter. So in the Black Swan, unlike all the other simulations, he tilts the camera up a tenth of a degree. I don't know why. If you put it at regular degrees, it doesn't match. So he takes the camera. So he's got all, he's got the tabs of different like observations.
You mean level?
Yeah. So he tilts it up 1 degree from level, or
right. Yeah.
From level.
Makes perfect sense.
Yeah, but he doesn't do that for any other observation in his little tabs of Sound Lease Bridge, like Pontchartrain, like he's got all these little tabs, right? So This is the only one where he does this, the Black Swan. He tilts it up. And then when you look at the ray trace, the rays flip it over. That should make an inverted image. When you have ray tracing path, right, and then the rays cross over, like the top rays become the bottom rays, and then the bottom rays become the top rays, that's an inverted image. But when you look at it, it doesn't invert the image. I don't know if he did this intentionally, or it's an error in the software, or a combination of both. It's not a bug, it's a feature. You know what I'm saying?
Well, if there's a point of inversion, your lens would have to be there in order for it to be an upright image.
At least he has a little graph where it shows where has the variables, and then it shows like this crazy, like, it has a graph of like the variables for like the temperature, altitude, that, right? So that is just insanely all over the place. So if he had to fiddle around with the variables until he got something close enough, right, to what the black swan looks like, but didn't think past like, oh shit, these rays are inverted. He doesn't care about that. As long as the software comes out the way the image is, that's all he cares about. That is some bullshit, dude. Like, you couldn't get away with that in like 9th grade.
It works. It works.
It fools people like this guy. You know what I'm saying?
So it does work.
Yeah, it does work.
Dude, once you're told that there's like he said, a greater than 50% probability, right? When you apply the Snell's law or whatever, that the horizontal rays will remain horizontal, right? That would be an impetus for you to maneuver the thing like at an up angle, right? Because if you just have the rays going straight and they're not passing any variability, they're just going to stay straight, and there's going to be very minor variability. But in their worldview, they have infinite variability of path probability, so they can just pick and choose any paths they want, and then draw lines like as if they're heat-seeking missiles shooting you straight in the eyeball. And again, that just makes their claims unfalsifiable in principle.
So I'm going to take a screenshot of this shit.
But by the way, all his claims also backfire on all optical observations that the globe makes, because the scrutiny that he demanded of the flat Earth side was not applied to any of the globe Earth observations.
Yeah, like, did you measure in the middle? Remember that? We got to measure in the middle. He don't. But
Yeah,
the middle is where you're going to actually have to measure it, right? You're not going to measure it at the edges.
Yeah, all the models, all the refraction models are based on measurements that were taken at some point, not current measurements of the current conditions, anything like that. And then it's like you can stretch those boundaries, so it's just used to fill in the gaps to make things match.
Yeah. Well, the Itchel test, they did measure in the middle by hitting the panned targets. And they demonstrated the variableness of whatever alleged refraction would have been there. Well, it really just all about the bias that we already know the Earth is a globe. This observation doesn't fit geometric-wise. Therefore, the light must have curved. Oh, well, what model did you apply to know how the light curved? Well, simple. We just plotted out the geometric points and then applied a circle, and then we said this light had to follow this trajectory to get to you. Therefore, it did. It's the most ex post hoc bologna sandwich of rationale.
Doesn't the infrared observations just throw the refraction argument out the window anyway?
Yeah.
Not having a globe radius to refract does that pretty well too.
Yeah, it's just they make the claim that all the light is bending around the globe, so it appears flat. And so we can see 10 times further than the geometry in the black swan, and they just bend everything to make it match. But if that were true, then we would be able to just use infrared and be able to see that the horizon is always closer in infrared. Do we see that in real life? I don't think so. All long-distance photographs in infrared that I've seen taken close or with short duration between a visible light picture show the infrared actually seeing further. So I don't I don't see how they can get away from that.
Dude.
Well, that was.
Yeah. Hold on. I gotta show you all something. How far is the Black Swan? How far is 10 kilometers? Or 10 miles in kilometers? That's
16.
Okay, 16. Yeah, I should have known that. 1.6. Should have been able to do that in my head. I'm sad. It's just sad.
Well, that's just the next greatest whole number after the demarcation point of the rig. It could be much further than that.
Yeah, how interesting would it have been to see that Black Swan taken one with infrared and one with visible light? Like, how far would we have seen the beach of the island that's back there? I don't know. It's hard to see because it's the light is so diffused near the horizon.
Look how insane this is. This is Bislin's ray trace. These are the path of the rays. Look how just insane this is. This is what it takes, right? These extreme situations as evidence for the globe, right? That there has to be an extreme, and that's the only way that they can even approach what they're claiming is happening all the time. That's the thing, is you're claiming that this is the general condition, right? That we see too far, and we have to apply this refractive index, this standard refraction all the time. And occasionally it's a little bit worse. How come it's never a little bit better? Oh, that's when ships go over the horizon. Well, how come refraction doesn't make it look even closer still? How come the refraction doesn't make it look like an extra curvy ball?
Exactly. Or make the horizon appear like at 30% in the top of your viewpoint.
Yeah, why doesn't it make the horizon appear like a mile away when it should be 1.2 miles away or 500 feet away or right in front of your face?
How come they can't even show a picture that even matches their claim standard?
Yep.
Good question.
Dude, why does this picture you post have a big yellow block for obvious contrast, like it's flashing at me and it says custom refraction?
That's I don't know why you're there bragging about that.
I know.
So the way I figured out that this was tilted, right? These rays are tilted up. I'm like, man, look at all those rays that are all really close together up top. I mean, that's kind of weird, I'm thinking. And I'm like, he must have did something. So I start clicking through the tabs, and these rays are tilted up, right? So they tilted the camera up, so the rays that are entering, so what you're taking is, so what they're doing is, right, they're taking the image, right, and they're taking one pixel in the image, and they're moving it across the grid, right, and moving it up and down based upon, the angle of change of the refractive index, and then they're projecting it onto the image that is going to be presented on your screen, the one that quote unquote matches the observation, right? So there's just moving this pixel up or down relative to that. But apparently that must be clamped because they're not moving it into their correct actual location. But in order to do this, they had to tilt the projection plane, this is being projected on. He had to tilt it back to get the geometry, the shifting to match the so-called black swan, and it still isn't even a match. You know what I mean?
Yeah.
It's A for effort, but not quite.
It's also if you look at like your image at like 2 minutes after the hour, like if you follow those rays, why like on the globe, you'd be seeing the ground like up in the air, really high up in the air.
Yeah, it's all messed up. Like this is I just use this as an example of like post hoc, right? It's just completely post hoc. We're going to sit here and fiddle with the dials until we get it to match, right? And we're going to make, refractive indexes that are absurd and not seen in nature. Like dogs are gods was citing, right? We're going to do tests that aren't seen in nature to prove that these phenomena exist in nature. No, dude, that's not how it works. If you have to do an absurd test, then that phenomenon does not exist in nature because you're going outside the natural order to demonstrate that it can happen at all.
Yes, a roided, jacked up, serum-induced, Neanderthal can lift, 2,000 pounds. Therefore, I can lift 2,000 pounds. Therefore.
Yeah, everyone can do 2,000 pounds. 2,000 pounds is happening all the time. People are just like picking up 2,000 pounds. And here's I didn't want to point it out because I didn't want to go down this rabbit hole. Kept saying you're using a genetic fallacy. Literally, he was doing the exact same thing he was complaining about. Remember when he started talking about epistemology? Right? And he because what he said was a genetic fallacy was because I don't know how somebody did something, that means it's not true, and that he used it for epistemology. So some people had to come up with the epistemology, right? So they said that this epistemology is correct, and that we don't know about it, therefore it's not true, right? He did the exact same thing, the exact analogous thing, 5 seconds after he complained about you doing it. Or he complained about Miggy doing it, quite honestly. Yeah, it was Miggy. So, I mean, it is what it is. I just want to illustrate that, like, that was my only laser focus. I want to illustrate there's no rational basis for applying refraction just because. Right? We can say other phenomena exist, and we're not just going to willy-nilly just apply them to, like, observations. You could think about it like this, right? So we have diffraction, right? So we can model the path of light as if going through a shitload of holes, right? There's an infinite amount of holes, and we can use this diffraction model. There's an infinite amount of holes between point A and point B. And then we can just say, well, the light's just all over the place because, it's actually, that's not even a real image. That's just like a hologram of an image because you have all these little, you can model the air as like a hole because the light's going between the freaking atoms, right?
All
so that's
the little
just
balls,
like,
yeah. Exactly.
Yeah, so it's all scattering and diffracting, and so when you actually see it, it's just a hologram of the image because of wave interference. It all just comes together and coalesces in your eye, and and we have a model for this, so we're going to apply this all the time on why the Earth, ships over the horizon is bullshit because we have this diffraction model. Okay, so we have a model. It doesn't make predictions, but we're just going to apply it post hoc to every single observation. Nobody would accept that, and they should not accept it because it's bullshit. And this is what these guys want us to accept. This nonsense.
Wait a minute. Did you just say that every space between a particulate is an aperture and therefore compounds diffraction? So you have an infinite diffractive path model, which essentially would become the same thing as their infinite refractive path model.
Yeah.
So you could just pick any path you want, and as long as you can trace that path from the source to the observer, then you can validate your claim.
Yeah, I mean, we could all play the same game, right? We can say refraction makes the Earth look, the Earth look like a globe, right? Like, I mean, we could say anything. That's the whole point of unfalsifiability, is that the underlying claim can prove both propositions. Well, not prove it, right? Or you can be used as evidence for both propositions, right? We can claim
either one.
Yeah. So we can claim refraction makes the Earth is actually flat, and when it doesn't look flat, that's refraction. And and they can claim the Earth's a globe, and when it doesn't look like a globe, that's refraction. It makes it unfalsifiable. Well, how about there is no refraction, and that we're just misapplying it, like the optical phenomenon that we're seeing is not refraction. It's turbulence, or internal reflection, or any number of things. The point is, because the refractive model can't make accurate predictions, that's actually wrong, and it has to be, because they've been trying to figure it out for 150 years, and they still aren't any farther, right? And to the point, man, I wish he was on here. I should have asked them, if they have a predictive model, why are they using AI? What's the purpose of that? They have a predictive model. That's redundant. Why even use AI to do anything, right? We have a predictive model. We can just take a picture, and we know what the refractive index is. You understand what I'm saying, right?
If I was going to feed my AI, right, what I would do is I'd take a bunch of pictures that have supersedery information according to globe geometry, feed them with that presupposition that the bottoms of things are cut off because of globe geometry, and then you have the squashing effects, right? And then I would tell the AI, create me a model that traces the path of light that assumes globe geometry from these images, and then it would give me all this, spaghetti string nonsense, right? So now they just have an even better Earth curve calculator. So you say, oh, look at this image of a mountain 500 miles away. Oh, yeah, well, look at this spaghetti string.
Well, see, this is, I didn't think of it at the time. I should have did this. So you could have took this AI, right, and fed it a model of gravity, right? So little g, not big G, right? So that when the mountain is displaced down, that means there's a greater acceleration, and you could put in the equations for it, you put the mass of the mountain and the acceleration of gravity at that particular spot, and you would just say, okay, what's the acceleration of gravity if the mountain's in this location? What's the acceleration of gravity if it's displaced this much, right? And then you could feed the AI a bunch of data, and the AI would say, yes, it matches. When the mountain's here, the acceleration's this. The mountain's here, the acceleration's that, right? And you could just come up with, because you're making correlations between one model in the AI, in the image, right? So you have a model, right, the equations of gravity, and then you have the images, and the AI is making a correlation between a particular image and a particular value in the model, right? But it has to start with some reference location. And as long as it has that initial spatial reference, right, then it can measure the displacement of the pixels relative to that. And so you have a reference, okay, the image is here, the acceleration of gravity is this. Now, we're going to show you all these images. How does the acceleration of gravity change based upon the images? And you apply the vertical displacement is because acceleration increases. And the AI just figures out what's the correlation between those two. That's what I was trying to tell them. You don't understand what machine learning is doing. It's just making correlations between two pieces of data. But you have to start at some reference, right? You have to start at some reference location so it knows how to make the correlation. And you could have literally stuck in any mathematical model of any phenomenon and told it program the AI so it said, oh, if any causal mechanism for the displacement of the pixels, right, up or down in the image.
Yep.
You literally could just said anything.
I choose women's feelings about the color blue presently.
You could actually do that, which is kind of scary.
So the more women who are happy with blue, the more refraction is present.
You could have correlated to the menstrual cycle, how many times freaking someone watches clown porn on Pornhub, you could have done anything. The people don't understand, AI, they're caught up in the hype, this thing's thinking. It's not thinking. It's not doing anything. It's just making a correlation and giving a probability on how two particular data points are correlated within their data set, right? Within the data set that it was fed. Because when you start increasing the size of the data set, values change, right? Or if you decrease the size of the data set. So it reaches like different quote unquote conclusions. It's not reaching a conclusion. It's just, it's just a giant fucking lookup table.
So long story short, how this all works is you have a distance between point A and point B. You have the assumption of straight line rays, right?
Yeah.
You can't see the bottom of something, so you shift the rays down. You then assume a curved Earth horizon is blocking it. Then after that, when you see any observation in the real world that supersedes that, you then say, oh, well, maybe these straight line rays aren't straight, they're curved. And then you just draw curved lines. And you notice how all of this just occurred on a piece of paper and not actually out in the real world.
Yeah, amazing, man. It's amazing what you can make up in fiction. I mean, there's no difference between writing down a bunch of refraction equations and saying that's terrestrial refraction and that's evidence of it than me, like, writing a book of fiction about wizards and elves. There's no difference. It has no relation in the real world.
What always got me is this idea of curvilinear graduations, right? And how they would apply these apparent straight line redirections of the light, because it seems like they would just be driven off rather quickly if you assume any kind of curved boundary. So you almost have to go into this infinite boundary. Do you remember that refraction model where it was vertical gradations from the target point to the observation point? And that's how you could get it to the light to go with, I think with Snell's law, maybe.
Yeah, well, yeah, what they use, like, yeah, it's like, I'll pick graphic. I mean, there's the best really way to just show it in images. Wherever the hell it is. Yeah, so I got, refraction. So we got this. So this image, right? So each one of these, this is how you would model Snell's law, right? You'd have a bunch of layers like this. If you look in live stream voice text, you have a bunch of layers. So it's like the how many layers you want to use. Basically, you're like, how cheap is my computer? That's what you're asking, right? How long do I want the simulation to run? How cheap is my computer? And as you start adding layers, right, like, it deflects more because it has like this set value. It's not like a smooth curve, and like it'll approximate a curve, but that curve isn't going to look like the curve of the Fermat's principle. And like, I don't know what he didn't understand. Like, it's a divergent value, right? So say you compare them at like 110 kilometers distance, the divergence is going to be small. But if you have a longer and longer and longer optical path, the divergence becomes larger and larger and larger, obviously. It's not like a ratio. It's not like they stay like in this ratio. It's only 10% different forever. No, it's like the difference like increases over time. The divergence becomes greater.
Right, but
because the error accumulates, right? So the error, like if you were going to like, okay, this ray would hit at 10 feet versus 15 feet. Well, as you move down, right, because that angle is continuously changing, right, and they're not continuously changing the same, that difference compounds over time. Right, so now one ray is like shooting up at a 45-degree angle, and the other one's only going up at a 10-degree angle after some distance. Well, now when it starts like curving some more, it's going fucking straight up, and the other one's going up at 45 degrees. That's a huge difference. That difference went from 30 degrees to freaking 45 degrees. Right, so like I don't like he just didn't. I don't know if he don't understand or what the issue is. I don't think he wanted to understand quite honestly. Probably how I should have characterized it. He didn't want to know.
Yeah, well, he did call you a cunt, so...
Yeah, well, he could be right about that.
Right, but those are still horizontal gradations, not curvilinear gradations.
Yeah, yes, exactly. So what they're saying, like, you know, with calculus, like if you take an infinitesimally small straight line, it'll approximate a curve and yada, yada, yada.
For what?
For the earbuds.
You're hot. Way mixer, you're hot, dude. Your mic's hot.
Also note that, like, there's a specific angle here. They would require all these specific angles and boundaries to get things around the ball.
See, in Snell's law, you have to calculate where the light intersects, the angle that it intersects the boundary, and then it bends towards the normal. So you need to know 90 degrees from that. That's what the normal is. The normal is in mathematics is called, it's 90 degrees from a boundary, right? So that's the intersection point. So that normal in a gradient keeps shifting, right? So you have to keep calculating that over and over and over again, and then like to get the angle of incidence at the boundary, and right, like one location isn't going to be the same as some other location, which is why they just use Fermat's principle, because it's just simpler. It's simpler, more accurate. It's just like, why would you use? They just don't use it. So like saying it's this whole shit about like whether the boundary is physically real, not in the application you're using it for.
Well, look at my picture there, man. Look at that picture. You see what I'm saying?
Yeah, man.
See where I'm going with this?
Yeah.
If you got curvilinear gradients, bro, your little 180 degree summation is going to take all that light and just drive it into the ground.
Yeah, man. It just ends up a mess. That's why they don't use, like I said, it doesn't sound redundant, why they don't use it. Like, they don't even think about using it. They know it doesn't work. They know it, like, you know.
Right,
but for a long time.
And does nobody remember that vertical gradient thing where it says this is the way it would have to be, and it shows like it's black and white, and then it's got vertical columns, but they're splayed out in radials, and then it shows the path of the light going through. Yes,
all
right
that,
there.
yes, yeah, Trace, you're the man.
Yeah, like that's what you need to chart it out nicely and spicely. Otherwise, you get my picture.
This is wrong. Culver say this is wrong because the gradient is radial, right? It goes up from the center.
Right, but if you have a radial, like curvilinear gradient parallel to the alleged curved surface of the Earth, then in my opinion, you get the nonsense that I drew.
Yeah, but your nonsense supports the globe, so it's obviously correct. Actually, it doesn't support the globe. I don't know what that supports. That supports insanity, I guess.
Concave Earth, welcome.
Oh, fuck, dude. banning you right now, man.
This was an elaborate troll to get you all set to the concave side.
Gandalf has entered the chat.
Wait, what's concave Earth?
Exactly.
It's a mental illness, man.
It's a joke.
Concave Earth is very simple. So go to your house or go to a store and look at a globe, and you're seeing a ball with everything on the outside of the ball. Now just imagine all of that is exactly the same, but on the inside.
Yeah, all the math works too. Yeah, the math works perfectly. You just add a negative sign to all the values.
I was imagining like a bowl.
It is a ball, but you're inside the ball on the inner surface.
A bowl. Oh, like
a bowl? Oh, no. Well, I mean, it's two balls upside down touching each other, and you're inside each ball.
Well, like, there is a model of like that. It's what is it called? It's what the Brazilians did.
Oh,
what's the difference between hollow Earth and concave Earth?
Hollow Earth is Earth's the globe, but it's hollow on the inside, right? So there's like lizard people or whatever's in there. And then like concave Earth is where you're like, I don't know, held to the inner surface of a hollow sphere.
Yeah, it's basically concave Earth is you're on the inside of the sphere right now. Hollow Earth is like there's like a concave Earth on the inside of the sphere. Although there's also hollow Earth conceptions under like many different other conceptions. It's just
there's a bunch of hollow Earth ideas. Like they're pretty varied. Some think they're just subterranean, right? So that there's subterranean stuff. Some think there's there's a whole land, like a different, complete ecosystem. You know, so like
the concave also has different conceptions. Some of them are just like our ball wrapped on the inside, so we're just the same sphere, but just we're on the inside of that sphere. Others are just like it's a flat spot on a gigantic sphere, and there's a ton of them.
Yeah. So concave Earth versus globe Earth is globe Earth thinks your feet, someone is antipode to you, your feet are pointing at them. And in hollow or concave Earth, if you're antipode to somebody, your head is pointing at them. Your heads are pointing at each other. They're at the top of the inner sphere and you're at the bottom. And what's in the center, the thing called the stars, right? The night sky, is also a giant sphere that is too big. That it's so big that you can't see that it's a sphere, right? So it goes all the way to the horizon. And that, like, when you travel, right? So if I, quote unquote, fly, do they even have a word for it? I can't say fly around because you're not going around anything. So what happens when you go, quote unquote, around the world in a concave Earth, what do you call it? Is there a word for that? Like, is there like a mathematical term? Okay, so you can't you go around a ball, but if you're inside the ball and you go like you're on the inner surface and you like trace a path on the inside, that can't be going around.
Yeah, it's called centrifugal navigation.
Going within.
Just like skimming the crust.
We call it in round. We call it in round. You go in round or
in round.
Okay,
I don't know, man. I'm grasping at straws here, man.
So the Brazilians called theirs convex Earth.
Yes, that was it, convex Earth. Yeah.
I'll show you the picture. Since you're since you're gonna love it.
So also about the concave Earthers, they're led by someone. Did he pass away, Lord Stephen Christ?
Well, if he did, he certainly didn't rise again.
Well, I mean, he's like a paranoid schizophrenic perennial jail inhabitant that kind of like it's like cell Earth, concave Earth. So what they think is that the sky is a big giant ball that you can't see the edges of, but like when you walk around the Earth, you are basically walking around this ball thing. But the sky is projected from the Great Pyramids in Egypt. It's called the Black Sun, right? So the sky is the Black Sun, and the sun and the stars and everything are within it. So when you look at the stars, you're not looking out, you're looking in. Everything is backwards. Like I said, all the math is the same, just add a negative sign to all the values.
Yeah, but there's a big problem with negative curvature.
What's that?
I'll show you. 1 second.
Oh my God, that image is so cringe, man.
Dude.
That really is, man. That image is mad.
Dude, it's mashed potato Earth with blue gravy and a little parsley.
I know, man. There's some chives in there. Is that chives or parsley?
So a sphere with negative curvature. What is it going to look like? You guys ready? Hold on. I got to get the photo. Download. No, Now, this is actually very relevant to what we were talking about earlier, which is the catenary curve problem. Because a sphere with negative curvature forms a catenary curve. If you take the two ends and flip them around, so the inverse, the negative, and then you end up with a catenary. Here it is.
That whole debate was a train wreck, man. 100%. That's where I live, man. Ouch.
That, my friends, is a sphere with a constant negative curvature.
In 2 dimensions? How many dimensions is that?
3.
You sure there isn't a 4th dimension I can't see?
I don't know, maybe.
That's a black hole.
Yeah, that catenary curve thing, that was a train wreck, man. That was an absolute train wreck. Like okay, they pulled the string taut. Well, there's a catenary curve. Well, it was negligible. How do you know? Did they measure the string? No. Like, what?
How long was the string?
He said it was very slight, so there was curvature of the string.
Right, so he couldn't answer how long the string was, which means you don't know how much of a sample size it was of the overall structure, and he couldn't tell you how they affixed the string in free space, meaning, did they just put 2 sticks in the ground and attach the string to 2 sticks? How did they make sure those sticks were level to each other? Because the whole point was, he claimed, is that they were referencing the curve of the Earth based on calculations that they were applying to the string, and then they were using a string as a reference. That literally makes no sense, unless you can tell me all the parameters of how the string is oriented compared to the size of the overall structure and at the 2 points, the 2 ends.
Well, let me talk about how much of a useless exercise that whole thing is, what they did. Now, let's say they did everything they said. They're going to make 2 tanks. They're going to make a tank where they think there's curvature and a tank where they don't think there's curvature. And then they're going to stick a toy model boat in there and simulate the boat's action through water on the ocean. Right? And then they're going to build a boat. And then they're going to stick the boat in the water. Right? They made one with the tank designed one way and one with the tank designed the other way. Do you think there's going to be a fuck bit of difference between those boats in the ocean that you can tell? Oh my God. This one's going 13.0001 knots faster. You wouldn't be able to tell the difference. It would be so infinitesimal because when you actually model fluid dynamics, the functions are nonlinear, so they normalize them. So there's errors that are greater. There's uncertainties within the mathematics that are greater than fucking their tolerance of their measurements by probably 100 orders of magnitude or thousands.
Yeah.
So the Navier-Stokes equation, which is about fluid dynamics, is a Millennium Prize problem. And if you can figure it out, if you can prove it, then you can have $1 million. It's considered the hardest one out of all of them, other than the Riemann. I mean, the Riemann one is thought maybe provable. The Navier-Stokes equation, because of the nonlinearities, is probably not provable, whether it's valid or not. But they use it to model shit within a range, right? They just basically clamp the infinities, right? Normalize the infinities, and that's it. But what I'm saying is that they didn't need to do that. They didn't need to do that. They didn't need to do that like engineering adjustment, because for practical purposes, he kept saying it worked. It worked to do what? Yeah, they made a tank, right? And they stuck a fake boat in it. Yeah, it worked. They didn't have to account for curvature to make a tank full of water and stick a boat in it. It makes no difference, right? Because what were they designing? A yacht or something, right? A racing yacht? Okay.
Well,
I don't understand what even the purpose of this was, because it seems like just doing it to do it. We got to publish a paper. Let's do this bullshit.
Assuming a curved water level and lining stuff up to it worked. Would it not have worked if they hadn't assumed the curve that they never measured or verified? What's his point?
Yeah, that's what I'm saying, man. That's exactly what I'm saying.
Yeah,
they like when they built the boat, when the boat like sank because they didn't curve the fucking tank 0.06 of a millimeter. Like,
yeah, that step is key. Yeah, you first have to imagine that there's 0.6 millimeter of a bulge, and then everything will work.
Yeah, and then everything will work, or your ship sinks to the bottom of the ocean.
No, but you got a good point, which is, I believe he read they used a bubble level.
Yeah, it said they used a master level, whatever the hell that is.
Yeah, it's probably the brand of level that they used. Which, by the way, you can only level with the precision of your ability to hold it level, and your ability to judge the bubble between the lines.
Okay.
So they're just using local water techniques or liquid leveling techniques, and then they're just trying to make it parallel to the water surface. That's pretty much all they're doing.
Yeah, well,
what else could they do?
They think that parallel. They think that they're trying to quote unquote level it to the water surface, but in their model, level is curved. So they have to curve the rail so that the rail is one height above the water, and that it has to be, for some reason, 0.6 millimeters different in the center than at the edges, right? So it has to have a 0.6 millimeter curve over this distance, whatever the distance was.
Right.
I can actually, and that somehow if they didn't do this, it would work.
If you intentionally put a curve that's higher than the base with the water, it'd be arced in the center.
Yo, what's up, fellas?
I'm just trying to figure out why they would even do this. Like, what was the purpose? I really don't get it.
Like, if you have a 170 foot long piece of metal and you just go to the middle and jack the middle up, dude.
The tank is, so just to tell you, AI, the tank is 138 meters long and 3.5 meters deep, which corresponds to 3,000 cubic meters of fresh water. Despite appearances, the bottom of the tank is flat. And the maximum carriage speed was fixed at 12 meters per second, which is high for a facility of this size, but gives the ability to run a wide range of experiments. The dimensions were selected based upon the experience of university staff, past recommendations, and the site's physical limitations.
Yo, what are you talking about?
Yeah, we're talking about some corny-ass dude that came in here earlier saying...
Yeah.
So there's a tow tank, like it's a tank to model boats. It's like I was just describing its dimensions. And they claimed that they measured, that they had to account for curvature to make this tank because there was 0.6 millimeters of curvature higher in the center than at the edges on some rail. And the rail had to be exactly the same height above the water. So they took a string and then they measured, they pulled the string tight, and then they measured and adjusted this railing to make sure that it was curved exactly with the water. Just, it's a bunch of horse shit. Anyway, we had someone come in, we were just like laughing at it, basically, at this point.
Yeah. Well, it is
that, like, well, it is a joke because his argument was it works, right? So their design of their tank to test boats, it worked. Like, what if you didn't account for 0.6 millimeters of curvature and 153 meter rail? What would the result have been? Like, you wouldn't be able to design boats anymore, and like your boat would sink to the bottom of the ocean now because you didn't like account for curvature in your little tow tank. Like, you're being dumb. Just shut up. You're embarrassing.
You know what's weird is the last guy who came in and argued that, which by the way we have recorded, and you guys could go watch that if you want. It was much more technical, but his argument, I believe, was that the sled or whatever that pulls the boat wouldn't be able to ride correctly on the rails if they weren't perfectly, in tune with the curve of the Earth, to the degree of like what, a 0.6 millimeter or 0.06 millimeter or some nonsense. Less than a credit card thickness, supposedly.
I'm reading like what was the justification for doing this? Like I can't find anything. Like
I just can't believe that people still in 2023 people still think we live on a spinning ball. It's just crazy to me.
Dude, it's worse than that, man. The last week, man, we had 3 people coming in. I think it's a ball because of the authorities. After what just happened with that Mexican beer germ, why you're trusting the authorities is beyond me.
And they call us, conspiracy theorists and nut jobs. And no, they're the nut jobs for, they're just brainwashed. Like zombies. Like the Night of the Living Dead.
Safety, man. They think there's safety in numbers, right?
Yeah.
So you ever seen the penguins in Australia? They like all huddle together, and like birds do the same thing when they flock. They all flock together because if they flock together, there's a probability you won't be the bird that gets eaten. It'll be some other bird. Because I've seen it, right? And, like where I live, there's pigeons that fly around in flocks. But when there's a hawk around, they go mad, but they stay in the flock. And you're the bird in the flock. You're hoping I'm not the pigeon that gets like snatched by the hawk. Some other bird that's right next to me. So that's kind of like a defense mechanism that they have, right? Stay in the herd, right? And they do it with antelope, elks, bulls, you name it. Go ahead, Joyce. Sorry.
It's all good.
Say, I've been listening on YouTube all morning. I couldn't get in here, but I tell you what, it'd be more productive to shit in your hands and clap than listen to dogs all day.
Yeah,
that's how I feel. I mean, thank you.
Yeah,
that's
I like listening to India though. Man. But the thing is, they're the conspiracy theorists. They're the ones saying like, you shouldn't believe your eyes. Like you see the sun moving, it's not moving. It's trying to fool you. It's actually you that's moving. Like the Earth looks flat. It's just the light is all trying to fool you. The world is all just out there, out to get you. It's actually a globe.
I really don't understand this tow tank argument because all that rail is doing is towing a model boat. What is that boat going to, not float on top of the water? Is it, what's going to be the
I don't under... Yeah,
oh
that's what I'm trying to figure out by reading the document is why did they do this? Why did they go to all this effort? Because one way or another, it doesn't make any difference in what they're doing.
Dude, right now, brother, right now, check this out, friend. I specifically told him because I said they parallel this with the water. Did I not say that multiple times? He said the tank is empty when they do this. I told him they have a leveling trough that runs along the sidewall, and they use that to level against the rail. Okay? He said, oh no, I said, I know that we did that in the other one that we did, right? He said, well, I don't know about this one. Now keep in mind, this is something he posted as proof. So let's read from it right here. The tanks are fitted with a small trough in the concrete. This trough was filled with water. 2 steel pins were precisely machined. A datum bracket was installed at one end of the tank to adjust the length of the pins, so their pointy end just broke the surface tension of the water. Another bracket was then moved along the tank to the desired alignment location. Each pin was checked and readjusted.
Was the curve, did I get it wrong, but was it like 0.6 of a millimeter?
No, let me pay attention. Pay attention, you ready? I'll read it for you. The rails must be aligned vertically to follow the curvature of the Earth, horizontally and in roll. In Southampton, the Saginaw for an east to west oriented tank of 138 meters is about 0.06 millimeters. That's an assertion based on the model. It's not a measurement that they did. Or
oh, it gets better, AI. Read farther. Dude, this is hilarious. Listen to this, though. Sorry. The towing tank only has a walkway on its south side, so the north rail alignment had to be performed from a floating pontoon, which was complicated. Dude, I can't believe this.
I don't know. Anybody who works with steel would probably be able to tell you that, 0.06 of a millimeter was
over 153 meters, right?
Over
that's the span, right?
Meters. That's like their tolerances are higher than that.
Dude, that is a higher tolerance than CERN, probably.
Dude, look at this photograph of the pin system at the brackets. Look what they're doing there, bro. If you're looking, it's the brackets with the red thing and the 2-pin system. So the 2 brackets are at the joints of the thing, right? And so when those pins touch the water, they break the surface tension of the water. That means that the distance from that bracket down is correct. So they are just paralleling it to the water. Exactly like I said. What else could they do? How else could they have 100 and plus meter continuous level unless it was a trough of water? They also said in here that they couldn't use lasers to do it.
Yeah, I'm going to read that citation too. I'm going to find that. They cited something about them making a different tank in Australia. I want to know why they think they can't use lasers to do it. And now there could be reasons, right? Legitimate reasons, like inside. Sometimes you have differential heating inside of a building and stuff that will throw it off. Yeah. If you're trying to do a long span, I mean, you guys you do it incrementally, like you do in regular construction, right? You do, right? I don't know. I have to read it. My God, dude. This is what passed us for a Glober citation. I swear to God, that dude was just Googling furiously. The most frustrating part is that he didn't understand what, when I was predictive model, I'm talking about not Snell's law, not Fermat's principle, an actual model for terrestrial refraction as a phenomena, right? Not like the general rule of refraction, right? That model, generalized refraction model versus a model applied to a specific phenomena. That shit was going over his head, man.
They just try to talk big so that they sound important and they know what they're talking about. And then, as Miggy would say, they get their wig snatched. They like to repeat. But not
that must have been frustrating to listen to, from your point of view, right? When you're in it, it's a different thing. Dude.
I just want to get in there and tell him what a fool he is. That's all. I've had some experiences with this guy before, as well as heard a fair few debates that he's had, and I just can't stand him, to be honest.
Yeah, his debate techniques are transparent, dude. Whenever he gets cornered, he starts talking about you or talking about flat earthers or start calling you dumb, right? So he just does this all the time. Or he postures and pretends like you don't know something and he did, or you're freaking but it's a pretend, it's a freaking ruse, right? It's a diversion, right? To take eyes off the topic. Look over here. No, look over here. Look over here. Just don't how long did I talk to him? I never got an admission that there's no predictive model. I had to go through every goddamn iteration, right? Of just I call it
https://discord.gg/flatearth. Welcome to 24/7 Flat Earth Discord channel. Be sure to go to VC Check and 1 to get your VC verification tags to get involved in the conversation about our Earth. Be sure to bring your verifiable Earth curvature evidence, though.
XD Hunt. Measured. And when you go to Google, it says that there's a number right there. So clearly, someone had to have done it right. So, but yeah, I mean, that's an important thing. If you told me XD Hunt that you're 6'7", okay, great. So
I wish.
Yeah,
I
me
wish.
too. I know, me too, bro, Chad. But you would need to back that up with measurements. So that's essentially a big part of this server. Is like they're saying the Earth is a certain quote height as well, 3959 in radius, 25,000 miles circumference. So it's like, okay, well, we would back that up with measurements. So we go look for the measurements, and fortunately, no one did that. It's basically just someone claiming they're 6'7", like Lil Wayne.
Actually, I have a question, right? If the Earth is flat, as people say, right, how does the day and night cycle work?
Well, I want to just quickly, because when you say "as they say," most people don't know what that means. Most if I took 10 random strangers off the street, I said those words to you, like flat Earth.
Well, I
they'd be
don't
like,
know how to
"Oh,
word
so
things properly, but
no,
I
you're
guess what
fine.
you.
You're fine. I
Okay.
was just gonna say that most people don't know what it is, and so what they typically do is, like I used to play PlayStation 2 back in the day. You know how like some games are like Halo was an Xbox only game. You know, you
Yeah.
can't take Halo and put it in a PlayStation, expect it to work. So they're not
Mm-hmm.
compatible. So the issue is a lot of people, they take some disk and they try to load it into outer space, and they go, well, how does that work? And we're just trying to help people understand that it doesn't work. That's what most people think. If I took 10 random strangers off the street and said flat Earth, they're going to try and insert a disk into outer space and then ask questions based off of that. Oh, well, how can I go jump off the edge, and how does day and night work? Or those ideas are not compatible. So you have to at least understand what flat Earth is first. I would say it's a very important thing. Jedi, did you want to chime in?
Oh, no, sorry, buddy. I was just walking outside. I do apologise to interrupt.
No, you're good. You're good. I just saw you, a little celebrity guest popped in, so welcome.
Hey.
So when you're like, well, flat as they say, most people don't know what it is. So I think it's important to understand what it is. So I'll give you something to chew on.
So you're basically telling me to understand what flat Earth is first.
Yeah, I can help you with that a little bit. So like, most people think of the Earth as an object that's within a larger space, right? I would say that the Earth isn't an object within a large space. I would say Earth is the large space. We don't see the Earth as a floating pizza in space. You know what I'm saying? But when you go to Google or YouTube, that's what it'll show you. That's what they're trying to tell you. That's what we think. But there's not a single person in this server that thinks the Earth is like a floating pancake. So it's important to understand.
Like a big piece of mass that's like infinite. Is that what you're trying to say?
I don't know about infinite, but like your worldview would essentially be a.
I'm not trying to troll, but like you're like trying to like think along like Minecraft world gen type of stuff, like that. How it just goes on for infinite, and it's like, you know.
Would you say outer space is infinite, or do you think it's kind of like a limited thing? I don't know if there's a wrong answer, because when you go to Google and search it, you'll see both answers. There's like an article that says like we asked five experts.
What's that satellite thing that's been going for like over 40 years?
Yeah, Voyager.
Yeah, that thing. It's like 20 billion something. I don't know what it is, the measurement, but it's like 20 billion something away. So I think it's. Yeah, well, so they say, like you say, but.
So in that same like there's an article that says we asked 5 experts if outer space is infinite, and some say it is, and some say it isn't. So, and like, so if it isn't, and then we have the Voyager, then the answer is like, well, we haven't explored it all to say where the edge is or what shape it is or any of that stuff. It's not like you can leave outer space, hop out of it, and then like take selfies with outer space from the outside. There's no like outside of outer space. You know what I'm saying? So in that same way, like that's how we see the Earth. You can't pop out of the Earth, some quote outside place, and then take selfies. There's no outside view. So, but people come here all the time. They're like, well, where's the edge and what shape is the Earth? We don't know, bro. Just like they don't know where the edge of outer space is. They can't pop out of outer space and say, oh, well, all of the reality is shaped like this. You don't have that POV. You know what I'm saying? So just like the Voyager hasn't explored everything, we haven't explored the whole Earth either. Go ahead, Jedi.
All I was going to say is that's why we are called flat earthers, because flat is a description of a surface. It's not a claim to the shape of the Earth. The Earth's surface, the waters of it, for example, apart from the hills and topography, the Earth is flat. Now, we don't know how big it is, its expanse, for example, but the idea if you've only got two choices, it either goes on infinitely or it is finite and stops somewhere. So understanding that flat is a description of a surface and we're not making a claim to the shape of the Earth because we couldn't make a claim to the claim to the shape of the Earth, because like CB just said, we don't have that God's eye view, for example.
Yep, and I would say there's another two options as well that's really important. XD, I want you to just take like 30 seconds wherever you are. Just look around you at everything. Everything has a surface, right? So look at all the surfaces. I've got a cup here.
All right, right now.
Yeah. I'm inside of the library.
It's nighttime. Let me turn on the light.
Well, I mean, you can kind of think about it too, picture it. But like, I've got a computer here, my keyboard, there's a mouse, table, a cup. So what I'm saying is, I'll present to you a dichotomy. I would say there's only two options for the surface. Things can either be rounded or curved in some way, or they're not. So like my mouse, for example, it's curved, right? It's rounded. The cup, my water bottle here, is rounded.
Hold on, let me get something so I can understand better, like an object.
So then, like, you have my screen, my computer screen. The front of the screen it's flat, but the back is rounded. So I'm presenting to you that those are the only two options. There's no third option here. So I would say that that dichotomy also applies when you go out into reality. It can only be doing one or two of those things. It can't be doing both, right? My mouse isn't, flat curved. It's, the top of it's curved, all of it. So I would say that there's only two options here. So the same thing applies to the water, for example. When you go to the ocean, it's either doing the curved thing or it's not. So that's what we're saying. It's not a claim to the shape, it's a claim to the surface. We're saying the Earth, the surface is flat, just like your table. It doesn't matter if there's bumps or either as well. Like some people get confused. They're thinking we're asking about like a smooth Earth or whatever. No. If you have a floor, and I take like a lion rug or a zebra rug or a bumpy rug, and I put it down on the floor, well, that doesn't make the floor now curved. It's still a flat floor. So the same thing applies with like mountains, trees, hills and valleys. It's just like the bumpy rug. Essentially,
so you're like trying to say bedrock is flat, but then the stuff like on top of it makes it different, like elevation or something.
Sure, you can think of it like that, I think. So, but then again, like you look at, that's why we go do tests over the water, because obviously the water doesn't have those features. It doesn't have mountains and valleys. So we're essentially going to the water. Because look, bro, we look at the space selfies, right? They show you a curved water, curved oceans, curved lakes. Okay, great. Well, let's go into reality and see if the water's really doing that. Well, I don't know if you live by the ocean or a lake, or maybe one day you'll take a vacation and you can try out some tests. But that's what a lot of people here do, is we try to go out to the field, into the reality, and test to see whether the Earth is doing one of those two things. So I spent a month in San Diego, California, at the beach, doing long distance observations, looking for this quote curved water. And newsflash, it's not there. We're saying that it's flat. So I would encourage at some point, you don't have to like leave this Discord call and say, oh, well, these guys said it, so it must be true. Maybe one day you can go to a lake trip or a beach trip. You can do your own little tests and find out for yourself what the Earth
sure.
is really doing. So
when I went to a beach, I mean, when you look out into the horizon, it does look flat, but
yeah,
what I've been told in school and everything just explains it.
Right. Yeah, I mean, obviously, you're not just like flapping your eyelids. If this, for example, like if you and I both go to the beach, you're still a global believer. We both see the same thing. So it's like you're saying no, it's a globe. I'm saying it's flat. So we don't just look. That's why you have to do the tests. The tests are the important part. Because obviously we all observe the same Earth. We just have different conclusions essentially. So yeah, you want to set up a test. And there's ways to do that. People have done laser tests. So think of like for example, think of like a hood of a car. I don't know if you drive, but I'm sure you can understand that most hoods or bonnet, if you're a Jedi, they generally are curved. I would say, unless you drive like an old Cadillac or something. I think most hoods are curved. So let's take that hood and let's blow it up to the size of a state or a country. Let's make it huge. And we ask you, okay, go test for the curvature. You don't have to. Well, let me start with this. Essentially, to do that, you would need some type of straight edge. So maybe you could take a laser and shine that straight above the hood. If there's any deviation, if the hood starts dipping down away from that straight edge, you know right away, okay, well, it cannot be flat, period. And you don't even have to, go across the whole thing. If there's any curvature, then it's curved, period. Can't be doing both. So that's essentially what we're doing. We're using, people do laser tests. We have an observation or an argument called the black swan. We could go over with you if you'd like to, but yeah, look at what
What's the black swan?
Oh, yeah, the black swan.
Yeah, what's that?
It's a really good argument. It's one of the when I first joined the server, they're like, "All right, what do you have for us?" I was like, "Well, I know the black swan. I think it's a really good argument, so we can go over that with you. Let me start, guys. Don't post anything just yet on that. I want to start first with the first screenshot, and then these guys will have some more stuff for you. But let me post something in the chat, and I have a question for you based off of that. So, let me get this one. Okay. I just want you to know, where do you see the horizon in this image?
Like, if I can see it, like where the shade of yellow changes, I guess.
Yeah, would you say it's in between, in front of, or behind those oil rigs?
In the middle of them, both.
Oh, okay. Well, let me give you another image here, just to help out a little bit. How about this one? This one has like a multiple choice. So would you say it's at A, B, or C, or D?
Oh, let me look at the image. So I'm looking for the horizon, right?
Mm-hmm.
A.
There you go. There you go. Exactly. All right. Well, now let's go to the argument. So this is an observation just off the coast of California, I believe in Santa Monica. I can give you a screenshot here if I pull up Google Maps, but let me just not get distracted. Let me get the argument first. Here. All right. So remember earlier I said Santa Barbara. Apologies. So remember earlier I asked you, like, we talked about like the size of, if you claimed you were 6'7", all right, well, that so essentially I mentioned that the Earth had a certain size as well. So they're claiming it has a radius of 3,959 miles. That's how the argument starts off. So if the Earth is a sphere with a radius of 3,959 miles, as they claim, then every horizon distance measurement must be no more than 1.22 miles, or 1.225 times the square root of the observer's height in feet. Now let's go over that. I know that sounds a little complicated. So this is based off of an Earth curve calculator that I will post here. Get a screenshot for you. And I'll get a screenshot and a link. There's a screenshot. Let me get the link here. You can play around with this a little bit if you want to, but essentially, I want you to look at.
Does it work on phone?
Sorry. Yeah, it
Does
should.
it work on phone?
It should. But if
Is
you
it
look
that
at this,
link there?
yeah, at the bottom, the DisIb GitHub. But if you look at the D1, you'll see D1 horizon distance 1.224560 miles. Essentially, what they're saying is, if you're 1 foot off the surface of the Earth, the distance to the curve, essentially the horizon, should be at 1.22 miles. Just like if you were 6 foot tall, then there has to be 72 inches there. It's a requirement based off of the size. So it's kind of the same thing. It's just a breakdown of the claimed size of the Earth. So they're saying, 1.22 miles is the distance to the horizon at 1 foot off the ground. So we go back to the observation. This image was taken. There's the video there if you want to. So he's got his camera about 1 foot off the surface, so those oil rigs, they're obviously not like floating on the water. They're drilled into the ground, so they're not moving anything. So let me actually go to Google Maps and I'll get you a screenshot. You can kind of see how they look off the coast here. But we know the distance. We know their distance from the shore. The first one's at like 6.1.
Wait, have those oil rigs been like confirmed to be ones that are being drilled into the ground, or?
Yeah.
Yes. It's quite established. They're very when they built those rigs, they were cemented to the sea floor. So yes, they're quite. You can know exactly where they are from the distance in Santa Barbara. You can actually know where they are from the seashore. Yes.
So yep. So the reason why we use them, it's important because obviously if you just go to the ocean and you're just blindly looking out at the water, you don't really have a way to gauge how far you're looking. So that's what the rigs are only there to tell you how far you're looking. So the first one's at 6.21 miles. The second one's at 9.41 miles. And I did say I was going to get you a screenshot from Google Maps. So let me just take this really quickly.
Wait, the second one's 9 miles. That doesn't look that far away.
Yep. The screenshot has some of the numbers on there, but if you want to play around on Google Earth or Google Maps or something, you can definitely do that too. Take this screenshot really quickly.
It's really not going to change anything about the argument, though, because it's not right. Exactly. So it's just, these oil platforms are that distance, and they're dormant now. They're not even extracting oil anymore. They're just still out there, but they're not even being used. Nobody's working there. Nobody's standing on those platforms utilizing them. They're and at the same time, they're just a node of demarcation from the shore at Santa Barbara, from one to the other. And when you put the camera at 1 foot observer height, you see the horizon behind them. So simple.
Yep.
Why are people making this more than it should be? Because they want the Earth to be a globe so bad.
Yep.
I don't know why they want the Earth to be a globe when it's obviously not, but that's their fault.
It's not in contention at the moment. CB's just running through the observation, mate.
Yep. Sorry, I was trying to go to. I have Google Earth Pro on this computer, so I was trying to get some fancy extra screenshots. But yeah, essentially, as long as you can agree, those are the distances. So clearly, the horizon's past that 1.2 mile mark.
I'm a bit lost right now.
Yeah, we can bring it back full circle. No worries. So
sure, yeah.
So they're saying that the horizon, the Earth curve, is supposed to be at 1.22 miles. If you look at that screenshot I posted on, I can post it here.
What, the one with the circles, like the red ones?
This one here. Take a look at D1 horizon distance. You
Oh,
see that?
there's loads of screenshots being posted right now.
I know. Sorry about that. 3 minutes past the hour from creation bear is the Earth curve
okay.
calculator.
Yeah, the website one. Okay.
Yeah. So you've got that D1 horizon distance, right? So you've got your 1.22 there. So they're saying that that's where the horizon is required to be at 1.22 miles, right? So let's go back to the observation. Get another for you. And again, you could tell, obviously, the horizon is behind that second oil rig at 9.41 miles. So essentially, what we're doing is debunking the idea that there is a geometric or a physical curve of the Earth. We're saying that the water essentially is flat, bro. There is no curve.
Sure.
Essentially, is the argument.
Right, and the idea, if the Earth is the size that they say it is, right? 3,959 miles in, with radius, and the circumference 27,501 or 29,501 or whatever. So there should be a drop value. So when you're looking across so are you looking up over? Something should be blocking these oil rigs, but now you see the horizon behind it.
I've got another screenshot for you that might be helpful to wrap up this point. Let me drop it in the screenshot. So what we're seeing in reality is that green line. If you take a look at that screenshot, right? I drew a circle. We're seeing that green line there behind that H1. Do you see the red arrow with H1? Is this target with the red arrow?
Wait. So if I'm understanding correctly, the image you just posted about the green circle is what is claimed is happening.
Correct.
But the above image of the oil rigs is reality.
Yes. And so in with the green circle, right? How is it that you're seeing that green line if there's supposed to be essentially a hump or a hill or whatever, a curve in the way? How are you seeing this green line? Well, we're saying there is no hump, essentially. That's kind of our argument. But if you want to hear...
and I would say what you actually see is what you actually see. So when you see something, you can believe it. You can believe your own eyes right in front of your face. When you...
Thank you. Sorry about that, Helio. We'll get back to him in just a second. I just want to give him a quick... this is what our opponents essentially are saying, XD. This is me talking to a guy who dubs himself Bob the Science Guy. This is what he had to say about the argument.
There's also horizon way beyond where it's supposed to be, so there's that too.
Yeah, what's blocking the bottom of the oil rig there?
Not a hill of water. So
yeah, actually, that's exactly what it is.
Okay,
and if you look at how much is actually hidden.
Okay, buddy.
Right. So he's essentially saying that, like with the green circle, that screenshot from the website, he's saying that there is a hill of water there.
That's not possible.
I would agree. So,
well, what the hell? Why is that Mario shit playing?
Sorry, that was me, bro. But
have you? Sorry, XD. Sorry, CB. Have you ever heard the claim or the argument? I can't see the bottom of that boat because the curvature of the Earth was in the way. We've had it for the Greeks from a few thousand years. They can't see the bottom of the boat because the curve of the Earth is in the way. Have you ever heard that before?
Don't think I have.
Okay, well, this is primarily the claim that we're dealing with. With distance over the surface of the Earth, if the surface of the Earth was curved, we wouldn't be able to see beyond that curvature. So boats that sailed off into the distance would disappear from the bottom up, and eventually the curve of the Earth would get in the way. What CB has demonstrated to you is if the horizon was physical and was to get in the way from an observer height of 1 foot, the physical geometric horizon should be at 1.2 miles away. CB's demonstrated to you that the horizon is beyond that limitation of the geometric post
You're lagging.
Horizon is not physical.
You're lagging, bud.
Sorry, CB.
Hello? Am I
Yeah,
lagging or
was
is he lagging?
lagging for me too. Jedi, we heard the first half of that, but the second half definitely was chopping up a little bit. You want to just do a quick radio check with us?
Can you hear me any better now?
That came through.
Awesome stuff. So all I'm pointing out is that the horizon is beyond those two oil rigs and beyond the physical limitation of a curved surface at 1.2 miles away. We're showing you that the curvature of the Earth isn't there and isn't able to obstruct things in the distance. Sorry for my robot and my lagging, mate. I do apologise.
No worries. I'm glad it worked out the second time. No worries at all. So that's, and I'll say, XD, I know it sounds really complicated, but when I
It
first
is very complicated.
I mean, honestly, at the end of the day, you'll come to realize it isn't that complicated at the end of the day. It's just like if you said that you're 6 foot, when we meet up, well, there has to be 72 inches there, or that claim is cap. What we're saying is, they're saying the Earth is a certain height as well. So it has to have certain. It's required to have a certain, the horizon is supposed to be at a certain distance. So what we're saying is that claim is cap. You can go and test that claim just like you can go and test how tall you are. So it's just not that complicated. I know there's a lot of numbers and it sounds a little crazy, but when I first joined the whole conversation, like 2017, this is what this was what the argument was. The horizon. What is the horizon? Is it a physical curve, a hill? Is it the thing that boats go over? Or is it not that? We're just saying it's not that. But if you go to, any website or whatever, I'll post a screenshot again. They're telling you that the surface between you and the ship is not flat. They're saying the water bulges up, just like the guy.
All right, somebody muted me, and that's okay.
Hold on. This wasn't quite finished. But what they're essentially is just like that clip I played. They're saying there's a hill of water. Go ahead, Helio.
The horizon is or isn't the curvature of the
Get your
Earth.
mouth away from the microphone.
Bottom line, horizon is or is not the curvature of the Earth. Yes or no?
Shut up, bitch!
Helio, everything is alright. CB will take over. Everything is cool. Even I've spoken. Everything is cool.
All right, well, fuck it. I'll shut up. I can take a hint.
No, you won't. No, you won't. Shut up. No, you won't.
It's like 6 o'clock.
No, you won't.
You already drunk. You making it awkward, bro.
Y'all a bunch of bitches anyway, so whatever. Fuck.
It doesn't matter what you think!
Does anybody remember what the last thing CB asked this guy was? I don't.
I'm lost.
Yep. I think we all are.
I haven't understood one thing about this whole conversation yet. So for the interruptions.
Do you understand the words that are coming out of my mouth?
I feel really stupid.
Don't worry about that. This last minute.
Stupid.
If you were listening, CB about geometry and drop over distance, you can get it. I think over the sea, because there should to be drop. That's simple way to say if you get that. But that what Helio. Don't worry about that.
Alright.
Oh, well, bro, if it's too complicated, just know there's no hills of water, all right? You remember that?
Yeah, I know there's no hills of water because of like the level stuff.
Yeah, well, welcome to the dark side.
I still don't believe in the flat Earth. I'm sorry.
Well, there's nothing to believe in. Just like you don't believe in your height, you just go measure how tall you are, and then you know.
You know what I mean? I think.
Hold on. Sorry. If there's no curvature to the surface of the Earth, then how can the Earth be a ball?
I don't know. I can't really explain it myself because I'm not like bloody Harvard person, whatever the fuck it is.
You don't have to be a Harvard person
Well,
or
yeah, I know.
professor or somebody.
I'm just using an example.
Yeah, yeah.
I'm not like someone that researches into it. I'm just somebody that thinks whatever I've been taught, from a young age. So, yeah.
I understand that. I mean, that's primarily how we all first started off, right? We all thought and got taught that the Earth was a ball. That if the Earth was a ball, then that would mean the surface of the Earth was curving. We're observing that the waters of the Earth are level and do not curve, and there is no physical geometric obstruction called the horizon to stop us from seeing at distance. So if the surface isn't curved, the Earth cannot be a ball.
Sorry, I was talking to someone on chat. I'm getting told off for burping on accident when I can't mute my microphone.
It's alright, brother. Just remember we're live on air, so we try to treat it like a little bit like a radio show. So just keep that in mind.
Wait, we're live?
Yeah, baby, we're live, son.
Live on what?
So, but look, dude, I posted that screenshot. This is Google Earth, right? You see that big hump of water right there?
That's what? Yeah, I see that.
Okay.
I see
Well,
it.
when we say there's no hills of water, we're saying it's not doing that. So if you're saying, yeah, that there is no hills, then you're kind of agreeing with.
Yeah, but that's not a real image, is it?
What?
That's not a real image. If that's what you're on about.
No, but either way, that's what people are saying the water is doing. And so you can either agree with us or you can go back to your hills of water. Don't take your pick, bro. At the end of the day, it's not super complicated. It's either doing that or not. Oh, simple.
And maybe it's only hard to swallow because you heard this information for the first time.
Kind of hard to follow right now because it's 1 o'clock in the morning.
Yeah, I understand because it could be, it's not like somebody stole something from supermarket,
Huh?
It's not like the news that it was some robbery in supermarket. It's a story about reality. There is no curvature in reality, and it's not easy to to concede that because there is a belief that there is a sphere. But you can look into that. You can ask more questions if you're.
Yeah, I mean, bro, we people are already in this like autopilot, auto believe mode. We're trying to get people out of that. So you don't want to just leave this call and be like, oh, okay, well, what they said is true. You eventually want to go and test to see if what we're saying is true. Just like you should go test to see what they're saying about the earth and the water is true. So it doesn't have to be tonight. You don't have to like leave tonight, rush to the lake. But maybe one day, I'm sure one day you'll have a trip to the beach or whatever. There's your chance. You can say you actually went to the field and did something, regardless of what you quote believe in. You don't have to believe in anything. But yeah, that's what the goal is, man. Go into the field. Go do some tests. Go find out for yourself. You don't have to just believe us. Don't believe
You don't
anyone.
have to buy stuff like measuring equipment and stuff.
I got a starter pack for you. Here, check the chat. Starter pack requires one $20 large door mirror, one friend, 2 camera phones, body of water. I'm sure you can make it happen. For
And
me,
what
I
do I have
live.
to do with that?
Okay, I got you. So for me, the closest lake, I live in Ohio, so there's not too many big bodies of water nearby. But I go on Google Maps. There's like a 5 mile lake. It's like 5 miles wide at least. Um, it's like maybe 2 hours north from here. So essentially, you could have, say, a friend on one side, you're on the other side. They're saying that if you're 1 foot off the ground, there should be a hump in the middle at 1.22 miles. So if the lake is 5 miles wide and your friend is on the other side, and don't pay too much attention to the chat, but make sure you they are trying to keep the show running. But anyway, so if your friend is on the other side, maybe he's got a mirror, he's flashing some, maybe the sun is hitting the mirror, you're seeing a flash, right, from the other side. Well, there's your test right there. If there's a big hump in the middle, number one, you probably shouldn't even be seeing your friend to begin with. But if you're seeing this light flashing across the water, well, that's how you would essentially test to see if there's a big hump in the middle of it.
Yeah, I don't think I can do that anywhere near me. I don't think there's any big enough lakes for that.
Yeah, I mean, I'm kind of in the same situation. So I didn't actually go to the lake. I spent some time in California, so I went to the beach. And then there's things in the water just like those rigs, right? There's things. There's
Would a
boats
reservoir count?
A reservoir. What do you mean by that?
Like a big body of water. Like, I don't know what reservoirs are. But...
Okay, I see what you're saying. Yeah, as long as it's big enough, right? If they're saying that, again, if they're saying at 1 foot off the ground, the distance is 1.22 miles, then actually, let me get a quick clip for you. Because most, I think average person is around maybe 5-6 feet.
Hold on.
Right? So they're saying
let me just search up how big the reservoir is that's near me. I'll see if it's big enough.
While you're searching that up, I'm just gonna put a 90-second clip on in the background. We'll take a listen.
Hi, I'm Josh Clark, and this is Brain Stuff, and I'm here to answer a very pressing question. Have you ever been standing at the edge of water, say like an ocean, and looked out on the horizon and said, I wonder exactly how far away that horizon is? Where the sky meets the sea, that's the horizon. Well, it turns out because the Earth is curved that it depends on where you're standing and how far above water you're standing. Let's say that you are in the water, right? And you're up to, say, your eyes are about 8 inches above the water surface. Well, again, remember the Earth is curved, and despite the ocean seeming flat, they actually curve themselves, which if you've ever really looked at the horizon, it kind of goes like this a little bit, which is pretty cool. But it also goes like this, right? So if your eyes are 8 inches above the water, right then you're about a mile away from that horizon point where the sky meets the ocean as far as you can tell. If you're standing up above water and you're like I am about 6 feet tall, that means your eyes are about 5.5 feet above the water's edge, which means that you're about 3 miles away from the horizon. Isn't that amazing? Going from 8 inches above water, 5.5 feet above water, is the distance between 2 miles between you and the horizon. Mind-blowing, if you ask me. If you like this video, there's plenty.
Right, so you asked how big does the reservoir need to be? Well, it's going to need to at least be bigger than what he just told you. If you're 6 foot tall, the curve is supposed to be at 3 miles. If you're 1 foot off the surface, like the Black Swan, then the distance would be at 1.2 miles. So as long as the lake is 5
I don't think
miles.
I'll be able to do it on mine.
Yeah, how big was the reservoir?
It's in acres, so
Acres. Go on Google Maps.
260 acres.
You can go on Google Maps. It'll give you like a.
I'm on my phone, so I can't really go on Google Maps and.
Well, we don't need to dox you or anything. It's fine. But yeah, essentially that's.
I don't mind telling you what the reservoir is. It's
I can look it up. I can look it up on
Cheddar.
Google.
Cheddar. Let me type it. Cheddar. Reservoir. Cheddar. What that? Cheddar.
Let's see. Oh, in England.
Yeah.
Okay, cool. Let me pull this up on Google Maps here. Oh, okay. Damn, that's nice. Yeah, it's not big enough, bro. It's like 1,000 feet, 2,000.
Oh.
Less than a mile big. So yeah, you're gonna need some water that's a little bit bigger than that. Yeah. Well,
Don't
we
know
have.
of any places that's big enough
What is
near
that?
me.
What is that? The Bristol Channel. That's perfect.
The Bristol Channel. I don't want to be. Isn't it like in like? That's like in a populated area. I don't want to be like seen holding a mirror.
Well, you don't have to do that. You can do like, for example, you can go to, I don't know if there's like a beach or a shore. You can maybe try to look across it, or you
I'm
don't have to
pretty
do
sure that the shores on like that stuff is like quicksand or something, or like
Oh,
mud
really?
stuff.
Oh,
Yeah,
damn, that sucks.
it's pretty
Okay.
disgusting.
Oh, wow, I didn't know that. Well, look, there's some stuff in the middle. There's a hospital in the middle of the channel there. So you can do things like that. Maybe if there's a ships in the water, you can kind of track them. You have there's apps on your phone that can see how far away they are and that kind of thing. But yeah, that the distance between those two shores are like 5 miles. It's perfect. 5-10 miles. So yeah, you could do that there. But
Wait,
yeah,
what is the area again? Bristol Channel, you say?
well, I mean, this is near that reservoir at least. There's a big ass body of water. Let me take a screenshot for you.
Pretty far away, I think.
Oh, is it? Okay. Well, like I said, dude, this doesn't have to be something you go rush off and do tonight. But I mean, most people get a chance. Hopefully, most people get an opportunity to go on a little vacation somewhere. And so, I mean, when I was in California, I was like, all right, well, perfect. I'll do it there. I combined my tests with my vacation, so you can definitely try that. But here's a screenshot that body of water right there, the Bristol Channel. I don't know. You can kind of use that body of water there to do some tests if you'd like. But
Yeah,
that's
that's
what we do,
like
man.
super duper far away.
Really? Oh, okay, gotcha.
Yeah, and I
No
don't
worries.
think I'll be like going anywhere like that anytime soon. Or
Oh,
just a
like I said,
test.
no rush, no rush. It's I did my test in 2021, and the first time I ever even heard the words flat Earth was in like 2017. So you got time. Go ahead, Sasha.
I was there. I was there 3 days ago.
Oh, really? Nice.
Not in Bristol, but in Swansea, and it's near.
Okay, nice.
I
I see
posted
it.
the picture.
Oh, wow. Okay, cool.
I
That's
have more.
beautiful.
Yeah, I have beautiful beaches. Yeah.
That's what we do, bro. That's what we do. But if you go to Google, right, YouTube, they're gonna tell you that Bro, I was watching Tim Pool recently, and they like brought up flat Earth and like, oh yeah, the flat earthers think that there's guards guarding the ice wall and all. It's like, bro, no one thinks that. Like, that's the media will try to make it seem like we're like super goofy, but all we're talking
So
about is
what?
the surface of the water.
I have a question. You know, like the Antarctica. What do you think about it?
I mean, dude, have you been there? I don't know. I don't think it's an
No.
island, like it's depicted as some sort of island or whatever. I don't think it's that. I'll take a screenshot just for people that don't know what I'm talking about. But yeah, yeah, I don't think it's an island, bro. I would say that. But yeah, there's just like memes like, oh, they think there's guards. Like, no, dude, no one. We don't think that, bro. Like the media will try to make it seem like we say all these goofy things that we don't say. They're not actually giving you the sauce that we really think. No one's trying to teach. No one's trying to teach you about the horizon like we are. You know what I'm saying? Like they want to make it seem like this is a stupid thing, but all we're doing is going outside, testing the earth, bro. It's that simple. And like, I didn't make the earth. This topic isn't like answers to the universe. There's a lot of things we don't know. Even like people on the globe side will admit that we don't know all about the oceans. We don't know about the rainforests. So it's like we don't have answers to everything in the universe. We're just talking about the surface of the earth. But people try to complicate it, make it about, oh well, like, oh well, what's in the Antarctica? I don't know, bro. I never been here. Like, I'm not Lewis and Clark. Like, bro, like 3 years ago, people could barely travel to the grocery store to buy toilet paper, and now they're talking about, oh, well, let's explore the whole world. Why don't you pump the brakes? All right, go to the beach first, that type of thing. That's what I would say. So just start there. You don't have to start in locations that you've never even been to. But I don't know what to think about Antarctica. Anybody else want to chime in, guys? Y'all letting me cook today, huh? I'm gonna have to go here in like 15 minutes or so. So, guys, get in while it's hot. Y'all shy today, huh? Yeah, that's one of the big arguments, bro. Surface of the Earth. I asked you if you thought buildings move earlier. That's another thing we talk about. You know, we're saying this place doesn't move, period. So that's another big one. And I think the third thing that's kind of important is, like, I remember I told you that, you know, you can't put Halo in a PlayStation. So
Yeah.
You can't put a flat Earth in outer space. So we don't, you know, it's a tough pill to swallow, but we're saying that there is no outer space.
Huh? Space is the platform for the globe. We don't have a globe, so we're not talking about space.
Yeah, the Earth doesn't belong in outer space, so it's a really cool setting for like books and movies and anime, video games, but the Earth isn't in that. Okay, so
What is above us then?
well, remember I said that, you know, you can't pop out. Okay, so if you believe in outer space, right, you can't pop out of it. Like you can't leave the Earth, go
Yeah,
to
yeah.
space,
You
and
can't
then like
leave
pop
outer
out.
space. Yeah.
So we're saying you can't leave Earth, pop out. There's no outside to pop out to. Just like there's no outside of outer space to pop out to. But we're saying that this is it, bro. It's not an object in a large space. It is the large space. So you can't leave and take selfies from some outside area. There is no outside. So, no, we don't know what shape this whole place is. How would you know that? You'd have to like, you can't look at the Earth like you can look at a puppet on your hand. You don't have that perspective. The only perspective you have is the current POV that you have right now. You can go up in the sky, you can zoom in, but you can't go out, and you can't zoom out your eyeballs and see the whole Earth. So, yeah, so yeah, we don't think the Earth is in outer space essentially as well. So if you see like images on Google that's like, look at these flat earthers and their pancake, you can already know they're capping and lying to you. None of us think that. There's not a single person in this panel that thinks that there's a floating disk in space or whatever. It's a straw man, and it's sloppy, and it's there to kind of get people to make you think the idea is stupid, which it is a stupid idea. No one thinks that. So I'm just gonna search flat Earth right now on Google and see what comes up. Images. Yep. Let me screenshot this, dude. That's what I'm talking about. So you have to be careful. They're not gonna give you the real sauce. They're not gonna hook you up and tell you what we're really saying. They're gonna do this. There's a screenshot in the chat. They're gonna cap and tell you, oh look, there's water falling off. They're on a disc floating in space. Whatever, like magic pizza, ice cream cone, frisbee. It's all cap.
Stop the cap. And then when you see that on the Google, because you will, like everyone, you will look that, then you will come here, and your first question will be, what do you think about Edge? What do you think about these things? You know, what we didn't put it on they put that. You know, they will never speak you about geometry or something of horizons that we are telling you. They will never speak you about who proved the rotation. And third thing we even didn't touch, because if somebody touch you about gas pressure, I don't know how your night will finish, but okay.
Yeah, it's a tough argument, bro. The gas pressure is a tricky one. I mean, I got like 10 minutes left. We can hit you with the last little question here. Can you have? I'll give you some examples. I'll ask the question. I'll give you an example. So, can you have gas pressure without a container. Well, now I'll give you some examples of gas pressure with a container. Say if you have a bicycle, right? You've got the tire, and then you've got the gas pressure on the inside. Even like a can of soda or a bottle of soda, right? You've got the container, and then you've got the gas pressure on the inside. And so, you know, if you open, say you open, yeah, look at the chat there. If you open the soda, and maybe you pour that in a coffee cup, you leave it on the counter for a week, essentially the gas pressure is going to dissipate. You need the container to have the pressure. So we're asking, well, if you look at the space selfies that Miguel posted there, there's no container there. So we're asking, how do you have the gas pressure that you're breathing right now, the air? How do we have that if there's no container to contain it? Because every example that I can think of, car tire, bicycle tire, soda can, you need the container to have the pressure. So that's what we ask people is, how do you have gas pressure without a container?
Oh, I don't know.
Well, I mean, we essentially have two options. We could send you on a goose chase to look for a demonstration, or we could just rip the Band-Aid off and tell you how it is. I think some people don't want to hear it, but we just point blank, there is no demonstration. I would say that's a violation of natural law. High pressure moves to low pressure. You open high pressure, low pressure. You need a container. So we're saying that's another reason why there's no outer space, is because we're contained. The Earth is contained. It's a weird, tough pill to swallow, but essentially outside is inside. So you might have to pinch yourself next time you go out there. But yeah, we're essentially living in a container. There's no outer space. But again, it's tough to hear that, and a lot of people. It sounds.
So we're living in a container.
Yeah, I mean, yeah. Unless you can provide.
You know, like telescopes, right? You know,
what else could it be?
What?
Yeah,
Who?
Well,
so if we're in a container, how come? Well, is it see-through or what?
No, hold on.
He told you. It's a natural law.
Yeah. See the
thing. Do you know what is natural law?
I have no idea what's going on right now.
It's more about the antecedent to what is, right? So if you have the steak on your plate, you're not asking. You're not. Hello.
I understand you. Your microphone is really loud. Let me turn it down.
My microphone is loud. You know, there's a feature in this Discord that you can lower the volume yourself.
There's like 20 million people in this chat. Hard to find them. What the fuck?
Yeah. What was
so the antecedent to the gas pressure is containment. To have the gas pressure, a container is required, and that's how it works. It's not bots or imaginary why nots.
I have a joke about telescopes because I say that telescopes don't whisper in your ear. What I notice a lot of people do is they see what they see in the telescope, and then they add a bunch of details that the telescope doesn't provide. Oh, I saw millions and billions of miles with my telescope. Well, no, hold on. You saw things in the telescope, but they didn't tell you that was millions and trillions and billions of miles away. You added that. So, like Gemsy pointed out, I think this is a great example. It's called an antecedent relationship. If I plop down a nice juicy fillet on your steak, no fake stuff, no tofu, this is actual steak. I don't have to show you a cow. You know it came from a cow. I don't have to tell you what it looks like. I don't have to tell you how many spots it had, what name, what color. It's from a cow, period. So the same thing we're saying with the gas pressure. You cannot have gas pressure unless you have a containment. I don't need to show you,
the color of the cow, if it's a Chinese cow or a Japanese cow or American cow. You know, there's a cow because there's a steak on your plate.
Steaks are always from cows. Air pressure is always due to containment.
Yep. So I know when you look up, you see dark and stars, and you were told, a nice little bedtime story that's outer space. Well, take that away, doesn't it's just
The Glober, some of the Glovers argue, oh, there's a steak on the plate, but I'm not gonna eat it until you show me the cow that I came from. That's the Glober.
Stupid. Yeah.
This argument always comes down to gravity, though, right? Can we just address that? Because I know XD is probably not going to talk about that.
Gravity doesn't contain air. That's just a claim.
That's the claim. That's the claim, of course, of Globers. They'll claim it's gravity, but
Just like steaks don't hatch from eggs, and gravity doesn't contain air.
That's a good one, Central. Steaks don't hatch from eggs. I want to remember that. That's a good one. Nice.
I'll be here all week.
I have a recording from Richard Feynman about the second law, and I have a little GIF here of the second law in effect. So we can see when we test this in real life that there's nothing stopping the gas from going up. And so I'll play Feynman.
Well, there are the three laws of thermodynamics, very simply expressed. Now let us look at some examples of spontaneous changes and see how they are accounted for in terms of the second law of thermodynamics. We'll take the simplest first and look at changes where only the entropy changes. Now, one, perhaps the simplest of all, of these, is the expansion of a gas into a vacuum. I have in one of these bulbs some bromine, and in the other I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy. So without the entropy concept, that would have been difficult to understand and difficult to account for. True.
Yep. I mean, it sounds complicated, but he's saying you gotta have the container. If you don't have the container, you're gonna have the pressure move from a higher pressure area to a lower pressure area.
How old is that video?
What is that, Drace? 19 something?
Why haven't they made a new one modern?
It's one of the natural laws. It's just called entropy. So this one's pretty set in stone, I would say. It's just a really good example. But I mean, you can see this with a can of soda, for example, right? If you take a can of soda,
proven.
Leave it on the counter for a week, it's gonna go flat.
Yeah, it's going to go flat. Yeah.
So it's basically saying that you have to have that container to have
It
the
won't
pressure.
taste nice.
no container, no pressure. So we're saying that since we have all this air pressure on Earth, we're breathing. Well, it's contained. And like our ops will say, well, gravity does it, but gravity doesn't do that. Gravity doesn't.
What do you mean by ops?
Our enemies.
Okay.
I'm just joking, but the Team Globe essentially saying that, oh no, gravity holds the air in, but no, it doesn't actually. Gravity, like if you let go of a balloon, where does which direction does it go? Up. Not gravity's supposed to do what? Pull things down. So no, gravity doesn't hold air down. That's silly. You don't even observe that. So yeah, that's the third argument that we offer. The first one we talked about was your moving house, whatever, moving buildings. We don't think the earth moves. Right? The second was the water. We don't think that water forms in the hills. And the third is we don't think that earth is in outer space. So that's the trifecta for you.
Very cool.
Don't let the people on YouTube make you think we're talking about freaking guards at the ice wall and crazy stuff like that. That's all gap, bro. So That's what we get down about: gas pressure, rotation, or movement, and then the surface of the Earth. It's really that simple. So, and yeah, again, you're more than welcome to come by anytime. I might have to leave here in a few minutes, so I see some other legends in the panel. Guys, don't be shy. If you have questions,
I came here originally to listen, but
hey, I know. Hey,
got dragged in.
This is like Dancing with the Stars, bro. We'll teach you how to do the.
I even got warned about it, but I didn't listen really. I got dragged right in.
So, we'll show you how to rock back and forth, man. We've done this rodeo a lot, so we can show you how it's done. But yeah,
I think other people appreciate you being here. Honestly,
I agree. You've been a good sport, XD. So we appreciate you. A lot of people come in and have their emotions. They get triggered. No. It's like, well, it's gonna be okay. Like, you can disagree and still understand our point. It's like a game of catch. We're just gonna throw a point out to you and see if you can catch it, and then maybe you can return it and throw it back. So that's really all it is. So you've done a great job, man. We really appreciate you. I'll give you some extra rolls for your time here.
Thank you. Thank you for taking time out of your day to explain.
Hey, we're here 24/7, man, and you're the one who took time out of your day to come here. So
It's night time for me. I had nothing to do, so I just came on, just to listen.
All right, nice. Well, like I said, this place is we're open 24/7, and there's a lot of people who are willing and happy to answer your questions. So if you do think of something like, hey, I heard this, or maybe someone DMs you and you're like, hey, they're all stupid, don't listen to what they're saying, say this, let us know. Hit us, bro. We got you.
What is your profession?
Old friend, I brought more souls.
Number 6, axial tilt contradicts Newton's theory of centripetal force. Remember, the stone in Newton's sling was neither rotating nor was it tilting.
Newton's sling? What in the world are you talking about? You're not talking about Newton's cradle, are you? No, I don't think anyone's that stupid to call it a sling. Welp, no idea what you're on about here, buddy. Let me just ask my live audience of this premiere if they know what it is. Yes, very interesting. Oh, there, Farhago says it's made up bullshit. Okay, yeah, that confirms it. There's no such thing as Newton's sling as far as I'm concerned.
I mean, this is absolutely pathetic, dude. Oh my god. Dude, I can't believe I'm having to do this. I can't believe this, man. This is pathetic. This is absolutely pathetic. Okay, let's, as Red's Rhetoric, that douchebag would say, let's break out the crayons. Let's break out the crayons, kids. So I'm in Newton's Principia. Okay, this is the primary text of your tradition, which obviously you haven't read. This is page number 74. And I'm in definition number 5. A centripetal force is that by which bodies are drawn or impelled in any way tend towards a point as to a center. Of this sort is gravity, by which bodies tend to the center of the earth, magnetism, by which iron tends to the lodestone, and that force, whatever it is, by which the planets are perpetually drawn aside from the rectilinear motions, which otherwise they would pursue and made to revolve in curvilinear orbits. A stone whirled about in a sling. Did you catch that, Professor Stick? A stone whirled about in a sling endeavors to recede from the hand that turns it, and by that endeavor distends the sling. See the word? Sling, Professor Stick? And that with so much the greater force as it is revolved with the greater velocity, and as soon as ever it is let go, flies away, and et cetera, et cetera. He goes on talking about, he demonstrates centripetal force with this sling. I mean, dude, this is fucking pathetic, dude. Like, I am embarrassed for you right now. How bad you are, like, making yourself look. Dude, this dude has 150. Professor Stick, are you an actual academic? Are you an actual professor? Because seriously, every single person that has paid you to teach them needs to, like, sue you for their money back.
in case you don't know by now. The whole system's a dead thing. Free your mind, free the man in the cell, because to live in reverse is EVIL. I give this shit to you for free, I ain't got nothing to sell. Every word that I'm spitting's REAL, the real DEAL. I ain't trying to talk about how we play well, I'm trying to wake your ass up off beat as well. So if it all kicks off, we don't end up in hell. Listen, you better watch the clock. No time for ignorance and those who mock. We used to have trust when the doctors knocked. Now we all feel terror when they're on the block. And the cops, they're a captured lot. WHO, that's a captured block. The BBC, that's a captured flock. Everything on TV, captured. Still nobody's raptured. Families are fractured. So much fears manufactured. So much fake news that it's chaptered and overacted. The devil's overactive, and those who lack spirit are attracted. Don't make me laugh, kid. It's more than just lyrics over chords. Cause if you put an S in front of words, you get swords. The MPs and the bankers are all frauds, and our scientists are so specialized they get bored. It's not that I wanna be relevant, but the current crisis has a criminal element. Depending who you are, that could sound negative, but the truth is only a matter of evidence to be foolproof. Let me add some more juice. You can't be sitting on the fence no more, you must choose. Atheists, Christians, Muslims and Jews. Good must conquer, evil must lose. Tell me whose history is still intact, when the lost tribes of Israel are still in fact being born into bondage all over the gaff. And the only slaves I ever read about were black. I'ma tell it how it is, I ain't taking it back. I'm taking you back to King James. Remember that king's name. This is a big plane, and it's a big shame how the truth gets hidden with a bad name. It's a sad game, stuck up in the rap race, trying to live your best life. This ain't fucking West life, but me and you ain't enemies. I'm trying to wake you up and hook you up with some herbal remedies. Everybody wants to go back to before, but before caused the problems we chose to ignore. So from here forth, there's no more ear talk. We're kicking down your door hardcore with sincere and clear thought. You are what you eat, they ain't keeping it quiet. Seems they forgot about this in science. I ain't trying to cause a borderline riot, but the cure to disease is an alkaline diet. Try it, better yet, grow it, don't buy it. Can't get a drug if the government don't supply it. Quiet, you can see the harm in harmony. We need the farm, not the pharmacy.
Welcome to 24/7 Flat Earth Discord channel. Be sure to go to VCG Check-in 1 to get your VC verification tags to get involved in the conversation about our Earth. Be sure to bring your verifiable Earth curvature evidence, though.
Enemy spotted.
Deck. And you receive because there could be some kind of variance or interference that you're not aware of, right?
No, I mean, in this world where we live, the physical world, that we can kind of more solidly verify, because there's way more variables that we can kind of confirm. It's like way more solid. It's we can experiment. We can vary the variables, right? We can have an independent variable. We can actually manipulate.
Yeah, but where does that stop? Like you go a little bit higher on a mountain, suddenly there's less air density, so now there's slightly less variance. You go a little bit higher, now there's no air at all.
I wouldn't count that as an independent variable.
Why not?
Because it's not really something you physically manipulate yourself. It's just
an independent variable is just something that you are changing within your experiment to figure out what changes when you change that, right? And you can change it by either moving your location so that the ambient
natural phenomenon. So you're trying to actually see something that's in the real world, and you can confirm that it's independent, right? And then you do that. Then you can manipulate it. But before that, it's anybody's guess.
Independent variable. From my understanding, if you're conducting an experiment, the independent variable is just something that you can change whilst keeping the rest the same to see.
Yes, but you have to be confident in its ability to be independent, right? that it's changeable.
Yeah. So if you have a tool that can measure that specific variable,
But
and
you
you
can't
go
do
to a
that in the
place that
sky. You can't do that in the sky because you can't verify for sure that things are you can actually like adjust those things.
you don't have to. You physically have the ability to adjust it using some means. You don't have to do that. You can just make sure that variable is different when you conduct the experiment, right?
The difference is that in the world that we do live in, we can measure the air that we breathe in.
We can
measure the oxygen and all this. But we can't measure it in the sky that far up.
Yeah, we can. We can go up there and check. People do it all the time. Weather balloons or manned missions up a mountain.
Sure, that high up, yes, but even higher, where the assumed space is.
Sure. I mean, you take a balloon and you go as high as you possibly can with the density of the gas you've got in the balloon, and that gets pretty fucking high up. And then, if you want to go higher than that,
you won't go to Jupiter with your balloon.
You won't go to Jupiter. That's true. That's true.
That's what we're trying
to. You need some other technology, such as some kind of solid fueled, liquid fueled rocket to blast your way out. Fair enough.
And you're assuming that it's a place you can go to in the first place. You're assuming it's a place you can actually land on.
You are making that assumption, and some would argue that people have made that assumption and then checked, and that assumption turned out to be true because their data came back.
Yes.
But you choose not to trust that. That's fair.
Yeah, that's what I say. I try not to base my things on trust, but
yeah, and that's up to you how much you decide is worth trusting, etc. I just it feels like there's a lot of like how do you say trust the fact that this Discord app is working without the back end of knowledge and technical development and this, that, and half the technology comes from, NASA's space agencies and that's forwarded civilian tech, blah, blah, blah. All that is documented, recorded, historical and scientific knowledge that you can trace back and see, well, this developed from that, and then that developed from this, and this developed from that, et cetera, et cetera, et cetera. If you can trace that back, I don't see where.
Nobody's arguing that you can't develop things on the Earth. You can still have technology on the Earth, so it doesn't mean
it stops working once it leaves the Earth. I don't get it.
Okay, but first you have to say that something left the Earth. I mean, but that's actually a claim, so you have to prove it.
Sure, but if we have a rocket and that rocket goes up within the bounds of the Earth and the sky, do we assume that it stops going up once it crosses that boundary?
I mean,
and if we can maintain radio communication with that rocket and see it and bounce radar off it the whole way up, and then we can continue doing that past where we can see, we can assume, okay, we can't see it anymore, but the radar's still working. There's no reason it would suddenly stop working, or it's now imaginary or something. We can continue to do that until it goes past our vision.
I would prefer not to assume those things. I would prefer just to know that. So that doesn't mean that technology can still exist on the Earth that we have. So just because there's...
Yeah, but where is the bound between know and assume? If you use any kind of technology, you're assuming it works, right?
I'm not assuming it works. I know it works. I have a phone. I'm using it right now. I know this shit works.
Exactly. So if I have a radar that I know works, and then it keeps working for higher and higher up, it's the same thing. Then nothing's changed.
This is such a jump in conclusion, going from phones work, therefore you can go to space.
This is not the argument I'm making. You're deliberately misrepresenting it. What I'm saying is, if you have a radar device that works on Earth, you can point it at something and it says 30 meters, 50 meters, or it makes a scan of that thing, which we definitely can do with sonar or radar or whatever you want to do.
Okay,
and then you point it
no idea what you're measuring. You have no idea which thing you measure to build upon it, right?
No, you do it. Yeah. You can have an idea for sure. You can point it at something and then you stand in front of it, suddenly the number changes to the distance that you are away from it, and you go, oh, this is measuring the distance.
You don't know the distance, though. You don't know the distance, how far it is. So you don't know if you measured the thing in between or the thing that's actually there. You don't know. You're just making up.
You do know. I feel like you're deliberately limiting your amount of RAM or memory to be able to keep multiple things in your mind. But the point is that...
What are you measuring? What are you measuring?
What are you measuring?
He's measuring things in the sky. He doesn't know how far they are.
You're measuring the time it takes for a sound wave or a electromagnetic wave to extend out and then bounce from a physical object that it can bounce off of and come back. And if you time that and you know the speed of that thing, then you can measure the time it takes.
How are you doing this?
You don't know the medium. You don't know the medium which through it travels through. So you don't know how it alters those things.
We breathe the medium, and we know that the rate at which that medium changes by
you don't know what medium is in the space part. You don't know what medium is there. So you don't know if it's going to travel.
And who's doing this?
It's the...
Can you explain how you're doing it and who's doing it?
This is a hypothetical situation. I haven't done this. So
why are you using a hypothetical?
He's using because hypotheticals are very useful ways to construct scenarios in which you can explore ideas.
Hypotheticals prove? What do hypotheticals prove?
They can prove anything depending on what the hypothetical is, for sure.
Because you're using a hypothetical.
They work with ideas, for sure.
It's not a real life situation, is it?
Well, what do you think a hypothesis is? I mean, obviously that doesn't prove anything, but it outlines it. Yes, of course it is. It's in the name. Hypothesis. Ooh. It means something that isn't tested or verified yet, but is an...
You're just making it up. Hypothesis is something you've observed and you're trying to work out.
There's a reason they both start with hypo. Hypothetical means involving or being based on a suggested idea or theory.
A definition of hypo.
I've googled hypothetical, and the definition that's come up from Merriam-Webster Dictionary says involving or being based on a suggested idea or theory, being or involving a hypothesis. That is its definition. So that's what it is.
What's the hypothesis for rockets flying into space?
So the hypothesis is that the Earth has a force that acts downwards on all things. In order to overcome that, so you don't come back down, you need to eject and generate enough force to have enough velocity to escape that without being pulled down. And it takes a lot of fucking juice to do that.
Don't you? You know that's not
a lot of juice to do that. Have you tried jumping in the air?
I have tried jumping in the air. I haven't tried jumping out of orbit, though.
Oh, okay. So you're talking about hypotheticals, right, bro?
We were talking briefly about hypotheticals and their relationship to hypothesis and how they're basically the same fucking word, but yeah.
Okay. So...
Okay, do you know what a hypothesis is then?
Yes, I do.
What's a scientific hypothesis?
A hypothesis is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation.
So how is that basically the same word as a hypothetical?
Because a hypothetical, by definition, is something that is being or involved in a hypothesis. That is what that word means. You can look this up for yourself. Yeah, dude. I'm looking at it.
Hypothetical is not the same.
I'm not engaging this. If you can't be bothered Googling the definition of a word, then
I need to Google it, man.
Obviously,
No, you're right all the time. Except I'm looking at it right now, dude.
It is basically the same word. It is basically the same word. It's not the same word.
I did say that, and it is basically the same word. One's like an adjective, one is a noun, but...
Are you claiming
Am I claiming we're on a ball?
Yes.
Not right now. I could make that claim, but I think that's probably not a good idea, given the current
for rockets to go to space, you'd need... For your rockets to go to space, you'd need a radius, which your ball needs a radius, wouldn't it?
All balls have a radius, that's correct.
Okay, so you are claiming a ball then.
Okay.
No, I mean, if it was flat, you'd still probably need a rocket to get off of it to overcome the anomalous acceleration that we all experience.
You
have to generate enough.
You live on a globe, don't you? Not a flat surface.
It doesn't matter if I live on a flat or a globe, because if there's still an accelerating force acting on me downwards, right? Which I assume there is in both circumstances, because in a flat Earth or a globe Earth, I still jump up and come back down, right? So there is some kind of force coming down.
You only need
whatever.
Yep. So
they mean different things with a globe and a flat. But the point is that even if it doesn't matter if you're on a...
Not? You live on a ball?
What question are you asking?
My question
live
is,
on a ball
are you
or
on the
not?
fence? Are you on the fence about this?
Do you live on a ball or not?
In some ways, maybe. In the sense of like, if I truly believe the Earth was flat, maybe my experience of reality would be totally different, but I don't believe it,
Do you
unfortunately.
live on a ball or not?
Yeah, well, that's
I believe I live on a ball.
Okay, why?
Okay, there you go. So, what's the radius of your ball?
Off memory, something in the mid 8,000 kilometers, but I can Google it.
More like 6,000 kilometers, but who measured that?
That's true, sorry. 6,378.
Who measured
that? People have taken various measurements throughout history, but I think our latest ones probably used...
measurement?
It's 3959 in kilometers.
Sure.
It's what?
Obviously, measurements involve calculations. That's inherent to the mathematics of the measurement. I would hope you would agree.
So, can you name someone who's measured it?
No, I can't. I'd have to Google that.
So you've got a belief?
Yes, I said that already. I believe the Earth is a globe. That's true.
Do you know how they got the R value of the radius of the Earth? And that would be the transit of Venus over the Sun.
Maybe. Is that one of the methods they can use? I'm sure there's multiple different methods to measure the radius.
That's incorrect, though, isn't it? That's how they got the Sun.
That would make a lot more sense.
Yeah. Do you know?
You
of your ball.
Sorry, are you asking me?
Do you know how you got the R value of your ball that you live on?
I Googled it. That's how I got the value.
So how did they get the value?
Google probably got it off scanning a website. That website probably got it from citing some scientific
Do you know who measured
report.
The radius of the Earth?
No, I don't know their names. I've already said that.
Do you know how they measured it?
No, but I know there's multiple different measurements. You could use whichever one you like.
A spinning ball in the vacuum of space, and you don't know how
the
they
size of Venus during its transit over the Sun. That's how they got the R value of our round Earth.
They've used many different methods to get the radius.
Oh my God. They assumed that Venus was the same size as the Earth. That's how they got the distance to the Sun. You're wrong, mate.
You talking to me or this other guy?
No, I'm talking to Spring Corpse.
Go for it. Prove me wrong. You're just Googling things and then saying, like...
Okay, back to it. So, do you know how they got it?
You asked me the same question a million times, dude.
Okay, so you live in a belief that you live on a spinning ball in the vacuum of outer space. Tell me why it's not a belief.
I've told you already I believe that, and there's no claim otherwise.
Okay.
I believe we live on a globe. There's no...
confirmed?
So it's
how have you confirmed that you live on a spinning ball in the vacuum of space?
I haven't done the necessary science myself, but for better or worse, I trust my scientific institutions with certain facts that I live
The
off
priests.
of.
So you're in a religion.
Yeah.
If you want to call it that, sure, yeah.
It is. That's what it is. Do you know what the definition of religion is?
Hit me.
Well, it's having a blind faith belief in something that has no proof.
That doesn't sound dictionary-based, but the belief in and worship of a superhuman power or powers, especially a god or gods. I don't know if that's probably not quite right, but maybe a particular system of faith and worship, that might fit it a bit better.
Yeah, there you go. Faith and worship.
Right.
You worship the ball. Your gods
I wouldn't say worship it. I mean, depends what you mean by worship. I don't go around, bowing or anything.
And you have a faith-based belief in a ball. Isn't that amazing?
You're defending the thing that you believe in, so you're worshiping it because you're defending it. You don't even know what it is. You're just defending it. Why?
If defense is worship, fair enough.
And blind belief at the same time.
Well, yeah, defense is worship when you're believing something without having evidence of why you believe that. Like there's no.
I have evidence. I understand that you guys, your like burden of proof for that evidence is a different level of mine or has different things. That's fair enough, but I still personally consider it evidence. That's
Well, here's the thing. We
fine
know
for me.
it's
No,
flat.
it's not evidence. It's belief, bro.
Yeah, we
it's not
know it's
evidence,
flat.
It's belief. Yeah, go ahead.
So how do you separate knowledge and belief in your mind?
Listen. Go outside. Like, go outside. Look, we are not moving.
Can
We
you
are
answer my question?
motionless,
How do
okay?
you separate
But
knowledge and belief in your mind?
You believe that we are on a spinning ball, tilting, wobbling in the fucking vacuum of space. But when you go outside, we are not moving, bro. Motionless. And water, bro. Water. Listen. Okay. If you put water in a cup, I say this so many times. If you put water in a cup, right, the cup become the container, and water is flat, is level when it at rest. You move the same water into a swimming pool. Guess what? The shore around it is the container, and water is flat and level. Now we put the
You're
same
dead
water
right so far.
No, listen. When we put the same water in a lake, right? The shore around it, it's the container, and water is flat, is level when it's at rest, right? Now you put the same fucking water in the ocean. What's gonna happen? It turn into a ball?
No. If you take a similar size measurement, if you take a cup size like circumference of the ocean, it will definitely appear as flat as the cup does. No disagreements there.
So
but when you start zooming
where
out
did
to
you get
like
the ball from?
thousands and thousands of kilometers, a curvature starts to appear because it's a matter of scale. But
So there's bumps in the ocean, water bumps.
there was actually, they're called tides. But yeah.
Okay. Could you?
Yeah,
show
that's what a
us
tide
water
is.
bumps?
It's just a bump. Yeah, dude, like watch the water rise up and down. It's a bump. That's how that works. So it's very fascinating.
When I
actually.
look at the beach, I see waves that are crashing on the shore of the container, right?
Yeah. But you'll also notice over like an 8-hour period that flat level will rise and fall. And if you zoom out enough, you can see the actual gradient of that rising and fall. And you'll notice that coincides with the moon. And then you realize, oh, they're tides and the gravity is being shifted and they're actually little balls. It's very interesting how water moves.
Well, keep it simple, right? Does water always find level?
As best it can with the forces it's being subjected to, yeah.
It's always going to try and find level, right? No matter what container it's in, water always tries to find the equilibrium, right?
Yeah, a balance of forces and equilibrium for sure.
Okay. So one fact that we have to both agree on is that the Earth is 72% covered in water, right?
Yes, by surface, by just, that doesn't account for volume, but yeah, sure.
Let's just
I'll
say.
go with 72.
Yeah, 72%, right? So if water
Surface
always
area,
finds
to
level,
be specific,
yeah,
not
if
volume.
water,
yeah.
if
yeah,
water
yeah, yeah.
always finds level, and 72% of the Earth is covered in water, right?
Mm-hmm, mm-hmm.
Then how are we on any type of spheroid or sphere? Doesn't make sense.
It does make sense. I mean,
so water can stick to a ball?
Yeah, in the same way a raindrop is a sphere. It's like it's a distribution of forces.
The convexity of water. Is that what you're talking about?
I'm talking about the tendency for water to form an equilibrium with the forces it's being subjected to. In a raindrop, there's like van der Waals forces on the outside and hydrogen bonds and all this shit that contain the water in a sphere. And in the same manner, and that's the most balanced force. Obviously, when it's falling, it starts to elongate as there's different accelerations and blah, blah, blah. In the same way, on the Earth's surface, the water will take the shape of a container. If it was flat, it would be flat, sure. If it was a sphere, it would be spherical. But depends on the shape of the container. Again, this is begging the question.
Well, what do they call it? They call it sea level, don't they?
They do. There is a name for it, sea level, and that is the relative...
Because it's flat.
Yeah, you can use like the terminology to prove your point, but it doesn't really.
No, but it's true
mean
though,
anything.
because it's sea level.
That is true. It is called sea level.
Why?
It is the level, the height. Why? Because it's a very useful measurement when talking about ships and distance to the bottom of the sea
the
and
ocean
the distance.
is flat over a stretch of like a span. Like when you have water in a container, right?
Like, what would contain the oceans? Why are the oceans
the sides of it?
Right, the shores, or
sure, the long sloping continental shelves, or whatever you want to say. Yeah,
it's being contained, right? That's why waves are crashing, because it's like water in a bathtub sloshing around. If you think about it like that.
Somewhat. Waves are kind of there's wind and shit, but yeah, fair enough.
Right. So 72% of the Earth is covered in water.
Mm-hmm.
Flat, sea level water.
Yeah, I mean, you're throwing in flat, as in implying that that's the container, but if you want to say that, sure.
Yeah, because
flat. Yeah.
If it's 72% of the Earth's surface is covered in water, that means 72% at least is flat, right? So how can you shape that into a ball? That doesn't
in the same way a raindrop is shaped into a ball. Just because, listen, what you're saying is the same thing as saying a raindrop surface is 100% water. So why isn't a raindrop flat? It's because there's other shit happening. That's why.
Well, okay, so you're talking about raindrop, right? So what would happen when the raindrop drop on the ground or drop in whatever? What do you think is going to happen, right? Let's say 1,000 raindrop drop in the same spot. What do you think is going to happen? It's going to rush to every direction to find its level.
Well, it's gonna hit the ground, and then all the momentum from each of those raindrops are going to splatter. What do you think happens if a hypothetical spherical Earth hits a big fat wall? It's going to do the exact same thing. It's going to splatter like a raindrop.
Yeah, well, because you think that we're living on a ball. That's why.
Yeah.
Yeah,
that's exactly why. You got me.
Well, the only ball really exists in your imagination, and where you see from NASA, picture, photo, whatever you want to call, videos. But in actuality, bro, you go outside, water is fucking flat. Water is flat with the same.
Dude, I understand. I understand
3959. There's no curvature. Drop over distance, my friend. You live in fantasy. Hello.
Okay, man. Yeah, like you can insult and say I'm fanny, whatever, but it's not going to change my mind.
I'm telling you real shit. Well,
you're telling me what you believe, and I appreciate that, but it's not changing anything.
Deck.
I'm just here to chat. Yeah, but I'm here to understand your positions, why you believe it, and I'm hoping that you would take the same position for me as well.
It's not a belief, bro. We know fucking water does not curve into a ball, bro. You believe, bro. You just admitted earlier that your whole fucking shit is based on belief, and you want to point at us that we believe? No, fool, you believe in that shit, bro.
Yeah,
no one's actually told me what the difference in their personal definitions between belief and knowledge is. How you separate those two things? I would like to hear that.
Timbo said it pretty well earlier, right, Timbo?
Kembo, he just said go outside, it's flat. That's all I heard. I'm not sure really.
Okay. I'll reiterate what he said as best I can. But belief in something, the difference between knowing something and believing something is belief is having faith in a subject without having any evidence to back up that belief. That's why it's called a belief. That's why it's religious. Because you're not using evidence to back up your belief. You're using a feeling. You're using subjective evidence.
Well, listen, on the dictionary, what belief is saying is an acceptance that something exists or is true, and then it says especially one without proof. So it means that, yes, a belief without... No, but listen, a belief, right, can be without proof, but it can also be with proof. The core crux of it is that it's something that you accept as true or existing, right? That's the core of it. Whether there's evidence or not, the point is that you believe it, or that you accept it to be true and that it exists. That's the definition of belief, or the one that I use at least.
Well, let me ask him a question.
Hold on, let me clear that up, Kel. One sec. You can't believe something and know it. Yeah, you either know something or you believe it, but you can't believe something.
Why not? No, they're not. They're not antonyms. No. So no, the verb in the dictionary says be aware of through observation, inquiry, or information. Okay, and then a belief is an acceptance that something exists or is true. So I don't see any reason why you can't both believe and know something to be true. They're very similar words in definition.
No, forget. It's a contradiction. If you know something to be true, no, let me finish. If you know something to be true, yeah, I don't believe I'm speaking to you now. I know I'm speaking to you now 100%, okay? There's no belief here. I know what I'm
What are
doing.
you defining as belief?
So belief is, well, as explained to you several times, is a faith, okay? It's a faith.
That's what your definition of belief is, okay?
No,
sure,
no,
we can use that one. But the one in the dictionary is different.
Everybody has the same understanding here.
No, that is wrong.
To know something is to have some sort of direct experience, okay, where you know 100%, right? I know 100% I'm talking to you now, Dec, and I can't believe it because I know it. You can't hold both positions at the same time.
You can. I don't know why you think you can't, but if you look at the definitions of the exact words and their meanings, they're not contradictory in nature. They just aren't. You can look at the words and see for yourself, they're not contradictory. If you want to make your own definition, then they might very well be contradictory. But in my mind and in the English dictionary's mind, that I can both believe and know something. Right?
No, you're even quoting the dictionary wrong. To have a knowing is not the same as a belief, and if you think that it is, then you need to scratch up a little bit. You need to, tighten up a little bit with your definitions.
I'm reading them to you right now. How much more scratched up can I be? Okay. I mean,
you're holding a contradictory position, okay? To have a belief is a faith. To have a faith, is not to know something, it is to believe, okay? But to know something includes direct experience of some sort. Hence why we do not like to believe that the stars are anything more than what we can see they are as lights in the sky. You believe that they are something else, but we know, we don't believe, we know you can't prove that. So there is a difference, and science is a good marker for this, because when you've got a method, like the scientific method, that can take you from belief, i.e. a hypothesis, to knowing. And this is the main difference between you and us here. We understand you can know something, and science does prove things. You seem to think it's every opinion for themselves. And that's not how we work here.
That's not what I'm saying, and that's fine if we can hold different beliefs. That's not a reason to arc up, all right? That's cool. If that's the way you do things here, fair enough. And I'm happy to adopt your personal definition of belief and know, then, in that case.
Not a personal definition. It's not a personal definition.
If it's not in... Bro, the actual dictionary, the Oxford Dictionary, is different to what you're saying the word means. Therefore, it's a different definition.
Makes a distinction between the word belief and the word knowledge. Otherwise, we wouldn't have two separate words to detail the difference.
It makes a distinction between grab and hold. It doesn't mean that they mean different things necessarily. They're just two different words.
So are they synonymous? Are they synonymous?
They can be, depending on how you use it. Personally, I've been using it quite synonymously. So it is contextual for sure. Yeah, it is contextual for sure. So, but obviously, in this context, we are separating belief in terms of like something without evidence. So that's right. If that's what we want to accept as the definition of belief, then I'll say I don't actually believe the Earth is round. Then I know. In that case,
so it's not a personal definition. So it's not our personal definition, correct? It's in that context that it's being used, right?
Well, yeah, because it's the contextual definition of this.
It's built to be used in that context.
No,
just the most important thing is that we can come
built to be used in any context. It just is. But what did you say? Sorry, fine.
As long as we can come to an agreement how he sees the word, that's all that matters. If we can say
exactly. So I'm happy to accept that. I'll use belief now to mean without evidence. Okay, so in that case, or at least believe. I mean. For me personally, when I say I believe something, what I mean is that, like, when I talk honestly and what I truly think is reality, that's what I mean by believe. So, like, when I say I believe my hair is blonde, what I mean is my true, actual, my best to my knowledge ability to describe the world, I believe it's blonde. And in the same way, I believe the Earth is
that would be something that's based on experience,
but it sounds like you
can verify. That's something that's verifiable.
No, he's still using.
We can go. Listen. I'm just talking about definitions right now. We don't have to go into verification all that. But point being is that what I use belief meaning as in I know it and feel it and accept it to be true in my mind. I act as if this fact is true. That's what I mean by belief. So when I say that, I mean I believe the Earth is round. But if we're talking about no in terms of having evidence that you personally feel is enough evidence
which supports your belief of having knowledge that the Earth is round.
Why do you believe the Earth is round?
Many reasons, right?
Okay.
I mean, the fact that
one.
Fallacies
name
is the
a
reason.
single one. I'm sure you can pick to holes any single one I use, right? Using your own methodology. But if I can just throw out like a number of them, right? So like, obviously we have pictures and satellite observations. They get pretty iffy and, you know, could all be graphical, whatever. We have like mathematical observations. We have observations of different planetary objects using telescopes that are purely mechanical. There's no electronic
we can do for ourselves? What is that? We're looking for something that we can do ourselves to verify it for ourselves.
Okay, I mean, to me, and your burden of proof may be different, for better or worse, but to me, if I can go out, buy a telescope that's purely mechanical, doesn't have any electronic things that could maybe affect the image and generate things, right, that aren't there, whatever. If I can buy a telescope, point it at a different planet, and see that it acts as if it's a sphere, it spins, its face changes.
Whoa, slow down. Why are we looking at the sky? We're trying to determine the surface quality of what we're living on.
Yeah. So a good way to determine things that aren't directly observable, right, in terms of scale and things like this, is to look at similar objects and then extrapolate that information. Obviously, you don't.
It looks like a good enough standard for you.
Not usually, but looks like flat seems to be a good enough standard for you guys. So I'm using that one. But if that's
let's just clear this up. Let's just clear this up before we go any further. Okay, you seem to think that we have our own personal definitions for stuff. Okay, we have scientific
Everyone
method.
does.
Okay, no, listen, no. This is where you're wrong, right? We have something called a scientific method. Okay,
we do.
Yeah. Now that differentiates. That will help you to find the cause to phenomena. Okay, so we don't have to believe things. Yeah, if it is if it happens in nature, if it's an observable phenomena, then we can use science. So we don't have to. We don't have to pre-assume. We don't have to. We don't have to make assumptions or have beliefs. Yeah, we can take
assumptions happen in science all the time. But sure.
No. If there are assumptions, right? If your conclusion is if you're making assumptions, what you're doing is pseudoscience, which is fine.
No,
but what I'm telling
if your assumptions are too big for the conclusion, then yeah, fair enough. But like normal science makes assumptions all the time for the purpose of the experiment, for sure. Like you assume ideal conditions, you assume this.
You can't pre-assume a globe when the question is a globe. You can't pre-assume the planets are spheres.
That's fair enough, yeah.
When what is in question is the actual sphericity of the lights in the sky. So what I'm saying is you are jumping into these mistakes and you are scattergunning all over the place because you're not keeping it to the scientific standards. It is not our standards.
Okay,
it needs to be observable and repeatable within nature. We can call it science, and then it goes. 100%. It leaves belief and enters the realm of knowing. And that's the difference.
Sure. So let's say that. Well, like let's create a hypothetical experiment in which we're using the scientific method to determine the shape of a light in the sky, and one that happens to cross very regularly and in the same way across our sky for hundreds of years.
You've made a mistake. How the hell are you going to be able to manipulate any independent variables in the sky? Listen, you can't do space. You can't do science on lights in the sky, which is why we will tell you again and again, the lights in the sky are no way to prove the ground that you're walking on.
Right.
Because there is no science involved here. This is all pseudoscience based on your assumptions. Based on your assumptions of what the lights in the sky are. The lights in the sky are not. You cannot do any science here. So just recognize that.
I will not recognize that because I completely disagree.
To the surface quality of what you're living on.
We haven't even drawn any conclusions to what we're living on at all. I'm just talking about.
You're pre-assuming the lights the planets. You're pre-assuming the lights the planets, and then you're comparing.
I'm just saying they're lights, right? So far, I'm just saying I see some lights up in the sky. I want to know what they are. Are we good so far?
That's great and dandy, but that wasn't the question, man. The question was,
I'll get there. Right?
Why do you believe that you were on a globe? That's the simple question. Why do you believe? What would you do? Your top three reasons why you believe you're on a globe. Keep it simple.
Because of, listen, everything I say, you're going to say it's not scientific, even though I believe it's scientific. And then you're going to ask, well, why do you believe it's scientific?
Well, hold on.
And you say, well, I believe it's scientific as well.
You're assuming what we're going to do. We're giving
I'm
you the
making
spotlight.
a very valid assumption because every time I've tried to do it thus far, you've done this. I doubt you're not going to do it this time. But
Okay,
sure, I'll try.
I'll mute myself. I'll ask the question one more time, and I'm going to mute myself.
Okay,
Why do
sure.
you believe that you were on a globe? Your top three reasons.
So here's a big one, right? And I'm going to go on the planet thing, and if you'll let me finish, just so you can see my whole point in entirety, and then you can say where it falls down or where the fundamentals are wrong or whatever. But I believe that you can conduct scientific inquiry and observations on basically anything, right? You don't, I think your understanding of independent variable is a little confused, but my understanding is that there can be things in nature that as long as you measure a certain variable to be different at different times or whatever, then you can count that as an experiment where the independent variable is the thing that has changed, whether it be the sea level or the level of light or the angle of the sun in the sky or the wind speed, whatever the variable might be, right? As long as that variable that you're measuring is changing, then you can say, okay, that's my independent variable. And obviously this is going to have different things because depending on the environment, your controlled variables are going to be difficult to control, etc. But whatever, I digress. So let's say we can conduct scientific inquiry.
Yeah. Let's start with number one. Go ahead.
So scientific inquiry, I see a light in the sky, and I notice that it moves in the exact same way relative to all the other lights. They seem to stay the exact same position. This one moves. I go, what the hell? Moves in the same way. So then I build a device that can take in light and then magnify that image so I can look further. And I point it there and I go, oh shit, it's not just like a little tiny light generation. It's actually like what looks to be a circle in the sky that has colors and it has a shape and whatever. And then I build a better one, and then suddenly it's a lot more clearer. I can see detailed colors. I can see other circles cross in front of that, etc. And I can now,
real quick,
if I can finish, and then you can ask at the end. And then after I do that, and I make lots of observations, detailed with my very detailed light magnifying device, I can then track the positions and see where they go relative to me all the time. And I plot these things out, and I notice they repeat every single year. Interesting. So then I look at these different things, understand how these movements can rectify against each other, and realize, oh, well, if they move relative to each other and we, again, assume some forces, which we're obviously going to assume, we can not assume anything, but we don't get very far in science if we don't assume anything at all. But if we assume that the forces acting on all these things are the same, and there's not just random things acting on random other things, which wouldn't make sense because there's patterns that we can clearly see, which usually indicates some kind of underlying common variable across them all, we develop some laws that these things tend to follow, etc.
Is what does anything in the sky have to do with the measurable, observable Earth that we're living on? What does anything have to do with? Like, it has nothing to do with Earth, man. We're trying to
so
we can make Earth is flat. How do you know it's round?
So we can make two assumptions. We can either make the assumption that the Earth is separate from the sky and the lights in the sky and everything. We can assume that they're separate, or we can make the assumption that they're a continuous kind of continuum and there's nothing really separating it, right? Those are both assumptions we can make, and those will lead us on two different paths.
We're not making assumptions here, my dude.
You always have to make an assumption. You always do. Yeah, it's inescapable.
You know what an assumption is? It's a hypothesis.
No, it's a fact taken to be true.
That's not a fact. When you assume something to be true, you're assuming without evidence. You know what that's called? That's called a hypothesis until you prove it with evidence.
That's not called a hypothesis. Is different from a belief. A hypothesis is an outline of what you think is going to happen that you haven't verified yet, right? So that's
you haven't verified that.
An assumption is something that you accept as true without question or proof. You have to do that as humans. You can't operate having 100% scientific inquiry and method over every single fact in your brain. It's not a thing that happens.
Let's simplify the conversation, please. Like, seriously.
Can you not follow or what?
Oh, I can follow pretty easily.
Then why do we need to simplify it?
Because that's not you're beating around the bush to the question that I asked, which was give us a reason or some type of measurable experiment or some type of anything, any reason that you believe that you're on a ball. Like, why do you believe you're on a ball? Give me the number 1, number 2, and number 3 reasons. It's very simple. There's got to be something there, right? There's so many things you can point to, but you're not pointing to one of them.
I've pointed to several, but I was currently pointing to the planet thing. Yeah. So, the point is, you can make the assumption that either the Earth is separated from the sky and the heavens and the lights, or you can assume they're continuous. If you make the assumption that they're continuous, which I'm going to do, then we assume that the Earth is probably very similar to other things that we see outside. It makes no sense to assume that the Earth has a completely separate set of laws and rules. And
why?
Listen. I'll tell you why. Instead of just repeating it, when we talk about rules and like laws of nature in science, the point of them is that they are continuous. They act on everything without discrimination. So the idea that the Earth would somehow be different and above or separate from all the rest of the laws that govern everything else we observe,
but that's what you observe.
To me, doesn't make any sense.
But that's what you observe. That's what you experience.
It isn't what I observe, not at all.
Yeah, it is. It is what you observe and experience. You do not see a similarity.
The observance of it being flat?
Yeah, you don't see any observable similarities.
Sure, I do.
It's it's illogical.
Show me a tree on Mars.
Okay, there's no trees on Mars. Good one. You got me.
Well, what's
they have rocks. They have forces that
you don't see that. You do not. No, you don't. You don't observe that. You don't observe that.
Yeah, I can look with my telescope, see moons
and
rotating around around Mars.
See rocks. You do not see rocks.
You do not see rotation.
Hey, dude,
you can see the movement of objects on there. Okay.
When you look in your telescope at Mars, what do you see?
A red planet.
Don't lie to me.
A red planet. Okay.
Red planet. So, do you see rocks?
My telescope isn't quite that good.
So you just said you see rocks when you look at Mars. T-Dub said, what do you observe? And you said rocks.
Okay, let me be more specific. I don't observe any rocks with my telescope. You're right. I observe
light in the sky. Yeah.
I observe a circle.
I've got one. I've got a telescope.
Okay, our telescopes might be different.
What do you see in the sky? Man. A red light. Correct.
Red object. It's definitely very objective in my telescope.
Okay, so is that object spherical?
It sure looks like a circle.
It looks like a circle.
A circle.
Great.
Right.
But sure. But I don't really encounter many. I don't encounter many objects in my day-to-day that is a 2D plane. Doesn't happen very often unless it's like paper or something like this.
Get into reality. 2D does not exist. All right?
Yeah, 100% agree. Yeah, I agree.
Great. So why are you bringing up 2D?
Well, it was more colloquial. I was saying it like it's more flat than it is deep, but we can.
Okay.
Sure, it's 3D, but its depth dimension is much smaller than its length and width. Is what I meant.
You look up in the sky, you see a red light, and it looks like a circle.
And
a red circular object, 3D object.
How do you know it's 3D? You're looking through a uni lens.
Right.
You just have a fucking rage that everything is 3D and there's no such thing as 2D?
No. Yes.
Yeah,
How do you
but
know it's
2D
3D? Yeah.
Yeah, so if I'm looking at something, right, then I know it exists in three-dimensional.
But you don't know it's physical, do you?
I'm looking at it.
Yep. How do you know that's something you can land on?
I don't yet.
Okay.
Okay. So why are you saying it's got rocks on it?
Progress. This is great progress.
Okay, I will rescind the rock comment. We don't know enough about Mars with our telescope yet to understand the rocks.
Everything,
or lack thereof.
Okay.
Everything that you see in space is from a third-hand party that you cannot get any evidence by yourself to confirm.
Are you assuming stuff? I've got my telescope and I can see it, right? I know it's there.
You see a red light. That's what you see. A red.
Exactly. You just admitted
red. Not a light. It's not a light anymore. If it's a light with my naked eye, it's a point, right? With a telescope, it is a thing that has dimensions,
bro,
and is circular. It does have light reflecting off of it, obviously.
Are you talking about 3 dimensions?
Of course, you can see.
You can't see
I can see
dimensions with a telescope.
Right.
Yes, you can. You can see two of them.
One lens.
It's one lens, yeah.
What, you're seeing one dimension with a telescope?
So check it out.
Close your eye. Close one eye.
Yeah,
Do you
close
see
one
3
eye.
dimensions with one eye?
No, I see 2 dimensions. Is what I'm saying. I see 2 dimensions in a telescope.
That's not what you said.
That is exactly what I said. If you listened instead of just raging over. Me, you would have heard that I said I can see dimensions in a telescope. I can see 2 of them. I'm not calling you stupid. I'm saying you misheard me because you were talking over me.
I said I'm not stupid.
Sure, and you only said I'm not stupid because you assumed that I'm assuming you're stupid. I'm not, right?
Okay, let's back up a second.
Yes, let's please back up because he's very aggressive. I don't know why.
Yeah, I am. Because you're a fucking moron the whole time.
Oh, you're assuming I'm stupid now. Listen, dude, just chill out.
All right, Deck. All right.
Yeah, Beasticles.
Hold on.
Beasticles or Beasticles?
Well, whatever you prefer, man. It's okay.
Beasticles is a traditional Greek pronunciation, and it sounds cooler. I'll go with that.
Thanks. Let's get back to the conversation at hand real quick, man. And it's still the
Deck,
conversation.
I've just muted you, right? So I'm just going to give you a warning. The whole time I've been listening, making dinner, and all as you've done is beg the question and brought up fallacies. All right? You've got no proof of anything, and you can't prove anything that you're saying. So who's the moron?
Well,
there you go.
Yeah.
The moron is the person that forcefully mutes people that they disagree with, I would say, but that's just me.
But did you listen to what I actually said, though?
I did.
Are you going to bring any evidence to the table or not?
I mean,
I've been trying to. You just keep getting angry. I'm trying my best.
The evidence that you can confirm that you live on a ball.
That's all we're asking from you, brother.
Yeah, I know. I'm trying. I know you're trying to stick on his side, Beasticles, but I think you should probably distance yourself from
what I know to be true.
No. From old mate over here. Just because you believe the same thing doesn't mean you have to be buddies. But yeah, sure.
Am I wrong though?
He's not wrong. He may have a curt way of saying it, but he's not wrong.
I have no doubt that you think I'm wrong.
No. That's not what the question was. Was he wrong about the statement that he said when he had you muted, where he said you brought?
I've come in here. I've brought in conjecture, no proof. Yeah, I understand that he sees none of that as proof. I see it as proof. 2 different things. That's fine.
There isn't any proof, bro. You admitted earlier that it was all belief, and what proof are you talking about, bro?
Right. I've got you on recording.
Or something, man?
Yeah. And listen, Deck, we're just trying to demonstrate to you that everything that you're saying is a belief, right? And that there is.
I've agreed to that.
But listen, the logical position is to understand that there is no motion, there is no curvature, right? That is the That is the logical position. So the burden of
I
proof
would disagree.
would be no. It is because all of your senses will tell you we are not.
And I
moving,
would disagree.
we are
That's
not,
okay.
No,
Okay, let him finish,
You're wrong.
What are you
You're wrong.
disagreeing about, though? What are you disagreeing about?
I'm disagreeing that it's the logical position to assume there is no curvature and no movement. That's what I'm disagreeing
Okay, so
with.
go. Where is it? Where is it then?
So I think the most logical position, right, is that the Earth is not any different to anything else that we can look at. That's my position. I don't think that's illogical.
It is illogical.
I feel like it's more logical. So listen, you have to assume either the Earth is different to everything else or the Earth is the same
What do you mean
as everything else.
You don't even know that those things up there are physical. All right, so you do this. You walk outside, right? You walk to the beach, right? You look out. It looks flat.
It looks flat.
And it feels stationary.
Right.
Yeah? So,
I'm going to quote you from earlier. Is it now the scientific method that when things look the way, that's sufficient?
No. Well, that doesn't matter. I can give you laser tests if you want, but what I'm saying is,
Timbo.
Okay. What's that, mate?
I can put this in a different way that he might understand. Would be that when you're a child, if you were never taught that you were living on a spinning space ball, when you walked outside, you would never have made that assumption on your own.
That's fair. Yeah, that's true.
You're told.
Right. That's why it's the logical position.
That's why it's logical. Yeah. So you'd need really good evidence.
To be fully clear, every position you come to is logical in the sense you're going to have a reason for believing everything you do. But,
hey, mate.
Yeah.
So, him saying that, how do you come to the conclusion that you live on a ball?
Right.
Because everything outside tells you that it's flat and stationary.
Okay, so I don't think that, saying, well, I'm answering your question, dude, if you give me a bit, all right?
He asked you 20 minutes ago to give you 3 best reasons, and you went off into space.
You keep monologuing, dude. So, hold on. He just asked me.
No.
So he's put it in a different way, and he said that how come, as a child, you would never have thought that the Earth is a sphere when you would take your own observations in and go, oh, it's flat. I've got no reason to believe otherwise, right? He just asked me that.
That's a great,
Sure. In the same way, a child will look at a phone and assume it's magic. A child will look at a TV, assume that screens just play stuff. But the point is that a child does not have the capacity with their senses that they're naturally born with to understand a lot of what goes on around them. You need to have a base of knowledge that people can build up over time and learn so that... I'm answering the question.
Wait.
The point is that when you grew up from a child and you were an adult, you would still be looking out over the flat Earth and not assuming that you're on a spinning ball. The only reason you've got that assumption is because you've been told that. So you're believing what the authorities tell us to be true.
Yeah, sure. You can look at it that way.
Okay, I
an alternative
question now.
But listen, what you're saying about that is true for any kind of knowledge that is like multi-generational, right? Like if I was a child and no one taught me how to make fire, I would grow to an adult and assume fire just comes from lightning, right? But the thing is, I need to be taught that from someone that's figured it out. And then you extrapolate that for 2,000 years, and suddenly you can't only make fire, you can also make phones, you can make laptops, and you can make rockets, and you can look into space.
Deck, let me throw you a bone.
Flat is an observation, man.
Burn me, man. Burn me.
Observation.
I'm going to throw you a bone because you're almost there. And when I mean by almost there, I'm saying like...
nowhere near it.
Well, the thing is...
I won't be offended by the deliberate talking down, but sure, I'm almost there. Help me along.
What you said earlier, right?
Yeah.
Or what AJ said earlier about if you were a child or all the way up to an adult, if you've never been told you were on a spinning ball, right? Then you would trust your senses. Your natural senses tell you that it's flat, there is no curvature. So that means that your only reason for believing that the Earth is round is from authoritative sources. Now, having that in mind, do you agree with that, right? It comes from authoritative sources. Okay.
Authoritative in the sense of like the institutional, a lot of people.
Someone that has
not in the sense of they're enforcing the belief, like
not
at threat of violence or something.
Now my question
not
for
scientific, so
yeah, but
Kimbo, just like let Beasticles go for it this time.
I'm just reiterating that shape is not scientific.
So my question for you, Deck, is have you ever felt that authority figures, such scientists, anybody with credentials, has ever lied to you personally? Have you felt like someone was lying? A politician, president, anybody?
Yes, and also mistakenly told me something that they believed to be true but is actually wrong. Both of those things have happened from authority figures, 100%.
Okay. Now, knowing that, and knowing that humans have the capacity to lie and deceive for their own ends, right?
Yes. Man is evil.
Why do you trust these authoritative figures, right, so wholeheartedly as like a religious belief that you're willing to deny the science about observable, measurable phenomenon and go with the authoritative narrative? When you know that they lied to you, you've seen it. Have you ever thought about that? Like, what if they are actually lying to you?
Of course I have, and I'm sure they lie about a bunch of shit. There's probably aliens, there's probably fucking this and that. God knows what else, yeah.
So my next question is why would they tell you the truth about you being on a spinning ball? Like, why would that be true? Like, why do you believe that's true? If you know that the sources of information you're getting is capable of lying and probably has reason to lie because they don't want what's best for you. They want what's best for them.
Yeah,
well,
okay.
The fact
But
is
like,
that
what
they do
reason?
lie, because I think that everyone would agree that they tell you that the theory of gravity is science and that there's science behind this gravity. Would you agree with that?
There is a lot of science behind the idea of gravity for sure.
No, there's not.
Actually,
there's a lot of scientific papers behind it. If you count that as science, then yeah, but sure.
Then let's go through that. Let's go through that.
Yeah, let's go through that for real.
We can show 100% that it's not science. So, can you define science? What is the definition of science?
All right, let me get a proper one up.
He's going to Google. We're looking at natural science because we're looking at the world.
The science definition: the systematic study of the structure and behavior of the physical and natural world through observation, experimentation, and the testing of theories against the evidence obtained. Are we happy with that?
Beautiful.
Well done.
The dictionary does very well. Yeah.
Let's have a look.
It's actually not correct from someone. Okay, dude. Anyway, AJ, go.
Can everyone let AJ take this? Can you let AJ
Wait a second, though. Can we just wait? I just want to clarify one thing, that the last statement in that definition is incorrect.
And the testing of theories against the evidence obtained, you're saying that's wrong?
Yeah, it stops at observation and experiment. That's where it stops.
No,
well, it doesn't. Not according to the Oxford Dictionary. I don't know if you're a much
the Oxford
better
Dictionary
source than that.
A theory is developed. A scientific theory is developed after experimentation.
Yeah, but a scientific theory is inclusive of science as a whole, and scientific theories need to be tested against evidence. No?
No such thing as science as a whole.
Okay, we're going off track anyway.
Sure.
Yeah, we're going off track.
Anyway, we agree on the science. Most of us do, at least, on the definition of science. Sure.
Go ahead, AJ.
So then, what's the scientific method, and what are the dependent and independent variables?
Okay, going back to year 8 science. Let's get it.
Yep.
So the process in the scientific method, this is from Wikipedia at least, involves making conjectures or hypotheses, hypothetical explanations around your observations and what you observe in nature, getting predictions from that hypotheses, and then testing them against evidence and empirical measurements that you can make.
Mm-hmm.
Cool. And then we also have to have the dependent and independent variables as well.
Sure, that's inclusive within the experimentation, for sure.
Control variables and the null hypothesis.
The first issue that I would have is that with the dependent and independent variables, you have to manipulate gravity itself. You have to manipulate the cause, not the effect. So can you show anywhere where someone has actually manipulated the cause, gravity, and not the effect?
So there's no stipulation that you have to change. Well, I mean, sorry. So you're saying that you have to manipulate gravity itself in order to test gravity.
Right.
That's how you would establish that it is the cause of an effect that you've observed in nature.
Right.
So that's the first point.
Okay.
And then the second point, it's the study of the physical and naturally occurring world. So when we have a look at gravity, gravity was proposed in Einstein's relativity in 1905. And then we have, I forget the guy's name, but something Fritz came in about 1930 and showed that what Einstein had proposed was
I don't think Einstein wasn't it Newton that invented gravity? His whole apple on the head?
It's not actually Newton today. It's actually Einsteinian gravity that's actually accepted, which is the bending and warping.
Oh, yes. I mean, obviously, Einsteinian gravity is slightly different to Newtonian gravity, but Newton came up with the idea of gravity in the first place.
Okay, so
you know
Einstein,
the difference?
when he came up with his theory of relativity, when Einstein came up with the...
One is to do with the space-time continuum, etc., but the other one is just to do with methods and stuff. Everyone can tell everyone what to do. Don't get offended. Grow up. AJ, keep going.
Okay, so I just lost my train of thought then.
Yeah.
Okay, so we're studying the physical and natural world. So Einstein's relativity was about 1905, and I think it was a dude named Fritz in 1930 that actually showed that Einstein was about 99% incorrect, that the gravity or the whatever he had proposed could not actually hold that universe in place for what it was doing. So this is where they then proposed, instead of throwing that theory out, they proposed dark matter and dark energy, which now make up 95% of our universe. Now, dark energy and dark matter cannot be seen, cannot be detected. They admit they know very little about it. So how, again, is gravity scientific when, one, there is no independent and dependent variables, but two, there's nothing physical to actually study. You're studying a belief to make gravity work, right? And then thirdly to that, there's another part to that as well, but is that it's the bending and warping of space-time. And again, science is the physical. The space and time is a concept. Time is not physical. So you can't bend a concept.
Time is physical. It's the fourth physical dimension.
No, it's not. It's
physical.
a concept. It's not
physical
tangible,
means physics, means to do with
malleable.
physics. Time is definitely within the realm of physics.
Regardless of whether you believe that or not, we have no dependent and independent variables, and we have dark matter making up 95% of the universe that cannot be seen, cannot be detected, doesn't interact with anything. And we know that science, the definition of science, is observing the physical manifested and natural. So therefore, there is no possible way that there is science behind gravity. You have an agreed upon average of the rate that things fall, and then it's begged the question of what causes it.
And affirm the
concept. I see. I mean, if I can respond to that, I understand that you've recognized the fact that throughout scientific history, if you want to call it that there have been multiple revisions and changes and additions to the understanding of how natural laws work. And so when Newton first came up with gravity, of course, he got some shit wrong because he was the first guy to even think about the fact that maybe objects that have mass attract other things with mass, right? It's pretty, novel idea, sure. So then he got...
shit up.
Pardon me?
Now you're just making shit up. Can you answer what he actually addressed?
Dude, listen, just because you can't understand what I'm saying doesn't mean I'm not making sense.
Answer what he addressed.
Dude, he spoke for like 10 minutes.
Is it science according to science?
AJ, you don't have to get angry with dickhead over here.
I'm not getting angry. I'm just asking the question.
Good.
Is it science or is it pseudoscience? Because according to the definition of science and the scientific method, it has nothing to do with science.
I don't think that's quite true. So listen, obviously science is built to revise itself. People will get things wrong, and the point is that using the scientific method...
Just give a valid hypothesis for gravity.
Oh, just give it like I'm a fucking physicist that's like
but
experimental and theoretical.
So, should know it.
Your belief.
Dude, I can trust someone that has more expertise than myself that they have something right.
Why?
But you were just explaining.
Why? Because I can't.
You can't do it.
Unless I want to live and forage and build everything myself, build my own phone, build my everything, I have to be able to trust other people with different jobs and roles that I don't have the time.
What are you trusting? What are you trusting?
Yeah.
What are you trusting? What is it you're trusting?
I'm trusting individual people's ability to understand things that I don't, and then
So what is it that they did? What is it that they did that you are trusting?
Various scientific experiments.
Various.
Like what?
Dude, like thousands and thousands of scientific papers, not only by just Einstein.
You don't even know what you're trusting in. You just have a blind faith.
Like Einstein's general theory of relativity and special theory of relativity. That's two names of papers.
Define it.
Define it? Define a scientific paper?
Yeah, define the theory of relativity.
The theory of general relativity is like a multiple 100-page document about the science. Like it's very complicated.
You don't know it.
That's the point of it.
Right. Yeah,
I'm not saying I know the entire paper word for word off by heart. Of course I don't know it, and it's ridiculous that you would think that I would, right? But there are scientists in the field of physics who have studied this for decades.
Believe this shit. Who have said, trust us, we've read it, we understand it, you don't. That's okay, just believe us.
Yeah, just
okay. And you don't believe them, and I do. That's we can.
You think it's ever been proven?
You don't have to get angry about it.
It's
not. You think it's ever been proven?
What I'd like to do is just rewind a little bit because you've said that you don't agree that.
Yeah, go AJ. Sorry,
science, but we have just.
Yeah, I keep getting distracted from these guys jumping in. Sorry, it wasn't meant to be between you and I.
No, but we have just gone over the definition of science and the scientific method, and then we can clearly see that it's not manifest. So in that case, and we can't use.
So let me respond what I was trying to respond.
How do you believe that is science?
Sure. So let me try and respond what I was saying before. So yeah, you outlined Newton, and then this other guy, Fritz. I think Einstein's middle name is Fritz, but I don't know if it's a different guy. Newton, Einstein, fucking Kepler, Hubble, whatever, dark energy, etc. But this is a building over multiple decades of understanding. But what you miss is that from Newton, when he first thought about this idea of gravity and mass and stuff, and came up with his not calculations, formulas for calculating different accelerations and movement of different stuff. That worked to a large degree. And people would go, oh my God, these calculations actually predict things and they can, they work. So then they use them for a while and they build a bunch of machinery and technology and stuff that work until they go, hold on, this one's not working anymore. This should work, but it's not. And so then someone has to go, well, listen, it's worked up until this point. Why isn't it fully explaining it? And so then they change it a bit, and they come up with different ideas to explain more and more things.
Theory of relativity to them making shit.
We need to go right back to where you began, because again, you said, this science is continuing on. It's growing. They're growing in knowledge. It's progressive, yeah. But the problem is from the beginning, from the scientific definition, and from the scientific method, we can clear that it's not even science to begin with. So whatever they're assuming or whatever they're doing still has nothing to do with science, regardless of what they're progressing with. It's not physical. Yeah, it can't be seen. Therefore, it's not science. There is no dependent and independent variables. So therefore, it does not meet the definition of science. So from the beginning.
What do you
saying
mean?
that, okay,
What exactly doesn't have a dependent and independent variable? Because if you haven't read the actual like Principia Mathematica and like the actual like scientific papers, like you're not going to be able to see any experiments and see which ones have variables and not.
Manipulated gravity. Read
it and tell me. But like, if you're just arguing from ignorance, it doesn't really.
Hold on, Deck. Hold on. Time out. Read it and answer it for me. Right? That's what you just said to AJ? We know this shit, dude. We know...
You don't, clearly, or you wouldn't ask me.
What's true. No, man. Listen, you're the one that's coming in here with your belief about the globe, about you living on a ball. That's your belief, not ours.
Sure, we're talking about gravity right now, right?
Yes, but do you understand how you're like proceeding with this conversation?
Listen, my point being is that you're asking me, there's no independent variable, there's no dependent variable. I'm telling you, if you look in the scientific paper, you will find the experiment and you will see all these things
find no
listed,
hypothesis.
Right?
There's no
hypothesis. You'll find no hypothesis.
Yeah.
Of course you will. Of course you will.
Why do you say that?
Because you need it for some. Science. People wouldn't accept it as a valid paper if there is no hypothesis, if there is no independent variable, there's no dependent variable. You can laugh. That's how. Okay.
Have you ever been in a
so
situation?
who has manipulated? None of these papers show us that. None of these papers show us that they have manipulated the cause. No one has
none of them are claiming that they manipulated the cause. You're dead right.
That's right. So therefore, if they can't manipulate the cause, there's no independent variable.
You don't understand independent variables, unfortunately.
You don't understand it.
You don't understand it, and you making that claim means absolutely nothing. Jump on the internet, go and have a Google, and find out whether it's the cause or effect that you have to manipulate.
Okay, I'll do it.
Good. Man, eighth
Well,
grade.
an independent variable is a variable you manipulate, control, or vary in an experimental study to explore its effects. Yeah?
And are you varying or manipulating the cause or the effect?
So, listen, the effect is gravity. The
effect is things go down. That's it.
That's a different experiment. Our experiment is what causes gravity.
Is things go down.
Listen, just hear me out here. If you want to experiment on this mysterious force that makes things go down, right?
You're making it up.
You can hypothesize in your hypothesis that what causes this force is the mass of the objects. Yeah?
Wait, what force?
No,
what
you
force?
can't. What's the observed phenomenon?
Gravity is a force.
The observed phenomenon is there is a force that is making things fall down. Yes or no?
Where?
So
what force?
You're saying the observed phenomenon is things go down. That's it?
The observed phenomenon is I dropped a pen and I observed the pen go down and fall to the ground. Now,
without any external object acting on it is important. So it seems like it's just done it on its own, right?
Well,
you're already you're already calling this gravity, but you're trying to prove gravity.
Yeah, you're already assuming there's a force behind it.
No, so listen, we understood that forces exist before we even thought about gravity, right?
No, Deck.
We don't have to say it is. What we're saying is that forces exist that make things move, and we understand that if something is
two separate issues. Hang on, now you're conflating two separate issues because gravity today is not a force; it's the bending and warping of space-time. So if we're discussing gravity, then we're not discussing a force. So there's no point in bringing up.
We're discussing what Newton thought gravity was, are we not?
Newtonian, but we're in Einstein.
We're talking about Einsteinian.
Yeah.
I thought we hadn't even got to Einstein yet. We're still talking about Newtonian. You said go back to the very start. I thought that's where we were starting from.
Newtonian gravity was thrown out the window.
Okay, well, listen, the cause of whatever we want to call gravity, whether it's a force, whether it's a bending of space-time itself, whatever you want to say, the cause of that phenomenon.
We haven't established that to exist.
Can we establish... Okay, well, listen, so let me get it straight. What you're saying is the initial...
Let's make it real
Can
simple.
I try and make it more simple so that you can say yes or no if I'm right?
Whoa, Deck, let him talk.
Okay, go for it.
No,
Pen.
We'll make it real simple. I'm holding my pen. I drop it, it goes to the floor.
Then go down.
You've now observed something. So from that point now, what do?
We investigate how other things move when they're dropped, I would say, is a good starting point.
They all go down. Great.
Hold on. I see what AJ is trying to say.
Yep,
AJ is
they all
saying
go down.
we observe and see the effect, and what we're trying to figure out is the cause. That's what gravity is. It's a hypothesis, a theory about the cause that's never been proven.
Okay, sure. So we're trying to find the cause of why things go down.
Correct.
Yep, not all things
cool.
go down though.
So here's what happens. You drop it and you go, oh, it goes down. So then you go, I'm going to drop it from slightly higher up. And then you notice, oh, as it falls, the longer it falls for, it goes faster. Right?
Okay, I dropped a helium balloon.
Yeah, it goes up.
Okay, sure. So it goes faster up until a point. And it rises quite linearly, and then it kind of plateaus. And you're like, okay, interesting. That's a weird phenomenon. So then you test other things. You test different shapes of objects, and you go, okay, things with a wider surface area fall slower, and they. Yeah, we're fucking getting there. Just chill out. So then you go, okay, obviously air is like getting in the way of this thing. So now we'll do it in a vacuum chamber. We'll suck all the air out, and now we'll drop stuff there. We'll get air out of the equation. And now we notice without air, things just speed up indefinitely.
Gas in a vacuum chamber.
We've just missed a shit ton of steps here. We're starting here at the beginning. So we've witnessed the occurrence. So what is the next step after we witness the occurrence according to the scientific method?
Oh, we can write it down. I mean, we are skipping a few things, but you tell me what you would do then.
Check the live stream chat real quick. Just check it. Look at what Donato just put. What's the first part?
The picture, the scientific evidence of gravity thing.
Mm-hmm. What's A?
A sunset, apparently.
The naturally observed phenomenon. What we observe. What's B?
Yeah, he's observing a sunset. Are we?
No, don't worry.
What's this got to do with the pen?
No, don't worry about what's in yellow. Just look at the scientific method right there. A. What do? We observe.
Oh, okay, sure. So observe phenomenon, hypothesis, independent variable, dependent variable, physical test, results. Okay.
Slow down. We're going step by step here. We observe.
I was just reading it all out. Okay.
We observe something, right? What's the next step?
We hypothesize about why it happened.
Right. Then what's the next step?
Independent variable. We change something about what happened and see what that changes.
Right.
And then the dependent variable is what we're measuring to see.
The control.
No. The control is different.
The dependent variable is the thing you observed.
The controlled is separate, is the things you're maintaining the same so that you can just change the independent variable so that you can observe the dependent variable.
Okay.
Yeah.
So when has gravity been tested?
Okay, let's use the pen example, right? So natural observed phenomenon, pen drops.
Yeah, that's a man-made object. Let's try an apple from a tree.
Okay, apple, rock, sure.
Right.
You understand naturally just means things in nature. We're a part of nature. Everything we make is kind of natural.
Yeah, it means not man-made. It means not man-made.
No, it doesn't. That's not what it means.
Yes, it does. It means
not in science.
Man-made. Yeah, look up the definition. It means not man-made.
It can. You're thinking about like synthetic versus natural. That's
science,
fair, but
hang on. Natural science is the naturally occurring world. However, there are other divisions of science, but we're not looking at those. We're looking at the naturally occurring world.
Yeah, so when you drop a man-made object and then something happens to that within the natural world, then the natural laws are underlying. Whatever, semantics. So, naturally observed phenomenon. A rock falls when it's dropped. The hypothesis. The heavier it feels in my hand, the faster it drops. Do we like that?
Yep.
Oh, I love it. Ooh.
Cool. All right. The thing that we want to change, the heaviness of the object
your
I'm
hypothesis. I got to stop you there. Your hypothesis must include your supposition of what's causing the thing to fall.
No, it doesn't. Absolutely not. It doesn't.
Yes, it does.
No.
Well, you don't have to, but I'd like to see how you then equate that to gravity at the end of this.
How could you possibly just come up with a cause for something you've only just observed? That comes way later. You have to do a bunch of experiments to figure out what you're actually observing first.
No, your hypothesis is the supposition of what's causing the effect.
No, you're wrong.
No, I'm right. That's why you have a dependent and independent variable.
No, it's not. The independent variable is to see how things change, or how the results change when you change things.
The independent variable, when varied, is going to cause.
You don't need to know the cause. The assumption is that we can't know the cause until we get more info.
Guess the cause. You're trying to guess what the cause is.
That's what a hypothesis is. That's what a hypothesis is.
No, a hypothesis is just. Listen, we can get the definition of hypothesis again, but a hypothesis is just a prediction. It's a supposition or proposed.
Cause and effect relationship.
I am wrong here. Apologies. Explanation made. I'm thinking prediction. I've gone into year 8 science mode. That's my bad. I'm sorry. A supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. Okay, fair enough. So without hypothesis of this, we could say. So our prediction, usually there's a prediction in here somewhere as well, but
the pen is falling. I'm going to assume, my hypothesis is that the pen is going to fall out of my hand because the pen is heavier than air. That's going to be my hypothesis.
Okay, cool. So a density argument.
Right. Density and buoyancy. You don't need gravity to explain that. That's why things go up and why things go down. Because of differences in density and buoyancy. It's that simple. Where does gravity come into play with that?
Well, you can't really separate buoyancy from downward forces. If there were if things didn't fall to the ground, then things wouldn't be buoyant.
If I drop an
or differently
anvil
buoyant
made of iron, if I drop an anvil made of iron in a vat of mercury, is it going to float or is it going to sink?
A good question. Is mercury denser than iron or no?
It will float. That's right.
Okay, it will float. Okay, cool.
Right.
But that is presupposing the idea that it will fall. And in this experiment, we don't want to do that, right?
Because of whatever object that you're testing, right? And whatever medium you're using to test that, basically, this is the hypothesis.
But this is circular. Do you understand? Because if we're talking about buoyancy in terms of, buoyancy happens because things fall, and the heavier the thing will fall more than the lighter thing. Sure, but that's presupposing the falling. If we're talking about why things fall, you can't bring buoyancy into it because buoyancy presupposes the falling.
Why do air bubbles float up? Why is it going against so-called gravity? Why do balloons...
It's a great question. I would say buoyancy difference in density. But again, that doesn't address the underlying problem with this, is that we can't use buoyancy to explain something falling because buoyancy itself inherently has things falling built into it.
So then let's continue on with this scientific method and show us where gravity then comes into play.
That's the proof right there.
Sure. So scientific hypothesis. There is a force that acts on the pen and its direction is down. Do we accept that or no? That could be a hypothesis, right?
Well, if that's your hypothesis, yeah, I suppose.
Cool. Okay. So let's make that my hypothesis. There's a force acting on the pen, makes it go down. And let's build into that hypothesis as well that the heavier the thing is, the more the force affects it, and the more it falls, right? We're cool with that?
So
okay.
weight. Weight is the cause? Is your proposed cause?
No, I'm just saying, so the hypothesis is that there is a force acting on the object, and that weight plays into the effect of that force, obviously. Like F equals ma type thing, force equals...
to have identified, so your independent variable is a force?
No, we haven't identified any variables yet. We're just doing the hypothesis.
You're supposed to be proposing the presumed cause, the supposed cause in your hypothesis.
Yeah, so the explanation is there is a force acting on the pen downwards.
Independent variable. So independent variable is force?
No, because we're not changing.
But you have to, because you're proposing that's what's the cause of the effect that you've just witnessed. So now you need to manipulate that cause to see whether it is that.
Again, independent variable doesn't mean that you don't need to change the cause. You just need it's just a variable.
Correct. You're 100% incorrect, and everybody here listening knows you're 100% incorrect. You have to manipulate the cause, not the effect.
No. So listen, the point is that we don't know the... Listen. We don't know the cause, right? Yet in our process of A, B, C, D, we don't know the cause. We're hypothesizing the cause is a force that the pen is falling. Now, if we're just hypothesizing right now, we don't even know how to control the force. We don't even know if it necessarily exists. The point of the test is to test our hypothesis.
Then you don't have a viable hypothesis.
No. Just because we can't change the cause. No. Just because you can't change the cause in an experiment.
Well, what are you going to do?
Doesn't mean you can't change other things to explore whether or not that cause is still happening in the same way.
So you're going to affirm the consequent.
What does that mean, sorry? Affirm the consequent?
So you're going to do something else and then assert that there was an unknown, unvariable force behind it.
Like dark matter.
Well, that's our hypothesis, no?
No, but you can't declare something to be true based on an observation. You must test.
That's the point of a hypothesis.
Hold on, wait, Dan.
No, it's not.
The chat real quick. Donato's giving you some good stuff there. Just read that real quick, man.
The hypothesis should also contain a prediction about its verifiability. For example, if the hypothesis is true, then 1 should happen when 2 is manipulated. Totally. First blank 1 is the dependent variable. First blank 1 should happen when. So the dependent variable, what you're measuring, depends on what you're doing in the second blank. And the second blank 2 is manipulated, is the independent variable, totally. You manipulate the reaction, 100%. Yeah, so nowhere in there does it say it has to be the cause. Nowhere in there does it say it has to be the cause.
Wait. How are you going to manipulate this so-called downward force that you're saying gravity is a downward... Oh, so then you don't have an experiment. You're not...
No, you're misreading what he's just linked. So the first blank is the dependent, what we're measuring. So in this case, we'll say our hypothesis is there's a force acting on the pen or on the object, let's say, on the rock. And if I use a bigger rock, it will fall faster. Let's say.
Identify the force.
Yeah.
We don't know why.
Because that's your supposed cause. That's your supposition. That's your supposition of what's causing your effect.
If you've never understood this before, you've just seen something fall for the first time, and you have no idea why, how could you possibly identify the force? You need to be able to...
Why are you so gung-ho on gravity? Exactly. Like, why are you so hardcore believing in gravity when...
We haven't even made up the term gravity yet. You understand, I'm putting myself in the mindset of someone who doesn't know anything about, or any theory, wasn't taught anything in school, whatever.
We're just assuming that... You're saying we're uneducated?
No, we're assuming we're uneducated. That's different to dumb. But yeah, we're uneducated, unknowledgeable. We are Newton level. No one's talked about gravity before. We just see things fall.
I think you're projecting a little bit, though.
Different sizes of rocks is independent variable. It's going to vary the size of rocks.
Yes, exactly. Yeah, it's an independent variable, 100%. So it's something you're changing to see how that affects the dependent variable, and the dependent variable in this case is the speed at which they fall, let's say, or the velocity.
The independent variable is the speed?
No, the dependent variable.
Oh, so size.
So the independent variable is the size, or let's say the weight of the rock.
You say weight. You could say weight.
Yeah. Okay, weight's a better expression. So we'll say weight of rock is independent, and then dependent variable is velocity increase or acceleration increase, I guess.
Weight causes velocity or acceleration increase.
Wow.
Well, probably acceleration increase is better rather than velocity.
Okay, so weight causes acceleration increase.
Well, an increase in weight will increase the rate at which the object accelerates.
Right, so you're going to vary the weight. You're going to vary the weight of something.
Yeah. So we'll get a light rock and a heavy rock. And to make sure they're controlled, we'll get a... Let's not make them rocks. Let's make it a ball of steel and a ball of titanium, let's say. So that they're the same size, the same volume. So that's a controlled variable. We're making sure that that's not coming into the equation. But we're just changing the weight of it. Make sense so far?
No.
So weight causes acceleration. Right.
Okay. What does it make sense? So we've got a dependent variable. We've got an independent variable, right? And now we just need to do our test, correct? To see if our prediction is true. Our hypothesis.
Okay, what is the test? What is the test?
Okay, so we drop both an iron ball and a titanium ball from the same height, and we them at the same time. Our prediction is that because the titanium is heavier, I think titanium is heavier, maybe it's lighter. Because the iron is lighter, the iron is heavier, the iron will fall faster than the titanium. And cool. So we're changing the mass, we're measuring the speed at which they hit the ground. Which one hits first?
You've changed the weight. Are you defining
the object we're dropping? Yeah. Yeah, we're equating them in this instance because we don't even know gravity exists yet, right? So we're just saying, I hold this in my hand, I put it on a scale, this one is more than this one, right? It pushes down on everything. Yeah, we'll say weight. Sure. So, we drop those two things from the same height and we measure the results of the test. Now, our prediction was that because one was heavier, it would fall faster. Interestingly, it didn't. So they both hit the ground at the same time. That's our result. And we go, interesting. Our hypothesis was wrong. That is a good observation.
You proved your null hypothesis.
It wasn't a null hypothesis, it was an actual hypothesis.
In a scientific experiment, there must be a null hypothesis.
Apologies, what's the null hypothesis? That it doesn't affect it.
It's the antithesis of your prediction.
Sure. So the null hypothesis was proved to be true. That weight doesn't affect the rate at which things drop.
So weight doesn't call acceleration of a falling object.
An increase in weight doesn't increase the acceleration, yes. So that's our conclusion from that experiment. Sound good? Yeah? No? Yes? No?
You're doing an experiment, man.
We finished the experiment. We're done. That's our conclusion. So are we happy that was a valid scientific method and experiment that we just did?
How do you test?
Yes, let's just move on to using...
Someone said yes or no. Is that a good experiment to do? Or like a valid one that we can trust the results of?
No.
So why not? Why doesn't that experiment work?
What experiment?
The one we just meticulously described step by step about dropping an iron and a titanium ball. I don't know why you're playing dumb. You know what experiment I'm talking about.
Okay, so now let's then move on to that same...
Why are we moving on? What are we moving on? Like, tell me yes or no. Is that...
You've proved density and buoyancy. You've proved that
something... We're not proving anything. My question is that a valid scientific experiment? Yes or no?
Okay, so you've proven that weight doesn't call acceleration.
Yes or no? That's just two options. I want to know, does that experiment...
You want us to concede? Is that what you're yelling about? You want us to concede?
There's no concession. I'm asking this experiment that we constructed together and just did, that we could replicate. Yes, okay, cool. So that experiment is fine, valid, we accept the results of it. So just then, what we've established, right, is that if there is a force that is acting on this object, any object, the weight of that object doesn't affect the rate at which it accelerates the ground. That's a good piece of data when we're trying to investigate this natural phenomenon of things falling, right?
No, what do you conclude? Why are you concluding that? All you've done is just said that weight doesn't...
Well, any information is good information relating to the thing. I think it's a very innate intuition that we have as humans that heavy thing should fall faster. So it's, yeah, exactly, we do. And that's interesting. So now we've got to go back, change what we said. Or at least we've got to go back and use a different hypothesis that has a different independent variable in order to test different aspects of it.
No, the independent variable is testing the cause again, so it's going to be testing your hypothesis.
Well, no, it's not the cause. We understood that...
The independent variable that you're varying is your hypothesis of what you believe is causing the effect. That is the most simple thing to see, read, and understand, that you just don't seem to understand.
Yeah, I understand, but the cause we're talking about here is the weight of things.
You don't say you understand, because every time you say that, then you change what you're saying, and you try to tell us that it has nothing to do with your cause, but you're going to manipulate the effect, so you don't understand.
No one is saying, well, the experiment we just did then was not manipulating any effect, we were measuring the effect, and the effect was how fast they hit the ground.
Because your hypothesis was that the weight of the rock was going to make it fall faster or quicker, yeah? And then you manipulated the weight of that rock, you manipulated the rock, the cause, and you found that that didn't occur, you proved the null. So now, when you propose your next hypothesis, we need to vary the hypothesis to see if it causes the effect. And
cool.
Null or not.
So are we trying to figure out why things fall in general or why they accelerate?
Well, he was trying to show us gravity, but he was just starting in the beginning with his showing...
So he was just trying to establish a scientific method that you guys brought up first. Donovar, or whatever his name is, posted the the thing in with the scientific method ABCDG. I was asked to go through it, and we created an experiment.
Yeah, so you understand that. Sorry, you understand that things that that solid objects falling through a medium is what's on the table here, because not everything goes down, not everything falls.
Great point. Very true.
Some things remain at equilibrium, some things go up, some things go down, some things go in all directions.
Well, so far we've
Definitely.
only talked about rocks, so this is where we need to move on to the next hypothesis.
Well, we're talking about metal balls or different things, but yeah.
Balls, not rocks, metal balls, but okay, your metal ball example, yep, no worries. So now we need to, the whole point of this conversation is for you to show us the science and how gravity, the cause, is varied.
Well, we haven't named gravity yet, but we're assuming that there's a force acting on it, right?
Yeah, now we understand this when you drag it, something shocking, I just...
I have to, because otherwise you don't understand what I'm saying, and then you assume I'm like committing fallacies and frauds and stuff.
I haven't pulled you up any fallacies, I know exactly what you're saying, just burn through it, man.
Cool, man. Okay, cool. So anyway, the fact that we can create a scientific experiment like that, where we all accept cause, effect, independent variable, etc. We make a bunch of these different things. We change different independent variables. We change dependent variables. Sometimes we throw it up. Sometimes we add a bit of horizontal velocity to it.
When you're wrong and you're pulled up, you need to stop, because again, you try to slip in there about these dependent variables. There's only one thing that we're manipulating, and that's the cause.
Which is the independent variable.
Yes, but that's not what you just actually said.
Okay. Pretty sure I did, but cool. Okay, here we go. Assign new evidence. So rock falling, same equals more weight, more acceleration. Independent variable, weight, dependent variable, acceleration. Physical test. Yeah. Fine, rock it. I know what you're getting with. But one result failed. Cool. So now we know from the experiment there is a 9.8 meters per second acceleration downwards, right?
No, we have an agreed upon average of 9.8 meters per second, because some things go up, some things go down, some things remain buoyant, and 9.8 meters per second is not always the case in different locations and different places.
Sure. I don't know if we included it in a previous experiment, but we did. Well, we should have conducted it in a vacuum, right? So we should have gotten rid of any.
Okay. I let go some gas in a vacuum. I let go some gas in a vacuum. It didn't fall at 9.8 meters per second. What now?
Good point. Very interesting. How do we measure the... Well, for one, if we did drop carbon dioxide in a vacuum, it would fall at 9.8 meters per second. Right?
No. In what state? In what state of matter?
Oh, gas. True. It would expand, fill the volume, I think. Let's figure it out, actually. Carbon dioxide. Got all these results are about greenhouse gases and things.
From my understanding to this point, everything you have is just a belief. You trust what you're told, and no matter what you have seen or been shown, that you are going to somehow continue to defend that belief and do the mental gymnastics required to convince yourself.
Yeah, I could say the same to you, but yeah, is what it is.
All right.
Amen.
Cigarette. Hey, Deck.
Yo. Good Sigma.
How old are you?
I am 21 years old, 22 in November.
Okay. You going to college?
How old are you, Beasticles?
I'm 28.
Nice, man.
Well, I'm 43 and my son's nearly your age, so...
Represent. What is your son up to? Is he at uni?
No, he works with me. He's an apprentice.
Ooh, doing what?
We do signage.
Ooh. Like painting it and stuff? Or like do you peel that shit off and stuff like that? Or like actually installing it?
Mainly vinyl and wrapping cars and all that sort of stuff.
Is that satisfying as fuck?
Deck, are you okay?
Like getting that layer off? Oh, true, yeah. But if it gets good, yeah. Sorry, Beasticles, what were you saying?
No, let's do what AJ said. Let's get back to the debate, to the conversation.
I thought that's what you were saying.
Well, I was just curious about your age, but okay. So now that you know and you've accepted that what you hold in your mind is a belief, right? It's a belief.
We've already... A belief by your standards is in without evidence. I still don't think it's without evidence, but sure. We have different standards of evidence.
Again, where's your evidence of gravity, of you living on a ball?
We're not going to go over this again. I've given it all. I count that as evidence. I understand that you don't. We have different levels of proof. You need to do it firsthand, be able to measure it with your own devices, etc. You cannot trust other people or institutions to combine and create scientific... that's not in your mind valid enough. That's fair enough. In my mind, it is. That's where we diverge. That is what it is.
Listen, if institutions, so-called institutions, or anybody that is actually using the scientific method to take an observable phenomenon, a natural and observable phenomenon that we experience, right? Form a hypothesis about that, of why that phenomenon was caused, have an independent variable, basically control the cause, and the dependent variable to measure the effect and see if you can repeat that test. That's like fundamentals. You kind of have to have that in a discussion like this. And I'm just like I love all of your guys' patience, including yours too, Deck. But I think
thanks, man. You're very patient as well.
Well, I'm honestly new here. So, but new in terms of being able to have these kinds of conversations and kind of seeing how they unfold. It's pretty bewildering, or baffling. I don't know what to say. I give up. But I hope you have a great rest of your night, Deck. I hope you come back to this.
Yeah, man. I've popped in a few times, actually. It's good when it's not just the same people. I've come with, that one guy, Mayhem 100, whatever his name is, Miggy. He doesn't like me very much. But, yeah, I do enjoy having these conversations.
You got to understand that it's not that Miggy doesn't like you. It's just that we deal in reality here, and we deal in science, and we deal in the scientific method. And when someone comes in here trying to debate on beliefs, then Miggy is someone who's definitely going to hold you to account and not let you move.
Yeah, he absolutely does that. I'm well aware of that. And he does it without a degree of understanding or letting his boot off the throat of your neck to even get something out. And when I join, he plays air horns and plays like repeats of like things I've made mistakes with in the past. I count that as like a personal kind of thing, but you know, up to you. I wouldn't say he's forgiving, at least. But anyway, I'm glad that you guys take a bit of a different temperament to other people. But I'm also glad that there's a nice wide variety of different personas in this server. But yeah, thanks for having a chat with me. Anyway.
Valve, Flying, you guys want to say something?
I guess I just have one question. I don't know. I've just been mostly listening, but I'm curious, Deck, what would it take for... Maybe this is just such a nonsense question to even ask. What would it take for you to actually see the flat Earth in like a reasonable way? Like to see...
Interesting question.
What would it take for you?
I mean, I can't really say what it took to get me to believe or know that the Earth is round, right? Like, I wouldn't be able to give you a step-by-step of, like, when I was 4 and I was shown this and that and blah, blah, blah.
You don't.
So how I would actually be able to deconstruct all that and then build that up again from a flat Earth perspective would be interesting. I mean, for me to, like, invalidate the idea that the Earth is a sphere would have to invalidate, like, all the laws of physics that I know to work and underlie the things that I see every day, right? Like, it would completely disrupt my reality, right? So, like, even the simple idea of, like, things in space without any force acting on them will be attracted to each other, and that naturally forms spheres, which is why we get planets, stars, fucking black holes, etc., which are all spherical because of the way forces equally distribute equally out in all directions, right? Sure, you know, yeah. I know it's semantics, but what I'm saying is from my perspective.
I just kind of want to hear other opinions.
Yeah. No, I'm with you.
Can you kind of see why it's frustrating when you're asked of like proof of a globe? The first things you go to are lights in the sky, and other people have done science, and those lights in the sky are planets for sure, and what we're on right now is a planet as well. You can see how that's kind of frustrating, right?
I can understand why that becomes an issue for people. All I'm trying to do is answer as truthfully as possible as to what comes first to mind, as to why in my mind I think it's a sphere, and it's because when I think of all these other things, they're all spheres, and I have reasons for understanding why they came to be spheres and blah, blah, blah. I understand that's all based off of belief. The religious science institution and belief. Yeah, we get it, dude. Yeah, sure. But yes, I understand the frustration.
Real quick, what Valve's question... Yeah, what Valve's question was, is just like, why he said, what would it take, right? And what you said was, what would it take for you to go back to when you were 4 and essentially unlearn? Like, you're not saying it, but it's you know what I'm talking about. Like, you have to unlearn everything.
I think about it in terms of like you build like a Jenga block of ideas in like a belief system as you live throughout your life. Each idea connects and builds off the other as foundations. Blah blah blah. In order to think that the Earth is flat and everything I've been told is a lie and all the physics I've been taught is a lie is like pulling the bottom Jenga piece out and then going, oh fuck, right?
Well, the thing is, it's not about the physics part.
You haven't done that. If you'd done that, I'd be having a mental breakdown. But I appreciate it.
It's not even about the physics part per se. It's what you said just before the physics part that been told to you is a lie. That's the reconciliation that you need, especially if you've been here already, that you really need to focus on. It's not about why would they lie.
When I say that, I mean more everything that I've been taught in the way I think about natural phenomena and how they interact. I understand that most of the shit I hear from media and the government is complete garbage.
How they connect. You don't even know how they connect. You admitted that it's all just a faith that you have in some guy that said something.
I'm saying that because I know that's what you believe, and we don't need to go into the viscera of the conversation. We understand we disagree. We're talking about something else.
You admitted it.
I said it doesn't mean I believe it. Okay. I said it for the sake of you guys, but anyway, basically.
You said it because you didn't have a fucking answer.
Like, do you see why they're being curt though, Deck?
Yeah, because everyone they meet every single day tells them they're a fucking idiot and that they're, of course.
There was at
I
least
understand.
6 or 7 people today. I just fucking reading through it every 30 minutes. It was pretty funny, actually.
For me, it's frustrating, and it's got nothing to do with people calling me an idiot because I really couldn't give 2 fucks what anyone thinks about me. But
well, that's good. Yeah, that's good.
That's a good
It's very frustrating when I'm reading the scientific method and I'm reading about independent variables, and you're just not accepting that, and you're just putting your own spin on it that suits your belief. That's frustrating.
But the thing is, it's just as frustrating for me to hear you guys do the exact same thing. To me, it seems like you read all this stuff and you put your own spin on it in the exact same way that it seems to you. I read it and put my own spin on it. That's just how stuff works.
How do we put our spin on it? How do we put a spin on it? What do we put a spin on?
Yeah, there's no spin. We're reading directly from what it says it is. You're arguing with
you guys. Listen, you're currently arguing with the idea that every single human being doesn't put their own spin on every single thing they do, which they absolutely do, including yourself.
What we were just speaking about, because we were talking about reading out the scientific method step by step, and you not accepting that scientific method.
I accepted it, and we created a scientific experiment that we both accepted, so we can understand that we both accept the same scientific method of inquiry.
And then we tried to move on, and you changed again the meaning of that independent and dependent variable, and we still didn't actually get to the whole point or crux of the conversation, which was you were going to show us how we could use this scientific method to prove gravity, to confirm gravity, yeah? And we never got there either. So that's what's very frustrating when you continually change what.
Well, that's fair enough. And I'll concede on this that the idea of creating a physical experiment where we can manipulate all the variables involved with it and have complete control over controlled, independent, dependent, etc., isn't going to work.
Well, this is my issue. What are all the variables? Because the variable is, again, your hypothesis. So
yeah, exactly. The variable is dependent on the hypothesis. Exactly. You're right.
No, you're testing the hypothesis.
And therefore the variables are dependent on what you choose to be the hypothesis, because then you have to change the variables that you're measuring.
You said you've been here multiple times, right? With
3 or 4 maybe. Okay. Yeah.
Has there been any conversation that you've had in your 3 to 4 times, anything that made you kind of have a second look at what information you hold dear in your mind, regardless belief, whatever the definition of belief, however you want to I'm just saying, has there been anything that you're like, maybe these guys are onto something? Anything like that?
Yeah. I mean, I'm sure there's a few things that I see going past in the chat that are a random fucking meme with some text over it or whatever, that I'm sure have grains of truth to it. And there's obviously a lot of things that are covered up by the powers that be in order to keep the population under control, and that they keep getting the money and the power and everything, of course.
So Deck, so you understand that you're essentially in a cult, right?
But if you don't understand that flat Earth is somewhat cult-like as well, we're all in kind of cults of different things, personality, ideas, etc. We're all going to be subject to different things. I would say this Discord in particular is a lot more culty than other places you'll go to, only because if someone speaks out with a different idea, 5 people speak up and say, no, you're wrong, here's why, blah, 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 spamming. That's somewhat culty, all right, in nature, but sure.
Hold on, man. Hold on. Okay, so
being right is in being in a cult. Oh, okay.
Yeah, I mean, people in a cult would say the same thing. Is my point. Like, you can't really tell the difference when you're in it.
And again, you're just assuming. You're just assuming all this stuff. You know, I had nothing to do.
Well, I'm saying I'm victim to that as well. If I'm in the cult of science, then I'm blind to why it's a cult. And if you're in the cult of flat Earth, you're blind to why that's a cult as well. I'm just saying.
Hang on. So
why is flat Earth a cult?
Yeah, why is the truth a cult? And again, I don't believe I'm in any cult because, like I said, I'm 43 years old. I've believed or known this for a very long time. And I came to that conclusion through my own observations being out on the ocean for a long time and seeing different things. I won't go into that, but
please do.
And then further looking into it and doing these things. I've been on Discord here, if you check my profile, for about 6 months, and I really had nothing to do with any flat Earth groups prior to this. So, you know, to say that I'm hanging out in this cult of beliefs of flat Earthers, I was on my own with everyone telling me I was a fucking dickhead.
I'm sure you are. Yeah.
Well said. And Deck, the same for me. I've been a flat earther since 2014, and it had nothing to do with this room. In fact, every flat earther who comes to this room is very excited to find a place where other flat earthers hang out.
I have no doubt at all.
There is absolutely nothing that we talk about here that isn't just repeatable and testable in nature. So we're just observing reality. How is that a cult? You need to be indoctrinated to be in a cult. There is no indoctrination here.
Yeah,
you don't necessarily need to be.
My cult leader, right, is observable, objective, measurable reality.
Well said.
Okay. Yeah.
Whereas what you believe is very cultish because, like we said earlier, you have to be taught all of this stuff to build your belief system. Whereas in flat Earth, you have to strip away.
Honestly, tell me though.
What we do is we actually try and get you to get rid of this indoctrination and use your God-given senses to determine where you are. That is not a cult. That is called science.
Yeah, sure, but you've also got to see it from the perspective and have like the understanding, you know, that looking in from the outside, what you see is people come in and then without tell me honestly, how many of you guys have individually come up with all these scientific explanations and things that you post in the chat constantly, all of them, or a couple of them? Because there's no way each of you has individually tested every single thing that you post on here, right? So there's some ideas that get thrown around and distributed within this. I'm not saying it's a bad thing, it's an inevitable thing. And I'm sure there's plenty of people that sit here with their mic muted, just listening, taking it in. They've never heard most of the explanations you guys use when describing flat Earth. They haven't heard it before. They hear it, and it is a form of them learning, right? In the same way that they could be sitting in a science class and absorbing that. They're absorbing different things. But to think that you're different and separate, it's very egotistical, is all I'm saying.
Deck, because again, let's give the example of tonight. Someone says to me, hey, AJ, this is what the meaning of science is. Or let's just say I do listen to I read one of these things in the chat, or I listen to a YouTube channel that says something, right? It might be about gravity. It might be about relativity. You know, I even listen to globe channels that speak about these things, yeah? And then I go on and I'd go and research it for myself. If there's something that I can test and look at and do, I'll go and do it. If it's something about science, like tonight, I can go on and I can read the scientific method. I can read further and I can actually see what the dependent and independent variables are and what's manipulated. Yeah. So then I've learned something and I've accepted it. The difference is that when you seem to read that, you don't accept it.
Yeah, sure. The same thing says when you read and accept a globe thing, you don't accept it either. Like we're doing the same thing.
We're testing that and we're looking at that. Okay, for example, is gravity scientific? No. Purely no. We can see that through the scientific method. So that's a belief that you've held your whole life. This is what
that I still believe. And until I stop holding it, which I don't have control over, I don't get to snap my fingers and choose when my belief changes.
You do have control over it, brother. That's my biggest thing. It's like,
I know. I feel like I disagree.
We want you to come to these conclusions on your own.
That's the ultimate goal here, man. Is for you to open your eyes to your own reality, not trust anybody to tell you what you're observing and what you're feeling and what you're experiencing in reality.
I'm with you there. It can be an interesting, but like I've certainly gone on that path myself in a different, obviously not on a flat Earth.
It's you said how you're nearly there. Do you see how like your own like? Do you understand? Like,
yeah, I get it, man. I get it.
This is a self journey, man.
But Dec, for example, you're saying that we, sound a bit cultish, right? But it's only because we have refined the arguments. We've been doing this for years, and when I say we, flat earthers have been arguing and discussing with globers for years, and now the arguments are well understood by flat earthers. They're not as well understood by globers. Questioned, but these are the questions that we've been answering since well before 2015. So all you're seeing is refined arguments. For example, gas pressure. The second law of thermodynamics, which I hope you're aware of as well, states that you can't have gas pressure next to you can't have high pressure next to low pressure without some sort of containment. This is not a cultish idea. This is something that flat earthers have discussed and begun to question, because the heliocentric model goes against the laws of science.
It doesn't.
So
we can go into that if we want, but
basic laws
we don't have
of science. But listen.
But listen. No. I get what you're saying, and I understand that you've gone through all this very particularly, and you've been refining it since before 2015. Could be 1980. Could be 1950. Yeah, sure. But it's definitely not longer than regular science, which has been doing it for thousands of years, right? Like, you can understand that.
Hold on.
It's not the point. It's not the point. But can you recognize the fact that, yes, you've been doing it for a while, but so has the other science, right?
Dec, you got to calm down, brother.
I'm not particularly hyped up.
You're getting a little hyped up, but it's okay. This is what we call cognitive dissonance. We all had to go through it at one point or another when we first came across contradicting information about what we were being told our entire lives and shown.
The gas stuff is not contradictory to me at all. I understand it, and it makes sense to me.
Just hear me out.
There's no cognitive dissonance happening there. But sure, go for it.
Hear me out, though. What you're experiencing is the fact that if we are telling you the truth, right? Just assume for a second we are telling you the truth, right? What are the implications of that in your own life?
It's a lot.
We're telling you it's a lot, right?
Big time.
It's a lot.
That's honest.
I definitely want you to seriously consider the possibility that we are telling the truth and how that would affect everything that you experience in your life on a day-to-day basis. Who's telling you what to believe, what to eat?
Yeah, man. Yeah. I know, dude. I get it.
And it puts the burden of responsibility for your life on your shoulders rather than authoritative. And people don't like that.
Yeah, they don't. It's very
You don't like that.
I'm sure. Yeah. Right? Humans as organisms don't like the idea that the model that they've previously built up could be wrong and that they have to change it all. Absolutely.
But just you personally, from me to you, just hear me out, man. Like, do you want to rely on other people your entire life, or do you want to have some?
Yes, I do want. Not only do I want, but I think it's inevitable that I will have to rely on other people to trust that they are doing their job correctly. It doesn't necessarily have to be the people above me or in authority places, but I think it's inevitable that you have to trust some people.
At the end of the day, you are the only person that is responsible for you. That's it. No one's going to help you in this life. You can't trust anybody to tell you what's best for you. No, your family members, your friends, your teachers, your boss, nobody else. That is.
I think I disagree. I mean, not only you know for sure what's right, but you can accept advice from other people, and oftentimes they do have good advice.
You can have friends. You can have opposing ideas from other people and listen to that. But at the end of the day, you are responsible for you. Go ahead, Root.
Exactly. And once you sort of subscribe to the idea that, oh yeah, everybody else is smarter than me, so they can figure this out, you actually give your power away. You're actually assuming that you can't figure this stuff out for yourself. We're not saying you have to go and buy all this equipment and do every experiment, but you should verify whether these experiments fall under the category of science or pseudoscience, and you need to be strict. There needs to be a scientific method adhered to. Otherwise, you're dealing in the theoretical realm. So when you get into a debate or you're trying to figure out the truth in a situation, then really, if you can't find any actual real science backing this theory, then you put a pin in it and you say, maybe, possibly, but this can't be considered truth. This can't be considered science. And I think you need to be very careful taking that step by saying, oh, this is settled science, when it doesn't have an experiment.
Right back at you, buddy. 100%. I'm with you.
So when it comes to the globe, we have there are three areas where you need scientific proof. You need proof of drop over distance. You also need proof of the Coriolis or movement of the Earth. Okay, and finally, you need to be able to prove that space can exist next to an open system. If you can find science that backs any of them three, then
I can do.
Then you can start saying, right, okay, I have something tangible here, so I can go and verify it. This doesn't mean that you have to go and do every experiment yourself, but it means you need to go and find enough evidence to build what you can consider is proof. So without that evidence, you can't say you have proof. That's our argument.
Yeah, I can do the third one for sure.
No, theoretically, I can tell you why you can't, because you can't do an experiment proving where gravity, because your claim, without, I don't know if you realize it, your claim is that gravity is the container. Yeah, your claim is that gravity is a physical barrier. So
my claim would be that
shows this.
Listen,
that
without telling me my own claim, my claim would be that any object, regardless of if it's gas, liquid, solid, is affected by the same acceleration that we can measure on any object that we drop. That would be my claim.
No, that would be against gas law.
It wouldn't necessarily, no.
Well, it would, because gas, when released at the surface of the Earth, travels in all vectors with
This is true.
no
Yeah.
reason. Yeah, so
but the gas is not an individual object. Gas is comprised of trillions of objects.
For example,
Gas
I'm
has
addressing
mass.
your own example.
Gas has mass, and if mass attracts mass, then gas should be going down. Why does gas go up?
Gas. So again, when you say gas, you're talking about like a cloud of gas. But the difference between a cloud of gas and like a bucket of water or
Where is oxygen made?
Where is oxygen made? In the sun?
On the Earth, on the surface, yeah? So
Where is elemental oxygen created from? Is that your question?
Where does it, on the Earth?
Gases are made at the surface, yeah?
Where are we getting this oxygen from? It's made at the surface of the Earth, yeah?
No, it's not made. It's been there for billions of years.
Oh, yeah, whatever. We've got trees doing their thing, whatever, okay? We're picking at straws here.
Yeah. Well, I'm answering your question. I don't know where you're going through it, so I'm answering as honestly as possible.
Is it the surface of the Earth?
There is oxygen present in the air at the surface, for sure. Is that your question? Sorry?
It's produced.
It's
produced at the
produced,
surface
yes.
level.
Sorry, wrong word. Produced, thanks, T-Dub. It's produced at the surface of the Earth, yeah?
Oh, is it like an O2 gas molecule? Where's that produced from?
Yes.
Yeah, trees at the surface of the Earth, algae in the oceans, etc. Yeah, for sure.
Okay, cool. So now there's no downward bias there, where gravity's at its strongest at the Earth, and then all of a sudden this atmo...
Well, you're making a claim there. You're making a claim there that there's no downward bias. Downward bias is in like downward force vector. Is that what you're saying? Is that the same thing?
There is no downward. Yes, there is no downward bias. Gases and the atmo move in all different directions. There is no downward bias.
But there is though.
They run into each other or the walls of their container.
Yeah, but listen, if you separated an individual gas particle in a vacuum and you could track that individual gas particle.
Are we talking about here individual gas particles in a vacuum, or are we talking about where oxygen is generated at the surface of the Earth? And there is no downward bias vector of what we're observing, and that's part of gas law.
Listen, scientific method means we need to isolate as many variables as possible. When you're talking about oxygen released from a tree in the middle of the atmosphere and wind and stuff, that's too many variables. You can't really do a test on that, right? So in order to do a proper test on how gas particles...
Gas has a downward bias due to gravity.
That is correct, yes.
Well, you're completely incorrect, and you're going against gas laws, so it doesn't matter.
Okay, I'm not.
If I fart, does it fall?
It does, because the sulfur dioxide gases that you produce in your fart are heavier than nitrogen and oxygen and stuff, so it kind of sinks to the ground, I think.
You think? Okay.
No.
That's my understanding. I could be wrong there, but I'm pretty sure.
Because when someone farts in my house, it just seems to waft and linger around in the air for quite
That is also true. Yeah, you're right. Obviously, the gas in a room is completely diffusing. You're true. But like, say, like for example, the towns that like get fucking gassed from carbon dioxide expulsions from like geysers and shit, that like, or volcanoes or whatever, and like the gas kind of rolls over the town and suffocates them. That's an example of like gravity affecting different densities of gases. When there's enough gas. No, of course it will eventually disperse, but for the time that it is there, it will be at the bottom of the...
Why would it disperse? Are you saying that gravity is fickle and actually has no effect on gas?
No, I'm just saying that over time, entropy tends to lead to things not being ordered. That is obviously going to stop being one big cloud and eventually ping off and disperse amongst everything.
Oh, so gravity is very selective, right?
No, gravity is just very weak. It is a weak force, and, well, if you want to call it a force, but the effect of gravity is very subtle. And when you're talking about individual gas molecules, they're barely affected by gravity if we're considering it having a very low mass. That's my understanding of it, at least.
I don't know what the fuck you're talking about, to be honest.
Oh, I do. So
when you release something into our atmo, okay, let's just say it's a car tire, a gas cylinder, like a propane cylinder. I don't know where you live, but gas or propane.
Where do you think I live, mate?
I think you live in Melbourne or Sydney.
Perth, mate. But yeah, sorry. Go on.
Which one is it, Melbourne or Sydney?
It's Perth, you dog.
Perth?
Fucking WA, mate. Up the dockers.
Yeah, you fucking dog. Sorry.
Yeah.
Jeez,
anyway.
I got that one wrong.
Well, happens. There's only like 4 or 5 of us in Perth anyway, I think.
You just sounded a bit Melbourne-y there. It might have been Tim.
Yeah. No, if I put on my like deep Aussie accent, God knows where the fuck it's from, but my natural speaking voice isn't that deeply
so anyway,
regional. Anyway,
gases into the atmo, then they will travel in all different directions, like you just said. With someone's fart, it's going to disperse out, and some may eventually settle. Okay, but the fact is that there is no downward bias. Okay, and what the claim is that these gases travel in all these different vectors, and they're traveling higher and higher and higher away from the Earth, where gravity is becoming weaker, and then somehow gravity then contains these gases and creates a downward bias. So again, nothing to do with science.
Not what I'm claiming, but similar, I guess. If I can articulate. Yeah, how would you know what I'm claiming if I haven't even made the attempt to claim it yet? My claim. Listen.
Hang on, you're claiming a globe, and that is what the globe claims.
And therefore, you know exactly what I'm going to say. You've thought of it all in advance.
Well, then you don't actually agree with the.
It's hubris, my friend. No, the point is you just don't quite get it. If I could, let me just lay out the claim first, just so I can be completely clear. What I think is that when you consider gas as a full thing within a system of other gases, of course it's going to disperse, it's going to be very hard to track, and gravity isn't going to affect individual things. But when you're talking about individual gas molecules and their individual velocities and paths and things like that, in a vacuum, they are going to be affected by gravity. Obviously, it's very difficult to observe that very subtle change because of the very small mass, and of course, they're going to bounce into a trillion other gas particles in the atmosphere. But the point is that that effect averaged over the entire circumference of the Earth and the distance of the atmosphere, which is hundreds of kilometers up, right? Well, okay, not gravity, but whatever force or thing that makes the pen I drop fall. There's no reason it wouldn't affect gas, but it would affect a pen when I could like vaporize a pen and make it gas, right?
We can't measure it, but we can
observe it. I can watch my pen fall. I can watch. If I had a tube that extended all the way up into the atmosphere, there was a vacuum tube, and I put a single
I'm gonna go, man.
bit of gas. I see you, bro.
See you, G-Dub. Thanks, man.
If I put if I put a gas particle in a tube that extended up into the atmosphere, you would notice that even if it was going straight up and shot up with X amount of velocity, it will decrease as it is affected by this acceleration that affects all objects. And that's true. It can be observed. Obviously, you've got to trust your instruments and the things that can detect these particles at such a small scale, because our eyes can't. If you can't, then obviously you're not going to be able to do that test. Fair enough. But if you average that effect over an entire like system of gas, which is fucking billions of cubic meters and all this kind of stuff, it does become, when you treat it like a large, massive object, like all that gas, yes, individually the masses are very small, but when you count all the gas up in the entire atmosphere, it's going to weigh billions of tons. That, as a whole object, if you want to treat it like that, is absolutely affected by gravity because of the large mass of it, and it gets sucked in. You won't trust me on.
Then why aren't clouds pulled down? Because clouds.
Because clouds are very small. Clouds are very, very small in comparison to the entire atmosphere.
Can you just check for me what the weight of a cloud would be that's full of ice?
Sure.
And water?
You're talking about tons of oxygen.
Clouds are fucking heavy as shit. Yeah.
So they're not affected by gravity, but you're saying that mass is affected by gravity, and that these big masses in the sky would definitely be affected by gravity, but now we have clouds that aren't.
Well, they're absolutely being affected by gravity, but gravity, again, is very, very subtle. An individual cloud, while it is very, very heavy, like I've got here 1.1 million pounds, I don't know what that is in kilos, but if you compare that to the rest of the atmosphere, or say the rest of the air surrounding it, it's also going to be very, very heavy. And the density, of course, will line up with the fact that the density of a cloud is going to be less than the density of whatever air it's sitting on top of, because that's how it works, right? Obviously, the water that's evaporating off of the surface of the ocean is going to make the air below the clouds very, very dense, and thus the clouds are going to kind of hit this invisible, quote-unquote, wall of more dense air. But point being, when you take the entire atmosphere into consideration, which has billions of clouds, billions and billions of kilograms, etc., it's all going to be vectorized downwards towards the closest center of mass, which is the Earth. And in the same way, I know you won't trust this one, but Jupiter, Neptune, Saturn, etc., we know through spectrometry and samples and stuff like this, if you don't trust the probes, obviously the samples don't matter, but that there is gas in them. They're comprised of certain gases. Those planets are mostly gas, as opposed to our mostly rock planets and Mars and Venus, but they still stay together. They're still circular. Our sun, we know, is definitely fusion of atoms that is creating energy, heat, light that is coming out of us, and solar waves and blah, 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 blah. That is all a big ball of gas. That's definitely a sphere that's staying there. And that's much, 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 much bigger. So, and that has like what, 98% of the mass of the entire solar system.
How do you know any of those? How do you know any, like...
I gotta say, this is just dish gallop, man. This is just.
What can I say? I'm heavily indoctrinated. Sue me.
Are you
I've been
medicated?
indoctrinating myself since fucking
I'm
I
trying
could
to give you the
read.
benefit of the doubt and listen to you. This is so...
I'm
You're lost in it.
I got to ask you
You're so lost. So, ask questions, man, because I can explain it for you if you want.
No, I'm
you don't
saying
have to
you're lost
believe
in
it.
I'm saying you're lost in it. How do you know any of this shit about... I have to mute.
Can I get 2 questions?
Can you do me a favour? Can you have a look for me?
He admitted.
Know what you fear. Can you check if that is considered as a perfect
Oh, you
gas?
call it, I was wondering why you're calling it Atmo, because it has sphere in it. Okay, fair enough. That's
Well,
funny.
first of all, I'm saying that atmosphere is an oxymoron because...
Yes, flat Earth, of course.
No, atmo means air. And sphere means sphere. So we don't actually have sphere-shaped air on the Earth. So we'll say atmo.
Well, yeah, your claim is that we don't. My claim is that
It's not cultish. It's just logic again, Deck.
Yeah, you can. It's an empty statement because you can say that about anything. Like I understand you believe it, but I could say the same thing. I could mean it. You know. Sorry, AJ. Keep going.
Just have a look for us. Is our atmosphere, atmo, considered a perfect gas?
I don't think anything is really considered a perfect gas, but
Just have a look under our gas laws. Let's look at gas laws for a minute here, and let's have a look.
I assume it gets pretty close, hey, because it's very large.
Oh, we're not assuming. Let's just look it up really quick, like you've done.
The atmosphere is mostly natural oxygen, both of whose behavior is very close to ideal at the temperatures and pressures found in the atmosphere.
Ideal or perfect gas. Our atmo is considered an ideal gas.
So a perfect gas is one in which intermolecular forces are not considered. Okay.
So how's gravity affecting this?
Gravity is not an intermolecular force. There's no gravity acting between the molecules of air. So one nitrogen sitting next to another hydrogen, the amount of gravity affecting those is basically negligible, so you can consider it a perfect gas.
So let's go and have a look at the of this ideal gas and state what the properties or what it does.
Background shit talking.
I mean, again, all these examples, I mean, Donato's picture here, 100% right. If you're talking about a cube that's what looks to be like 2 meters by 2 meters, or fucking, if there's that many gas particles, it's like a blank length. Not quite, but...
You realize the antecedent to pressure is containment.
Yeah, sure. And you understand that a containment is a wall that exhibits a force when a gas comes into contact with it, right?
So therefore not gravity, the bending and warping of space-time.
Bending and warping of space-time, while not technically considered a force, I think, or I think there's debate on it. I don't know exactly, but there's no debate. There's no debate that gravity definitely affects objects and creates an acceleration that we can measure. Would you disagree?
Where do we see
or at least that
gas?
Dude, you have a great imagination.
Yeah,
seriously.
sorry,
You're a nice
the
dude,
question
but
is
you've got a
where
good
do we see-
imagination.
I do have a great imagination. Thank you for that. I'm going to play some Dungeons and Dragons actually next week, and I'm looking very forward to it.
Quoting Michikaku, we lied to
Honestly,
you. Gravity doesn't suck you down to the Earth. Space pushes you down.
What pushes you down, sorry? Space.
Space.
Yeah, but it still exhibits a force on you.
Yeah.
Space, absence of anything.
But like, how? I don't understand how you can possibly listen. How can you quote Michio Kaku? How can you quote this guy who is definitely not a flat earther? He believes the Earth is a sphere. How can you quote anything he says if he's like a fucking globetard or whatever?
And
like, isn't he the malicious scientific people that don't know what they're doing?
Listen,
no, he's a hostile witness. He says this, and he's one of the preachers.
We don't go around calling people globetards.
No,
Listen,
okay.
we're not,
I'm sorry.
We don't
I'm
go
sorry.
around calling people
You're right.
globetards. This isn't just a petty little game that we play. We're literally only interested in science. We're literally only interested in observable reality. This is not a cult, and this is not a game.
Yeah, I didn't say it was.
We want you to be accurate, and we really want you to focus on the curvature argument and the motion argument, because these are the only two things that you can test.
I want you to be logical as well. So I don't understand why half the time you're telling me don't trust anyone, science is a lie, they're all lying, they don't even use science to do their thing, and then in the next moment you link to me a very prominent professional physicist that's backing you up. Like,
you know what hostile witness is? So
I think so. I'm not big on legal. Yeah,
but it's somebody on, let's say, the heliocentric side. One of the preachers, a scientist, he says this. How silly it is! It's called using it as a hostile witness. Now we can use different people like Michio Kaku. He preach, for example, from this side in arguments. Then we can use them again as hostile witnesses, because not everything's agreed upon within the heliocentric model, for example, right?
Mm-hmm.
That makes sense.
Sure.
Cool.
I get it, but at the same time, why is it that I can quote, like you're trusting this physicist that what he's saying there about gravity and how it's not actually gravity, it's the force of space or whatever. Why does that have any weight at all? Or you're using it just to deconstruct my argument?
Lots of different. There's at least two different types of gravity, and there's lots of different scientists who prefer one or two different types of gravity. And those two types of gravity, they've got different opinions on as well. So
this is true, but it's also true that the basic equations, they're all going to agree on Kepler's law, say, of like radius and mass and stuff that affects the actual path that planetary bodies and stuff like take. That's very basic gravity. They're all going to agree on that because that's basically settled science. We can look at things in space. Well, obviously you're not going to consider it settled science, but in the wider scientific community, they can observe this stuff and they go, yeah, I mean, we're all looking at it with different telescopes, taking the same measurements and seeing it does the same thing. So we agree on that. But then when you get to the actual core, like why behind it, is it Einsteinian? Is it fucking all this other kind of stuff? Fair enough. There's going to be disagreements because that's on the fringes of physics. But when we go to the stuff that's actually like well established, that we use every day to satellites, internet, blah, 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 all this kind of shit, that stuff is pretty fucking solid. Very solid. The point is all this pseudoscience is not science, but it's been lumped in with genuine science. Yeah, sure. I'm sure there's a lot of stuff we got wrong. And the kind of the whole point of science is to be able to explore the stuff that we think could be wrong, that could be pseudoscience, and use better scientific inquiry and better scientific tools as technology progresses to see if we were right or if we were wrong. And if we're wrong, you just put a paper out, people peer review it and go, oh, this is good science. They're using good techniques, and it actually completely deconstructs what we thought of before. We'll put it in fucking Nature magazine or whatever the fuck. And that's happened hundreds of times. And I'm sure many times it's been put there because some fucking BP oil energy company has said this, that, and the other, and it looks good, and people go, whoa, you know, this, that, and the other. But that's going to happen either way. Again, you don't throw the baby out with the bathwater. A lot of it is genuine scientists that actually want to improve their field and understanding, and they've made a genuine improvement.
So many fallacies.
Truly baffled by your lack of humanity when dealing with subjects that you clearly have no prior knowledge of. According to you, sure, but I think I'd... Like, if I'm gonna be in this cult and belief in religious system, I might as well know it, right? Why the fuck are you here? Honestly, trying to learn? Are you trolling? I'm not trolling. I'm genuinely just here to talk and have a conversation and understand your point of view, and you understand more my point of view.
I don't think you've been trying to understand our point of view the whole time, man.
Well, that's your problem. I absolutely am, and you can believe me or not, but I'm definitely trying to understand you. And listen, the stuff you were saying before about how if I were to try and accept what you're telling me, then I would have to rewrite everything I think about the world, etc. I 100% get. And it is a very scary thing to think about. Okay, well, if that's not true, then that's not true, then that's not true, then that's not true, blah, 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 blah. And I think it leads to a lot of people having kind of mental breakdowns to some degree within this community. I'm sure you've seen it a lot, that some people go pretty off the fucking walls with this kind of stuff. I'm not saying that's you by any means. A lot of the people here are very, very rational and down to earth, 100%. But I think you would be kidding yourself if you think all of your community is exactly to the same level that you guys are intellectually and rationally and understand all the arguments.
Right back at you.
Right back at yeah.
I think it's the same for the science community.
Amen. Yeah, I'm not saying it's not.
What are you saying, Falv? Sorry.
I was just saying it's probably the same for like y'all just agreed with. I don't need to repeat myself.
It is. Yeah, it is the same in every single thing. There's going to be people that actually know what they're talking about. There's going to be people that just agree and nod their head to the guy in the room that's speaking the loudest and then repeat parroting talking points. Yeah, 100%, without actually understanding the underlying stuff behind it. I pride myself on trying to understand as best as possible the underlying mechanics behind it.
Are you, though?
Yeah, I am. And you need to believe what I'm telling you that I truly am trying my very, very best. Whether that's not good enough for you is your problem, but I am trying.
So earlier when we was talking about gravity and how do you scientifically, or how do you apply gravity to a scientific experiment and all this stuff, and you was bringing up your objects, right? Why is it that you was hearing relative density or a specific gravity, and why were they using that instead?
I'm sorry, I don't follow the question.
Why did I bring up density and buoyancy, basically?
You were trying to prove that there is a force, not a force, pulling an object to the ground, pushing an object to the ground, okay? And they're just saying it's specific gravity or relative density. Why? What's the fundamental reason why during that conversation?
Why are they trying to say it's buoyancy?
No.
Is that what you're asking me?
Yes. Why? Why would
because that's what they believe to be true.
Okay. Whenever they were going on and talking about how in the scientific method you have to be able to manipulate your cause. Okay? The reason they're not saying that there's a force, not a force, pulling or pushing an object to the ground is because they can't manipulate it. They can manipulate the medium and all the other variables around the object. They cannot manipulate the gravity itself.
Okay.
That's it.
Okay.
That's why that's a.
But the reason we went sure, but the reason we went through all that was to establish where we agreed upon things, and we agreed upon that scientific experiment of dropping the balls and shit. And so the point of that was to kind of understand where our ideas diverge and where we stop understanding each other.
Do you understand Kiko's disposition? Why he said to you,
disposition?
Why do you think we are bringing up density and buoyancy as a repeatable, measurable phenomenon? Because we can manipulate the mediums around us. We can use water, we can use air, we can use any medium we choose to, because the medium is what we're manipulating.
So let's
yeah.
two objects.
But why is it that like oil floats instead of sinking?
Okay.
And
I'm going to have, and I'm going to change the medium only. I drop a 1 pound of iron and I drop 1 pound of wood in air. They both fall. I drop the same 1 pound iron and wood into water. Iron sinks, wood floats. I drop the wood and iron into liquid mercury. They both float. Why? Because the medium.
Right.
Yeah. But you understand though that that's still
simple,
applying.
Bro. It's that simple.
Yeah, it is that simple. But you haven't asked why.
Hold on, wait. That's the point, bro. It's that simple. Do you understand? Like.
Okay. Yeah. So what you're saying is that
that's where the line comes in of gravity. It's just you don't need it.
So what you're saying is because there's like this whole atmosphere around us. When you drop a piece of wood, it's only falling because of the relative density between the air and the wood, or the air and the iron.
Just take a step back, simplify it, bro.
I'm asking a question because that's where I'm stuck.
I know. We all know.
And you refuse to answer it.
I'm trying to hear Kiko. He's breaking up. Go ahead, Kiko.
You established that there's a downward bias. Let's change it up. I put my two objects in the bottom of a container. Right? Now I fill it up with air. Nothing happens. I fill it up with water. The wood floats. I fill it up with liquid mercury. They both begin to float.
Yeah, but I've got a question for you. A different one that. I've got one that's gonna stick it to you real bad here. So we established, yeah, big time. So we established, right, that when we drop both iron and titanium in a vacuum, or even in air, they both fall at the same rate, correct? Correct?
Sure, I'll agree.
In a vacuum?
But then I'll have to follow.
They fall at the same rate.
Kiko, you're
if they're the same, so if they're the same volume, right, the exact same shape, then the air resistance isn't going to affect it like differently between them. So if we make sure it's in air, the object is the same size, and we just change the density of that.
Stream then restarts at 24 hours.
What is your profession?
Old friend, I brought more soldiers.
What it really means to live life golden. Yeah, we're golden, baby girl, we're golden. They're about to see us shine, 'cause we're golden.
Get back into full view when, according to the curvature of the Earth, it should be obscured. Part of the boat should be obscured by the curvature of the Earth, yet we're able to bring it back into full view. So I don't understand like why no one brings that up, that anomaly, but like
I think they do, but a lot of people
like it or not. You might not accept my answer, but I got an answer for you.
Sure.
Well, that's because of refraction, of course.
Atmospheric refraction, right? But unfortunately, atmospheric refraction it can only occur with very specific atmospheric conditions. It's not an everyday occurring phenomena. You have to have it. It has to be the right conditions for atmospheric refraction. I mean, okay, we can take another example of the law of perspective and, disproving the curvature of the Earth. Have you ever heard of Sawyer de Uni? Mayhem? The Bolivian salt flats?
Yeah, I know that place. I heard about it.
Okay. So, if you go there, if you've seen it, it's about like 100 kilometers wide, and in all directions. Let's say it rains a little bit, like 3 inches of rain per se in this Bolivian salt flats. The reason why it's popular and people know about it is because it makes it look like it's a giant mirror, perfectly flat mirror. It's not convex, not concave. It's a perfectly flat mirror for over 100 kilometers.
What's it called?
Sawyer de Uni. I'm not sure if I'm saying that right, but just type in Bolivian salt flats. There you go. Or Bonneville salt? Is that what it's called? There you go. Let's see here. Let's look at this video real quick. actually, I don't know about the Bonneville salt flats, but apparently that's another salt flats place. But the one I'm thinking of is in Bolivia. There we go. Secret Asian Man posted a picture of it right there. Gorgeous, by the way. So let's
Looks
take that into
legitimately
consideration.
heaven.
Yeah, it's like a perfect mirror. Like there's no warping in the reflected image. It's completely flat. That's not what I'm not saying that proves it, but what I am saying is if you're able to see for over 100 kilometers perfectly like that far of a distance, where it looks like it's a perfect mirror, completely, symmetrical with the image that you're looking at. Like if you're standing 50 kilometers away, and you're looking at something another 50 kilometers away over there, it's the same mirrored image.
Yeah,
Like
there's no curvature. Yeah,
there's
I
no
see what you mean.
concaveness. Yeah.
Yeah. But my argue, I mean, I solely believe Earth is completely flat too. But my argue there is that Earth could be that very big.
Okay, let's say that's the case, right? Let's say that that's the case, that the Earth is so big that you're unable to see the curvature of the Earth.
For a while, yeah, for like.
Okay, well, let's go back to Eratosthenes. Let's go back, because that's important. That's basically where we got the measurement of the Earth, right?
Yeah, but I thought you said we can agree to disagree about Eratosthenes. Why are we going back?
No, we are. But we're
Yeah,
going back.
that's-
We're going
I'm-
back to the measurement, though.
I'm
'Cause
doing. Yeah, I'm like I said, yeah.
Yay.
Up. Oh, Plant Man, are you there, bud? And we're also joined by Mag Nor. Welcome. And he left. And we're joined by Wonko. Get your pickup lines ready, folks. We got the whole gang joining the panel. Let's go. Got Flying, we got Grim, we got Wonko, we got Acid. Oh, you definitely don't. This guy in the chat. About to be good. Let me check and see how my mic is sounding. One sec.
You're coming through good.
How do I unmute? Man. There's some on Discord, huh? No, it's all good, bro. Hold on. Yeah, plant. You on your computer or phone? There's a button with a microphone. You click that. Just give me a sec. Take all the time you need, my boy. This is 24/7. Let's see. I am your host. Let's see here. Let me start up an event for us here, guys. What do you guys want to do for events? Should we do the smoke show? We can do emergency meeting. We can do fresh and flat. Guys, throw your vote in the chat. You guys are listening. I'm feeling a little emergency meeting. It's new.
Hello, hello, hello.
There he is. There he is.
Alrighty.
Do you know this guy, lowercase Ed?
No, dude, I'm doing this. I literally just saw in my Discord that I was in a flat Earth, and I was like, why the hell am I in a flat Earth? So I was like, then I saw the debate, and I was like, let's see if I can, talk to someone. This should be fun.
Yeah. Was this the first time you spoke to someone about this before, or what?
I've seen videos and shit like that, and I feel like my assumption that you guys think it's a disc isn't that crazy. I think you guys are overthinking it a little too much.
Yeah, it's crazy, bro. Don't let those videos lie to you. What's up, Central? How are you, brother?
All right,
Doing pretty good. How about you?
Give me a rundown.
Good. Do you know this Ed guy, Central?
Yeah, we talk to him daily. He's one of the copium artists over there.
Oh.
Who the fuck is that guy? Who the fuck is that?
Is this on YouTube? Is this live on YouTube?
Yes.
Yeah. Mm-hmm.
You're live. Caller, you're live.
We are live. I'll get you a link, bro. One sec.
I guess we could probably just give them VC verified because we talked about just sort of skipping the queue for these ones that we know over there.
I did hear about that. Yep.
Hello?
Sounds good to me.
All right. Just stay to the topic. Yeah. Don't break TOS.
Yep.
Same stuff you do at the other place, basically.
Yep. We don't want to know your street address, bro. Keep that to yourself.
Oh, actually, Plant Man, I don't know him, but I know Ed.
This is good timing because Plant Man's new
The
from the
main
chat.
debate guy here.
He thought that this was like a pizza, a pancake type of thing. So we're about to help him figure out what this means. So
Let's get some definitions in here.
let's do it, bro. Let's do it. Well, how about like just a quick trick question, a little pop quiz. If you were gonna draw the shape flat, what would you draw?
I'm not saying that flat is a shape.
There you
Like, when I said I'm like a
go.
round earther, I wasn't saying like the earth is the shape round.
There you go.
I think you can. I mean, you named the server flat earth. I mean,
Yeah, but it's not a pizza disc. What up, Ava?
well, then what is it?
Well, I mean,
That's
really
what I'm trying to get to.
the only answer, you're not going to like this very much, but the only answer is the earth when you go outside, bro. We're not sitting in here closing our eyes and doing a rain dance and imagining something in our head, right? We're just dealing with the way it presents itself outside. There's really no other way to do that. So let me give you like a quick example. If I were to be like, all right, bro.
Wait, hang on. Before you keep going.
Okay.
You don't think that? Sorry. You don't think that like the Earth is a shape? Like you don't define it with a shape at all.
Well, again, like, this is what I was going to ask you. Like, what shape is the universe?
Because the universe, you can never know that.
There you go, bro. There you go.
That's such a
well.
huge scale difference.
Hold on. Let's walk through why you can't know that, right? Because you can't.
So big.
Well, no. Well, that's what she said. But no, it is big, but also you can't like leave it and then turn around and take selfies with it. It's like you live within. What? Well, hold on. You think you can leave the universe? Like out? Not.
No, bro. I'm not saying that. I'm saying like we don't even like have like we have an observable universe, and then there's like more out there like that we don't even know. Like
Right.
so.
Okay, but you got it. This is what I'm
We're not
trying
even
to help.
we can't even like fathom the size of the universe.
There you
Like
go.
we can fathom the size of the Earth. I don't know
Well,
how
hold
that's
on.
like.
Can I make a point?
Hold on, Ed. Hold on, buddy. We're doing something here, bro. Don't just interrupt. That was kind of rude. But hold on. This guy's new. I mean, if you've been around for a while, let me help this guy out, and maybe Central can cook with you for a bit. All right? Because this guy thought that we're talking about some sort of pizza. We definitely don't talk about that. So let me help you. Hold on, I got you, bro. I got you.
Well, I'm trying to say,
listen,
like,
no, hold on. I got
you
you.
can't compare the size of the universe
Hold
to the size of the Earth.
on.
Like,
I'm not doing that. But the way you look at it, take the size out, but the same way you look at it as this vast place, you can't leave it. You can't pop out of it. Turn
you can
around.
leave the Earth.
Hold on, bro. You gotta focus here, bro. We're talking about the universe at the
I'm
moment.
trying.
Okay. So in your worldview, in your worldview, we've got the Earth as an object within a large space, right?
Yes.
And when you go to that large space, you can't, like I said, you can't pop out of the large space and take selfies with it from some outside place. One, you already explained it perfectly. It's quite big. It's not been fully explored. But also, it's important to remember, like, you can't look at the universe like you can look at a puppet on your hand from this outside perspective. So if you really want to know what our position is, it's not an object within a large space. It is the large space. So I'm not saying it's the same, quote, size as the universe, millions and billions and trillions, but it is big. And just like the universe,
You're
it's not
saying
big.
in the same way that we could never see outside of the universe, we could never see outside of the Earth.
Yeah. Again, that's because that's the
You don't-
issue.
so
Hold
you
on,
don't
bro.
think that
Hold
there's
on,
any
hold
sort
on.
of
I'm no, hell no. Absolutely not. We
You don't
don't.
think okay. Okay.
See, that's why you came in a little bit confused in all these videos. And let me just go to Google right here and I'll show you.
I mean, like, those people, hang on, before you keep going, those people say that they are flat earthers just like
No,
you. Like,
I
you guys are putting
highly
yourself under
doubt
the same
that.
umbrella.
I highly doubt that. You got to have some
If I
discretion.
look up on your live stream, go and look up flat earth on YouTube, and they will come up with the disc dome,
Yeah, I
Antarctica
know.
ice wall.
Yeah, that's not people from here. That's not genuine people, bro. That's what I'm saying. You have to have discernment.
Dude,
There's a lot of goofballs on the internet.
I think you're like your own like group of flat earthers. Then
No,
I
we're
think
just
you're the
real.
minority.
Hold on, Plant, bro. Come on, dude. We're just genuine, real people. Those people, if you just go to YouTube, you really think they're gonna give you the sauce there? If the first search result? No, hell no, they're not gonna tell you. Look at what I look at what I typed on Google. Right, I posted in the chat here. Can you see the live stream voice text?
Live
I'll
stream.
tag you just in case you can't find it. But yeah, this is what they're presenting you from the mainstream. So those first results on Google, you're not getting the sauce from YouTube, bro. I'm telling you. They're gonna tell you, look at
I
it's
don't. I
this.
can't. What is it?
You should have access to see the chat there. Live stream voice text. I put a little screenshot in there for you to see.
Okay.
I don't blame you for thinking that because that's what the mainstream pushes. Oh, those guys think it's this disc loaded. Like
Okay,
hell
well,
no.
like I feel like you're trying to act like this is absurd, but I feel like
It is
what
absurd.
you're saying that. Well, hang on. I feel like what you're saying with the fact that there's no such thing as space is equally as.
Well, we'll get into that. I know that that's a tough one to swallow. That's a tough pill to swallow, but we'll get into that. What's up, Ed? How are you, Joe? I think this guy had to mute up for a second, so welcome, Ed.
Hello.
You would go ahead with your question.
Well, I was just gonna say, I actually can't remember. Something to do about the shape. You're talking about the shape, right?
I got
It's
a
like
question for you
how
about
we
shapes.
can't see the globe Earth, right? So, is it what the bend in the fabric of the universe, like Einstein's equations suggest?
What?
How things with density bend the fabric of space. Is that the true shape?
not
And
true.
us as
That's
3D objects can't view it that way?
I don't know what you're talking about.
What do you mean?
I don't know what he's talking about either. He's going on a. He's out of his league.
So,
Let's keep this between you and me.
Yeah, I got you. So yeah, I know. Listen, I know it's a tough pill to swallow, bro. Like, but that's
what's
why.
a tough pill?
Well, the fact that
Well, like the
we're
entire
not
world
talking
disagree
about.
with
Well, okay, duh. You know, we're not.
98% of.
It's not a popularity contest. But anyway,
100%. So I'm here to listen.
maybe you remember. This is a
Where
good
did you get
analogy. I
this?
think. I'll give you the sauce, bro. Don't worry. But there's a good analogy I think that is really helpful. Let me just give this to you, and then you can ask your question. So, like, you remember back in the day, I used to play like video games more. Like, you know, you'd have Xbox exclusive games like Halo. I don't know if you're familiar with that, but you can't take like Halo 3 and then put it in a PlayStation 2. Like, they're not compatible. So you can't take flat objects, load it into outer space. Those two ideas are not compatible either. That's why when you see, if you go on the internet, you see somebody saying like, "Look, it's this thing in space, this flat magic carpet, pizza, pancake." You can already know they're capping, they're lying to you. No, those two
So
ideas
basically,
don't go together.
you're saying that if like their idea of flat Earth like can possibly make sense.
Those aren't real people. Like, that's not a real genuine person if they're like presenting you some magic carpet in space.
So
That's what they're lying to you. Don't worry.
I got some ways that we can make some progress here.
Yeah, for sure. That's why I
How
was like,
would you
yeah.
prove that space isn't real?
Good question. That is a great question. So it actually boils down to this gas pressure argument. So I can give you a couple examples and I'll ask you to provide an example of the opposite. All right. So think of like a car tire, bike tire, something like that, right? You've got your rim, you've got your tire, and it's the tire that holds the gas pressure on the inside, right? So if
A
you
closed system.
Yeah, hold on, Ed. Yeah. Well, yeah. So it's a closed system. We've got, so essentially, if someone or something pops the tire, you're going to need to replace the tire to hold once again the gas pressure that was inside. We could use another example. Say, I'm not a big soda drinker, but if you have like a can of soda, 2-liter bottle of soda, and you open the container, well, you right then there you lose a little bit of gas pressure. But let's say we pour it in a coffee cup and leave it on the counter for a week. Well, no pun intended, it's gonna go flat. And so what you realize there is that it's the container that holds the gas pressure. And so I would maybe ask you if you can think of an example where we have gas pressure with no container. And of course, we can't use the thing that's in contention here. We know what the claim is. The claim is that essentially, maybe you've heard of like rap songs where they're like, I'm riding around on 24s or whatever, right? So essentially, like the Earth is like they're basically riding around on 3959s. They got this huge rim with no tire, but what the gas is somehow still held on. So we're not going to use that as the example. That's the thing that's being challenged. So I would challenge you to think of an example where we can have gas pressure without a container. Take your time though.
Where we can have pressure without a container?
Can I say one?
You're it. Yeah, I mean, if you want to help them out, phone a friend.
Jupiter.
Oh, well, we can't do that because, again, those are in contention, and that's not something you can demonstrate here in reality.
Wait, so
that's
you
just
do think
pointing
that
up at.
Wait a minute.
You can't just point at the sky and say, "Yep, there it is." Like that. That's what's being challenged.
The moon.
That's again. That's in contention. So I gave you some examples
In
there.
contention?
Yeah, I mean that's what's being contended that you can't.
Okay,
have.
I can give something that we know is in existence and we know what it is.
No, well, you have to demonstrate it, right? So obviously,
yeah, but if we know what it is,
hold on, raising your finger to the sky and pointing is not a demonstration. So you can't use the thing that's in contention.
Like satellites.
Again, you can't. You guys have got to understand the challenge here. The thing that you're pointing at or pointing to is being contended. We're saying that
Does it mean to be contended? I don't really understand that.
It's let's see here. Hold on, I'm getting a message.
It means it's in question right now. We're trying to figure out whether that is possible. So you can't use it as an example to prove it itself. That's begging the question fallacy.
But I know there's gas on the planet.
You don't believe in it, or like I don't understand.
Well, again, yeah, that's the thing, Ed. Is that's what we're challenging is not possible. So, and that's the claim that's on the table. So you can't use the claim. Hold on, Ed. You can't use the claim as proof. Like so.
I don't get it though because we
can't
can
turn
see
the claim into evidence. Well,
we
let
can
me give you guys an
it.
example. Let me give you an example here, okay? So, what we'll teach you here is about what an antecedent relationship is. I learned this when I first joined. So you've got, say, you go to a steakhouse and you order like a T-bone steak, right? Well, you know that the T-bone came from a cow. Those two things are required. You can't have the T-bone without the cow, right? And so another example would be like a banana. I made this myself. That you've got a banana, and you like say we go to a picnic, right? I've got banana slices. Well, you know that the banana slices came from a peel. Right, you can't get the slices without the peel. So now let's put that analogy. Yeah. So here's the analogy, right? Essentially, the banana, right, the part that you eat would be the gas pressure. Now, the Earth is claimed to essentially. Mm-hmm, yeah. So the Earth is
force. It's not
hold
like
on,
No, let him finish.
It's an analogy plan, so maybe you can understand what an analogy is. So in this example, the beef on your dinner plate, the T-bone, the banana, the part that you eat, of course, would be the gas pressure, right? What essentially the Earth is claimed to be is a like a cowless T-bone or a peelless banana, right? They're saying, look, we've got the gas pressure, no need for any container. So if you claim that you've got this magic banana that grew in your backyard and it never had a peel, right? It grew on the tree, no peel, just a banana, right? And I was like, okay, well, you're gonna have to prove that. Well, if you just rolled up to my house with a banana, I'd be like, that's not proving what you're claiming. Okay, so what I'm trying to point out is you can't point.
I see what you're pointing out.
Yeah, you can't point at the thing.
Earth isn't a closed container; it's an open container.
That's the claim. So So essentially, and what people tend to do, the reason why I like the banana analogy is because, like if you think of like banana slices, right? People will say, well, we have the air, right, is formed into a gradient. They're essentially pointing at the slices saying, well, here's the evidence that it didn't come from a container. But if I were to roll up to your house and say, look, I've got a bag of sliced banana, that proves it's this rare banana. It didn't come from a peel. You wouldn't accept that as evidence. You would need to see an example where there's no peel. So essentially,
could you use a different example? Because I don't see that one as feasible. To, solidify your argument.
I really don't see how this has anything to do.
Like there's a difference of a planet and the gradient of the atmosphere.
Right. Essentially, the Earth would be like this. Well, the Earth would be like this magic banana that grew with no peel, right? Where we're saying that you must have a peel for the banana, you must have a cow for the steak, you must have a container for gas pressure. So if they're saying that, look, we don't even need a container, that's essentially saying, look, I've got this rare banana. It doesn't need a peel. Didn't grow with a peel. So if you're like,
the weight of the gas.
I'm going to prove it. I'm going to prove it.
Gas pressure has to do with anything.
Creation. It's the weight of the gas on itself, right? And the gas came from within the planet. So the planet spewed out like how a spot spews out pus on a face.
But again, essentially what you're doing is just pointing at the banana, saying, "Look, this is the rare banana," without showing it actually. Without
what is a rare banana? The one that is. You saying that like I'm trying to claim that a banana doesn't have a peel just because I showed the banana without the peel?
Yeah, let me just ask you this, right? So, if I said, plant, I've got a rare banana tree in my backyard. It grows with bananas with no peel on it. Okay?
Okay.
That's my claim. And you're like, well, prove it. And I'm like, okay, I'm gonna come over to your place, and I come over.
Sliced banana.
And I just come with a banana in a bag. Like, I use the slices for the folks that point at the gradient.
You would need to see the tree as proof.
Would you accept that as proof?
No, I would probably say I need to see the tree.
There you go. So essentially, when you guys say, well, look, the air, the sky, that's not proving the claim. That's just pointing at the claim.
Well, what was the claim? What was the original claim then? I've almost lost track of it.
Well, you didn't necessarily have to say it, but essentially the Earth is, if we look at the globe Earth, right, there's no container for the gas pressure. That's why we ask people to provide a demonstration, an example of this in reality. What about it? What does it do to gas pressure?
What does it do to gas or like gas pressure?
Yeah, gas pressure.
Because
we're talking about the air that you breathe.
Yeah.
So this is the challenge. What about this is the challenge, that you must have a container for gas pressure. Every example that I can provide to you involves a container. Your bicycle, your car, soda, propane. If I wanted to purchase propane or purchase as a gas, they're going to sell it to me from a container. They're going to put it in a container. So it always involves containment. So the magic claim on the table is that the air that you breathe doesn't even need a container. So when we ask for, okay, that's fine. If you're going to claim that, we're going to need to see proof of that. Pointing at the claim itself is just certainly not acceptable. Even you admitted I wouldn't accept just a bag of banana to prove that it's this rare banana with no peel. We know all bananas come from a peel. We know all gas pressure requires a container. So
well, let's remove gas pressure for a second, and let's just talk about gas.
That's the whole thing.
Well, hang on. Let's just talk about gas. I don't care for gas pressure. That has nothing.
But that's the argument.
Yeah, you're trying to take it off the argument. Do you guys know what gas pressure is?
I'm guessing.
I do. Yeah.
Let's before we get into let's just look.
Well, what do you guys think it is? It's not a gotcha.
You want to just Google it?
Doesn't matter if you don't know exactly what the definition is. That's fine.
I'm just. Google it. How about that?
I got the citation ready.
Would that be fair? Would you agree to a Google?
Well, that would be for
a Google search.
That'd be for your benefit. We know what it is, so that'd be for you, not for me.
Okay, well that's fine. Would you accept what Google has to say?
Not always.
I already did.
I'm going to look up gas pressure on Google, and I'm going to read it to you, and you're going to tell me if you agree or disagree.
All right, I'll put something in the chat as well.
Gas pressure is the force exerted by gaseous molecules as they collide with the walls of their container. If the volume and pressure...
Interesting.
Hang on.
You got it.
temperature of a container of
You
gas
got it.
are held constant, an increase in the number of gas particles will result in an increase in pressure and vice versa.
Yep, you got it. So, gas pressure
So
is
you're
the
saying
force that gas exerts on the walls of its container. So you guys believe you can have force that gas exerts on the walls of a container with no container?
Hang on, say that again. I think that I can what?
Have the force that gas exerts on the walls of its container with no container?
Well, yeah, that's the question,
What
right?
is
Plant,
the
you're
definition of a
breathing, you're breathing air. So what's containing that? Our presentation involves an actual container. It has to be contained, required. Just like the T-bone requires a cow, just like the
What
banana
is it?
slices
What is
requires a
what is
peel.
what is the definition of container?
All right, bro, go ahead, man. You gotta figure this stuff out on the fly, but go ahead. I think you know what that means.
Well, I'm asking you, like, you're saying that there has
Well,
to be a physical wall?
you brought up gravity. Does gravity contain gases?
Yeah.
Gravity's a container.
Wait, it does?
Yes. Yes.
Can
I
you-
mean, technically, yes.
Where?
Can you demonstrate this
Where?
container?
Can I demonstrate this container?
Yeah.
I think I have a feeling that I know what you're going to do.
I'm gonna point at this guy.
Do you disagree
Yeah.
with gravity? Do you guys not
Whoa,
believe that
hold on.
gravity
You have to
works?
present. If you're saying that gravity contains gases, show it. Don't just ask if I believe what you believe. Like, you got to show what you're saying. Remember, show and tell. Kindergarten? You can tell.
I
but you
try
gotta show.
showing you, but you would dismiss my answer. So.
Hold on, lower.
Yeah,
lower.
if
Think
I-
of it this
well,
way. Hold on.
if
Think
I
of it
get-
this way. Hold on. Think of it this way, right? You guys have to say this all the time, right? I'm the counsel for my client. You're the counsel for your client. So don't worry about what I would believe. Present your evidence to the jury and the judge. Let them decide. It doesn't matter if I don't agree with it. There's still the jury out there. So make your case. Don't worry. You would never tell the judge. Well,
I don't
judge,
care about
I
this.
would
It doesn't
present my
matter about
evidence. You just
believing or
wouldn't believe it.
disbelieving. I don't care.
So just
It doesn't
present
matter.
whatever
Let me
evidence you have.
discuss this. Okay. Let's get to gravity, because I think that's where this whole argument is kind of teetering on.
I don't think so, because all you would need to do is show a demonstration of.
Do you
gravity
disagree with the
containing
notion of
gases.
gravity? Like, do you not
No,
believe that gravity?
bro. We need a presentation of what you're claiming containing gases. That's all you need.
Yeah, I want to see the gas.
Well, hang on.
It doesn't involve belief.
Let's put that on pause for just a second. 'Cause
No.
I feel like we need to discuss gravity.
Hell no.
Why?
Hell no!
Why would we put the claim on the
Why are you
table
guys so
on pause?
hesitant to talk about gravity. Let's just talk.
I'm not.
Well, we're trying to talk about it. You're saying it's a container, and we're just asking you to demonstrate it being a container, and you're trying to not talk about that. You're the one trying to get away.
Well, what if I said the demonstration of it being the container is Earth?
That would be begging the question.
So exactly.
Well,
so exactly.
Plant,
This is why we have to get to the talk about gravity. Like, you guys can't take Earth as an example. So let's talk about what gravity is.
But Plant. We just explained why you can't use that as your example. Remember the banana in the
It doesn't
bag.
matter. Let's just talk about,
Hold
I'm
on,
talking about the fundamental.
1 second, dude. You already yourself. You already explained why that would never be acceptable evidence. You're just doing the same thing. If I presented to you this, if I just show up with a bag
Okay, what
with
if
a
I
banana
said?
in it,
What
you'd be
if I
like,
did
that's
any
not
other
evidence.
planet with an atmosphere?
No, that's the same thing. That's the claim that's on the table. That's being challenged. So you can't use the claim as proof. Claims are not evidence.
I mean, what's the claim?
That
planets have atmospheres?
The claim is the thing you're trying to prove right now, the thing that gravity contains gases. So show it.
If we witness it, right? If we got a really powerful telescope, and we witnessed it with our own eyes, is that not evidence?
You can't point at the claim and now call the claim proof. It doesn't work that way.
You're witnessing it with your own eyes.
No, you're not.
Yes, you are. You're witnessing a dense ball.
The telescope did not whisper in your ear, gravity's containing the gas over there. You see what you see, just like we do. You're adding details that the telescope does not provide. So
I'm not.
No, you're not witnessing that. We need an actual practical demonstration.
Please just talk about gravity. I feel like we need to.
Plant, we don't. We just need a demonstration of what you're claiming. That's it.
Okay, well, let me change my claim then. I don't care about.
Oh,
this
you don't
whole
get to.
gravity.
Hold on. This is where we get into this BYOB territory where people start bringing their own ball and making their own claims. We don't need you to change the claim. We all know what the claim is very clearly, precisely. So that's why we're asking you
Well,
to
that's
maybe
just not true. I
demonstrate
actually
that
never
claim.
claimed
If
any
you
of that.
again, we're not waiting around for you to claim it. We know what the claim is. You're the one who had to Google this stuff.
Okay, well, let's talk about gravity.
No.
What is gravity?
Gravity is the force of massive objects that brings us.
Ah, so you're an Einstein denier.
Wait a minute. You
Yeah.
never heard of Einstein, bro?
I'm using Newtonian gravity as of right now.
Why?
Hey, utter
There's a
failure.
far
This
better
is why
and
you-
superior explanation for the universe.
This is why you shouldn't quote talk about gravity. All you need to do is show what you're saying is happening. If you say gravity contains gas, just show it. I don't know if why you guys forget about
I'm just asking
kindergarten
you, do you think gravity
presentations,
is real?
right? Show and tell. We know you're just doing the telling part. Now we need to show it. You're like, well, I just want to tell more. We're not here to tell
hang on,
stories, bro.
hang on, man.
Well, now you got a problem with Einstein on top of everything.
I think we just need to rip the Band-Aid off with this dude because, to be honest, bro, we're just asking you for something that's impossible anyway. But I just get the sense that you believe it's possible.
Well,
So
it's
what we do is
impossible
we
because
send you.
it
is
possible
impossible.
example that isn't
Oh.
I
working for
got
you
your question.
won't work for you.
No, it's not, Ed. That's actually not the way it's presented. It's like this, right? There's an old saying called "A fool who persists in his folly may become wise." So if you do believe the answer exists, we're going to send you on a search to look for it. And then on your own, you'll realize it's not out there. Or we can just rip the Band-Aid off and tell you, you must have a container for gas pressure, period. There's no way
I'll
around
give this
that.
one to you, go.
I mean,
victory.
Oh, all right, sweet.
Let me.
The definition of pressure already told you that you need a container. I mean, it's a fool's errand at this point. Clearly, you can see.
You read it in the definition, so yeah, it was kind of over there. But again, you believe that oh well, we don't need a container. Well, on your own, make this your homework. See if you can find a demonstration of this. I mean, a practical demonstration, right? Obviously, you can't just okay. Let's just flip it around, right? If I was like, no, there is a container, and I just pointed at the sky, and I was like, look, see, would you believe that? Would you accept that as proof, Plant or Ed? If I said there is 100% a container and I just raise my finger to the sky and say, look, there it is, would you believe that? Would you accept that? Hell no, you wouldn't accept that. But you guys think that we should accept the same review. You said the Earth. You just said, well, the Plant. No. You said the evidence is the Earth itself. So if I said that, if you were like, whoa, where's the evidence of the container? I was like, Earth. Would you accept that?
I would say
Obviously
that
not.
it's gravity. Please, dude, will you just let me talk?
Okay, we know what you're gonna say. Gravity contains the gas. Show it.
Hang on. Let's take it 1 second. Let's find some sort of agreement on what gravity is.
You didn't even know what it was. We know what it is, bro. We don't have to Google this stuff. We
Is
spent
gravity
years.
real? Yes or no?
What you just presented is completely
Answer that
superseded.
question. Is
Hold on,
gravity
Plant.
real?
Not the way you presented it, right? You presented Newtonian physics, Newtonian's version, which is this mass attracting mass. They've superseded and replaced that with Einstein's bending and warping of space-time. So if you say, is it real? You don't know that there's like 3 versions of it.
What bends and warps space-time? It's still mass. It still works relatively the same.
Not Newton's version. So
they're different on the intrinsities, right?
It's a
on the
loose
specifics.
It's a loose question, bro.
How
if you're like,
how
well,
like,
do you
bad
believe
do you
it?
think Newtonian's version of gravity was? Like, do you
It's
think
been
that couldn't be used
replaced.
whatsoever?
It's been
That's
do you know what
because
superseded
Einstein
means?
just made it more specific.
No, he didn't.
They're not the same.
Okay.
No, he didn't. No, he superseded
That's not a
Newton's.
rebuttal either,
Look, you guys think that they're interchangeable?
No. Oh my god.
No,
You're not understanding what we're saying.
I'm saying that Newtonian gravity is still applicable. It's not as specific, and it doesn't give you the exact right answer, but it gives you a good ballpark.
You think that he refined Newton's gravity is what you guys think, isn't it?
Oh my god. Bro, why do you keep putting words into my mouth?
He kind of reshaped
That's
it in
what
its own
Plant's-
way. Like
that's what Plant's saying,
changed
Ed. Are you
the
not
understanding that it isn't the masses attracting each other, it's the masses warping space.
Yeah, completely different concept. They're in different geometries. One's 4D, one's 3D, one's limited by the speed of light. The other one has no limitation. It's instantaneous. You can't have instantaneity and relativity. They're absolutely different things. They are not compatible. You gotta pick one. Sorry.
They're just descriptions
So
of how
you
things
think
act
that
in the universe, right?
Yeah,
So
but
not
but
like
did you? Yeah, but they're
it's
completely
the reason
incompatible
why
descriptions, though. Did you catch that part?
it's descriptions of the same thing.
They're not
So
compatible.
inherently, they're linked.
They're not compatible. That's the point we're making.
Oh my
One
God,
replace
not
the
linked.
other. You got to take
Alright, that's
one.
the point
you
you're
can't just
making.
change. You can't just interchange them. It's not like, oh, we'll apply Newton
Okay,
here, we'll apply Einstein
let's
there.
do it in the
They're
let's do it in the
mutually
Einstein way.
exclusive. Okay.
The Earth is so massive that it warps space, and that warping of space is bringing the air down towards the Earth constantly.
Okay,
Yes or
Plant,
no?
that is the claim, bro. So now we would need
Do you
evidence
guys
of this
not even
claim.
agree with Newtonian? I mean,
Hold
not
on,
Newtonian.
hold on. Yeah,
Einstein.
you don't even know what you're talking about. Again, we know what the claim is. Okay, you don't have to repeat the claim. We know what it is, bro. So now that that's the claim, we would need evidence of this claim. So you can't just point at the claim and say, "Well, that's the proof." It's not.
You need evidence of relativistic gravity. That's what you're saying?
No, we need evidence of the thing you just said in specific, right? This thing is pulling the air down. So show it.
Yeah. Okay. So what if I drop a hammer in a complete vacuum?
Well,
It
first of all,
still
you're
drops.
gonna need a container for that, number one. And then we're also talking about gas pressure.
Dude, a hammer isn't air. Come on.
Holy smokes.
You guys know what mass
Still
is?
mass. Still
Do
mass.
you know what a demonstration is, my friend?
Right, so deflecting with a question.
No,
Okay.
listen, Ed. The question on the table is, can you have gas pressure without a
Oh, did you just
container?
kick Ed?
No. He's been bouncing in and out on his own. We don't just kick people for no reason, bro. Everyone's welcome here. So again, listen. He said I was deflecting. You guys know what the challenge is to show what you're saying.
I didn't say that. But hang on. Let's get back to what my point. I'm tired with you constantly going back to this claim.
Plant,
Let's
hold on,
try
bud.
and stay on track.
Hold on, bud. Yeah,
Yeah,
I'm trying to keep
you
you
hold
on
on, bud.
track. No, I will be leading the dance here. So again, you asked how you asked about our position, right? Our presentation involves this place that's contained not in this giant space. You're like, well, how is that possible? Well, we gave you our presentation. That's what we're trying to keep you on track on. You asked why not outer space? Well, we told you it requires a container. So that's what we're talking about. We're going to keep you on
Hang
track
on.
here.
Well, I liked where we were going with gravity. Can we keep on
You don't
that?
even know where you're going with it. You're like figuring it out on the fly, bro.
Yes, I do actually. We were talking
No,
about
you Googled.
you were saying prove that it pulls the air down, right?
Show it.
And I'm saying that the mass of air and the mass of hammer are the same thing.
What?
Both mass.
Which way does gas go?
Which way does gas go? What do you mean?
Yeah.
Which way does it go?
I mean, children know this, bro. Come on, you learn this in like 3rd grade. Which direction does gas travel in?
What?
You
got a
said
multiple
the hammer
choice.
goes down, and you draw an equivalence between the gas and the hammer. So, does the gas act the same way as the hammer? Please tell us if it does.
So you're saying
I'm
are
not
you
saying
asking me
anything.
if
I'm
the air
asking you a
is being
question.
pulled down?
No, bro. Listen, I can put it in a multiple choice for you. Does the air go down? Does it go up? Or does it go in all directions?
It goes in all directions.
Oh, it goes all directions. So let's talk about the hammer. Let's talk about the hammer. Does the hammer go up, down, or all directions?
It goes down.
So why are you so quick to compare air to a hammer? When the hammer goes down, the air goes in all directions, aka not just down.
Because that whole point was to prove that there is a force pulling mass downwards.
But wait a minute. Gas goes up and in all directions.
It doesn't go up. What do you mean it goes up?
It goes in all directions.
Wait, if I
by up, what do you mean by up?
Not down.
All directions, including up.
Holy smokes!
Oh, hang on. So if I have like, let's just name a gas that's more dense than air, and I drop that, it's not going up.
Yeah,
it will. Example.
It's gonna go down.
Give us an example.
Do it in a vacuum. It goes everywhere.
What is like what's the opposite of helium? It's like that makes your voice low. Like that gas will sink in air.
Sulfur hexafluoride, it'll disperse eventually.
Yes.
It won't stay like that forever. It will go in all directions.
Well, obviously it's gonna disperse. It's not gonna just sit in like if it's
well,
not
well,
in
no
like a little
duh, dude.
fishbowl,
It's not gonna just
sit in a fishbowl.
it's not gonna just chill there in the bowl forever. It is gonna go in all directions. It just won't disperse as quickly as a lighter
So
gas.
hang on. If I put sulfur hexafluoride in a fish tank, will that disperse?
Oh my god, who's DMing you right now?
Eventually.
Did somebody DM you that, bro?
I gave him sulfur hexafluoride, but yeah, somebody might also be doing that.
Someone for sure DM'd him the sulfur hexafluoride in a fish. We've seen this before so many times. A point anyway. Where do if I wanted to sell you,
bringing up
where
like
do you?
air going
It's
up and
not
down.
like you
and I was
just
saying
scooped
that.
it out of the atmosphere. Number one, it's a man-made gas, and number two, you had to wheel it in a container and then pour it out of a container into another container. You guys don't have any clue how this goes. You're giving us an example which involves multiple containers to prove you don't need a container. Holy smokes!
Yeah, I didn't even hear what you said.
The challenge is you're not you individually, but you're defending this claim that you do not need a container. You just gave us an example which involves not one, not two, but three containers. Again, if you want to defend this claim, you have to show what you're claiming. Period. Or we can just, again, we can just rip the Band-Aid off and tell you it's not possible. You're basically saying you have a magic rare banana with no peel, and you can never show that ever. You're just showing us more smushed up banana. That's not proving what you're claiming, so might as well just move on. You're never going to win this one. It's undefeated argument. So I don't mean just to say that to you. Like we've asked literally every single person that believes that you can have gas pressure without a container. No one. It's not a lack of trying on your part. It's just simply impossible. There's this law called the second law of thermodynamics, entropy. You'll never defeat it ever. It's like trying to have this gas pressure, right? You have your soda in the coffee cup. It's like trying to keep.
You're bringing up. Well, hang on. Let's just argue this real quick.
Not changing the subject.
You're bringing up all these scientific terms.
Okay, well, we
You
can
think
keep it
that
simple. I'll give you a demonstration in the
of
chat.
scientists would agree with you?
No, we don't do that. Hold on, bro. You would have to. That's not how this works. You just imagine this vague panel of people in your head that have answers that agree with you, and say, "Well, you don't agree with this imaginary group in my head." That doesn't work like that. If you want to call
What if Albert Einstein?
if you want to call,
he'd have to be pretty credible.
Oh, shout out to whoever did that. Exactly. If you want to call a witness to the stand, that's fine. We can call a witness and go through what they're saying specifically, but you can't present this vague panel of people that you've imagined in your mind that have these answers that you agree with and say, well, you don't agree? That's extremely vague and it doesn't work that way. But what I will do is I'll call a witness to the stand for you. If you thought that was complicated, the second law, I'll give you a demonstration and a little clip. We'll take a quick listen to the clip and I'll put the demonstration in the chat. It's like 30 seconds long. It should be really simple to understand. Let's listen.
Okay, where do I gotta go?
Oops. Hold on, let me stop the bot real quick. You just need to go to the chat for the visual, and then the audio will play through your headphones if you're, or your speaker if you're listening. So
the live stream voice text.
I'll put the visual in there right now, and then go ahead and play the clip here. Just 1 second. I'm juggling a few things, so let's take a listen.
Can't hear it.
Yeah, the bot's being weird. Hold on, let me try a different one. Thinking bot. What the hell? I don't know why it's not playing.
I heard valves for a second.
Yeah, I don't know why the bot's being weird today. Central, do you want to try this, or somebody else want to try this? Links in the chat in the bot room. If you try. In the computer, it never works when you want it to, huh? Try again. Fuck. Oh, he's back to Central. I like it. I like it.
I thought I'd go with the CB theme.
Let's go. Try again, Graham. Go ahead, bud. And where's Drace when you need him? If someone has like a it's not working. If someone has like a phone or something, if you want to play it through your speaker so we can hear it, or bro, if you just want to listen on your own, it's pretty short. It's like not that long.
One of these bulbs, some bromine, and in the other, I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy. So without the entropy
All right, let's walk through what he was saying. Can you see the visual there? Just a GIF that's looping in the chat.
Him opening the valve and then the bromine goes into the other thing.
There you go. On one side, he's got the vacuum. One side has the gas. There's a container. There's like a valve in the middle. It's sealed. So he opens the seal. The high pressure area where the gas is moves to the lower pressure area. This is showing you, one, if you don't have the container, you're going to lose the pressure, just like with your soda can or your car tire. It's the container that holds the pressure. What do you think would happen if there was no container there, right? It would just piss off all over the place. So that's what we're trying to say, bro. You must have a container. It's damn near required. It's required, just like with the beef on your dinner plate. You don't get a nice beef dinner if it didn't come from a cow. You don't get banana slices or a banana smoothie or whatever if it didn't come first from a peel. And so in the same way, you don't get gas pressure, the air you're breathing right now, unless it is contained. So I know it's a tough pill to swallow. It's one of the last things that went for me. I was a big space fan. I love space. I still do. But now I enjoy it as a fictional theme, a fictional setting, because you got to have a container for gas pressure. We're not just living in a giant void of space. We live within a container. It's a tough pill to swallow, man. Sometimes I pinch myself all the time. You go outside, you're like, hold up. I'm actually inside. So, look, that's why if someone's presenting you with this pizza planet floating disk in space, you already know they're capping and lying to you. So
I agree with literally all of science. It's just that because you think that there's no container, that means it's impossible for there to be gas pressure, and therefore the Earth isn't round.
Well, that's just not. That doesn't say anything about the That's just. I just wanted to present to you why we don't think space is real. That is a very tough. You said, "Wow, that sounds crazy." I know it sounds crazy, but if you look at the quote science, I know you love that, then you'll see why it's not just an idea that people came up with. It's based on second law of thermodynamics, based on this law of entropy, period, and antecedent relationships and how gas pressure works. So it's based on this very undefeated argument. I like to call it that. So in terms of the shape and the surface, we can get into that, but that doesn't prove anything about
well, hang on.
The surface.
I'm gonna be honest. That guy explaining the pressure change and bromine flowing into the other bulb, I don't get how that's entropy.
Let's listen one more time. Hold on. Let's just play.
Well, no,
it's only 30
that
seconds.
he says it's entropy. Dude, I'm not denying that he said the word entropy. I'm just saying that I don't know for sure if that's actually entropy. Like how entropy is almost hard to explain, but
go ahead.
It's not because gas is moving over to the other bulb. That's not entropy.
Oh, really?
A thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work.
Here we go. The Google expert. So 20 seconds ago, you didn't know what it was. You're like, you're using all these terms. So we played you just a demonstration, very simple. And then you turn into this is what's so funny, Plan, is this is what people do, is they turn into an Insta expert after Googling it. So what does Google say? It just goes from hot to cold. Is that what it says?
Well, this isn't my only thing. There's a, do you like Veritasium?
I mean, you can drop a link. We'll take a look at it together. It's fine.
Here, just look up Veritasium entropy, and he'll explain it.
All right. YouTube, let's go. You know how much flack we get for like, oh, you just watch YouTube videos? We don't, but all right, so Veritasium. Entropy. All right. The most misunderstood concept in physics, that one?
Yes.
You watched that whole thing? It's 30 minutes long.
Yes, I did actually.
What? How? We just played this clip 20 seconds ago.
Well, no, I'm saying I've watched it before this, like before all this.
Okay.
This is a video.
Hold on, let me just.
So, entropy.
Ideal engine, entropy, energy spread. So, all right. Well, why don't you just break it down in a nutshell? Why is what the clip that we just showed? Why is that wrong?
Because entropy has to do with like the energy of a system and how it kind of like dissembles into like low entropy energy and high entropy energy are different energies that can be used in different ways. Like the high entropy, I honestly can't even remember which one is low and high because I always think it's the other. But basically, the energy we get from the sun is low entropy, and then we turn it into high entropy. And it might be switched. It might be we get a high entropy from the sun and we turn it into low. But it's a conversion of energy from high entropy to low entropy. It's not like when gas moving into another bulb is not entropy.
Yeah, it is. This
How?
is really simple stuff. It's just like with, bro. It's just like with it. This is very simple. It's not a very complex thing. If I puncture the listen. If I puncture the tire, right, that's where the high pressure is. Like my bicycle tire right now has like 50 psi in it. The air that you breathe right now is like 14.7 psi. So we have a high pressure area and then the lower pressure air on the outside. So when I puncture the tire, the higher pressure area moves to lower pressure area. This is just basic entropy, right? The second law of thermodynamics. Same thing with like maybe you have a
That's what
coffee
I'm
cup.
saying. I'm saying a high pressure area moving to a low pressure area. I don't know if that's entropy. Let me look
That's
this
the
up.
most basic. Listen, let's play the clip one more time. It's really short. It's really he's gonna tell you he's reducing it down to the most basic point possible, right? There's no energy change. There's no temperature change. It's literally just entropy. That's it. Let's listen.
One of these bulbs, some bromine, and in the other, I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy. So without the entropy
There we go. So in your example, we're involving now other things like energy and temperature and all these things. We're just trying to show you how entropy works on its most simple form, right? It works in a lot of ways, right? Just I gave you the example of like the car tire. You could think of like maybe a hot cup of coffee, steaming hot. Water boils at like 212, so it's going to be really, really hot water. But then because the environment around it isn't, obviously, you're not living in an environment that's also 212 degrees, well, it's going to cool down. Just like the little thing Acid Rain put in the chat for you there. So it's things seeking equilibrium, high pressure move to low pressure, hot moving to cold. That's just a very simple idea of entropy. You were like, oh, you're using these crazy terms. It's actually really simple. So that's why we gave you a very simple example. Of course, you could start involving other things like energy and temperature and things like that. But just so you could understand the concept, that's what we're trying to say. Without a container, you're going to lose the pressure. That's it.
What if there's gravity? What if there's
Well,
gravity
again,
pulling it down?
okay, listen, that's fine. That is the claim on the table, friend. If you can see the post from Flat GPT there, it says non-vacuum vacuum how. We know that folks who like to come defend the claim say gravity holds the gas down. That's fine. We know that, but the repetition of the claim isn't evidence of the claim. So it's fine to claim that, but we would then need the
Well, hang on.
evidence to show that that's happening, not just pointing at
So
the
like,
sky
yeah,
or pointing.
I like that you. Well, hang on. Let's look back at the example, like non-vacuum vacuum. Like
Mm-hmm.
that blue area is obviously the air, and I'm saying that it's gravity that's holding it.
We know, bro.
To the earth.
I know. But that's not the evidence. That's the claim.
So you need me to bring up evidence that
How else
Isn't
would you
gravity?
prove that? How else would you prove it? What's besides evidence? What do you think? Just saying it like 33 times is the
Well,
proof? Hell
I'm
no.
trying to find out what would be considered evidence to you.
Just whatever.
Demonstration.
Yeah. Just like, dude, think about like kindergarten, right? You go to kindergarten, they're like, all right, we're having show and tell today. So you tell, and then you show. So you've done the tell part. We appreciate that. Now you have to, quote, demonstrate it, like Central said, or show it. Really simple.
What if I said that magical invisible elves and fairies can contain air? I don't need a container to carry around some propane. I can just use magical elves and fairies. Would you accept that, or would you demand a demonstration?
Well, I believe it if you say it 33 times in a row. That's proof. Just say
Yeah.
it over again.
I just keep reasserting it. I just keep saying, well, no, I mean, elves and fairies can be a container. And you say, well, demonstrate it then. And then I just keep saying, well, they can.
Oh, you
Obviously.
don't believe in
Well, I can't
fairies? Like, you
use
don't
the
believe? Let's
Earth
just
as
talk
a
about if you believe.
demonstration.
No, you can't. That's the claim, ding dong.
No, I get it. So hang on.
So just demonstrate it, right? You say that gas can cause air pressure. Just show us a demonstration of... gravity can cause air pressure. Just show us a demonstration of it doing that.
Hey, give me a second. I'll actually look this up.
All right, good luck. I love the discussions here, Central. I'm glad you're back, man.
Yeah. Let's get it popping again.
This is good. This is good.
Okay,
You've
so I
been a
look
great
up
sport plan as well. I
gravity
gotta give you that.
cause. Hang on. I just do a quick Google search and I look up can gravity cause.
Well, I'll tell you what you're going to find. You kind of need to do this for yourself to see, but you're just going to find what you've been doing, which is the claim repeated over and over again. You will not find a scientific demonstration of this, but you need to find that out for yourself. So, yeah, I encourage you. I encourage your Google efforts.
Okay, well then. So what about like satellites? Like, do you not think that we've been to the moon or like that?
Well, are we done with air pressure? Are we folding
Let's
on
move
this?
on from it for a second.
Okay, but I mean, let's put a pin in it properly, though. I mean, if we're gonna fold on it, then let's just say, okay, there's no demonstration of gravity causing air pressure, so we're gonna move on to some other topic.
And then
no example that you guys don't like.
Don't worry about me. It's not about what we would believe. It's about just presenting a demonstration, just like anyone can see it.
But don't qualify it. It's not about us, though. It's just that we haven't had it. Look, it's not that there's no example that we won't accept or whatever. There's just no example.
So, like, here's the thing: is like you guys are saying that the Earth is in a container, right? That's how we have air sticking to the Earth. Is like it has to be in a container.
Well, we have air pressure, right?
Well, I'm just going to your claim. Like you guys think that there have to be.
Well, let's break it down.
There have to be a container.
We have air pressure, right? Okay, and another way to describe that is the force that gas exerts on the walls of its container.
Okay, I am.
I'm here with you too. What's up, Bear?
Okay.
What's up, Bear?
Hey, CB.
What's going on?
We're having a ladies' night takeover here, actually.
Sweet.
Yeah.
Siri.
Let's go.
Yeah, so we appreciate again everybody that joined us here. We're gonna continue our usual stuff. Flatsy, take it away. I'm just gonna make sure that some things in the background are done. Okay.
All right, sounds good. Yeah, for the whatever misconception about how we can perceive the world, you wouldn't be able to see forever because of the attenuation of light. First of all, second of all, the atmosphere is opaque, which is
creation. What's going on, man?
And also, I don't know if you notice, but in the distance, things like the ground, things underneath you ramp up in your vision. So there's no way that just by that whole angular resolution, you would not be able to just see forever. Just want to get that out there. It doesn't make any sense that people would think they could just see forever.
Is there any way we can get our own like voice chat? Like, what's going on?
Oh,
We just
real
got
quick. Yeah,
hijacked.
sorry. Real quick. Yeah, I guess we're doing a. It's been a while since we've done a ladies' night planned. So I know you're new here. The girl's gonna take over at this point. You can definitely ask them your questions. We can pick up where we left off. So sorry to interrupt, but yeah, Plant Man, welcome to the panel. There's a couple gals here. You can continue our conversation with them. So.
Well, hang
Yo,
on.
Bear, is it only with females or what's
Well,
the?
they're taking over, right? They're taking
All
over.
right, cool.
So
Let them
you
talk.
can chat with
Oh,
them.
can we join our own voice chat?
Nah, that's cool.
Here's the thing. It's only the flat earth men that cannot talk. So if you're a flat earther and you're male, just mute yourself. Everybody else, if you're a glober, female, whatever, you can talk. So Epsilon, you're more than welcome to keep saying
I
what
can
you're
talk
saying.
then.
Plant man, yeah, if you're a glober, you definitely are welcome to talk, ask questions. We just like to give the ladies a chance to answer and participate because you know, we don't get to do that a lot here. So
Wait, so hang on. Let me ask this. So you guys don't think it's a flat pizza or like a flat disc either, right? Because creation is saying that.
no, not at all.
Okay, so you don't think so? Then you guys agree with the creation that there's no shape to the Earth.
We don't know if there is a shape. We can't really tell what it is.
Yeah, and also asking like the shape of the Earth
Golden
is.
ellipse.
It's also like saying what the shape of a tree or a lungs or a heart. Things like those don't have some sort of inherent shape. They vary. They're weird shaped. A rock isn't just like a certain shape. Rocks have weird shapes. They're not. Can't just place a shape to it.
That's just because there's like we probably could. You would just take lots and lots and lots of math.
It wouldn't have like a shape.
Like think about it.
Attribute.
Like we can
It would be
mathematically
more.
make any shape. We just have to have the math to prove that it is like a shape. And
Then
so
what does
things that
math?
are crazy shapes.
Sorry, my son is being crazy.
Okay, wait. What were you saying?
I was trying to say that like if you found like a randomly shaped rock, it's not that like just because we don't have a definite shape for it doesn't mean that we couldn't. We haven't really come up with the math for it. We probably have. If I'm being frank.
The map for it or the math for it?
Math.
Like mathematics.
Yes.
Okay, but here's the thing. We are comparing it against the math that we're given, right? And so according to those calculations and supposed measurements that we were given, it doesn't match up to what our reality. So the surface of what we're standing on at least measures
Like
flat.
trigonometry. Do you not think that applies
To
the
what?
real world?
You can apply
Reality. Like
you can apply it to the real world, but what I'm saying is the curve calculation that they're giving us doesn't match to reality.
like talking about like the curvature of the Earth, right?
Yeah, and that's what we were just talking about over there. There's pictures that shows that we are seeing way too far.
But why can't we see like forever then?
You can't see forever.
What do you mean by seeing way too far?
Farther than what the globe allows. Oh,
Right.
go ahead, let's see.
No, you said it. I'm sorry. I think I'm having connection issues.
No worries. But I do want to just say welcome to Over Fences, and also Salt Lake Stacy. Welcome. Thank you for joining us. If you can talk, please go ahead and unmute your mic and participate at any time.
Thank you. Hello, everyone.
Hey, thanks for joining us.
Yeah, thanks for coming, Stacy, and Over Fences.
Yeah, I woke up in time. Woohoo! 6:30 a.m.
I know it's time zone crazy.
Man, I really wish we could.
What is over fences? I don't know what that means.
Stupid.
Over fence.
Suck my dick, creation bear. What's over fences? What does that mean?
Yo, keep it PG, okay? Come on.
Oh, sorry.
You are amongst ladies now, okay? Keep it sophisticated.
True. So do we gotta keep it to the ladies?
What is it? No, you can ask.
Okay, so you believe the Earth is flat?
I know the Earth is flat. Yes.
You know the Earth is flat.
Yes.
How do you know the Earth is flat?
Because there is no measurable curvature to the surface.
But under your I guess system of belief, wouldn't you need to use measurement, or are you saying that as yourself visualizing the Earth?
It is part of the my day-to-day experience. I observe the Earth as flat and motionless. Not in the sense we see mountains, valleys, or whatever. But when I go out to the ocean, it's flat, right? But also, I have observed things that I shouldn't be observing, further away. And that's what we were talking about with plants, is that there are pictures, videos that shows us things that we shouldn't be able to see on the globe that we're seeing.
There's things on the globe that you shouldn't be seeing.
According to the globe, we shouldn't be able to see, but we see in reality.
And what is that? What? Give me an example.
Okay, we literally just went over this on the in the other server. So I want to give I've been talking for an hour.
Okay, I'll let someone else talk then. Yeah.
Yeah, I no, not you, but I will mute myself and let Stacy or Flatsy or Over Fences take over, so that I'm not hogging the mic. But you can talk, Epsilon.
You know why we use the black swan, correct? Do you know the swan argument? Do you know what we're even discussing in the
What's the black swan? Sorry, I don't know.
Hold on, I'll post it.
Okay. Well, can you just tell me? Summarize it for me.
Yeah, of course. That's what I'm.
Yes, you do, Epsilon. Come on, you've been in this game for a while now. Don't lie.
No, I haven't. I really haven't.
So I put the black swan up. The reason why we use the black swan is because we are using the oil rigs as demarcators of distance.
Who is we? And then also, you're using oil rigs as your
distance. Yes,
I understand, but
okay. All right. So the actual argument is, where do you see the horizon? In front of the oil rigs, in between them, or beyond them?
The horizon is a concept.
Brother, you can tell where you see.
No, the horizon is a concept. It's not like 1 + 1 is a concept. The horizon, when you look at the horizon, obviously, when you say the horizon, if you're in China, does not mean the horizon when you're in the United States of America.
What is the definition of horizon?
Yeah, sure, I'm stupid. Creation Bear, can you stop that, bro? Please. Come on.
Yeah, the Snell board is kind of annoying.
But what are you saying?
It's funny.
I'm asking you a question. I just
ask me the question again.
What is the definition of horizon?
What is the definition? I actually don't know. Let me look it up for you.
Stupid.
Sorry, I'm not a fucking flat earther. I can visualize it.
Why are you being a fucking dick, man?
Me?
Answer the fucking question.
I literally said I don't know the definition, so I'm going to look it up. Is that
so? How can you say before that the horizon is a concept when you don't even know the definition of horizon?
The horizon is the apparent curve that separates the surface from the celestial body.
Wasn't that what?
That's literally what the definition is, and I was honest about
Timbo,
it.
bro. If you on their side,
Timbo got this. Sorry,
you guys are wild. I don't even know what's going on. What's going on?
All right. So the horizon is the apparent location where the ground
Meets,
the sky.
yes, yes.
Surface of the Earth meets the sky.
Sure, yes.
Okay. So where does it appear to meet in the Black Swan photo?
Let me see this Black Swan photo. Let me see the Black Swan photo that you're referencing. Can you send like a photo? Because I don't see it in the side chat. Sorry, and I'm also playing games at the same time.
Oh God. Okay, yeah. Well, Donato sent it again.
Can you just send me the photo? I'm paying attention.
It's right
Where's
there.
the photo?
It's the chat.
Okay, the NASA. Is this the NASA link? It says 404 not found.
No. What?
It's
What are you talking about?
in the voice live stream voice text is right above this room.
Live
And
stream voice.
we tagged you in it too. It's literally above the room.
Okay, let me check it.
Yeah.
I'm not part of this. Okay, so that is so. Okay, wait, what is this supposed to show me?
Okay.
Oh, so there's a platform there at 9.41 miles, and then there's this platform at 6.2, right?
Yes, but where is the horizon? Is it in front of the oil rigs, in between them, or beyond them?
It would be both. Because the horizon exists. The horizon is like, because you can't use that concept and try to explain what a horizon is. It doesn't really make sense. Sister, I'm trying to like make it make sense to you.
Yeah, you don't seem to be getting it. The argument is, where is the horizon in the photo?
Do you see the lines that like cross? Even if this is a real photo,
Would the horizon in the picture be the line of the sea versus the sky?
It would just
The line
be,
of
yeah,
Earth
it would
meeting
just
the
be
horizon?
the difference between like what you're seeing on what we call Earth, whether it's flat or not, versus what is, I guess, the sky, right? Which you guys don't believe in. I don't know.
Listen.
You're being disingenuous.
I'm not being disingenuous. I just don't know what you. I
The
don't
horizon
know.
where the surface
Meets the.
appears to meet the sky.
Okay.
Where does it appear to do that in the
Where does
photo?
it? Okay, where does it appear to do it for you? Based on that definition, where does it do it for
We
you?
all have eyeballs and can see. I'm asking
So
you.
no. I'm asking. So okay, I am in the wrong. Let's just say I am in the wrong. Where does it? Where is it for you? Because I would love context.
Oh my gosh! Can't you
No, that's an honest
No, look, I
question.
feel like it's a fair question. That's 100% a fair question, Flatsy. Where would you say the horizon is on that picture?
No, hold on. Before you answer, Flatsy, you guys, we're trying to figure out where you guys claim the horizon is first, and then we'll go through it with you guys. Don't worry, we'll tell you where the horizon is. But can you guys be honest and look at the picture?
Epsilon. I'll let him answer.
Where does the sky meet? Looks like it meets the water.
Where does the sky looks like it meets the water?
Yeah, because that's
the right?
definition of horizon.
Why is Epsilon muted? He got server muted. Someone unmute him.
Listen, stop concern trolling about other people. Don't worry, he'll get unmuted once you answer.
What? Okay. Where do I think it is?
Yes.
Okay, I think it looks like it's kind of hard to see honestly because it looks like it goes past the oil rig on the right, and it looks like it's closer to the oil rig on the left.
So is it in front of them, in between them, or beyond them?
I would say it goes probably like behind them.
All right. Okay. So now the whole argument of the black swan is where the horizon is, or where it appears to be, and the reason why we even have the oil rigs as because they're demarcators of distance.
Okay.
Where the horizon appears to be in the black swan is by 10 orders of magnitude than the globe predicts. That's why we use the black swan, because it's very comprehensive. It's simple. We've got plenty of black swans all over the place. But this
Okay,
one we
well,
use
what about
because
this?
it's
So,
by orders
I
of
guess,
magnitude, dude. 10 orders of magnitude. You would have to say that the
okay, well, hang
globe
on.
is 10 times bigger.
You're saying that I'd have to say the globe is 10 times bigger to even be able to see these things, is what you're saying?
Yes.
Okay, well, before I get to that, let's talk about like the fact that the farther the oil rig is, the shorter it is. Like if that oil rig if we kept moving backwards, that oil rig would keep shrinking and
Yeah.
shrinking until I could only see the tips and tops of it.
So that it's not about the oil rigs, it's about where the horizon is.
Well, like what Epsilon was saying is like you can't really measure the horizon. Like you can actually do that.
The globe does that. The globe predicts where the horizon is. It's not where it's supposed to be by orders of magnitude.
Okay, so I'm gonna look this up. How far can you see for curvature?
While you're doing that, I just want to quickly say, for those of you that don't have any roles, you can go up to the VC check-in and they'll quickly check you in so that you can get roles and be able to talk in this VC as well as access the VC chat room. So continue. Thank you.
All right. So this is why we use the black swan. Because
Okay,
not only
okay, here we go.
simply point
Hang on.
across.
Hang on. It says what I just looked up. It said that like before anything starts to even below the horizon, even by a little bit, you have at least 3 miles.
Yeah. Uh-huh.
So
So the demarcators of the oil
you think
rigs,
that's before it even starts to like sink below the horizon.
that's the distance to it. You're getting a prediction from you, the observer, to where the surface and the sky appear to meet. That is a prediction of the globe of where it'll be. We have evidence that is by orders of magnitude off of that prediction.
I don't know why Epsilon is still mute. Like there would be. It makes no sense. Anyways, like so I should be able to see something like normal for about 3 miles, and then like once I do that, then like little pieces of him will start to be like swallowed by the horizon, and you can see this in your own example.
Listen, the globe predicts where the apparent horizon is. Because it's not supposed to be.
Predicts the apparent horizon. Well, like what is
Yes,
the
because
apparent horizon? Like what's
it's
the
painfully redundant.
where are you getting the? Can you give me the equation for the apparent horizon?
Yes, of course. At 1
Okay,
foot of
please.
observer's height, the horizon should be physical. I keep saying apparent horizon because that the definition of horizon is the apparent location. So it's painfully redundant, and I apologize. But for your globe, the horizon needs to be physical, and there should be a predictive value of how far away you could see it. So at 1 foot, which is where that camera is taking the black swan photo, is at 1 foot of observer's height in feet, and the predicted value of the horizon should be at 1.225 miles. And like you can tell, the horizon is behind the oil rigs, which is 10 miles plus. So your globe would have to be 10 times bigger, which is by orders of magnitude, or the Earth is not a globe.
I feel like this is kind of. I mean, you can't expect me to just take this like one picture and be like, yes, the observer height is 1
I
foot
told you
and
why we
whatnot. Like,
used that was the whole point of this conversation is, do you know why we use the black swan? It's simple, easy, comprehensive. I'm not sitting here asking you where the horizon is for a gotcha. You can see it with your own eyes where the horizon is, and you can go and find out how far these oil rigs are from where is it in California? Oh, it starts with a B.
Santa Barbara, I think.
Santa Barbara, that's it. Yeah, Santa Barbara. So you can go and test this out yourself. You can even go watch the video where the black swan photo comes from, because it's a still image from a video where he shows you how far he has the camera up from the surface of the water, and he shows you because you can figure out how far those oil rigs are from you if you use whatever. You can go online and you can figure out how far away they are from you. You can even use maps and measure from you to them.
And I'm looking at the result he sent a distance to the horizon.
Yeah, we use this image. We've got many others, but this is the one that we use because it's
Can you
super
give me
easy.
another one?
Yes, of course.
And do it from one where it would be like the human height. So someone like 5 to 6 feet observer height.
All right, I took this picture from Dolphin Island, and you could see the little island over there off in the distance. It's like 6 miles away from me, and I'm 5 foot tall, so I'm not normal height. Sorry, I'm kind of short. But yeah,
I really cannot see an island. I'm sorry. I'm not trying to be like.
you can zoom in. It's in the on the right hand side. You can see that land over there.
Where are you also, by the way? Oh, this looks like a beach.
Dolphin Island, yeah.
Island. I'm actually gonna look this up. Dolphin Island.
Yeah, I'm 5 foot tall, and that's about 6 miles away. They don't spell dolphin right. It's not like dolphin.
Yeah, you're right. It's like dolphin. I did look up Dolphin Island. Okay, so it's in Alabama, and you're saying, and you're looking out like to the south.
Yes, yes. I'm looking towards the sunset, kind of, because the sun had just set.
Yeah, I get what you're saying. And so then those islands you're seeing, I'm guessing, are the Breton National Wildlife Refuge, like this like little strip, or is
Yes,
it the
yes.
Gulf Island? Is it the Gulf Island National Seashore?
Sorry, my son's making a lot of noise. No, it's that strip. So you can kind of see there's like a little burrowed beach there, and we were off. I was trying to get a good look. I could have gotten an observation from even further, and was still getting the island out there in the back.
It's
And I'm
my
not normal
so
height, 5 foot, but you get the gist. Shouldn't be able to
okay.
see
So
miles
how
away.
I guess my only question is how tall is like are those mountaintops? They're not obviously like mountaintops,
They're
but
not
how tall
mountains.
are those?
They're not
Yeah, I know
mountains.
they're not. I
Just
know
the
they're
land.
not. I know they're not like actual
Yeah, it's
mountains.
land. It's really like flat land too. Because over there, it's just a bunch of sand and bushes.
Yeah, but it's still you can literally see it that there are like hills on it that like seem to, reach some sort of height. And I'm trying to
Yeah,
ask
it's
what the
not
height
that
is
very
on
high in
those.
elevation at all. But I shouldn't be able to
Like,
see.
can you give me like you saying that you know for a fact that you shouldn't?
According to Earth, the distance to horizon Earth curve calculator, yeah, I shouldn't be able to see it. I shouldn't
Well,
even be
like
able to
part of that
see.
you need to like
I
know the
shouldn't even
height of
be able to.
like those
Sorry,
mountains.
I'm at 5 foot, so most people are at a 6 foot observer height or higher than me.
National Wildlife.
That's just my own personal black swan. I'm sure that they can post you a bunch of their own.
Max.
Also, Stacy, if you wanted to share some of your beautiful images of your hot air balloon rides, that'd be awesome to present those if you wanted to.
At the moment, I'm just doing some gardening. So once I put the soil where I want it, I can be a bit more chatty.
Sure, whatever you want to do. I was just throwing it out there since it went quiet.
Yeah, I'll just put the load down because it's such a heavy load. I almost made it fall over, and I thought, oh no, that wheelbarrow all for nothing. I conjured up all of my strength.
My son is being so loud. I apologize, guys. It's not licking his phone.
They're fine. What is he finding?
Oh, I had presented my own black swan and my observer height and how far away in the distance that land is. And I took this with my iPhone, so it's not with like a P1000 like everybody else has. But it is still my own personal black swan.
Yeah, I was looking at it. It's but what is Plant Man? Is he calculating something?
Yeah.
Okay.
Give me a second, I'm sorry.
Yeah, no worries. Take your time. Over fences, are you able to open your mic now?
What happened to Epsilon? Is he still even here? No, he's not.
No, he left. He got upset and left, unfortunately.
Well, I'd probably be pretty upset if I just got muted for no reason.
Yeah, there was a reason, but we wanted to let you have the floor and actually engage with Flatsy, because he's heard these arguments before, and he's just saying the same old things over and over. Over fences. Hello. All right, I'll start the countdown to 2 minutes.
Wait, for me?
No, not you. I'm just joking. And let me just see if there's any other ladies in the house.
Okay, I can chime in a bit more now.
Ah, nice. Please go ahead.
Okay. One of the most interesting things I have found out recently, which I probably may have talked about here before, but I think it's a little bit of a misnomer is the wrong word for it, but misbelief that flat earthers tend to have is they tend to think infrared. I can see further with infrared, but actually I think with I guess with a few experiments I've done, I'm now inclined to think that infrared, you don't see any further. You can just see a more defined image, which helps clarify the landscape you're looking at more than actually seeing through things. So I think you have optical limits the same as your visible light spectrum and also as your infrared light spectrum. So that's my random conversation starter.
Alright, so I did the calcs. Ready, Flatsy?
You
Yeah, go
can remove your calculation.
Okay, so what I was able to find is it said like if you had two humans and they walked away from each other, when the person like would completely disappear, would it be about 10 kilometers? That's like 6 miles. In your Black Swan example, those islands are at least like 5 meters tall. So you should 100% be able to see them. Hello?
Hold on. Say that again. I'm sorry. My son is playing.
So
And
in your personal Black Swan, right? Hello?
Yeah, we can hear you. Go ahead.
Yeah, go ahead.
Okay, well, her personal Black Swan, she said that she shouldn't be able to see the islands in that picture on the right, right? We agree on that?
Right. Yeah.
So you should. I'm saying that you should be able to, because if it was like, let's say those mountains were human, if it was a human, then no, you probably couldn't, because they would just be too short. Like if they walked like a couple meters forward, you might be able to see like some hairs on their head. But for like a 5 meter tall like hill, you should be able to see it from that distance.
I was walking away from that because you have to walk like close to like
Well,
a
like when
half
we were
mile
talking about it, you said like
up.
6 miles.
Hold on, booger.
You said like 6 miles, right?
Yeah, well, that's where I was when I took the photo. But there's like a half mile
Yeah.
walk. Yeah, there's like a half mile walk to the beach through like the bushes and stuff. From
Well,
where,
either way, you could probably be
yeah,
on any point on that island, and you'd still probably be able to see them.
yeah, but I can see it clearly, like the whole way to the beach, at the beach, away from the beach, and even because I can't
And
capture
I'm
it on
saying that that's normal.
very well, but with the naked eye, I could see oil rigs out that were like 8 miles and further.
You'd have to get the. I mean, I can't. You don't have a
Yeah,
picture of that,
there's
so
a
I mean, I
lot of
can't
oil rigs out
argue
there
with that.
at Dolphin
But
Island.
even if you
It's
if you
dark, you
were,
can see
then you know,
lights.
as long as the oil rig is tall enough, then you should be able to see it from.
Hey, Plant Man, can I ask a question?
Yeah, go ahead.
How did you determine the 6 miles, and what was the observer height?
It was the observer height was 2 meters, so like an average human.
Okay, in imperial.
Yeah,
So we
so
have 6
it's
feet.
two
So
humans. So
actually,
both of them are 2 meters, and they walk away from each other. Like when is the
okay.
last moment that you can see each other?
Well, they don't really need to walk away from each other, but at a 6-foot observer height, the distance over sea level would only be 6 miles. I'm sorry, 3 miles.
As long as like it's two humans though, like because the height of the object that's being observed
Oh, you're
matters.
saying something 6 feet above the surface?
Yeah, so there's two. So let's back to the two humans. So two humans standing next to each other. One of them walks away. How long can the human that stands still see that person walking away? Like what's the maximum distance?
Okay, so you're saying you would just see the top of that other person.
I've like 2 meters is like 6 foot, right, guys?
Well, the point is, if there is a globe with a radius of 3,500 or 959 miles, then we have
And
cutoff.
I'm not. I'm looking at the chat. Sorry, I didn't.
Oh,
Sorry,
okay.
listening.
Yeah,
Give me a second.
we have a given radius, right? So that necessarily implies there has to be a physical geometric horizon. So at 1 foot observer height, the max distance that we should see before that obstructs things behind it is 1.22 miles. We agree on that?
And
Just
hang
keep
on,
it
say that
simple.
again.
From 1 foot observer height at sea level, the geometric horizon should be at 1.22 miles, correct?
Are you're trying to get back to the oil rig
Well, I'm just
picture?
trying to keep it. No, this applies anywhere. It doesn't matter if there's oil rigs or not. I'm just saying this
Well,
is the
yeah, but
baseline.
Yeah, but then you're gonna like, hey, look back at this picture. Like that picture doesn't really mean much. Like the one she sent with like her standing at the horizon, like that I can 100% use. I think that's
Okay, well,
100% fair.
we have another picture that's been posted in chat. Maybe someone else can post it with the wind turbines. Have you seen this one?
Yeah, I like the pictures where it's like, no, it's you taking the picture.
What do you mean?
Like you can pick it. Like I could just look up oil rig and then be like observer height 1.22. Like you know what I'm saying?
No. Can you explain?
No. Like so, if I looked up a oil rig on Google and I took a picture and then I just put, look, guys, observer height here is 1 foot. So that means the horizon is this, and that means that this thing is this far, so I shouldn't be able to see it. Like could have just got. I can put all those numbers on any Google picture of an oil rig.
Yeah, anyone can manipulate the numbers, so why don't you go out and actually do it for yourself?
Well,
Yeah,
that's why I like. That's why what I'm saying. That's why I liked Flatsy's picture. Because
So are you
I
claiming
know
that
Flatsy took that picture on that horizon. Or
so are
on
you
not on
claiming
that
that
horizon, on
the
that
black
beach.
swan picture is not taken at 1 foot observer height, or it's not in Santa Barbara, California? I'm not sure what your argument is.
Yeah, I guess I'm arguing that I can't like validate that picture. I can validate Flatsy. Like I believe that
Yeah.
that Flatsy's picture is applicable
Well, why is hers more valid than the other one?
because I know it's coming from her. Like her picture she sent was just like a plain ass picture, and then we can apply like see this height, we know that this is this and this is that. But with like the pictures you guys are sending me, I could just Google up oil rig, and then get into Photoshop and add the text there that say all the things that I wanted to say.
Okay, so your claim is that the oil rig picture could be manipulated where Flatsy's picture is not.
Yeah, I absolutely. I know for a fact, absolutely, that Flatsy's picture is not, and that's why I like it more.
Okay, well, the beauty of this is that you can do it yourself. You don't need someone else's picture.
Okay, how do I do this myself?
Well, you just need to go out somewhere where you have a large expanse of water, and you need
I don't have that near me.
to have some. Well, then I guess you can just look at other people's photos. Can you go through like vacation photos?
That's what I like. Flatsy was claiming that picture is her personal her personal black swan.
Sure, we all have them. I mean, I could just go through my vacation pictures right now and pull up
Yeah, but
a couple
that'd be
dozen
great.
black swans. Well, you can do this too.
Yeah,
Are
let's
you
do
not
it.
near a lake?
Not near what?
A lake? Are you really like no water?
I mean, like there are like lakes, but they're not like that big. Like you talking about like Lake Michigan?
Okay, Lake Michigan is fantastic. Which side of it are you on?
I'm on the American side of it.
Well, I meant more. Are you on like the Wisconsin, Illinois side, or are you on the Michigan side?
Indiana.
Beautiful, because we actually have photos from Indiana of the Chicago skyline, which should not be visible if the globe
But
is curved.
that I know what you're talking about with that, but that's like you guys also have to throw in like refraction and stuff like that. Like
Well,
you guys are 100%.
Does refraction move things from the back of a ball upright?
Does refraction move the thing from the back of a ball upright?
Yeah, because that's what it would have to do.
It's just refracting light. Like it's light bouncing off of shit, and it just looks like it's there. Like I honestly personally can like get into like all the science, but there is somebody out there that definitely could.
Well, don't you think you should verify that?
That 100% is a great example, no doubt. But there is like explanations for it.
Things can be explained away, but the fact is, if you drive yourself to the shore on a clear day, check the visibility on your weather app before you go out. You can verify this for yourself, and you can decide whether what you're seeing is some kind of mirage that happens to look exactly like the Chicago skyline, or maybe you're actually seeing the Chicago skyline.
Okay, so how would you prove if you are actually seeing it, or if you are seeing like what about like seeing like New York from Europe, like that?
Well, we have a limit to how far we can see.
But why?
Well,
what's the limit?
we have
Like, what about
limitations
like
for our eyes,
I guess?
atmosphere.
Well, hang on. What about like in terms of my worldview? Like, we could
Uh-huh.
technically use a telescope to see like stars that are infinitely far.
Okay, well,
Technically,
that's right. Well, A, we don't know how far away the stars actually are. B, there's a lot less obstruction when we're looking up because there's less atmosphere. So
what
we're
proves to you that
necessarily,
we don't know how far the stars are? Like, we know how far
well,
the moon is from us.
we don't know, actually.
We don't know. We don't know. Like,
No,
we don't know the distance between the sun and the moon.
no, we don't.
Why don't we?
How would you measure that?
Let me look it up.
Well, anyone can claim anything. I mean, think about this. The
Then
distance
so
of the
technically, so
sun.
can you. Like, if we're talking purely about like that, then like you could claim anything, and then there'd be no way to prove it. Like, you guys aren't
Well,
necessarily like.
right. But there, we can look at the ground and we can measure it and determine it's flat. Looking at the sky doesn't tell us anything about the ground, correct?
What? I'm sorry, what?
Looking at the moon doesn't tell us anything about the nature of the ground that we stand on, does it?
Okay, so let me ask you this: like, if you were sitting on the moon and you perceived it to be flat, and then you looked up at the Earth, like you could say the same thing, right?
What?
I'm not quite sure what you mean.
So you want us to jump realities and like go to somewhere which we're not sitting on?
What'd you say?
You want us to change our realities to
Wait, hang on.
entertain your argument?
No, okay, we can move on from this. I don't even know what we're talking about anymore.
Let's keep it
Back
simple.
to what I was saying. So like a telescope. I'm looking out into the sky.
Mm-hmm. Does the telescope
What do you guys?
how far things are?
What do you think that we're seeing?
What specifically? What, the moon?
Like anything, like the moon, stars, Venus, like planets within our solar system.
We're
Like
all
you don't
seeing
think
the
that they're
same
like
thing. We all see the same thing.
Well, hang on. So do you not see like? I guess like, do you not believe in a solar system? Like, you don't think that there's planets surrounding us?
I think that we all see lights in the sky. We can't tell what nature, what shape they are by just visually.
Oh, hang on. With like
The flat
really like
Earth
I've
doesn't.
actually this is actually hang on.
The flat Earth doesn't fit into
With
the heliocentric paradigm. It's not the same. It's very different.
okay, well hang on. So like with a really nice telescope, you can 100% like see like Venus and see its
Yeah,
curvature and see
absolutely.
its colors.
Uh-huh. That doesn't prove its
So
shape.
what do you mean it doesn't prove its shape? You can see the shape.
Okay, I just posted something in the chat.
Okay.
Can you take a look?
Yeah. I
Okay.
see it. What's going on?
All right. Well, which one of those is a sphere?
I mean, they all kind of look spherical.
You're right.
You guys
And
are
that's
trying to use like shading though.
maybe someone can
You guys are
look
acting like if I like are you guys trying to make the point that if I can draw a sphere on a flat plane, then it's impossible to determine something's shape?
No, she's
What?
trying to debunk your claim because
No.
you claim that if you look at the star.
Sorry, Germany. What we're saying is whatever you're looking in through the telescope or whatever visual technology you can determine the shape of it just by looking at it.
But yes, why not?
Okay, that's why she's asking you in those pictures, which one is a sphere?
I feel like that isn't applicable because you guys have to think about it like this. Like, sure, if I look at one image of, like, if I look at just one side of these spheres, then I would know. But we can literally see Venus rotating and get different pictures of it, and then like add those pictures up.
Let me
Like,
ask
okay,
you,
this is probably a ball.
of those four images that I sent, are they all spheres?
Yeah.
They are.
Visually to me, they all look like spheres.
Okay, see, that's exactly the point I'm making. If you see motion on the surface of Venus, there's no way for you to objectively and empirically and definitively tell that you are observing a sphere. You see a light. You think it might
if it
look
wasn't in
spherical.
motion.
But you're not seeing multiple sides, right? We can't objectively look at it, walk
What do you
around
mean
it.
we're not seeing multiple?
There's no way to tell. But honestly, we're kind of getting into the weeds because we don't look to the sky to determine what we're standing on, right?
We don't look into the sky to determine what we're standing on. Why
Right.
wouldn't we? Like, I feel like we could definitely use other celestial bodies to make something.
Do you see trees in the sky? Do you see grass up there? Do you see anything that you see here down on the surface of Earth, water up there?
No, of course not.
Then why would you reference something that is, to the naked eye, just a light in the sky, and with your telescope?
Well, we're like a very rare type of planet, no
Yeah,
doubt, but
no,
it doesn't mean we're not a planet. It doesn't mean we're
listen
not
to
a
what.
celestial body.
Just listen 1 second. You're zooming in with a telescope on a source of light, and then you expect to be able to add more attributes to that is a light because you can zoom in to the light. That doesn't make any sense to just go ahead and determine that it is a certain shape, and just because it's that shape, that the Earth must be that shape. That doesn't even logically follow.
Well, under your guys' view, that Earth doesn't even have a shape.
Well, that's because Earth shouldn't be told. I shouldn't be able to tell you that Earth has a shape because nobody's ever seen the entire Earth.
People have seen what about you guys don't believe that people are in like a space station? You don't believe that people are in space?
They don't even see the whole Earth.
Well, they can still see
in your
good parts of
paradigm.
it and see the curvature of it. Either
Even in
way,
your
Kelsey,
paradigm, are
you
you going to
don't
listen
think that people are in space.
respond? Even in your paradigm, the ISS, if there is people there, if the ISS is there, even in your paradigm, they don't see the whole Earth and they don't see curvature.
They do see curvature. They 100% see curvature.
No, I'm sorry, they don't.
So how do they not see curvature? And
Where you're saying
do you
you're
think that
seeing
people and hang
visually
on,
seeing globe
before
and
we
Earth
even get to
curvature?
this, you agree that people in the
Sorry.
ISS are in space?
Sorry, can you repeat that? Your mic kind of cut out.
Okay, I'm saying that before we even get to what they see, do you even believe that ISS are in space?
Hell no. Well, let's get to that in a
Hang
minute.
on.
Can we stay on
Hang on. No. I really need an answer to this. Lexi Klein over the fences. Do you think that people are in a space station orbiting the Earth?
You can't have gas pressure without a container. So there's no possible way, even if there was you can't have a pressurized system adjacent to a vacuum because the gas will fill the available volume in any and all directions violently. So it's not possible.
Unless there's a force, unless there's an outside force, right?
No, it needs to be a physical barrier.
Yo, someone please mute creation.
Yeah, but let me ask you.
It's kind of obnoxious at this point.
Yeah, see, we just tone it down a bit. But let me turn the question around to you. How do you know people in the ISS?
Wait, say that again?
How do you know there are people in the ISS?
I mean, I'm gonna just do the obvious answer and say like the YouTube videos.
Okay, so you believe that there are people in the ISS. There's no way to confirm or verify that there are, right?
Well, like our government says that they're there, and like other governments around the world are like, yeah, like it's a communal thing. Like every world government like has a person who they're sending to the space station.
Right, but you only have to take the words of the governments that supports these programs, right? There's
Well then there's the people like you can like the people that have been there like they're real people and you can like talk to them like people do that all the time.
Let me
supposedly, right?
Like it depends on what like proof is to you.
Go ahead, over fences.
Okay. Are you saying, Plant Man, that people in the ISS is proof that the Earth is a ball? Is that what you're saying?
People say that again. The people in the ISS.
Yeah, that
what?
people being in that are you saying photos from the ISS? What exactly? I didn't quite understand what the claim was or how ISS came into play here.
Yeah, I'm just saying like, do you think that there are people are orbiting the Earth in a space station?
Well,
called
it's
the ISS,
really
the International
well.
Space Station.
No, I don't, because that would be a second law of thermodynamics violation. But if there were,
how the space
are they
would
still
be a
high enough?
violation of thermodynamics?
Yeah, absolutely.
Okay, so then you do not believe that people are in the space station.
I believe they're somewhere. I don't believe they're in what we are told is the vacuum of space next to our atmosphere with no barrier. No, I don't. It's not that I believe it. It's that I know it's not possible.
So then, how could you ever try and use like what they say as like, proof? And like you're saying that like what they see isn't flat, but you shouldn't even be like saying that. Like it means nothing to you because you don't even
Well,
believe
I
that
was
they're
just
there.
we often hear globers say, oh, photos from the ISS, or I saw curvature from a plane, or any number of those claims. And actually, the ISS isn't even high enough for you to see curvature from. So someone in the chat posted a really great diagram of that, where you can see the height of the ISS relative to the claimed size of the Earth. But it's really not relevant, because if the Earth is flat, all the rest of it is disproved. There's no reason to argue what NASA is or not.
What?
Then it's disproved. There's no reason to argue, is the ISS, real? Is are we going to Mars? Is Hubble actually, taking photos in deep space? All of that's irrelevant if we can objectively see that the ground is flat. If the Earth is not a ball, none of that holds.
The Earth is not a ball. None of that holds. But that's the thing is like the Earth scientifically is seen and known to be a ball.
Stop the cap.
But that's a belief, not. Go ahead.
No, I was just gonna ask, what science says the Earth is a ball?
Like literally anyone with a science degree would say that the Earth is like in some way, shape, or form spherical.
So now it's a science degree person, not science.
Well, I mean, you guys you guys try and use science, right? Like with like the containers and whatnot. You guys to some degree have to believe in science. Like you can't have we can't be on this
listen.
computer without science.
We're talking about pseudoscience, okay? We're disproving the pseudoscience of the globe. We're not talking about science. The actual science disproves the globe. So that's why when we bring up the gas pressure, the globe falls apart because it doesn't hold up to the science of reality.
Gravity can cause gas pressure.
There's actually
cause
gas pressure. Gravity causes gas pressure.
gravity can cause
Can cause fast pressure.
Something.
I'm gonna let.
It is the only
Can you
cause.
cite a source for that claim?
Sure.
Okay, great. So we've already shown you some photos showing that there is no geometric horizon at the claimed location that would validate a ball Earth. Correct? And
Sorry,
and it seems like what you have right now is just saying that the photos could be manipulated. Correct?
Sorry. You got to start over.
Okay. Well, it seems that your objection so far is that the photos we've shown you of the wind turbines and the black swan and flat seas photo that
I didn't disagree with the black swan that Flat Sea Climb gave us.
okay.
Right.
I had
I was going along with that one.
okay. Well, I'm not sure what the observer height was. I mean, she really has to discuss. I missed that part. So, so you're willing to accept a photo from her, and
yeah, I did,
since
and
you live
I
in
think
Indiana, right?
Go
So,
ahead.
you basically what I hear you saying is you accept this as evidence, but you have justifications for it. So, okay, yes, you can see Chicago from the other side of Lake Michigan, but it must be a mirage, right? Or refraction. Is that what you're saying?
Refraction definitely has effect on what we can see.
Even though it's
height
15
of the object, our height, where we stand, that all has an effect. That's what I'm claiming.
I'm sorry, can you restate that?
Yeah, I didn't hear what you said.
Am I cutting out or something?
You just kind of got quiet.
Can you hear me?
Yes, I can hear you. Can y'all hear him?
Yeah, I can hear you. And I'm gonna unmute Sticky or Moss, just so you can have some sort of backup.
Okay. Well, where were we?
We were discussing the validity of what we can see, like, for example, being able to see the Chicago skyline from Indiana.
Yeah. What
Well,
about
I would just the beauty of the truth is that it's objectively true. We don't need a million explanations to talk it away. We don't need to convince you to just believe and set aside your own thought process or logic. You can just go out and do it. You can drive yourself to the shore and you can do it. And you don't have to believe us, and we don't want you to believe us. We want you to know the truth.
Okay, well, what about? I feel like we need to get back to the whole gravity thing. Do you think gravity is a thing? Yes or no?
Do I think it's a thing? I think it's a theory.
Do you?
I mean, which type
Well,
of gravity are you talking about? You're gonna have to tell me what you mean by gravity.
Well, the most accepted version of gravity right now is relativistic gravity, right?
But I'm sorry to interrupt. Before we go off to gravity, can we finish off on the curvature thing? If you concede, yeah, we concede the globe. The globe calculation doesn't make sense.
I'm saying the Chicago skyline is a big part of it is refraction.
Okay, so
that one you guys can show me that picture all you want. That's not going to change anything.
Okay, so over fences. I don't know if you were at the politics server earlier, but one of the ones that I presented was the mountain, the Guinness Book Record mountain one with infrared, and infrared is supposed to kind of help you disregard refraction because you can see farther, right? So would you accept pictures as such?
I have a question. Would you accept?
Hold on. Sticky, hold on. Let him answer first, please.
I'll be quiet.
Thank you. Plant man?
Yeah, what's going on?
I asked you if we present to you a picture that refraction has no play in, but we are still able to see too far, then would you accept it?
Well, like, what's the picture? That's important. Like, that's kind of what matters. Like the Flatzy-Klein picture, 100%. I'm with that.
No, it's a picture that's in the Guinness Book of Records. It's the furthest picture that was taken. It's 200 over a fence, dropped it in the live stream. It's over 255 up, 9,000 feet up high. We accounted for the height of the mountain that we're seeing. It should have been below, I forgot the numbers, but like 5,000 feet below the curvature or something. We shouldn't even be able to see the top of the mountain, let alone the base. And we clearly see all of the mountain. I mean, aside from the other mountains covering part of it.
I would not say clearly. That is quite the stretch to say you see it clearly.
Aside from the mountains in front of it, covering some part of it, and that's just due to the obstruction of the mountains. It has nothing with the actual curvature of the Earth.
Zoom lens, blah blah blah.
I guess, I'd ask, are you willing to claim refraction at 255 miles?
I don't know. I guess not. Oh, hang on. I guess my biggest thing is like you guys think that there's like a distance with what we can see. Like I don't really think that is. It's just a matter of like light can hit our eyes.
That's the claim of the globe. There has to be a distance to like how much the curve or the bowl is going to obstruct our view. After a certain distance, we can't see because we are being obstructed by the physical. That's not our claim. That's the globe claim.
The globe claim is that Earth is not a perfect spheroid. Therefore, it's kind of hard to figure out where that distance is. Hey, Plant Man, Planty Man 13, check your messages. I got a photo for you in your messages. So what I'm trying to say here is refraction.
I don't even know where my messages is.
Refraction is very advanced trigonometry. Okay.
Okay. I'm just gonna mute you for a second. No offense, Sticky.
Whoa.
Let's get Stacy to say something because I want him to share the picture he sent you as well, so that we can be participant of this.
So someone said that.
I don't even know where to check where it is.
Yeah,
you guys would unmute him. Like let him talk to me.
Okay, he'll talk
Just
to you.
A little bit.
Just chill for a second. Okay.
Can I quickly chime in quickly? Okay, so someone said that it's hard to do work out the curvature stuff because the Earth's an oblate spheroid. But for purposes of calculating curvature, we can assume it to have the equilateral radius, which is the bigger radius than the polar radius. And by doing that, we're actually giving curvature the benefit of the doubt. So there's going to be less curvature drop. So we're only helping the globe model by assuming it to be a perfect sphere of the equilateral radius. So it's not a concern.
Perfect point.
Okay, so there you go. If Sticky or Matt Moss, if you could share the picture as well so that we can see what you're talking about to Planty Man, that would be nice.
Yeah.
And did you hear what she said about the oblate spheroid?
Yeah, and don't feel free just to tell me to stop talking. How about that? And then I can share when I can share.
She was trying, but you couldn't hear her. That's why I muted you.
I apologize.
Yeah, no worries.
Okay.
If someone interrupts me, I'll stop talking. How about that?
Yeah,
See,
are you able to speak up a little bit? Your voice comes through kind of low. So
Okay, I'll change my settings.
awesome. Okay, go ahead, Sticky or Moss.
I can't share yet.
You can share in the. Okay, send it to Creation Bear. Send it to Creation Bear. He'll post it.
Okay, thank you.
Yeah, no worries.
Oh my god, dude. We got to jump into a time capsule and go back to 2013 with this one.
Oh yeah, you love that, don't you, Creation? Talk about it. Love it.
Hang on, where is this picture? I want to see it.
I'm posting it right now.
See it too. Share.
I literally rapped about this in one of my songs. So I got you.
Yeah, let's hear about it.
Are you throwing it in the live stream
There
voice
it is.
text?
All right, I'll mute up. Go ahead.
Out in suspense.
Okay.
Oh my gosh.
Oh, now tell me how that's different than your Black Swan. Tell me how this makes any sense.
Come on, guys. Let's be class here.
Yeah, let's.
Let us talk.
Okay, yeah,
And,
we'll
kinda
give you the
explain
floor. We'll give you the floor, Sticky or Moss. Go ahead and make your state your argument and so on and so forth.
No, the picture's the argument. You guys need a rebuttal.
Okay, what are you claiming in this picture?
What I see curvature.
Just say like. Okay, so your point is that the picture is curved. So like.
I can see clearly now. The rain is gone.
Hey, Sticky, I
well
posted something at 7:37.
My point is refraction is very complicated. It's very complicated. Trigonometry. That's what I'm trying to explain here.
Well, it's not just simple trigonometry because of all the factors involved.
Exactly.
However, your picture does not prove curvature. Why don't you take a look at what I posted at 37?
Nor does yours.
Post a picture. Could you go ahead and read what I posted?
No, I am not legible at this. When you have a degree in something that doesn't exist.
Not legible. I'm not quite sure what that means.
I don't see what you're talking about. Is what I'm trying to say.
37 minutes after the hour. In the chat.
It's so crazy to me, like that you guys think that like astrophysics is real. That's crazy.
That's a lot of scrolling up. Would you explain?
I'll repost it again.
Thank
you.
So everybody stop posting in the chat, please, so that he can look at this. Okay, I just reposted it. Do you see it?
Is it this? Good afternoon, sir.
Yeah, that's it.
I spoke with one of our lead engineers in reference to the question.
I please read it out loud.
Just read it.
Yeah. Let me read it out loud. To the question.
Let a man read it out loud.
Pertaining to the Causeway Bridge, please see our engineer's response in the red font below. Does the causeway hold a uniform altitude above water level, parenthetically, throughout its entirety? No. There are 5 locations, parenthetically, 3 humps, and 2 channels. that allow
The
passage of
soundboard
boats
is so
of
obnoxious.
various size, north, center, and south humps have 25 feet of clearance. The north and south channels allow 45 feet of clearance, and the north bridge level has about 15 feet of clearance. Over the 24 miles of distance, how much earth curve is the causeway accounting for? Seems to be a rare occurrence. Where Lake Panadakaran,
Wait, you posted it and pronounce it? Okay.
This is your post. You don't even know how to say it.
This is not my post.
Here,
Is long enough to
Vicky, take
experience the geonomic.
I'm gonna read it. Stop. Okay. Over the 24 mile distance, how much earth curve is the causeway accounting for? Seems to be a rare occurrence where Lake Pontchartrain is actually long enough to experience this geometric drop-off. And then we have the response. There is a drop-off of 522 feet, but the bridge is constructed in spans that are either 2,240 spans that are 56 feet long on the southbound bridge, or 1,500 spans that are 84 feet long on the northbound bridge. So the drop-off per span is negligible. The difference between a chord and an arc of 24 miles is less than 3 inches. 24 miles is long, but not when compared to the entire Earth. The next question, is the causeway truly a straight line as it appears in the aerial photos, or is there a deviation left to right? The southbound bridge, constructed in 1956, is a straight line. The northbound bridge, constructed in 1965, is parallel to the southbound bridge for the majority of the length, with only the ends angled toward the southbound bridge near the shores.
Okay. So water doesn't seek level, or what's going on here?
So no curvature, no Earth curvature was accounted for in the construction of this bridge. If the Earth is curving like a plane, if the Earth is...
It didn't say it wasn't there, that it was negligible.
3 inches?
No. What I'm trying to ask is water seeking level here? Because it's diving into it.
You posted a photo that shows a curvature that's possible over that span. So we're just going to...
The definite.
Because there was no curvature accounted for in the construction of the bridge. 3 inches is negligible, as it was stated. And let's move on to something, with some meat to it. A curved photo of a bridge isn't cutting it. I mean, we have actual, numbers for where we should see globe curvature.
Let's get away from the black swans then too, right?
That's not a black swan argument. That's a globe argument.
No. It's the counter argument to the black swan, right?
A photo is not a counter argument.
Okay, so then stop posting photos. Stop talking about photos.
What are you referring to?
You requested me to give to Creation Bear.
You have a photo that...
Exactly.
Okay, can I ask something about that photo you posted?
Yes.
Okay, when you look at that part at the very end where you think it's curving, do you notice a symmetry with like the top end of like a vertical symmetry of that sort of blurring part?
Yeah, it's like setting like the sun.
But do you notice a symmetry? Does it look like a reflection?
I can see that.
Okay.
I can see what you're... I can go out on a limb.
All right. So if there's a reflection and there's like this line, which from that line onwards, things start to be reflecting downward relative to it, which we see like whenever you go to the coast and stuff, you'll actually see this effect. Does that mean, is that the horizon? That mirroring line?
Do you see the top of the nearest to us? These are called struts, structural struts that are coming up. You can't see the nearest ones, but the farthest ones get so much shorter. Why is that?
Sorry, just looking for the picture. Can't find it.
Probably because of the
You
curvature of the
understand
Earth.
like basic art perspective?
I love how you say perspective and then you say black swan, like the pictures mean everything until they don't.
Okay, we're talking about your photo now, right?
I hope so.
Okay. So you do understand that things they move away, they get smaller as they move away from us, right?
Yeah, just like that second rig.
Okay,
and I'd even go out to say the further away they go,
Let's bring up that black swan and count how many platforms down it has versus the same exact rig.
You realize it doesn't matter. It could be a stick in the water. It's the actual oil rig isn't the issue.
So when they sent sails out and they watch them disappear into the water, what does that mean?
You understand that even on a flat surface, things disappear bottom up. You can
No, they don't.
test
What?
it on you can test it on a table. Yeah, they do.
How?
Here, I'll
Okay,
post
explain to me
for you.
how. Yeah, I need proof for this one.
Yeah, and if you'd taken an art class, you'd understand this. It's not even. You don't even need to get deep into globe Earth, flat Earth stuff.
No. This is crazy. I need some real proof on this one. You're saying that things on a flat surface would disappear bottom up the same.
Absolutely. So here, I posted something in the live stream. And if anyone has something better, I like this one, but
I'd be a bit more careful than saying disappear bottom up. I'd be, I guess, a bit more technical in saying they'll reach its like mirroring line, and where that mirroring line is, it will start to merge, and that's gonna anything below that mirroring line until the point it stops reflecting.
That's if the camera is at like the horizon of what they're walking on. What if the line is following their head? So like, what if you had the camera at head height and they walked off like that?
It would take
It would
longer.
never disappear bottom up.
You'll have to.
They would never.
What if he's walking down a hill?
No,
Did
he isn't.
anyone?
You
How
realize
do you
it's a
know?
football? Because it's a football
Let's
field.
look at. Well, hang on. Let's look at the diagram you sent, where like the guy's camera is on the ground, and then they walk away, and then they disappear bottom up because the angle, like you can obviously you can visually see why it happens. But what if that camera was head level? That would be then your example would. No, you're like
you will
the only
have
reason that like your guys' proof in this is that the angle gets shorter, so that means that distance, like the height of it, would be different.
You will have for the height of the camera if you are placing the camera at the height of the guy's head, and so it will take longer for his like Stacy says, we don't. It's not really disappearing bottom up, but for the conversions to happen.
I would argue to say that the camera is angled down in a fashion, and in this photo, it's only 100 yards, and the guy's missing half of his body. That doesn't make sense to me.
I did an experiment of this.
Have you seen someone walk? Have you been able to lay down and see someone walk 100 feet and miss past their body? No, that is not how perspective works. I would argue that the camera is angled down, and this is cherry picking.
I'll show you what I've done. So I went to a Salt Lake, and I had my friend walk out. I think maybe 1 kilometer. I think, which
That's like way farther. No.
Yeah.
Let's go back to this. Let's go back.
Bro, can you?
Hang on. My God, please stop at the example.
Cut it
My
out.
God.
Let her finish what she's gonna say, bro. Please, we'll let you talk, okay?
As my friend was walking out, I had a telescope fixed, and I was watching my friend walk further and further and further away, and there was no geometric horizon he would have met at 1 kilometer, so he shouldn't have had any, like, theoretically you should have seen him properly and fully, but you started to see, oh, his feet are starting to like, I don't know, like get really long because like the ground started to reflect where he was standing. It was actually like, it looked like sky. And so his feet were becoming really stringy. And then like the further he went out, he turned into like just like a blob of a torso and then reflected upside down as well. So that's what perspective does. You can do, like try it
Exactly. So
yourself.
let's not post any photos anymore because, like I said, refraction is a thing. It's very complex, and we can post back and forth photos.
This is a refraction has nothing to do with this.
Absolutely, it does. And if you don't understand how light can refract, then you don't understand photography and what makes a picture.
So what two media are we looking through to see refraction in that picture of the football field, which is 100 yards, not 100
Your eyeballs. That would be a conveyance.
For refraction?
No, that is not what I'm talking. Refraction just means reflected. Okay.
No, it doesn't.
Yeah, it does.
No, it doesn't.
How light interacts with things is refraction. Please Google it.
You said reflect. That's not the same thing.
How is it not?
Refraction requires two media. That isn't saying your eyeballs in the air.
That is a medium. Your eyeballs are a medium.
There is one medium.
For light.
Your eyeballs are medium.
Yeah. How do you process light? How is it not a medium?
Your eyes
That's my
are.
question.
You're the observer. Your eyes have to perceive things through two media for it to be refracted.
Correct. That is correct.
You don't understand refraction.
No, you don't.
The argument goes both ways, ma'am.
No, you're projecting.
No.
You can say no. I can say no. Good job.
But you don't have to make up your own definitions.
No, okay. I have been this whole time.
Making up your own definitions? Yeah, we know.
You have.
That's fun because you said I couldn't, and now you say I can, and now you say I haven't.
But that doesn't work in reality, and we're dealing with reality. Your eyes are not a medium.
Your eyes are a medium for the numpty clips.
I can make up something, and you can phallicize whatever you want to.
Well, then we're not having an argument. We're not even having a discussion if you just make up things on the fly that don't work in reality.
Let's get back to Planty Man. At least he's sticking to actual
well, I guess my thing is if you put that camera at head level, I don't think the guy is disappearing bottom up. Because in your example, you guys are using the angle of the angle of the camera to well, hang on. You guys are using the angle of the camera to prove that he would get shorter the farther he goes. But if he's at head level, it gets rid of the angle. That problem doesn't happen anymore. So if I'm at head level and he keeps walking, what would make him disappear bottom up?
Like I said, the camera is on the floor. If you were to bring it up to the height level, you'd have to account for the height level. The higher you go, the further
height.
That's just.
I'm saying, like, think about it like this. I'm saying it's the you guys' proof on why somebody would disappear like bottom up on a flat surface is because the camera is below and it makes that angle, and that angle gets smaller and smaller, so they still appear to disappear bottom up. But at head level, that problem goes away. Like you can't use the angle because the angle's not there anymore.
Yeah, you're not understanding. The camera is on the.
No, I don't think you're understanding. I feel like you're kind of disregarding what I'm saying.
I'm accounting for the height level. I'm saying if you put the camera at the height level, isn't that what you're saying?
Hang on, we could actually.
Hold on. Are you saying if I put the camera at the height level, or at the guy's height, you're saying he doesn't disappear bottom up, right?
Yeah, like that. Like, why would he disappear bottom up in that example?
Because you're gonna have to account for his height. that means it's going to take a longer distance for him to go out of your view of field.
The height has nothing to do with it because they're the same height. That's what I'm saying.
Plant-Man, you can do this yourself.
Yeah,
Just set a camera around, long haul. You know, you can do it yourself.
What?
But the height.
I'm trying to argue like the mathematics here, guys.
Math can show that Superman can fly. I'm really. It's kind of irrelevant.
What do you mean math can show that Superman fly? That
That
is the dumbest shit I've ever heard.
Really?
Yes, that was really dumb.
So math.
Like, what does that mean? What does that have to do with anything?
Because you're saying we're going to use math to disprove something that we can objectively prove. That you can go in a long hallway right now and prove yourself. But we're going to use math to explain.
So like you're saying like math isn't applicable to the real world or something? Is that what you're trying to say?
No, I didn't say that. I said
when
we have measures.
Like, you guys are trying to apply math, and in this example, like let's use the math to discern like why they would disappear bottom up, right? In fact, and now that I'm looking at it, it still doesn't make sense to me on how they would.
Listen. If you're something, if you're looking at something, and let's say you have your head laying flat on the ground, and you're looking at something in the distance, right? Whatever you're looking at.
Let's get away from the flat on the ground. Let's get it to eye level. How about that?
No, bro. Let me finish. I'm trying to get there. Okay. So if you're looking from the bottom, now you got me all confused. If you're laying flat on the ground and your eyes are like a few inches above the ground, right? You're not going to be able to see as far away. As you're standing up, you're going to be able to see further away. Why is that? It's called perspective. That doesn't mean the ground that you are curves and that you're seeing some sort of whatever you were looking at was hidden behind a curvature. It just means that you are raising your field of view. So as you go higher up,
I never argued that. I'm not arguing that like whatsoever.
Well, then what's your contention about the camera being on the ground? What do you not understand?
Because in the way that you're trying to prove it is that so the camera's field of view, like on the ground, it was limited, right? And when we bring the camera's point of view upward, then it has more of a field of view, right?
Right. So it just take longer to do the exact same thing.
Why? So here's the thing: with the camera's view on the ground, like you guys are, like over the fences, you can see the picture that you sent into the chat, right? Over fences, you can see it, right?
I can see what?
Like the picture that you sent, the diagram.
Oh,
the camera
and the
being
football
on the floor, and then yeah, and the football. Like let's get rid of the pictures of the guy in the football field. I don't care about that. I care about the diagram of the camera looking at the guy.
Do you understand the direction of the view? Do you understand how that changes based on your? Yeah, I mean, obviously, observer height.
I get it. That's part of the reason why the field of view gets disrupted for the guy walking away is because the camera's on the ground. It's not level with his head. And I'm saying if you had it level with his head.
Are you claiming the grass is in the way? Is that what you're claiming?
Well, that and also like the camera's field of view doesn't like match with the guy. Like as he's you can do the thing. So like look like the first line on the first guy, right? That you can see the top of his head, right?
Here, I'm gonna post it again because like way up in there.
I'm gonna try to find the actual video and not just the picture. So
thank you. Video.
Yeah.
You know, Grim posted a ton of videos in chat. I pinged you and Sticky to take a look at those. They might be helpful in helping you understand what's going on here.
I'm looking for I don't know what math you plan. I'm going to go to the bathroom really quick, but I'll be right back.
Okay, there, I found it.
Did you find the video or is it the picture? Oh, dang.
You wanted me to post the picture, but you know, the video.
Oh, yeah, I found the video if you haven't.
I think he's trying to say that the camera is at level.
I honestly don't understand the argument he's presenting. Like,
it's code.
Yeah. It's like, why isn't it at the at the head level? Do that. It'll just take longer. What the heck? All right. Is anybody else here while he's gone? Or you ladies want to say something?
Hey, I'm back. Hey, so
Oh.
Is there any way that one of you guys could someone could do like a screen share or something? That way I could like show to you guys what I'm trying to say.
I posted the video, by the way. Just scroll up at the top of the hour, and you should be able to see the video.
Yeah. Okay. I don't care about that. I'm trying to do it from like. This is why I need like some sort of screen share. Like, is there any way that I could like
Just
draw
take
something
screenshots and send it to my DM. I'll post whatever screenshots you have. You don't do screen share here.
Oh, I don't have like screenshots prepared. Like I would need like a draw space, and then I would just want to show you guys the draw
Go
space.
for it. You can send anything to my DMs. I'll post it for you. But we don't do screen share here.
That's gonna.
You do, and
it's gonna.
The camera, we have the same effect, correct?
Well, hang on. Wish this would be so much easier if I could just like screen share.
That's never gonna happen. So I'm just trying to offer help, bro. DMs.
Yeah.
Okay. Oh, let me just try and explain it this way. So, can we get the diagram back? I don't care for the video. I want the diagram. But here it is. Everything's just got it up right here. You guys see it too? The diagram of the camera on the ground and then the guys walking away. Hello?
Yeah, I hear you.
Okay. So, I feel like that makes sense that he kind of goes away because in the field of view of the camera, he is, kind of leaving it. The field of view of the camera goes, up and down as well, but half of the down camera is gone. So he's slowly getting farther away. If you had it level and he keeps walking away, there's no reason why he should get shorter. Like in your example that you sent when he's on the ground, it gets shorter because the camera is at an angle to the top of his head.
The camera's not at an angle.
Wait, then why would it show like an angle marker? Like you looking at the diagram, you see like that yellow line that like makes it a little round. To try to visualize that there's an angle and that it's getting smaller and smaller the further and further away he gets, so he takes up less of the field of vision.
I think that this would be helpful if you just looked at some of the videos that are posted.
Yeah, or, I'm looking at it like that means nothing to me. I'm talking about the diagram because it's the same thing.
Well, it seems like we're at an impasse with that. So I would direct you back to the videos that are posted, or to do this yourself.
Okay, let me try and draw it. Let me try and draw it, screenshot it, send to the guy. Give me a second.
That angle is not the angle of the camera. It's just from what you would see from
It's the angle of the camera to the guy. Yes or no? It's the angle from the camera to the guy.
It's the angle. It's not the camera being angled. It's the camera is level at all times, and it's saying as the guy.
Hang on. So the camera. So the lens of the camera to the guy's head. There is no angle in between the ground and his head.
Your question was why is
why would your example visualize it? Why is it making sure to note the angle?
Calm down, bro. Can I explain? You keep interrupting every 2 seconds.
Okay, sorry.
Your question was why is the camera angled? and we're saying the camera is not
I'm
angled.
not saying the camera's angled. I never said the camera is angled.
You asked why is the camera angled? That's what you asked.
I did not ask that. I'm
Yes, you
saying
did.
that I never asked why the camera is angled.
In that diagram, the angle that is showing with the yellow angle,
Fine,
right?
yeah.
What
What is that angle then?
Okay, I'm about to explain. It's just showing that as the guy is walking, the angle of like your field of view is decreasing. So the farther you walk away,
absolutely.
it would be. So therefore, it appears like.
So the whole reason that he's disappearing is because that angle is getting smaller. Yes or no?
Yeah, not because the oh my gosh, not because the ground is curving. It's your perspective.
100%. 100%. Hang on. Oh my. Okay, perfect. We can. You guys realize that like Kansas is like as flat as a pancake. Like I'm not arguing that there aren't places that are flat. I'm just saying the Earth as a shape is round, or not round. Sorry, spherical.
What is your contention about this picture?
Like you said, the angle is showing that the smaller the angle gets, the shorter he will look, and like the angle will start to disappear bottom up, right?
Yeah, because the angle from the ground to the man to his feet is smaller than the angle the upper part. Do you get it? So the farther away he walks away, it would appear like he is dipping into the ground. Because the angle it gets smaller and smaller until he completely disappears. And not due to
my point is that if you eliminate that angle, by just making it head level, then there is no reason why he should sink into the ground. Because there's no angle there's no angle to get smaller. There's no angle to get smaller. So how would it get shorter?
There will always be an angle there's always going to be angular resolution. It's just that now you have
0 degrees angle. So is a 0 degree angle an angle? Is 180 degrees an angle?
All right. I'm going to keep muting you while I talk because you cannot seem to let me finish my thoughts. As you put the camera at the height level, are you looking at the diagram? Let's look at the diagram. As you put the camera up to the height to his head level, right? Now you have increased your field of view. So now it's going to take longer distance for him to disappear, right? So that's what we're saying. The same concept is going to apply no matter how you keep going up. You're just going to increase the field of view. Again, you're not putting any sort of curvature to the ground.
I'm server muted. Okay. Yeah, and I'm saying that like makes no sense. How? So if the whole reason, hang on, let me explain this. If the whole reason, like on a flat, like hang on, indoor, in Pooter, if it's on a flat plane, and the reason that he perceives to become shorter and like sinks into the ground is because the angle keeps getting smaller. If there is no angle, why would he sink into the ground? It's dependent on the angle, and then we removed the angle, so there should be no reason for him to sink into the ground.
Okay, what do you think is happening in that picture that we showed you, or the video?
I don't care about the video. I'm talking purely like the idea, like the diagram of it.
Yeah. What do you think is happening?
You should technically be able to with the diagram that you have, just imagine putting a camera on the ground and then do what you do, like measure out the angles and be able to come up with a prediction for like what's going to happen in real life, and it will be 1-to-1.
All right, ladies, I'm gonna let you chime in this one because I don't know how else to explain it to him. I've said the same thing. So
yeah, I know what you're gonna say. You're gonna say, well, it's at a flat angle, so it just takes longer. But like my entire point is that there's no angle. How could you possibly have an angle to like prove to me in Pooter that if there isn't an angle, he would still get smaller? Why would he get smaller if there's no angle that decreases?
Are you willing to look that have been posted?
What do you mean? Like, look at what? I'm talking purely diagram. Like, I don't care about the video. The video means nothing to me. Where the fence is in Pooter. Come on now, let's talk.
Well, I'm sorry. I'm kind of losing hope as to your understanding. So, what's your question again?
Okay, so my question is, like, the whole proof that, like, camera is that it, like, the person sinks is because the angle gets shorter, and so they will sink from bottom up. Right? Yes or no? Even on a flat plane.
Yeah. So
things over distances will always sink bottom up, even if it's on a flat plane. That's what you guys are trying to claim.
Yeah, sure.
What do you mean? What do you mean? Yeah, sure. Are you going back on that? Is that not what you're trying to claim?
I just want you to get to your question. So go ahead.
Well, I'm trying to make sure we're just on a like basis of understanding. That obviously we're going in loops. So
I don't know if we are on the same understanding because I've explained field of view, perspective, height, and you don't seem to understand. So I don't know where, like, how else to explain it to you.
okay. Well, here let's try and explain it this way. You think that something, it's no matter if it's a flat or if it's curved, if something keeps getting away from me, it will disappear bottom up. The whole point of the diagram. I mean, that is literally what you guys are trying to prove. Yes or no?
Okay, yes.
Okay, yes. Okay, so in your example, you have the camera at the bottom, and I'm saying that the reason that the person disappears bottom up is because the camera is level with the ground, not the person. And so if you make it level with the person, it doesn't matter about field of view. That has nothing to do with it. It has to do with the angle of the camera to the person's top of the head, the top of
Do
the
you
person's
realize
head.
if you make
That's what we're measuring.
if you make it even with the person, you have just drawn a parallel line to the ground, correct?
Yes, correct. 100%.
So why would that be any different? It's just going to take longer.
Because in your example, because in your example, the lines that are being drawn are diagonal and create an angle compared to where his head is. So
take
if
the
it's
same
parallel,
angles.
it doesn't. Take what up?
Take the same angle and lift it 6 feet above the ground.
If you did, then there would be no angles. That's my whole point. There could literally be no angles. Because the camera would be level with the head. The angle that is insinuated by the yellow line is the angle of the guy's head to the camera and the camera to the horizon. That's what creates the angle. But if you have it level to his head, there's no angle to be made. It's just a flat plane parallel to the horizon. And so there's no reason for him to get shorter. Because the line will go on forever and continue to match his head.
Okay, I encourage you to go somewhere that you know is flat and do this experiment yourself. I mean, not experiment, but like
what
go
about
out.
how well, you guys don't even have like mathematics for this. So like what distance should I start to see my feet disappear from my at what distance
Okay,
would you
well,
expect it?
what's your observer height?
What's my height?
What's your observer height? Because that impacts how far you can see things.
Well, we can do both. We can do the where the observer height doesn't matter because we put the camera on the ground, right?
That is an observer height. If the camera's on the
Yeah,
ground,
but
the lens is
has
the
no
observer.
height.
Yes, it is. The camera lens is the observer in that case.
Yeah, I know, but because it's on the ground, there is no observer height.
That's not true. It's not. It's not flush with the ground. It's sitting on top of the.
We can just the distance between the camera. Like if I put a camera on the ground, the distance between the lens and the ground is so minuscule that you can disregard it. It doesn't matter.
Okay, let's pretend the camera is at 1 foot. Okay. How far should we see on a globe of the given radius.
Dude, I don't care about this. We can let's
You don't
forget
care
1
about
foot and let's either do it.
What?
Well, hang on. Let's do it like this. We'll either do it from the ground or we'll do it from like human height level. So like 6 feet, 2 meters, whatever you want to say about that. No
Sure.
1 foot. Let's not try to go in between.
Cool.
What?
Okay. So go on now.
Okay. So at sea level, from a 6-foot observer height, we are back to the beginning now. I should see 3 miles.
Well, you should be able to see unimpeded. Like that's without it getting shorter. You should see 3 miles without anything impeding, like impacting your view. And then after that, it's going to be
before the
things will start to
curve.
impact it.
Yes, before the hill
curve
impacts my view. Correct.
Yeah. For sure.
Okay. So we don't see hills of water, which is kind of a problem.
What is a hill of water? I never said anything about a hill of water.
Has to be a hill of water, right?
How does there have to be a hill of water?
Because it's curving around your globe.
What about like you can put a straight line on the top of the globe, right? It's called a tangent.
I understand what a tangent is.
So if you just continuously follow along that tangent, where is the hill? You would almost perceive it to
drop
be
off at
continuously
3
flat,
miles.
right?
It would drop off at 3 miles. There's something posted at 16 minutes after the hour. Take a look.
Like, is it that oil rig thingy again?
No, it's wind turbines, which we know you globers love to use.
I don't know why I would like to use wind turbines.
Well, not you necessarily, but
If the Earth is a sphere with a radius of blah blah blah, then every horizon distance measurement must be no more than
for now.
observer's height in feet. The lens, like this means like this is like the same thing with like the oil rig thing. Like it doesn't really mean anything to me.
Why doesn't it mean anything to you?
Because like I could just look up wind turbines and then like I could then Photoshop like any distances I want in there, and then put in any of the numbers.
Okay, so your argument for the globe is that these photos are photoshopped.
No, that's not my argument.
Your argument completely rests on this being photoshopped, correct?
I mean, not exactly. No, there could be 100 million like external reasons for why we perceive something as it is.
So the globe just has excuses why we observe and experience the Earth is flat and non-rotating. So we just get excuses. We never get any kind of empirical evidence of actual Earth curve. You always want to say that's refracting. That's doing well. You need the Earth curve first, and then you can start giving us all the reasons why we don't see it.
Oh, Platzi, we were using like your black swan, and in that example, it was wrong.
But it wasn't.
What?
It's just you saying
but
that.
It was.
You just saying that I should be able to see that on a globe doesn't prove the globe. That would be logically fallacious. You need to be able to present the evidence of the curvature that we don't ever see.
So what would prove to you guys that the Earth is like what's the empirical evidence that you guys are looking for?
Direct measurement of drop over distance curvature.
Drop over distance curvature?
This experiment would convince me the Earth is a curve. If someone did a laser test and they had, say, 5 different target locations, so as the laser will stay level, but the curve will drop down. So the further away you are, the higher the laser will be. So at each location, say the closest location, someone will stand with a camera, try and get that line of sight laser.
Did you send something? Yeah. I don't know what you're referencing.
I'm trying to explain to you a test which would prove the curve of the Earth, and that's when I'll be a curvature believer, is when someone does this test. So you have different, like say at 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers, 5 kilometers, different setups. The laser stays in the same place. And then at the first place you have your camera set up, you work out, okay, say 5 meters of curvature drop. And then you have, say, a ladder 5 meters above sea level, and you have your camera, and you try and get that perfect core of the laser into the camera. Then the next location, 2 kilometers, say that's 8 meters, go on a ladder 8 meters, and so on, and actually confirm, okay, we're actually seeing the laser right where it's meant to be. And then if someone would do that, I would be convinced.
Okay, so you're saying that if so like this Indio guy sent like a picture of like the Earth curve, but it's like doing some weird stuff, but that doesn't matter. What matters is like it seems like what you're saying is if we do the viewer height and if we show the laser like perpendicular, the way to prove the Earth is curved is by taking a pole from distances that like we should be able to calculate the height of the pole, put it there, and then it should hit like it should cross the laser, right?
Exactly, yeah. And you do multiple different distances to, like, if you just do one, you know, like, you're not actually confirming curvature, you're not showing a consistency in, okay, it is curving this expected thing, but if you have, like, a few markers, then that's confirming it, and that's what people don't do. And I mean, like, it's a hard test to do for sure, but
well, yeah, it'd be really hard because of gravity.
Illusion, why don't they do it?
Oh, the military.
Well,
You can reference the military.
What?
The military did it. You can reference them. They did it with 3 different colors so that it would they would all have different refractive indexes. But funny enough, over a 30-mile range, they were able to paint the target with every color.
So were they using different distances?
Wait. So you don't think that like a bullet can move along the curvature of the Earth then? Like
they were using
that.
No. What are you talking about? That was completely non sequitur.
Well, you're saying that like they shot something.
Laser.
Like your example was. Okay, can you send that? Can you send it like the military doing this?
I'm sure that somebody's about
after.
Oh, hang on. Say, is this it? The over the fences thing that you sent?
Yes, sir.
Couldn't paint
And
a
there's
target with a laser beam 50 miles away. And because there's no curve.
And
if
old
the
dude.
Earth is a globe and is 25,000 English statute miles in circumference, the surface of all standing water must have a certain degree of convexity. Every part must be an arc of a circle. From the summit of any such arc, there will exist a curvature of declination 8 inches in the first salute mile. In the second mile, the fall will be 32 inches. In the third, 72, showing the following diagram. You couldn't paint a target with the laser. I'm so confused. I don't even know like what it's even trying to say. Do you want to explain it again, Flatsy?
Well, this is a different one, but it still applies because the military did this up until like 2014, I think, or.
Well, hang on. So hang on. Before you bring in like the military doing tests, you think the military would agree with you?
A lot of military people are flat earthers. Why do you think that we know all of this stuff?
Like I would like what percentage of military people do you think are flat earthers?
Does it matter?
Who
It
cares?
matters a little bit. Well, I mean, you're trying to.
We don't
If you're trying to use the military as a source and they don't agree with you, then like that's kind of dumb, right?
Well, how many people do you think that just got out of basic training and that are going overseas or doing any of this kind of ballistic work? They're just thinking, oh, where's the curvature of the Earth? No, they're not thinking about that. But when they do think about it, you get flat earthers.
Because they're just like, well, science class told me it was a ball, so I'm just gonna kind of go with that.
Not the people who have to do this.
What?
They don't account for curvature.
So like
but,
like I was saying,
but Joe,
how are you going to use the military as a source if the military doesn't agree with you? Like that doesn't make sense.
It's the results of the testing that it doesn't matter what they
people
believe.
That like did like well for one thing like the people that did that
color Does that mean
Test,
globe?
they still think the Earth is round, like they know it.
They don't know it. They believe it, just like you.
Well, then can I say that you just believe that the Earth is flat?
No, because it can't be flat, or it can't be a globe because of this reason right here. The sea sparrow is a great reason. That you can shoot a laser line of sight to a sea skimmer.
Where I don't see this example.
Over
I don't know
50,
where.
they only give you up to 50 miles because the actual distance that they can shoot this laser is classified. So they're unclassified, it's up to 50 miles.
I'm sorry, I literally don't know what you're referring to. I can't see.
Okay, then you are just plugging your ears and not understanding.
No, I'm saying like I'm looking in the chat and I can't find what you're referencing.
The sea sparrow, the one that you read.
Yeah, what about it?
Stupid. Yeah, the military has to use these lasers to target something 50 plus miles. They've had to do tests on these lasers that they use for line of sight targeting to the point where they use all like 3 different styles of lasers, different colors, because different light spectrums have different frequencies. So they would have different refractive indexes, right?
Okay.
Okay, so all 3 of the lasers that they used all painted the target, no refraction that you guys like to invoke.
Well, it seems like in this thing it says that the Block 1 sparrow couldn't paint it. It's saying that it couldn't.
No,
At least that's what the thing that her thing said. The thing that over fences said, if the Earth was a ball, Block 1 sea sparrow couldn't paint a target with a laser beam 50 miles away. Wait, okay, never mind. I read it wrong. It can because there is no curve.
Stupid.
Okay, that was warranted.
Yeah, you can. Yeah, it's fine. I misread things a lot and misspeak. We all do it. Either way, the point that we're trying to make is that there is no Earth curvature in that scenario specifically, and in many of our references to the military and their testing of lasers, do they ever have to account for curvature?
Rarely in the testings of weights do they ever have to account for the curvature of the Earth.
It's okay to
guys
say
win
you don't.
today. I will do some research. I'll be back. How about that?
That's perfect. Yes, please do. Yeah, of course, do your own research. Yeah, I
Yeah.
mean, it's nice to have some help here and there, but that's how would you do a research paper? You would want really good references and really good sources, not just Wikipedia and not just Google searches. That's not what I wasn't able to do that when I had to write research papers in college. I had to go deep dive research into all different types of sources before I could write a paper on it.
And Plant Man, you understand, we all used to be globers. Every single one of us. And the only reason we're not anymore is because we actually did the research. Not because someone told us to believe it. Not because we just
I don't
got
know,
an
bro. I
idea.
feel like
Or we thought we'd be contrary.
it's kind of funny that you say that because like what about all the people like all the like PhD scientists out there that also
Well,
have equally done just as much research, if not
no, they
more,
haven't.
and
That's
they
the
think that
problem. And you actually dig into this, you will find that there isn't the research to support the globe concept. And see, we all grew up believing it was done for us. We believed it was taken care of, that smart people had measured all of this, that smart people had done this, and we didn't need to question it. But it's not true.
I'm gonna follow up on that with asking you, Plant Man, what is your proof of curvature? Like, besides what they tell you, NASA.
I would say like
What is your proof?
the way that like things move in the universe, like I feel like it almost has to be a sphere to accommodate for gravity and to accommodate like the way that everything works, like especially with like the solar system, like things that we observe that are like really close to us.
Okay, so celestial bodies are things up in the sky, is what you have as proof for curvature of the ground.
Yes.
Why are you
Well, not only
equating?
that, but like, how can you have gravity? Like, do you guys believe that gravity is a thing?
That is a good question. How can you have gravity when there is for gravity?
Like, how can you have gravity?
Did I cut out? Did you hear what I said?
No, I didn't hear what you said.
Oh, I said how can you have gravity when there is no evidence for gravity?
What do you mean there's no evidence for gravity?
Okay, first of all, we want to ask you what is your evidence for gravity? Then, if you're claiming there's evidence for gravity, what's your
Yeah,
empirical
like
evidence?
I drop a pen and it falls to the ground.
Bruh.
And it accelerates at 9.8 meters per second squared. What do you say to
On
that?
average. That's
I
an
would,
average.
yeah, and also I would say
Yeah,
that's
because like if it dropped like a piece of paper, it wouldn't accelerate at that because it would have air friction and stuff like that.
that's just an observation that you're doing. What is your experiment to show the
Experiment to show what you keep cutting out.
Oh, okay, sorry. I'm saying that's the observation that we all make, right? What is your experimentation to show that the cause is gravity?
What do you, so if I am doing nothing to the pen, why does it fall?
Well, you had to pick it up first.
Sure, like that's like energy conversion. That's like putting potential energy into it. Like, why does it fall?
It returns to where it was.
Why? What is acting on it to do that? There is no reason like it should do that, but it does.
What about a helium balloon?
Less density. It's less dense than the air around it.
So that can't be the answer of why it falls when you pick something up and it drops to the ground? Can't be the
No,
same
because
reason?
density is like like think about it like this. Like if I have a helium balloon, it'll go up all the way to the top of the sky, but it won't just float off into space.
No, because space doesn't exist. But let's stick to the
Well,
point.
okay, well, and in terms
If
of
you're
my view, like it won't like the helium balloon will go up until its density, like the things that are around it are the same, and then it'll chill there. Like it will never just go off into space because it's still being pulled down. Like um density is caused by gravity. Like it's a thing because gravity is constantly pushing it down. So things that are less dense have to be pushed up by the things that are more dense and that are essentially like more heavy.
Or maybe the balloon seeks equilibrium.
It is, technically.
Well, you said gravity is pulling it to a certain place, and that's why it doesn't continue up.
Yeah, it doesn't just float. Like you guys don't believe space is real, but like in terms of like my perspective, like the balloon floats up to the top, but it doesn't leave like our atmosphere because
it can't
it's being
exist.
pulled down.
Okay,
What do you
show proof of gravity acting on the balloon, on the pencil, whatever?
Yeah, well, like why does it fall? Like isn't that the proof?
No, you need an empirical evidence. That's what I meant when I said earlier. You don't have any.
Like how like
Okay, you need to stop interrupting us mid sentence, bro. Okay.
For real.
So what I'm saying is, you see the effect, and you're saying that that is gravity. We're saying that we both see the effect. Now you claim gravity is your causation. What is your experiment for that claim? I don't know if I'm cutting out or not.
No, it came through good to me.
Okay, so let's just hang on. Let's talk about like this. Like we agree that for something to move, something has to act on it. Something doesn't just move for no reason.
Right, you picked up the pencil.
Yeah, if I have like my headphones standing on my desk, like they're just gonna sit there, like nothing's gonna do it until and then I hit it with my hand and then it moves.
Right.
Right. So if I'm holding a pencil up in the air, then I let go of it, so which means like I didn't act on it. I'm not throwing it downwards. I'm not throwing it upwards. Just let go of it. It will still just fall to the ground. What is acting on the pen?
You tell me.
It's denser than the medium it is in, so it's gonna displace all of the air, right? But I'm gonna ask you again. We're not the ones claiming there's a causation. Sorry, we're not the one claiming that gravity is the causation. So you keep obfuscating to other
Wait,
things.
so hang on. Well, hang on. You're saying that like.
I'm gonna ask you again. What is your empirical evidence, experimentation to show that when you let go of a pen, it is the gravity pulling on it? What is your experimentation?
Okay. Yeah. Okay. Here. So you guys are saying that that it could easily just be the air displacing around it, and that's why it falls, right? You guys are saying it's density. It's not gravity. It's density, right?
Which is why a balloon by itself falls, but a balloon filled with helium rises.
Yeah. Okay. Awesome. So, what about if we completely took out all the air and then dropped something, and then something still dropped? Wouldn't it be wouldn't that have to be gravity or some sort of external force?
Still heavier than the medium.
Nope.
What do you mean it's still heavier than the medium? What is a medium?
In a vacuum, whatever
Things
you
don't
are
fall the
dropping is still heavier than
Well,
the
you
medium.
can't. So then if I can't use space because you guys don't believe in space.
It can't exist. Quit saying that, dude.
Let me
Why can't space exist?
hold on. Let me clarify something, Flatsy. Space doesn't exist as a vacuum, is what we're trying to say. We look up and see black stuff at night, right? And we everybody observes
Hang on,
this.
explain this to me.
So hold on, bro.
What is a vacuum?
Every single time. Calm down, dude. Okay, we let you speak. You ask a question, then you're gonna interrupt. All right. So again, I'm just clarifying. When we say space doesn't exist, it doesn't exist as what they tell you. Okay. God damn.
Oh, well, back to what I was trying to say. What is it like? What would you guys define as a vacuum? Like, you guys agree that vacuums exist. So what would you define
Okay.
as a vacuum?
Let's at least put it this way: an absolute vacuum is not possible. Also, um, I mean, nature abhors a vacuum. So it's always trying to entropy is going to always fill every space. It's just that's the way it happens. It always increases. That's
Say that
why we
again. What did
say
you
that
say?
the vacuum of space can exist because we have gas pressure here on Earth, and you're talking about living on a ball that's an open system adjacent to this supposed vacuum of space,
Well,
where the
in
air
my
can't exist
worldview,
adjacent to.
gravity can cause gas
Gravity
pressure.
can't be a physical barrier. And also with
Well, if it's pulling if it's like because let's look at it from the relativistic
it's at the
gravity
weakest
point.
point
Like
where it would
Earth
be
is so massive that it bends the curvature of space time around it.
Bruh.
So when air is on that bended curvature, it'll constantly keep flowing towards the center of mass of Earth.
Cool. Can you show us
that force is what is containing
is
the air.
by
And so
gravity?
you could almost imagine that as its container.
Cool. Prove it.
Oh, yeah. Prove all of the stuff you just said.
You just made so many claims, baseless claims that you have no substantial support for. So everything that you just said is super hypothetical and not reality.
Super hypothetical, not reality.
Show us space time. Show us. How can we measure it? Can we touch it? Can we feel it? Can we manipulate it?
Esteban, you're dude in your chair, buddy.
Hey, you're not modding this.
Yeah, the next thing I want to hear from you, Planty Man, is some sort of experiment that proves gravity is what you say. So if you need to look it up, go ahead, take your time, but please prove your gravity, whether it's space-time, whether it's mass attracting. I know you can't talk. That's why I'm talking, because you keep interrupting everybody. So prove something about gravity, or just forget gravity. I don't want to hear it. Anything about it.
Okay. Okay. About like a vacuum. Like if we make a near perfect vacuum, and then we drop something in it, and it falls.
Things don't fall. Right.
Sorry, you cut out.
Things don't fall.
Things don't fall. I can't. You guys are constantly cutting out.
Okay, so let's take your vacuum experiment. What is your independent variable?
What is my independent what?
You're claiming that's your experiment to show gravity, right?
Yeah.
Okay, do you know what experiments consist of?
Yes.
What do they consist of?
The scientific method. Okay. So you're asking what's the independent variable of my experiment where I drop it in the
in this
drop it in the vacuum.
Yes.
Wouldn't the independent variable? So hang on, let me think about this. Because if we have to have a control and then we have to have an experimental.
You have to have a dependent.
So the control in this scenario would be the normal. Would be like you just drop it in normal air, but then the experimental would be we take out the vacuum and
so what
we take out the air and then we drop it.
What's your independent variable?
The vacuum.
How do you isolate gravity?
Wait a second. What? Sorry, say it again.
She said, how do you manipulate gravity? That's your independent variable.
You can't manipulate gravity.
Therefore, you can't falsify it. So that's why we're saying there is no evidence for gravity. Thank you.
Hang on, say that again.
Oh my god, bro. You said you can't manipulate gravity, which means you can't falsify it, which means you can't experiment on it, which means it is not a cause of anything if you can't experiment or prove it in an experiment. So in your vacuum scenario, am I cutting out again? The only thing you're manipulating in your vacuum experiment is the medium, which is what we're saying is the causation.
Wouldn't the medium be the independent variable then?
Yeah, that's the medium. That would be the independent variable, not gravity. Therefore, you're not testing for gravity here. You're just testing for density.
No, well, that's the thing is you're taking density out of it.
You're manipulating matter. You're removing the air, which is the medium.
Hang on. Let me re-answer your question. So the control is one is normal. We're just outside, and one is we're in that super like vacuum. Both drop a hammer and a feather. The independent variable is that one has air and one does not, and then the dependent variable is what happens. Right?
Yes.
You agree on that?
You said what was your independent variable? Not gravity, right?
Well, I'm taking it. Well, I'm taking it back. I'm saying my independent variable is the medium that it's in.
Wait, the independent variable is.
Sorry, what's going on?
I'm just clarifying. You said the independent variable is what?
Is the medium. So like whether it's in a vacuum or whether it's not. That's the independent variable.
So that's what you're manipulating, not gravity.
So what does that have to do with anything?
Bro, you have to manipulate gravity in order to the cause is gravity. I'm gonna manipulate fire.
Okay. So you're saying if I can't change how gravity works, then I can't prove that gravity exists or doesn't?
Wait, say that again?
I'm saying since I can't manipulate gravity, like what do you mean by manipulate gravity?
Scientifically, right? When you're using the scientific method, saying the cause of things gravity, then you have to show that you're actually manipulate, isolate, and increase and decrease whatever how the experiment. That's how you're gonna manipulate gravity to show that the causation of gravity. But in this case, you're not doing anything with gravity. The only thing you're doing
so you're
is
saying
the medium.
So because gravity doesn't change in both experiments, that means that I can't prove that gravity is a thing. That's what you're claiming, right?
What?
You're not doing anything with gravity, bro. You keep trying to insert gravity in the experiment. You're not doing with gravity. Maybe Fatih, you can explain to him. I clearly can't get anything.
We can't explain anything to him. He keeps acting like he doesn't understand. If you want to make a cause claim, if you want to make a cause claim, what you presume to be the cause needs to be a part of your experiment. And it has to be the independent variable. Otherwise, it's just a baseless stacked on claim upon stacked on claims that you've not proven to begin with. So stacking claim upon claim does not prove your initial Earth is a globe.
Let's try this. How about this? So, well, I guess what I'm claiming is that there's a force that brings things down. All right, that's my claim, and I'm claiming that that force is called gravity. Okay,
Not everything is going down.
Not everything is going down. What do you mean?
Gases are going in every direction, up, sideways, omnidirectional.
They're not.
You're not
but
having.
They still stay within. They still stay within a certain
because they're
area,
contained.
right?
They have to be contained.
And I'm saying that they're contained by gravity.
So you're saying something
that's
baseless.
my claim.
Yeah, but your baseless claim isn't a physical barrier that the gases are bouncing off of.
The only thing I need to do to prove that is prove that gravity exists, right? As long as gravity exists, then I hold true.
Is gravity what's keeping my propane in the tank? Can I have propane without the tank? Can I have propane without the tank?
Like pure propane? Probably not. Like it'd probably disperse if you just opened up the tank.
Right. Okay. All right. So we're getting somewhere. Continue.
Okay. So what is that? How did that prove anything?
Any one of you ladies want to interject?
You have to have a container for gas and gas pressure.
What?
Where does gas come from?
Where does gas come from?
Yeah, the gases in the air that we breathe in our very dynamic system.
I could literally never answer that question.
Yeah, you can. It's very simple. It comes from inside and from the surface of Earth.
From the inside and the surface of Earth?
Yes. Things put out these gases into the air, into the system. You know, like how
well,
you know how
let's just get back to
we breathe in the oxygen.
Like you're saying that
breathe
we
out.
can't have gas pressure without a container, right?
100%.
That's correct.
What if I'm saying what if I'm saying that the container is gravity?
You would have to be able to prove gravity can be a physical barrier.
Okay, perfect. Awesome.
Listen, buddy.
Awesome.
Stop.
Well, hang on.
Stop. No, let me finish my thought. You'd have to prove that gravity is a physical barrier where it's weakest.
So if I just prove that it's a force, the thing.
But even in your own paradigm, it's not a force.
You said it was the bending and warping of space.
Which results in a force.
It can still be represented as a force. It's just what it really is it's just potential energy being released and being turned into kinetic energy. It's still
Cool.
like there's still a force being applied.
Show us how that contains a gas.
How what contains a gas? Gravity?
Your bending and warping of space-time.
Gravity.
Yeah, show us. Because the example you gave was not able to isolate gravity, so that one doesn't count. So do you have another one?
Well, all I'm trying to like with that example, what it's trying to prove is that there is something that is pulling us down.
You basically just proved density to us.
I just proved density to you?
Density is a force.
You didn't prove gravity.
If there's no air for density to apply, then why does it keep falling? Like there's literally nothing to like act on that hammer or the feather in that sense.
You're
So
saying
like,
they fall
why would
if
it
there's.
fall?
Are you trying to disprove gravity? I don't know what you're doing.
All right, we'll say it again. What are you confused about?
Your vacuum chamber experiment that you presented to prove the existence of gravity didn't do that. So let's move along.
Why?
And
Hang on.
because we could not
I'm not done.
isolate gravity. We can't manipulate gravity in that experiment. We can't turn gravity on and off.
You could
Change
never
the
manipulate
masses.
gravity. That's hang on. If let me ask you guys this: if I dropped hang on, over the fences, just answer this. If I, in a perfect vacuum, dropped a feather and a hammer, which would hit first?
Bruh.
What does this have to do with gravity?
Because you guys are saying that
in a
if you change the
vacuum?
masses, you guys are talking about if you change the masses of the thing, then it would alter how it like gravity would change depending on that.
How the masses? You're altering the masses through putting them in a vacuum chamber?
I never
Did he
said
say?
that.
Okay, that was I think Bruh L said the masses.
Sorry.
We're equating different things.
So
in the vacuum chamber, it's the acceleration due to gravity, which is constant based on the masses.
Prove it. How do you manipulate gravity to show that? You don't.
You don't manipulate it because the Earth is a constant mass.
What does that have to do with things?
Okay, so how can we prove that gravity is the cause?
Hold up here. Did you say Earth is a constant mass? Let's go with this. Let's roll with it, okay? So Earth is constant mass, yes? Is the moon a mass?
Of course.
Yeah.
Okay, so the moon is a mass and the Earth is a mass, yeah? And gravity is mass attracts mass, yeah? So in billions of freaking years, and the moon and the Earth haven't, attracted to each other because of this purported gravity?
Because there's orbits. We can.
Because there's orbits, so like there's not gravity now.
No, it's okay. Orbit. Have you ever heard of like when like you take a marker and you like swing or like a glass of water? Like if you take an open glass of water and you swing it around your arm, the water will stay in the glass.
That it would have to be physically attached to something like my arm.
No. So like, let's say you have like you can literally do this yourself. Like fill a glass of water and then take that glass of water and you put it in your hand and then like swing your arm in a circle.
Yeah, I know.
The water won't fall out. It will stick to the bottom of the.
Okay, but that's not the same concept because you have liquid inside of a container, sir.
What? What does that have to do with
what?
What I'm trying to get to?
Yeah, it does. Okay, hold on. Okay, because you have liquid inside of a container, and you're trying to prove that liquid stays on the outer surface of something with this same concept.
Okay,
well,
all right. If you didn't fucking
welcome to Flat Earth.
Man, I just love holding up a mirror of your paradigm. Thank you, Jenna. That was precious.
You're welcome. Always happy to help.
I mean, we used to be Globers also. This kind of crazy stuff that you're spouting is baseless claims that have never been verified. So Why can't we talk about what really is on the really is level? Things that we know through observation and experience.
But didn't everybody used to be a flat earther when they first grew up? I mean, when you're a kid, you're a flat earther because you don't know any difference, right?
No.
Matthew.
Probably had astronaut pajamas. You had a solar system mobile over your crib.
Yeah, but you had to be taught that the Earth is a globe, so you didn't
Sure, and it
believe
was
first.
indoctrinated from birth.
Right.
Yeah.
Matthew, long time no see, buddy. How you doing?
Hey, I'm doing all right. Been
Good,
fun listening
good.
to you guys.
You still doing Bible study, Bible teaching?
I teach at a university that's a Christian university, so I teach computer science, but try to incorporate
Okay.
Christian stuff.
Right on, right on. You still hung up on Isaiah 40:22?
Well, I don't think I've ever been hung up on it. I mean, I just read it figuratively.
Last time I spoke to you, you were hung up on it.
I mean, I'm just saying I wouldn't call it being hung up. I'm just saying I read it in a certain way.
What does Isaiah 40:22 say?
That's the one.
What does it say?
The circle of the earth, God's
It
citizen.
is he who sitteth upon the circle of the earth, whose inhabitants thereof are like grasshoppers, who spreadeth out the heavens like a curtain as a tent to dwell in. That is a description of this earth, and it does not describe anything spherical.
Yeah, so circle, grasshoppers, tent, and curtain. So you want me to say literal, figurative? I'd rather just say figurative.
Yeah, there's certain parts that are literal, certain parts are parabolic, some they're just parables. So, certain parts are songs, certain parts are histories, wars, lineage, battles, all that stuff.
In the same verse, you can mix up all those genres in that one verse.
No, I'm just saying that's what the Bible is. It's like a history book. It's not even a religious book,
Right, but we're not grasshoppers. And
but see, this is there it is. That's what you were hung up on last time. That's the thing you were hung up on last time is the grasshoppers. We are like small like grasshoppers in the image of he who sitteth upon the circle.
Right.
That doesn't mean we are grasshoppers, Matthew. This is the problem we had last time. We're talking about how the heavens are spread out like a curtain as a tent to dwell in. That's the focus point.
Yeah,
not the grasshoppers spread out like a tent to dwell in. That's the focus point. That's where you got hung up last time I spoke to you months ago.
Right.
Is that good person, Matthew? Nice, good guy who.
Sorry. I just wanted to add, in 56 minutes after the hour, I posted, it's an ancient Hebrew conception of the universe. This was not made by flat earthers. This was made by biblical scholars that studied the Bible. They are globe earth believers, but they're Bible scholars, and they admit that this is the conception of what the Bible was trying to portray according to the Bible. Do you see it?
I see it.
Okay, so I'm just saying, I was deafened for a bit. I just jumped in, but you can't go around and say that the Bible is not a flat Earth book.
That's an accurate conception of the Hebrew conception of the universe.
This was made by scholars, biblical scholars. Right. And they have an explanation as to, they weren't, God didn't, they have their own reasoning as to God didn't tell, people that it was a globe and why he portrayed it to be a flat earth in the Bible. But at least they're intellectually honest about, what the Bible actually portrays,
I see what you're saying. And that's a good argument. So fair point. I generally take it more figuratively, but you could say that some people take it literally.
Well, it's it's not about independent interpretation. It's about what does the Bible actually say, and you can't just say I take it figuratively when the Bible is trying to convey a certain cosmological idea, and you're just going to ignore that because you globe. It's okay to say that the Bible, but it was wrong. You could say that because that's what the globe Christians, the biblical. There's a reason why God wanted to show them a flat Earth instead of a globe Earth, because whatever, right? I think you're in that sense they're calling God, but I get the predicament.
It's a little bit choppy there.
Oh, sorry. I'll mute. Go ahead.
Yeah,
a fair
the Bible. Yeah, the Bible does depict a lot of things, and will let you know when it is being figurative and literal. The Bible doesn't just read like a novel; it reads like history. If it's the
That's why I
inspired,
say
if it's the inspired word of God, what are you? You think that they were just told a bunch of figurative things, or did the Holy Spirit guide them to write down actual truth? That would be the question to ask.
Yeah, that's a good point. And I would say that we need to figure out what the Bible's message is in that particular context, in that verse, and that type of thing. And I would generally say that most of those verses are meant to be taken as spiritual truths and that kind of thing. So, for example, Psalm 112:6 says, "Shall not be moved forever." I don't think that means literally moved. I think it's sort of a figurative spiritual sense. Doesn't mean that.
like literally, it shall not be moved.
Yeah, he shall. The word "moved" is the question is the word "moved" figurative or physical?
Well, Psalms are songs, so I like referring to.
Hey, I'm back. Are we ready to talk?
Sure.
Alrighty. So Donato sent in a great picture of what I was trying to. 8:59. Y'all see that? Hello.
Fugal force.
Oh,
Yeah. What are you trying to say?
The guy who has like the bucket and he's like swinging it around his body.
Yeah.
What is the force that's keeping the water in the container?
Isn't it
What do they
like
call that? Centrifugal?
Why can that? Hang on. Why can that guy do
force?
that?
Yeah.
Yeah, centrifugal force. So why doesn't that apply to like an orbit for a planet?
You have a container. Once again, you have water in a bucket, a container. Okay. And when that centrifugal force is being applied, guess what happens? The water levels out. It flattens out on the surface of that container. It's not, it's a terrible argument for the globe, sir.
I would actually agree on that.
The only
They're
thing
different forces.
They are different forces indeed.
I'm trying to get to is that centrifugal force is obsoleting the gravitational force, and that means it just moves across an orbit. That's why it doesn't just sink into each other.
I would kind of disagree. The centrifugal force comes from the fact that the water wants to go in a straight line, but the bucket is pulling it in a curved line. It's more of a pseudo force, whereas gravity is a real force that holds things like planets in orbit. It's different perspective.
Right.
So you're
At
trying.
the top of that
Centrifugal
circle,
force
the
is not a
water is the
pseudo
free
force.
fall.
Gravity is the pseudo force. Gravity is the pseudo force. Centrifugal force, we know, is a force. We can demonstrate it.
You're talking in terms of the forces on the system. When you consider the bucket being thrown in that circle, the bucket in the water, they want to fly off tangentially from that circular path, but somebody's pulling it inward to a circular path. Whereas that would be kind of an outward force because the bucket, everything else wants to go away from that circular path. But gravity is pulling it inwards. It's different directions.
No, bucket is pulling it inward.
No, the
Yeah.
bucket's under tension right now. It wants to fly away. If you were to let go of it, it would fly away tangentially from whatever
Okay.
point you let
Right.
go.
So
Without
It
so
would, it
there's
would, it would fly
there has
away
to be something
perpendicular to the
physical
tangent.
holding. There has to be something physical holding that.
Bucket.
Bruh,
Like your
it wouldn't
arm.
fly away at the tangent. It would fly away perpendicular to the tangent.
Well, tangent or perpendicular to the radius, which yeah, that's the whole point.
You could technically say
Tangentially.
it would go, no, not perpendicular from the radius. It would be in line with the radius, technically.
No,
No, it's
definitely wouldn't.
perpendicular to the radius.
A tangent is perpendicular to the radius. It would
Yeah,
fly away.
100%. And I'm saying that the way that the bucket would fly would be perpendicular to the tangent.
But when
Yeah,
we
but
talk
without
about a centrifugal force, it's the feeling of want to fly away from the point of rotation. That's the pseudo force. You're not actually being flung away from it. Because like in our kind of inertial reference frame, you would feel like you're being pushed against the wall, right? Like consider, one
Like
of
the
those.
gravitron thing.
Yeah,
The
exactly.
the
You feel like you're being pushed against the wall, but what's really happening is you want to fly away tangentially, but the wall is impeding that motion.
That's what we said.
Again, is a different force, given that it's pulling you in. It's not something impeding your outward motion. It is attracting you towards the center of the radius. They're different
Cool.
forces.
Can you prove that?
I mean, I would say Cavendish, but people don't like that around here.
what is Cavendish? Go ahead and break it down for us. That'd be
But
great.
in that experiment, you're attracting mass to mass. You're negating.
Oh, okay. Wait. So hold on. Let's take it but step by step. It's an experiment.
Who's interrupting who now?
I want to take us through it. I don't want him to just
Just
gallop.
saying.
I was going to explain it, but you can ask your questions and I'll answer them all the same.
Okay, so Cavendish is an experiment, right? Is that what you're saying?
Yes, it's called the Cavendish experiment.
Okay, so what is the independent variable?
The independent variable would be the two masses that you're attracting to one another.
Okay, what was the observed phenomenon?
That they were attracted to one another.
So
you can measure it as well.
So you're okay. Lay it out. So your independent variable is
the two masses being attracted to one another.
And that's also your dependent variable.
No.
It's if the objects get attracted to each other or they don't.
The dependent variable would be the torsion on the wire that they're suspended from. You can measure the actual. Sorry?
I don't think that would be a dependent variable then.
No, it would. The amount of torsion that is applied to that wire is very much dependent on the masses that are suspended from it.
Okay, so it proves that mass attracts mass, right?
Yes.
So we're back with Newtonian gravity?
It's both. I mean, it's Newtonian in its basic understanding because Newtonian physics describes the observation of forces and the laws of motion, all that sort of thing.
But his field equations were taken out taken out and replaced by Einstein's field equations.
It's not necessarily taken out.
They are not mass attracting mass.
They are, though. I mean so mass attracting mass is the observation. Relativity is the description of why that happens.
That's not correct.
That's very much correct.
That's actually very correct.
That's exactly what happens, yes. The mass attracts mass because of relativity. That's exactly what happened.
I know we've got some citations we can post, y'all.
I mean, I would post Einstein's relativity, but I only have the book at the moment.
I like the book 100 Authors Against Einstein.
I'd be kind of curious to read that. I've also got the book On the Shoulders of Giants by Hawkins, which goes through all of this, from Kepler, from Copernicus, all the way through.
I wonder how many of those 100 are Globers.
Oh, I would say all of them.
Yep.
They started out as likely, I would say, probably heliocentric, and maybe even less than that. But a lot of them, yeah, they eventually learned.
I also like the book Earth Not a Globe by Samuel Robotham. That's an old one, like a really old one.
Wait, I'm confused, bro. Do you think that the Earth is like what they? Do you think that do you agree with them or do you agree with me that the
Sorry,
Earth
I'm trying. You're a little quiet there. What was the question?
I'm saying, do you agree with me that the Earth is spherical or no?
Oh yeah, no, of course. If you look at my
Yeah.
descriptor, my title, I'm a globe earther. They gave me that probably 5 minutes in. I'm not even Bra L. I'm Bra 1. I was given the name Bra L.
Am I said to be a globe? Let me see.
Hey, bro. At
Flat
in
Earther in denial.
Yeah, that's a good one.
9
I like.
what's the title of Cavendish's experiment? It's been posted at 9 minutes after.
I mean, experiments to determine the density of the Earth by Having to Cavendish. That's a good one, yes. But it doesn't deny the fact that mass attracts mass. It actually relies on that fact. Now, the whole point of his experiment was to determine big G. That was the main purpose of the experiment. And then
Except mass doesn't attract mass. The Earth is like, if you fall, I will catch you. I will be waiting.
Earth's
Like,
not going to catch you. I mean, it's an abrupt stop. It's not pleasant. That's definitely for sure.
I mean, catch
Also,
you, abrupt stop. However you want to look at it, right?
It's an abrupt stop. It's not pleasant. I'll give you that. Did I miss that one?
In general relativity, gravity is not a force between. Do you want me to repeat it, or are you just gonna look?
No, I understand. It's not, but it appears
According
as
to
a
this,
force, of course. Like
not
as far as
not a
we're
force, but you said you basically said it like describes the force, but Einsteinian gravity says it's not a force.
warping of space-time, which causes mass to move, which we perceive as a force.
So mass does attract
You can
mass.
still measure it out as a
Yes,
force.
of course.
From what I understand, it's mass times acceleration creates a force.
That's Newtonian, yeah.
So
The acceleration is gravity in that equation.
Gravity not
It's like
a force.
F equals mg
But
is.
you can also
You don't get to
technically in that equation you can substitute mass for momentum. Like light that is massless can still move things just because it has a momentum.
light has momentum. I thought light speed is undetermined. Like that it's.
It kind
No,
of
light.
falls.
We've definitely measured the speed of light. So.
Yeah. It kind of falls out of the idea that energy and mass are interchangeable. That's kind of where the idea comes from.
But different kinds of light, different spectrums. It's a different frequency. So
Different
not
wavelength.
all light would travel at the same rate.
No, it
That's so
does. Like,
false. It's just electromagnetic wave. That's what it is.
like frequency is related to intensity. Wavelength is what you think of in terms of
So it's
different.
interesting that you said that, right? Hold on. It's interesting that you said that because there's an MIT professor who was giving a lecture on how gravity is nothing. It's an idea. How it's electricity, it's electromagnets, it's this electricity that holds everything together. So just to bring that full circle.
Yeah, electricity definitely it definitely holds atoms together. That's for sure.
It's not gravity doing anything. Gravity is an idea. It's a theory.
When it comes to
It's not
atoms,
even a
gravity
law.
is
It's,
negligible.
gravity is negligible in this.
It's actually one of the weakest forces. The idea in terms of an atom, the masses of an atom are so tiny that gravity doesn't really play any part. I would say non-existent. But when it comes to gathering untold numbers of atoms together into one mass, that mass definitely has an effect on space.
we already know that there is an electromagnetic field. So there's a lot of electricity going on. Like you can pull electricity from the air.
I don't think
Some
an
Tesla shit.
electromagnetic field just means that there's electricity.
Yeah,
So
you would it's
on the
actually in the
cap.
name electric, magnetic. It's in the word, man.
So are we still in the Cavendish thing? Sorry, I had to do something.
It definitely drifted away from that.
Man, okay. So Cavendish happened way before Einstein's special general theory of relativity that superseded the whole mass attracts mass. Superseding something means replacing it. So in your gravity claim, you need to have just give me a hypothesis. Which one of these, the Principia, which would be superseded by the general and special theory of relativity, where in there is there a hypothesis even? I don't even care. You don't have to show me an experiment. Just give me the hypothesis.
They're different on both accounts. The
There, okay,
Principia
give me just
Mathematica.
one. Just give me one.
I mean, one of them is that you can derive the acceleration due to gravity based on two masses, right? And they derive the mass of the Earth through the radius and density, which is part of the Cavendish experiment. And you
No,
know the mass of an
no,
object, so you can then
no.
derive. I know. Hang on. You want me to finish, or like we're
But you're
talking about?
saying you're wrong.
No,
You're wrong.
only they're
We're talking
allowed to
about little
interrupt
g
people.
here.
But you're
You're talking about
wrong.
little g. You're talking about trying to define the acceleration due to gravity.
No, I'm trying to
The
find any kind of hypothesis in the papers of whatever gravity that you keep appealing to.
the hypothesis is in terms of defining those quantities using known masses.
No,
You use
no.
known masses and you use known laws to derive the acceleration due to gravity.
Cite it, please. Would you please give us the hypothesis formerly in formally in the text chat with citation, please. I don't understand why Globers will come in here and act like in their paradigm gravity is such a thing that they can prove it by dropping something when even the people that came up with the gravity that they appeal to feign no hypotheses.
No
Like, what is
hypotheses
up
for
with
what?
that?
Like,
Why do you
what are
act
you
like
trying to
you're a better
say?
expert than the people that you appeal to for the gravity that you talk about?
Well, aren't you technically doing the same thing by saying that you don't agree with what they're claiming? Because they would agree with that the Earth is a globe.
Listen to what I'm saying. They feign no hypotheses. That means that they are giving you a scientific theory, quote unquote, and
No, a
not even
hypothesis and a
hold on.
theory are
They're not
completely
even
different.
okay, see, they're not even feigning hypotheses. So that means they didn't take their theory through the scientific method, which by definition is pseudoscience. That is where we have our hang up. And rightfully so.
Where was the hypothesis? Not the theory. Are you talking about
They
like
don't
his like?
have any hypothesis, and there's no hypotheses listed in either paper. They even Einstein said, "I don't feign hypotheses," but he still calls his result a theory. A scientific theory has been through the
Yeah, a
scientific
hypothesis
method.
is different than a theory.
Yes,
A
that's what
theory
I'm
has
saying.
100% has been through the scientific method. If you think that a theory, anything that's
A
like
theory
claimed to be a
needs to
theory
go through the
hasn't
scientific
been,
method, and he doesn't even feign
it has.
hypotheses. Put two and two together, buddy. If there's no
Hypothesis is before
hypothesis,
you even.
how is there an experiment
Hypothesis is
to
what you
have
think is going to happen before you even test it.
fuck's sake, dude.
A theory is what like is how you explain what has actually happened.
Yes, exactly. But it's gone through what? The scientific method, right?
A theory has, yes. A hypothesis hasn't.
The hypothesis is part of the scientific method. Am I right?
Yeah, it's the very start.
Oh, okay. So if Einstein says that he feigns no hypotheses, but he still calls his result a theory, he has by definition just given you pseudoscience.
Oh, okay. Are you saying that because he doesn't have a hypothesis in his like work that it can't be a thing? Or are you trying to say that him
You
saying
call
that he doesn't like wait, hang on. Let me finish. Are you
I
saying
just
that him
quickly
saying that
chime in
hypotheses
one
don't
thing.
mean anything? Well,
I just want
I
to say
never
bye,
finished.
everyone. I gotta go. Nice talking. Bye.
Okay.
bye, Stacy.
Stacy.
Are you saying that because Albert Einstein says that hypotheses don't mean anything, that his is
No,
still a theory, or are you saying that
no.
he never had a hypothesis for his theory?
Are you
Which one?
purposefully not listening to what I'm saying?
I guess I'm just misunderstanding you. Have you ever like heard of that? People like not
Okay,
understanding each
yeah,
other.
that's fine. I will say it again. Okay, I'll try again. He concludes that his conclusion is a theory of relativity. But in his paper, he plainly states that he feigns no hypotheses. He doesn't even entertain any hypotheses. Yet he still results in his conclusion with as a theory. So by definition, it's pseudoscience because it's a collection
Okay,
of beliefs
you so you
that are mistakenly based on the scientific method.
so you do think that theory. So are you saying that a theory and a hypothesis are the same thing? That's what you're
No,
claiming.
Dude,
no.
hold on. You just agreed with her earlier that a theory needs a scientific method. Hypothesis is part of the scientific method. He doesn't have one, therefore he didn't follow the scientific method. Therefore, pseudoscience.
Oh
It's really
no.
simple.
Okay, well here's the thing. So hang on, Flexi,
Really
are you claiming
ignorant.
that Albert Einstein didn't have a hypothesis in his paper?
Oh
He
my goodness.
he
Wait,
did
listen,
not even
Pooter, go
feign
back to mute.
you're
Hey,
not
hey, 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 you don't tell me what to do, mofo.
yeah,
Shut up.
exactly.
You go on mute.
This is our house and it is ladies' night. Cheers.
Bro, he's been acting like he doesn't understand anything. We've entertained you hours and you still act like you don't.
And so true. I don't understand how you don't understand what I'm saying. If the definition of pseudoscience is a collection of practices and beliefs mistakenly based on the scientific method, that's the definition of pseudoscience. And somebody who doesn't even feign hypotheses, doesn't even entertain a hypothesis for his whatever his equation, because all it is a mathematical construct. He doesn't even feign hypotheses, then he didn't use the scientific method and still came to a conclusion that he labeled ding ding a theory. The conclusion being a theory should have gone through the entire scientific method being observable, testable, repeatable, falsifiable. He didn't do any of that, and yet he still called his special and general theory of relativity it's pseudoscience by definition.
I'm gonna unmute him for your sake, but plant man, don't be. We've been nice to you, so don't get all attitudey and say.
It's just annoying when I'm trying to talk and then you guys just mute me. Like I get it, like you guys don't want to be interrupted, but like neither do I, and you guys do the same thing. So it's kind of like unfair.
No, I muted you because you were being rude. Okay, so let's move on. Address her.
Okay, well, I was okay,
Address.
Flatsy. So you're back to what I was trying to say. Flatsy, you said that Albert Einstein, his quote was that he doesn't believe in hypotheses, right? He doesn't give them credit.
No, I didn't say that. I said he stated in
He
his
doesn't
paper.
feign.
which
He
means
doesn't
that
fame hypothesis. He gives them no power, right?
no, that's not what that means.
Well, then
He
please
doesn't.
re-explain. I need another definition. I'm too dense.
It's fine. It's fine. That he didn't even attempt at a hypothesis. He didn't even attempt
That's what
one.
you're saying. You're saying that he did not
Yes.
attempt one. He didn't. So then your quote has nothing to do with what you were trying to say then. Because say the quote
Yeah.
again about him. What he doesn't do. He doesn't
If he,
fame hypothesis.
yeah, if he didn't even feign, didn't entertain, didn't even come up with a hypothesis, then how did he take his conclusion through the scientific method?
Okay. Well, we can get on to why you don't need a hypothesis, but before we do, I'm I, you first claimed that he didn't. Your initial claim was that he said that he doesn't give any credit to hypothesis, and then you said that he didn't put.
No,
Then you
no,
were
no,
trying to say that
no.
he didn't put a hypothesis in his
No, no, no,
paper.
no, no, no. If he didn't feign any hypothesis, he didn't give a hypothesis at all.
So you know that
It's in
it
his
sounds like
paper.
he was saying that he doesn't give them any validity. Like he doesn't think that they mean anything.
No, I didn't say that. I didn't say that he didn't give them validity. He was just stating in his paper that he didn't even draw a hypothesis up. So there's no going through the scientific method without a hypothesis. You need an observed
Okay,
natural
well,
phenomenon.
okay, let's go.
Then
Let's
you need to
avoid the
formulate a.
hypothesis tangent. Let's talk about it like this. So if let's say I have like an experiment, right, and I have two plants, and one I'm going to use fertilizer with, and the other I'm not, right?
This is a non
Right,
sequitur.
Flatsy?
This is a non sequitur.
Well,
I
just
want
just
you to
just
be
just
able to
entertain it. Just entertain it for a second. All right, so we have the two plants, right? And one of them I'm going to use fertilizer, one of them not. If I don't say which one I think will grow better, does that change what will actually happen?
Do you know what a hypothesis is?
Yes, it's what you think will happen before you actually test it.
Okay,
Yes or no?
so
Do you
so
agree or disagree?
so in the theory that she's talking about with Einstein, are you agreeing that he doesn't have a
I don't know. I honestly would say he probably does, because it seemed like what she was referencing was just him saying that he doesn't believe in hypothesis whatsoever.
that's
But
not
that doesn't
what
mean that he
I
doesn't need a
said.
hypothesis.
and she clarified multiple times. I've been sitting here listening to her clarify while you strawman her over and over. Said.
You cut out.
Okay, you guys continue.
Well, either way, let's get back to what I was saying though. Like, we agree on what a hypothesis, right? It's the guess before you test it, right? We agree. You agree? Yes? No?
What did you say? I'm sorry. I'm just getting super
I
annoyed
said
at
the
how
hype.
obtuse you're being.
Okay. Well, we agree that a hypothesis is the guess of what's going to happen before it happens, right?
The scientific prediction. Yeah.
It's a prediction, yeah. It's a prediction before you test it, right?
Yes.
So if I don't make that prediction, but I still have the test results, what does it matter if I made that prediction or not?
Because you have to know the constituents of the experiment to be able to have an experiment.
Constituents of the experiment.
Yes.
What do you mean by the
The
constituents of the
independent, the
experiment?
indep-
Like, define
the
that.
the independent variable, the dependent variable, and control.
Yeah, but that doesn't have to do anything with the hypothesis. Those are
Yes, it
just
does.
those are
That's
what
what formulates,
what do you mean?
buddy. That is what formulates your hypothesis.
Okay, so let's go back to the two plant example. Okay, I got two plants. One of them I'm going to use fertilizer. One of them I'm not. The independent variable is that I'm going to use is the fertilizer. The control is the plant that isn't fertilized. Experimental is the plant that does get it. And the dependent variable is what happens, which plants grow the most. I listed all those out, but I'm not making the hypothesis of which plant is going to grow more. If I get the test results of which plant grows more, what does it matter that I did or did not make that hypothesis? It has absolutely no effect.
If your conclusion ends up being that magical unicorn farts are the reason why one grows more than the other, then yeah, I'm gonna need you to go back over that using the scientific method.
Well, hang on. Well, I'm not saying that it's farce. I'm saying that it's fertilizer, right? You would assume that fertilizer does something, but we go through the experiment, see the results. We see that fertilizer does make the plant grow more. If I don't say before we even
That would
test
be
it
the
whether or
hypothesis.
not the plant would,
You would say you believe that the plant will grow more because it has fertilizer. That's the hypothesis. And then you
Yeah,
test.
but I'm saying that. Well, I'm saying that if I don't make that claim, it doesn't change the outcome of the results. So it's obsolete. It doesn't
it's a
mean anything.
complete sequitur of your whole spiel about the fertilized plant versus the non-fertilized plant growing more than the other. It's complete non sequitur. This is something that you and I can do. We can formulate, we can even make the observation that, oh, that cow shit over there made that grass grow longer. We can isolate that down and see what the cause is, if it's the fertilizer or not. But when it comes to
What I'm saying,
Einstein's theory of relativity, he didn't even have a hypothesis to go off of. They did the
you don't necessarily
he
need it though.
used the Michelson-Morley experiment with the interferometer or whatever it was with, and they
Like if I
conclude they
go,
had
I
to
wonder
conclude.
what would make it.
Okay, dude, you go ahead and talk. I don't care.
Okay, let's go. So if I ask a question, what would make a plant grow more? A plant that's grown naturally or a plant that's grown with fertilizer? If I skip the hypothesis step and I get to the conclusion that fertilizer does make the plant grow larger, like I don't need the
You made a
hypothesis. It's
hypothesis,
obsolete.
but you just made a
Where did
hypothesis
I make the hypothesis? Where?
by not adding fertilizer to one and adding it to the other. Whether you formulated it formally or not, that is what you
No,
did.
no, no, no. No. That's just the experiment. The hypothesis would be like the hypothesis would be like, oh, I believe that the natural plant will grow faster because it's born in nature, and that would make it grow better. Or the other side of the hypothesis would be, I think that it's going to be the fertilizer plant because fertilizer helps the plant grow. That's the hypothesis. If I don't do it and I just find out that fertilizer does make the plant grow, it doesn't matter what my hypothesis was.
You
That
created
that
a
affected that affected the
you
experiment
created a
zero.
hypothesis by having the idea to even do one with and one without. That was you doing that. Whether you made it
That's
formal
the
or not.
experiment. That's not the hypothesis.
You thought to in your brain that, hey, I'm going to put fertilizer on this one and not this one, and then you do it. That's your hypothesis, buddy.
No,
Can I
no,
can I
no, no. That's the
The
experiment.
hypothesis is
My
definitely the
hypothesis
problem.
would be
can I add to that? If I was to come to you and ask, hey, plant man, what was your hypothesis for growing this plant or whichever, however you formulated it? And if I ask you, what was your what am I cutting?
Definitely cutting out.
Yes.
Okay.
You're cutting
Yeah,
out.
you're cutting out.
I think it's
All right,
because
I'll try to change devices. I'll just stay on mute.
it might be because you're using push to talk. I can tell that you're using push to talk.
Yeah, I don't have a mic or a headset, so I don't get feedback.
I gotcha.
But I'm sorry. Just
So hang on, Inputer, I know what you're gonna say. Tell me if this is right or wrong. You're asking me, like, if you come up to me and ask me about the plant like thing and ask me what did I think was gonna happen, what if I just said, oh, I didn't know, but I figured that if I had one plant that didn't have fertilizer and one plant that did, and just let them grow and seed, then I would have the answer. And then I'd be like, well, it turned out it was the fertilizer. I didn't know which one it was, but after testing it, I found out it was the fertilizer.
But that's the difference. I'm trying to tell you is you're using the scientific method and you're applying. You have your observation, and you're. If I come up to you and say, "What is your hypothesis?" You're gonna be able to tell me what your hypothesis is. If I go up to Einstein and ask him, "What's your hypothesis for?"
Hang on, please
He's not
say
gonna
that.
have
So you were saying that
hypothesis. He's saying he doesn't have a hypothesis. You know.
hang on. So, like, are you saying that if you come up to me after I've done the experiment and I tell you what the results are, you're saying that that's my hypothesis?
No, your results are your results. Your results are going to tell you whether your hypothesis is true, right? So you have an assumption. I don't want to call it an assumption, but yeah, like a.
What if I don't have an assumption? What if I
Yeah.
don't have an assumption? What if I'm completely unbiased?
You have an educated guess, right? And you're trying to test
What
whether
if I
that's
don't?
correct or not. So then you're not following the scientific method.
Well, that's not true. That's not necessarily true. Like think about it like this. If you and me, like inputers,
you're gonna follow the scientific method, right? You're gonna have to follow those. What? If you're gonna follow the scientific method, you're gonna have an observable phenomenon, and then you're gonna come up with a hypothesis. If you cannot have number 2, you're not doing science. You might be doing an observation, you might planting, but you're not doing science until you follow the scientific method. It's as simple as that. So if you're saying that, oh, he did follow the scientific method, he's decided to forego step number. You can't have that.
hang on. Okay. So let me ask you this. So if back to the plants. I did the experiment. We had the results. You come up to me and said, "What was your hypothesis?" And I said, "I didn't have one. I was just testing it, but here are my results." Are you arguing that my claim of fertilizer being able to grow plants better is wrong because I don't have a hypothesis?
Well, if you are presenting saying, "Hey, my fertilizer growing it," if that's what you're claiming, then I would say, okay, that's your claim.
I didn't claim anything. I'm unbiased. So like in this example, I'm unbiased. Like I wonder what would grow things faster.
You're
Natural.
not doing science.
What?
You're just farming.
Real quick, just make a point. It's like it
Yeah.
seems to me that the result of an experiment has no bearing on the hypothesis. The hypothesis is somebody's idea of what's going to happen.
Oh my god.
The result is the important part.
But you're trying to prove your hypothesis. That's the whole point of this method. Step 1, you're gonna observe. Step 2,
I think
you're
that's
gonna
what Albert Einstein was getting at.
saying that this
hypotheses don't matter because it's just their results.
You're always interrupting me, Plan Man. God dang, bro. Every single time you're standing on.
Is there a bit of a delay there, maybe?
No, you're just rude.
So for Brahman, oh gosh, I'm losing it, guys.
I'll take it. Brahmans are good.
Okay, you were saying that the result doesn't depend on the hypothesis. Then it doesn't. You're not. What was I going to say? You're not at that point having any causation. You're not proving anything at that point.
No, I think the idea of the experiment is so that we're not influencing it. We might have ideas of how it might end up, but the result is independent of the hypothesis.
We aren't manipulating gravity.
Lulu, would you mind if I stepped in for a second?
Oh, thank you.
Yeah, please go ahead.
I think there seems to be a misunderstanding because I've posted several citations in the side chat, so you understand that I'm not literally just pulling things out of thin air. This is the scientific method. The scientific method is the formulation of a hypothesis, a special type of prediction into a cause and effect relationship, which you will then test in an experiment. The problem with Einstein, you guys just said that he's just got lots of results. Yeah, okay, fine, he's got results. But he most definitely doesn't have science. Because if he was to have science, he would have a hypothesis, a supposition into a cause and effect. He would observe the natural phenomena. He would have a supposition of cause of that natural phenomena, the dependent and independent variables, for example. He will then test it, because this is what science is all about, experimentation, right? He will then test it in a physical experiment where he varies and manipulates his presumed cause to see if it has the effect. So I've posted several citations with regards to the scientific method, hypothesis construction, what independent and dependent variables are, all of those really interesting things. The point to this is Einstein didn't offer a hypothesis. So if he didn't offer a hypothesis, he definitely didn't bring any science to the table. Sorry, Lulu.
No, you're good, man. That's basically what I was trying to explain to them. Oh, I'll unmute Plant Man. I forgot. But I want L to Plant Man. Just keep quiet. L to respond to that.
Okay, hang on. Okay.
Well, just as a quick aside, the hypothesis being that mass bends space-time. It was experimented. I mean, but it is in terms of relativity. Like it's a consequence of special and general relativity. And it was proved
We asked for. I'm sorry to interrupt you, but we asked for what Einstein's Flatty. I think that's what you asked him. What his hypothesis was.
Yes. Now we're back to the actual point.
So we want citation for that as well.
But if you consider he's actually done the experiment, I wouldn't say he himself, but after he put the special and general relativity out into the world, people tested that. During a solar eclipse, they were actually able to observe a displacement in star positions around the sun. Due to that is actually what happened. Yes. You observe star positions during a solar eclipse and then afterwards, and they actually change because of the gravity of the sun.
That's interesting, being as he brought out in 1915.
So, okay, I wanted to address what Imputer was saying. Like, you were saying that if there's no, and what the other guy was saying, you're saying that if there's no hypothesis when using the scientific method, then it's not science, right? That's what you're saying.
That's what. Did you not hear Jedi? He was reading.
I'm just making sure. Is it wrong to confirm what you said? I'm sorry for making you say yes or no.
If you're not using the scientific method, yeah, you're not using science.
So like I said, if there's no hypothesis used, then that means the scientific method is completely wrong, that the results are inadequate. That's what you guys are saying, right?
No, it's not what he said.
No.
Citation. I told you got to address directly what Jedi said, and it wasn't just what he was saying. There's a citation. You're confused. Read the citation.
So
read it.
Let me say this one more time to make sure we're on the same page. So the scientific method involves a hypothesis, right?
Yes.
Yep.
Oh, if I don't use a hypothesis when I'm trying to conduct science, then my results are wrong.
I think I can address this based on one of the citations.
Unscientific.
Actually, one of the citations in Jedi. Oh, sorry. I think it's. Oh,
yeah,
okay.
Go ahead.
Well, one of the citations is Richard Feynman. Actually, he said if it doesn't agree with experiment, it's wrong. In that simple statement is the key to science. the distinction here is between hypothesis and experiment. The results of experiment are independent of hypothesis. If your hypothesis disagrees with the experiment, then you're
Experiment
wrong.
is the hypothesis test.
Sorry,
Yeah,
what was
your
that?
experiment is dependent on your hypothesis.
Your experiment is in a way structured around your hypothesis, but if your hypothesis disagrees with the outcome of the experiment, then you're wrong. That's what Feynman is saying there.
Obviously. So if you've got a hypothesis where you say this causes that and your experiment demonstrates that it doesn't, then it's wrong. The final arbiter of science will be the experiment. The hypothesis is the prediction that you take forward into the experiment. You observe something happening, you have a prediction of cause of something happening, you then test that physically to very manipulate your presumed cause to see if it causes the something happening. If your experiment doesn't validate your hypothesis, then obviously your hypothesis is invalid.
Well, I would agree with you entirely, but I would also ask why we're focusing more on the hypothesis and not the experiment.
Because the hypothesis is the first thing that you would do to have the experiment. You observe something happen. Yes, so you observe that, and we're doing natural science here, and I do apologise, ladies, but I need to explain this. We're doing natural science here. Natural science is hypothesis, construction, and experiment. The hypothesis is you, the researcher, observing something in the physical and natural world, something happening, then your prediction of the cause of something happening. These things must be physical, by the way. Then you must test your hypothesis in an experiment. An experiment is a hypothesis test.
Yeah, it's the test of it, but the outcome of the experiment, whether it agrees or disagrees with the hypothesis, is what takes precedent every single time.
Whole point.
But my point is why we're focusing on hypothesis and not the outcome of experiment.
Because you need one to do an experiment. That's why.
If you haven't got
observation.
If you don't have a hypothesis,
any outcomes of experiments, and I keep getting asked about the hypothesis. The outcome is the important part.
If you didn't have a hypothesis, you never had an experiment.
Your outcome is going to determine whether your hypothesis was right or wrong. So in this case, if you're saying space-time bending is because space-time bends, we see things falling, then you have to make an experiment based on that to show that is what is actually happening.
And that has happened. That experiment did take place. And they agreed to it.
No, it's not an experiment in 1919 when they observed a solar eclipse and declared the phenomena was happening. That's not an experiment.
The fact that it was 100 years ago make any difference?
No, there's two things that are a problem here. One, his paper came out that asserted this instance came out in 1915. Then he went forward 4 years later and made the observation. But this isn't an experiment. Nobody sat down in a bloody laboratory and physically manipulated their presumed cause. Natural science is the experiment, the physical manipulation of physical things to see if they have a cause. Observation, that's all he has done. He has just observed something and declared something. Now, we also understand that space-time bending is a mathematical concept. It's not a scientific concept. We understand that space-time is a reification of non-physical things into physical existence, a space-time fabric. Well, we understand that space, absence of anything, is nothing, so nothing physical. And we also understand that time is not physical as well. But what Einstein did is he reified these non-physical things into mathematics and bent them and warped them because of mass. There's no science here.
It starts with an observation. It always starts with an observation.
Yeah.
That's all there ever is.
You're gonna hold anything under the scrutiny of the scientific method. It starts with an observation, always.
And how can you guys even argue the fact that he can come to some sort of conclusion from an experiment and write a whole ass paper about it and even state that he has no hypotheses? You think that a whole ass paper that concludes a theory, he could have maybe formulated one if it had any kind of results that would have proven the premise? I mean, can you guys knock two brain cells together for a second? Sorry, I'll stop.
Flatsy. Oh, I
I'd
love
definitely
you,
love to
bro.
reply to that, but I do need to get going. I need to work in the morning. It's getting late. I appreciate the conversation.
Yeah, take care. Thanks for stopping by. I guess it's back to Planty Man.
Okay, so
Come on,
we're
Plant
gonna
Man, let's
keep going in
go.
this loop until we settle this out because I really need to get this point through.
But hold on, Planty, before we continue, did you understand
so-
what Jedi was saying?
Okay, this is how I understand it. Okay, so tell me if I'm right or wrong.
You're wrong. I'm just joking.
Okay, well, I haven't even said it, but
I know it's a bad joke.
all right. Okay, well, either way, it sounds like to me as Jedi is saying that if you don't have a hypothesis, you can't have an experiment. Yes or no?
Oh my god.
Bro, we just went through this. Yes, you can't if you're using for natural science, if you're going to use scientific method, you have to have a hypothesis.
Okay, if you use the entire okay. So basically, if I have the two plants, right? The two plant experiment.
Rather.
Bro,
Yeah, please,
in law
just
it's called
try and please.
asked and answered. You just keep asking the same question. It's been answered.
I'm
Stop.
dude. I guess I gotta keep asking it until I get an answer that
No!
like makes sense.
You've got
'Cause I'm
the
too
No,
answer.
no,
stupid,
no.
man.
You can ask the same question 20 different ways, and you're
Holy
still going
fuck.
to get the same answer. It's the definition of insanity to keep doing the same thing over and over and over again, expecting
Okay, well,
a different result.
okay, hang on. I just wanna. This is all I'm trying to get to, guys. All right, please just try and stick with me on this. You
Okay.
guys agree that the hypothesis is or the results are independent of the hypothesis. So it doesn't matter what my hypothesis is. What really matters is the results. Do you agree with that?
How do you design an experiment without a hypothesis?
Well, let's
In your
answer his
plant example,
question first over the fences because we
Because
don't
look,
want to
see here
answer
over
questions with
fences. I'll explain it
questions.
over fences. Let me ask you this. If imagine, tell me if I can if I have or tell me if I've come up with an experiment without making hypothesis.
You can't.
Okay?
no.
An experiment is a hypothesis test. Holy shit,
Okay,
man.
That's
well, hang
what it
on.
is.
Here,
Exactly.
bro. Just goddamn. Just let me explain. Can I
No,
talk? Like
dude.
y'all are
Yes.
interrupting.
Holy fucking
Please.
shit, bro. This is crazy.
Let him talk.
Yeah.
Let him talk. Let him talk.
Oh, you're so generous.
You
Let him
are,
talk.
Chris.
Let him talk.
Okay. Oh my goodness.
Let him talk.
So let's start out with the two plants again. All right. I have two plants. I don't know which one would grow more, with one with a fertilizer or one that doesn't. And I decide I don't know which one. I don't think it's going to be the fertilizer, and I don't know for sure if it's going to be the one that doesn't have the fertilizer. I'm unbiased. I don't make a hypothesis there. Go through with the experiment because the independent variable is the fertilizer. The um, the dependent variable is how much it grows. But I don't know which plant will grow more. I have no idea. I haven't
So
made
wait. Are
a
you?
hypothesis on that.
So you're saying that you can go through this without a hypothesis?
Okay, well, tell me if I have gone through it
I'm asking you a
correctly
question.
without a
Are you saying
hypothesis.
you can go through with your whole plant analogy? Are you saying you can go through this without a hypothesis scientifically?
Yes, I'm trying to show an example of how I could go through that experiment without making a hypothesis.
But you didn't.
However, that would be incorrect because you would not be following the steps of the scientific method, right?
I'm saying, okay, but my whole point is that the hypothesis, that being a part of the scientific method, is kind of just a semantic part of it. Like,
No.
It's not.
it's
No, no,
important
no,
to,
no.
it's a,
Okay,
You
I'll
made a
let you
prediction.
finish.
You made a
okay, well,
prediction.
like you guys are just
Let your
interrupting
plant.
me. Like, how is this fair? Like,
You
I'm
made a.
gonna get
I'm gonna
muted.
let
Like,
you
I'm the one
finish.
that's gonna get muted.
I'm gonna
Okay.
let you
Okay,
finish.
thank you.
Don't mute him. Let him finish.
Okay, thank you.
I set up that experiment, right? But I don't make a hypothesis on it, but I still get the results. Like, so if I come back with the results that fertilizer does make the plants grow, if you look through my research and you see that I didn't say which one I thought was going to grow more, are you disagreeing with the fact that fertilizer does make plants grow more?
What the fuck does this have to do with the fucking physical nature of the Earth, though?
Okay,
Well,
can I?
we're talking about the semantics of like that. Like you're saying that like science, it can't be science unless the experiment has a hypothesis.
Can
You
you?
have
Can
to
you?
have a
Because if it doesn't
hypothesis.
have a
It's part of the
hypothesis,
scientific
if it doesn't
method.
have a hypothesis,
If
it's not
I
following the scientific
hypothesis,
method, which means
hold
it's
up,
not valid.
hold up. If I'm planting a garden, I would hypothesize that my garden might grow better with nutrients, with fertilizer, with dead fish, with lizard shit. It's a hypothesis, so I'm going to put that to the test. You can't just go off all fucking willy-nilly and be like, oh, I'm going to just test this shit and not develop a fucking hypothesis beforehand. If you're actually going to do science correctly, you should probably go through the steps in order, from observation to hypothesis to testing it to getting your results. Okay, if not, you're lacking, bro.
Yeah, I'm just gonna before you go on, Plantyman, I'm just gonna read what another thing that Jedi posted. I need you to listen carefully. Okay, are you listening?
Okay, I'm listening.
Okay, good. So, California Institute of Technology physicist Sean Carroll arguing in Edge that hypotheses aren't simply useful tools in some potentiality, outmoded vision of science. They are the whole point. A scientific theory represents an hypothesis or a group of related hypotheses which has been confirmed through repeated experimental tests. Okay, so if you don't have a hypothesis, you don't have science.
Bingo.
Okay, well,
because you
let
wouldn't be
me
following the steps of
continue
the
back to what I
scientific
was saying.
method.
So like,
Did you hear what I
so, like,
said though? Did you understand any of that part?
yes, I get. I'm not even saying that like hypotheses don't have any meaning in the scientific method. I'm just saying that in the grand scheme of the scientific method, the hypothesis means nothing because what really matters is your results.
It means everything. It means literally everything. When you are observing something, right? When you're doing a scientific method and you're observing something, the first thing, well, besides observing it, the first thing you need to do is come up with a hypothesis, meaning what is the freaking cause for what I'm seeing? Okay? And then you're going
think is the cause.
Yeah, exactly. What do you think
what you
is
think doesn't
happening?
actually
That
matter
is your
whatsoever.
hypothesis. And hold on, once you try to figure out what you think the cause is, then you're going to go to your experiment and try to test your hypotheses, which is your guesstimation. Okay?
I'm not
If
arguing
you're
that no
You
one has
seem like
ever
you are
made a
arguing because you
hypothesis.
just said hypotheses don't mean
Well,
shit,
what
and
I'm
that's not
arguing
the
is that
case.
no, what I'm arguing is that yeah, I guess I am arguing that they don't like.
Well,
There's a structure here. Well, you listen to me. Just listen to me. All right.
What?
They're the structure of the experiment. The people typically don't come up with that whole two-plan experiment
Hey,
without having the
you
initial
don't get
like,
to write
which
your
one
own
do I think will
definition
be?
of scientific method. You
What'd you
don't.
say?
Yeah.
You don't get to write your own definition for the scientific method. You don't.
I've never disagreed that the hypothesis wasn't a part of the
Okay.
scientific.
Yeah,
You
you
realize
think
it's important because you said that there was an experiment showing the existence of gravity, and we showed that gravity was not isolated in that experiment. Now we're here talking about fertilizer.
Okay, well, the whole point was that
God.
because
And
trying
you're
to say that you guys are trying to say that if an experiment doesn't have an hypothesis, then they can't
Hey, your
put the
argument is
results of the.
Hey,
your
man,
argument is not with us. Then your
your
argument
argument sounds like fertilizer, like bullshit.
Okay. Well, then let's get back to then fine. Let's get back on topic. It doesn't matter about hypothesis, whatnot.
It doesn't matter what
We'll
you
move
think
on from
about
that.
it. It doesn't
Yeah,
matter what
for
you
real.
think about
Yep.
it. It just
I love your
is.
fertilizer
Alright.
argument.
Yeah, what you seem to try to like keep trying to separate the hype. It's funny. You are literally going against all of what science is just so you can have your gravity. Like maybe take a step back and maybe say, "Huh, maybe they have a point.
The
Maybe
whole
this
hypothesis thing had
stupid
nothing to do with
fairy
what I thought
tale."
about gravity.
Yeah, it is. It had everything to do with Einstein's relativity crap, right? That's why you brought up when we
No,
asked you when Flatsy asked what is the hypothesis for his relativity theory. You guys didn't have a hypothesis, but still wanted to continue believing that it is a scientific theory. And we're saying it's not a scientific theory
okay,
because
so
it fails
let
at
me.
the second step.
Dun dun
Okay, so
dun.
okay, so let's say you're like doing like you're setting up these experiments, right? Like you're trying to I don't know figure out like you're on the cusp of relativity, right? How could you ever possibly like know what would actually happen? Like you can't like come to that conclusion. Like think about like this.
If
The
wait,
the
can you please
go back to
stop?
the
My
fertilizer. Let's
Just
gosh.
stop.
imagine.
Please stop.
No, now you guys are interrupting me. Like how is this
Yeah,
fair?
I am interrupting you. 100% I'm interrupting you because I don't want to hear another long-winded tangent about fertilizer. So, listen, if the results of your experiment are not what you expected, then you change your hypothesis and you develop another experiment.
Bingo. Which means that the
Mm-hmm.
hypothesis is absolutely necessary throughout the scientific method. Because if you don't get the results that you thought you would get, no matter what, you have to change your hypothesis and test it again. And
Ooh,
you cannot avoid having a freaking hypothesis throughout the scientific method. You cannot avoid it. Why can't you
Mm-hmm.
accept this? Why are you in denial about it?
yeah. Just
Stop
try.
it. No,
Just
seriously. No, seriously, stop it. Shame
it is.
on you. You
It is.
fucking being in denial about something that has been used for hundreds of years, the scientific method, and you think you can go off all willy-nilly without a freaking hypothesis? Well, what if your test doesn't turn out the way you thought it did? Well, the fact that you thought it would turn out any kind of way means that you had a hypothesis.
Yep.
Well, what like that's my whole point is
No.
like, what if you didn't,
Can't
and then you
avoid
saw
it.
the
You
results,
can't
and you're like,
avoid
okay, so then
it.
Oh my gosh. Does this doesn't prove gravity, Plant Man?
well, yeah, let's go back to proving gravity, I guess, because you guys are. It's apparently impossible to just be like, hey, if I watch these two things grow, and one of them has
Oh my
fertilizer. I don't
gosh.
know which
Stop.
one's gonna grow more.
I don't
I don't
care.
know
We don't
which
care
one's gonna
about
grow more,
plants
but I
because
see that
this.
this one does, so I'm gonna assume that it
Stop.
is that
There's like
fertilizer
Stop.
makes it
20
grow more.
people watching on
Try to
YouTube right now. This doesn't prove anything about like the physical characteristics of the surface of this earth, right? It's a
Okay,
red
well,
herring
let's get back to proving
argument.
gravity is real.
It's a red herring argument. It's an obfuscation argument.
Yeah.
The whole point was that there is a whole paper dedicated to a supposed theory of relativity that has no hypothesis, no hypothesis test, no systematic experimentation to come to the conclusion of the
Well,
scientific theory. Therefore, Einstein's whole spiel of special and general theory of relativity is by definition pseudoscience. That
hang
was the
on.
point.
So tell me this. So you're saying that general relativity and special relativity has never been experimentally tested.
Well, I'm going
Correct.
to tell you. Yeah,
Ding,
I'm going
ding,
to
ding,
tell you right
ding.
now that. I'm sorry, Flatsy. Go ahead.
No, I was just saying correct. Ding, ding, ding.
Yeah, I was just going to say that the fabric of space time is a rubber tarp. Ha ha ha.
Okay, well, if you guys think that scientists have not tested theory of relativity, then that's just absurd.
Oh,
I mean, how like
wow.
You
Wow.
have a lot of
Yeah,
assumptions.
you
it's
just
fine.
respawned out of the whole thing.
Sorry, ladies. I do
Well, I mean,
apologise.
I guess though, because you guys always mute me. Right.
Oh, please. We've dedicated
Because we don't
like
want to hear
3
about
hours to
bullshit
you.
fertilizer anymore. Like, what the fuck? I'm
Like an
sorry,
hour.
bro.
Oh, shit.
Well, I know Jedi.
Okay,
He's
so
gonna like.
if I can find tests that prove the theory of relativity, then you guys would agree with me, right? That the Earth is a globe.
Hey, I only said you had to find a hypothesis. You don't even have to go. You can do the test. Yeah, go find the hypothesis, the experiment, the conclusion, with all of the systematic experimentation that's falsifiable, because that's what the scientific method is. It's
Here, let me prove
observable.
mathematically. Let
Listen,
me prove
Oh
time
my gosh.
dilation mathematically.
Mathematically.
Gonna have a
okay.
heart attack.
Bro.
Yeah,
Let her finish talking real
like
quick. Let her
I,
finish talking. Go
I need
ahead.
it to be, I need it to be observable, testable, repeatable, and falsifiable, because that is what you glean from science. Science
so
is
like
actually
time.
wonderful because you can go and do it and test it for yourself, and it's falsifiable.
Okay. Okay, what about this? What about this test? So time dilation.
What about? It's
Faster an
like sounds
object
like you're
moves.
begging the question a lot. Okay, I'm sorry. I'll let you talk.
Please, let me finish. I'm trying to
Who
talk here.
told you that? Who told you about time dilation?
Let him finish. Let him finish. Let him finish.
Yeah,
Somebody
like
just told.
goddamn. If this was me, I'd be muted. But
Go ahead.
You
time dilation. It's in the general theory of relativity.
A
What it
theory,
states
not a
is that the
law.
faster. I'm not saying it's a law. I'm saying it's a theory. Okay, but for something to be a theory, it has to be tested experimentally and proven that it's true to an extent.
Okay, let me. Can I break this down? Can I
Hang on.
interrupt you real quick? Can I
Yeah,
make
sure.
this
Go
a
ahead.
conversation? Okay, so the thing about a theory is it remains a theory, only a theory, a mere theory, until it is proven to be a fact, right?
No, actually, I don't know if I agree with
Yeah,
that.
no, yes. The correct answer is yes. Theories remain theories until they are proven as fact. So if you're still hanging on this thing that's a theory for hundreds of
Here, I'm
years,
looking up the definition of scientific theory. A scientific theory is an explanation of an aspect of the natural world and universe that can be repeatedly tested and corroborated in accordance with the scientific method, using
well,
accepted
okay.
protocols of observation, measurement, and evaluation of results.
All right, so let's get to the surface of Earth with that observation, that repeatable,
Okay,
testable,
so
verifiable
let's get back to what I was trying to say
information.
before you cut me off. So
Hmm.
what I was trying to say before was that time dilation is part of that general theory of relativity. So like faster an object moves, the slower it moves through time, because space, like the
Okay,
fabric of space, isn't just space; it's space-time. So
okay.
the faster you move, the slower time like flows for you.
Hmm.
That's what Albert Einstein theorized, and then how they tested it is they had somebody get into a jet with their own clock and go as fast as they could around the Earth, and when they come
Right.
back, if it holds true, then his clock would be behind the clock that they had from where he left off, right? And that's
Okay.
what they observed. That is true. So how do you explain that?
Okay, I've got a nice little fucking meme here for you. You know the Concorde? It's this jet. It's this little plane that flies fast as fuck. It actually flies faster than the alleged rotation of the Earth. How the fuck does that function? How
I
just
didn't even.
go ahead and make
I
sense of
don't see the
that.
Concorde. See the
Okay,
Concorde
hold
or
on.
what you're
Let
saying.
me see if I can pull up this Concorde image. The Concorde flies pretty freaking fast. It flies faster than 1,000 miles per hour. Like, holy shit, it's flying 300 miles into the future. Give me just a second to pull it up.
I'm pretty sure it's like possible to go to the past, but you could technically go to the future. But what would be happening is just your time is just slowing down relative to theirs. They're just
And
living through life faster than you are.
can I ask how this proves curvature or terrestrial rotation? How do these things
Well,
that you're
for
talking
one,
about, how do
I
they
would.
prove curvature or terrestrial rotation? That's what I want to know.
Well, if you're accepting one part of his theory of relativity, you kind of have to accept all of it, right?
But you're talking
Wait.
about
all linked within the same.
What?
It's all
talking
linked within the same concept.
You're talking about the
So
length contraction and the time dilation, right? Those were all
Talking about
imposed.
yeah,
Those were imposed
imposed.
imposed upon the or whatever the interferometer they used, and they just claimed and imposed that there was length contraction and
So
time dilation.
so let's give this. We can
Wait a minute.
actually
Wait, hang
relate
on.
this to the
I'm
meme
so
I just
confused on what
posted
you
in
were
the
saying.
chat. We can relate this to the meme that I just posted in the chat. The Concorde is traveling at 1,334 miles per hour. The Earth allegedly spins at 1,040 miles per hour. This would mean that the Concorde is traveling nearly 300 miles per hour into the future, buddy.
No, that's not at all what it's doing at all. Like, that makes no sense. That's baseless.
It makes no sense because the Earth doesn't move. That's why it doesn't make sense. You have this notion in your head that
What
the
do you
Earth
mean?
moves. Does the
Yeah,
Earth move in
I
your world? In your worldview, does the Earth move?
absolutely it moves.
So the Earth, so we've got this Concorde jet that travels 1,334 miles, 340 miles per hour. The Earth spins at 1,040 miles per hour. The Concorde jet is flying faster than the rotation of Earth. In your worldview, how in the fuck does this thing land? Where does it? How does this happen? How do you have a moving
How do you argue
object
it?
coming into contact with another moving object, and it's no fucking problem?
Well, because you
Like,
have to
say
think
it
about it like
lands,
this.
right?
Like, the plane is traveling. The plane. Here's the thing. You have to remember that the plane is traveling relative to the Earth. So while the Earth is spinning, the plane is spinning with the plane, but also still moving forward. So, like,
No,
let's say that.
no, you're wrong.
Okay. Oh, okay.
Wrong.
Am I
You're
wrong?
straight up fucking wrong.
Okay.
I took
Please explain.
I 3 years in junior recruiting officer training and Air Force recruiting officer training corps. The Earth does not fucking move. If the Earth moved, if the Earth were moving while we're trying to come in and land our jets, it'd be fucked off. It'd be so fucked up. It'd
Well,
be
for
so
you, the
fucked
Earth
up.
isn't moving, like, because you're moving with the Earth. Like, it's
No,
impossible
I'm not moving
to
with the Earth.
see.
No, I'm not moving. At 30,000 feet up, at 40,000 feet up, I'm not moving with the Earth. If I am in the Concorde and I am traveling 1,334 miles per hour, I am not moving with the Earth. If the Earth travels
Yes, you are.
1,040 miles per hour, I am definitely not moving with the Earth. In a Concorde, I'd be moving faster than the rotation of the Earth, sir.
That's the thing
These
is
things don't
you're acting
work.
like they're separated. You're acting like they're independent of each other, but they're not.
They are independent of each other. The Earth is moving. I am moving. If I am off the surface of the Earth, then I
You're
am
acting
moving
like if you're not
independently.
on the surface,
Then I
you
would
can't
be.
spin with it.
I'm sorry. Am I interrupting you? Interrupting me? I would be moving independently of the Earth's movement. At 30,000
No,
feet
you
off the
wouldn't.
ground, I would be moving independently of the
No,
Earth's
you would not.
movement.
No, you would not.
Where's the
You would
proof?
not be.
Where's the proof?
Where's your proof that you would be? I mean, that makes no sense. Like, you can't just say that I have to prove it, but then make a claim and not prove yours.
It's
Like, it doesn't
basic
make any sense.
trigonometry. It actually comes down to like basic trigonometry, dude. Like this Earth can't be moving. If this Earth is
Imagine
moving
like
and you're coming in for a landing, like do you think that planes just stay with the Earth, with this Earth curve? Like, where the fuck did you get this shit?
think about it. So think about it like this. Let's say the Earth is spinning, right? So we're
Let's
just
just say,
imagining it
right?
spinning at that
Right?
speed.
Let's just say, for
Yeah,
the
yeah.
sake of
We're
argument, that the Earth is spinning. Let's do it. Okay.
okay. So if we're thinking about like how motion works, if the Earth is spinning and I'm spinning with the Earth, we have a constant speed, and I'm always with the Earth no matter what. So even if I go into the air, it doesn't change that I'm moving in that direction.
Except the fact that there's not a single fucking thing that can prove Earth rotation. Nothing. Nothing. Cite me
What
one
about like the
thing.
day? What about the day? Like why does the day cycle
What about the
happen?
day?
Like wouldn't that
What about the day?
wouldn't that prove
You mean the celestial bodies that move in rotation over us? Where is your proof of Earth rotation? Where is your proof of Earth rotation? What do you have? Because there have been several
I guess
Hold on. There have been several experiments conducted, and every single experiment conducted to detect Earth rotation has failed, including Sir George
well,
Airy's.
how about the
Sir George
University of
Airy
Nevada?
said, do you know about Sir George Airy? Do you know about Sir George Airy's failure?
Here, how do scientists first prove that the Earth rotates? Through
He
the
was a
shape of the Earth
scientist. No, they didn't prove it.
had
They
been
didn't
settled
prove
for over 2
fucking dick.
millennia. A
They
scientist by
didn't.
the name of Leon Alcott designed an experiment in 1851 using a very long pendulum that showed both that the Earth is round and that it rotates. Let's look into it.
Except you've got Sir George Airy with Sir George
If you
Airy's.
place the
Okay, all
pendulum
right.
at the
Am
North
I
Pole,
interrupting
the
you?
direction of
Interrupting me
its
again?
swing
Am I
changes with
interrupting you?
respect to the
Interrupting me
ground, and it
again? Am I
completes a.
interrupting you?
I'm giving you the proof that
Am
you're
I
looking for.
interrupting you?
Do you
Interrupting
want
me
the
again?
proof, or do you just want to
Am
keep
I
rambling? Do you want to keep yapping?
Plantaman, please, please. Let's be cordial
He
here.
asked me to bring up proof, and I'm bringing it up, but she just wants to
Sir,
keep yapping.
no, I'm talking about like Sir George Airy's failure, where he failed to detect rotation of Earth. I'm talking about Michelson-Morley experiment where they failed to detect rotation of Earth. I'm talking about Einstein even fucking said that by no observation can rotation of Earth be detected. That's what I'm talking about. Why would all of these things say that we can't detect Earth rotation? We can't detect it. If we can't detect it, is it actually happening, sir?
The University of Nevada disagrees with you.
That's nice.
Oh,
Good for
do you
the
want me to
University
let me
of
read off?
Nevada.
Let me. Yeah, they're probably a lot more credible, a lot smarter than you. So I mean, I'm probably
Are
want to
they
do the
smarter
same
than me?
thing.
I mean, that's what, because
So
they
now you're
credentialed us
appealing
like
to authority.
pure
Nice.
credulity.
Okay,
Appeal to credulity
it's fine.
fallacy.
So would you
That
say
is
that?
an
So is
appeal
the
to
University of Nevada not
credulity.
a? Is it not a credible source? All these sources that you guys are putting in the chat are like what? Like what is you? It makes no sense at this point.
I would
If the
say that.
University of Nevada proved this, show us the Nobel Prize they collected.
Yeah, I want to know that too. I was just about to say that. Thank you, Over the Fences, because I'm like, okay, so like nobody's heard about this. Like it's groundbreaking, right? In the University of Nevada, this should be fucking groundbreaking. It should be top tier news, and it's not.
You wanna know why it's not groundbreaking? Because they figured it out 100 fucking years ago, 200 years ago. The experiment that they're bringing up happened in 1851.
Except there's nothing that can detect the rotation. Nothing.
The
Not even
University
the.
of Nevada disagrees. Do you want me to tell you how they did it? I can.
Are you
That's what
gonna
I'm trying to get to.
put it in the
Keep
chat?
yapping.
Are you gonna put it in the chat
You
or
want me to
what?
send the link? Here, I'll send the link.
Yeah,
I'll put the
dude,
link in the
that's what
chat.
we do here. That's what we do here, sir.
Here you go.
Definitely.
If you place the pendulum at the North Pole, the direction of its swing changes with respect to the ground and completes a full circle each day. Placing the same pendulum on the equator yields no change at all in the direction of the swing. These facts and
Can I
behavior of the
just tell
pendulum
you?
when it's placed anywhere else agrees with the fact. What'd you say?
Can I just tell you how much fucking construction work I've done? I have built buildings. I've built entire houses. And I'm gonna tell you right now, my life would be a bitch as a contractor if my plumb bobs didn't fucking hang still. My pendulums, my plumb bobs, they hang perfectly
You're
fucking
close to
still,
the
bro.
equator.
I
Are
don't
you
give a
near? Are you
close to
closest
the
to the?
near the equator. Further, it
That's what
doesn't
the whole
matter.
experiment
You
hinges on. So like
No,
you're
I
literally
don't
just
give a
yapping.
fuck, dude. Anybody doing fucking contractor work, anybody doing construction work, it doesn't matter if they're near the equator or not. Their plumb bobs will not fucking move. Their plumb bobs won't move. They will not fucking
Yeah, they're
move.
not at the North Pole.
Construction would be a bitch. Construction would be a fucking bitch. You'd never get a fucking 90-degree anywhere if your plumb
Working on the
bob
North Pole,
fucking
you
moved.
doing on the North Pole.
How come these things hang perfectly still if Earth is moving? Please. That's what I want to know. I've been wanting to know this
So hang
for
on, let me ask you
5.5
this. Let me
years.
ask you this. When you're in a
Why do
car,
plumb bobs? No, fuck you. I want to know why plumb bobs hang perfectly fucking still if Earth is
do you
moving.
want me to tell you, or do you just want to keep yapping?
Go ahead.
Okay.
Why do
Is it
plumb
at the
bobs
North
hang
Pole? Are you
still?
doing this at the North Pole? No, you are not. So there's no reason why it would move. Two, if you're in a car and
No reason why it would move.
you go up, if you're in a car, right? Let's say imagine you're in like a plane,
No
like right,
reason
you're in
why
the
it
Air
would move.
Force.
Thank you. No, I'm sorry. You just proved my point when you said there's no reason why it would move. Thank you. Welcome
Yeah.
to Flat Earth.
Yeah. How did I prove your
Welcome to
point?
Flat Earth. There's no reason why my plumb bob should move. No reason at all.
So did you
Because they
miss the
don't
part
move.
where I said, "Are you on the North Pole?" Because that's the only time when it would move.
Isn't that interesting though? Because like up at the North Pole, you technically, if Earth is moving, if Earth is spinning, it'd be spinning faster than it is at the equator because of it's a smaller concentric circle.
What? So would you say?
Earth
So
isn't
are you trying to say
moving.
that
I'm
it wouldn't
sorry.
take
Earth
24
isn't.
hours for that? It wouldn't take 24 hours at the top of the
Earth,
North Pole
Earth
for it
isn't
to like.
moving, man.
I'm at the top of the North Pole. It wouldn't take 24 hours for me to spin around because it's a smaller circle.
So wait,
My
are you saying that pendulum is proof that the Earth is moving? Is that correct? Am I understanding this correctly?
Like you're looking at the link that I sent, right?
I can't open the link right now.
Okay, well, it says that
Is that correct?
this is
It's
how they proved
yes
it.
or no?
If you
It's
place,
yes or no.
okay, let me.
Is
Yes or
it
no? What?
Foucault's pendulum? Yes or no?
Yes, it's
Okay.
Foucault's pendulum.
Okay, you
Leon Foucault,
understand what year was that?
1851.
Okay. What year did Einstein say that Earth movement cannot be detected by any terrestrial or optical experiment? Was it before or after?
After.
Do you think Einstein didn't know about Foucault's pendulum?
He definitely did, and I think you guys are misrepresenting what Einstein was trying to say.
Yeah,
You know what
Foucault's
Einstein
pendulum.
was trying to
You
get? What
fucking touch it.
do you want me to explain to you? What Einstein wanted you guys to understand is that in inertial
You
frames of
know what
reference, you
Einstein
can't
wanted us to
distinguish
understand, and we can't comprehend what he said?
yourself between a normal frame of reference, a motionless
He
frame of
said it
reference, and an
cannot
inertial
be
frame of
detected.
reference.
You're just making stuff up now.
So I made up inertial frames of reference. That's made up.
You read what he said himself. I'm not going to put the words in his mouth. This is your guy.
Okay, here, I'll quote it. Let me quote it on Google. What was the quote? Okay, look at this. It says, Einstein never directly said that the Earth is not spinning/rotating on its axis. No object in the sky can be considered stationary, and we can observe this by the rising and setting of the sun, the moon, the stars, and other planets. What did Einstein do to formulate the theory of relativity?
Why don't you read?
You
If
guys
you're
still
going to read
here?
something, why don't you read what I posted
Or what'd you post? What'd you post?
above your Foucault post?
Since they insist the Earth is moving around the sun, yet cannot detect it. Since the sun yet cannot detect it moving, nevertheless, they needed some physical and mathematical way of accounting for it, since there's obviously a difference between motion and non-motion. Length contraction became their convenient scapegoat. This is the essence of the special relativity series that Einstein invented in 1905. It was invented solely to answer Michelson's experiment, as Einstein himself said, to the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments. We have already remarked that all attempts of this nature led to a negative result before the theory of relativity was put forward. It was difficult to become reconciled to this negative result.
So, The theory of relativity was the band-aid to explain the lack of observable motion.
Lack of observable motion? Are you saying that like when we look into the sky and it changes, like do you not think that like that might insinuate that we're moving?
No, I think it means we see lights moving.
Okay, well, maybe he didn't know about it because honestly, I don't know why they would have this here if it wasn't like verifiable. And I bet you other people have done it. Let me actually look up.
The problem is you're running into
Has
the problems with the
anyone
globe model. You're running into
ever
the
redone
contradictions.
Leon?
Okay, yeah, this is cope, dude. But I think it's probably time for me to duck out. I know the guys are itching to get in here. Is that right, ladies?
I mean, yeah, probably. But I mean, yeah, you're right, by the way, with him. It's all cope. It's all fucking cope.
Yeah,
It's so funny because like you guys realize that like literally we're not like all of us. I hope none of you here feel like you guys could actually like credibly make a decision on these things. Like you guys, me, like I'm in the
why
same
not?
boat as you guys. We
Why
are
not?
not because we haven't
Why
studied
can't I
this.
make
Like
a
we're not
decision for?
professionals in this.
No, but you can go out and measure these things. That's what they want you to think, dude. That's what you don't understand. They want you to think that the information and the knowledge is so beyond
Oh my
you that you
goodness.
have to trust them. Yeah, you can keep
I'm
on
not saying it.
trusting the
You can do, like,
authorities.
You will respect my authority.
Okay. It's
99.99% of people disagree with you, and not only that, but
That's
for
actually
all
a
the people
false.
with
That's a very.
valid opinions on this
I'm gonna tell
disagree with
you
you,
right
which is like
now,
the
80%
the big red flag.
make up
99.9% of people disagreed that the Earth was a globe when that was first presented, but that one's okay
yeah,
with you.
exactly.
So that's a terrible argument.
Yeah.
Back in the day, look think about
I
it like
don't
this.
care what people think.
It's easy
It's
to
true
make
or
the
it's not.
assumption that the Earth is flat.
Can I lay down the
The
history
easy
lesson?
assumption is that the Earth is flat.
Can I lay down the history lesson? Can I lay down the history lesson?
Yeah, lay it down.
The untaught history is that I would say around the early 1900s, probably like within the 1920s, is around when the Rockefellers took control of the education systems. And this guy said, I don't want thinkers. I want workers. It was about that time that the curriculum changed and that flat Earth stopped being taught in public schools. Teachers were fighting against each other. School boards were getting into fights. There's a whole lot of stuff going down back then. And now it's part of standard curriculum in schools to teach the youth that we live on a spinning wet ball in some sort of infinite space vacuum. And it's so mysterious and wonderful. So there you have it. I mean, people were being taught that the earth was flat as early as the 1920s. So what changed and why? So what changed and why? Let's get down to that really intellectual conversation.
Let's get down to it. So at the start of like human, like let's start with like the beginning of humans. Like when that happened, humans thought the Earth was flat because that's the easy assumption. It's easy to look around at you and be like, man, this shit's like flat. And when I keep walking, it stays flat. So like this shit must be flat, right?
Well, I guess then, okay, yeah, I agree with you. I agree.
Okay, so I'm going to be talking for a little bit. So let me yap for a little bit. And around the era of the Greeks, that's when the first like concept of the Earth not being flat came around because they would see boats sink away off in the distance, and they're like, why would it do that if the Earth is flat? And they're like, well, what if it's ground?
But you know who came
So
up with
then-
that? That's the funny thing is actually pretty much all of the flat earthers in here are globe experts, okay? It was Aristotle. Aristotle said, oh, there must be a curvature because I see boats disappear from the bottom up. I can't
Yep.
see them anymore. Well, in that day and age, they didn't have a Nikon P1000, motherfucker. What? Okay. So now we've got this awesome optical technology that can help us resolve things even further away across water, such as these boats disappearing
Can you say
over
what
this
that thing was
alleged.
again? I'm
I'm
gonna look it
not
up.
done talking. Okay.
I'm just
Such as these
quantum
boats
of it.
disappearing over the alleged curvature. Aristotle was like, oh, well, we can't, we must be seeing some sort of curvature because we see the boats disappear. And now you come to
Bottom
fucking
up.
23 where we've got an Icon P1000 and we're like, oh,
Icon
we can see that fucking boat again, bro. Like, oh, there's the boat again.
Okay.
And we're hold on. Am I interrupting
Hold
you?
on, wait a
Interrupting
minute.
me? Am I
You
interrupting you?
did
Interrupting
technically
me? Am I
interrupt me to get
talking
on this
over
whole
you?
tangent,
Talking
but
over
go
me?
on.
Because we're now able to resolve these distances that we should not be able to see according to the math, the geometry for the globe. It's
Yo,
pretty
that's
fucking
wild.
simple. It's pretty simple when we realize, oh, we can see a lot further than we should be able to see according to a globe. Now, here's where I'm going to say that a lot of
Hey, can I
globers
get back to
like
what I
to
was saying?
hold
Because
on, shut
you
the fuck
completely
up,
cut me
please,
off.
for just a moment,
Hey,
okay?
watch
You're
your
A
getting
lot
back.
of
language,
You
young
cut
globers
you
lady.
off.
like,
You cut
I'm
me
not
off.
done talking, am I interrupting me? A lot of globers like to
I mean, I feel like this is unfair
refraction.
because you
I
cut
guess
me
I'm
off.
not
So I
going to
feel like
get
I
this
have the
point
right to cut
across
you off.
any fucking time soon. So a lot of globers like to invoke refraction for the reason why we see further than we should. However, on days where it is super crystal clear, super dry, refraction index it's at 0%, we can see even further. We can see even further when the refraction index is at 0.
You link these studies.
So your refraction argument is shit. That's a fucking okay. I can go through
You
this
link those
all fucking
studies.
day, and you're gonna sit there and try to fucking cope. You're gonna sit there and try to
You
cope
link those
all
studies.
fucking
Yo,
day
why are you so angry, bruh? Like,
because I'm
it's
fed up
it's a
with it. Like I'm not
discussion,
even
bruh.
angry. I'm just like there's these things that I hear repeatedly, day in
Like,
and
you
day
acting
out.
like your profile pic right
Refraction,
now.
refraction is why we can see these things that we
Well,
shouldn't
no.
see. Refraction is
When
why
I
we
talk in
see
keynote,
things
to me,
that are hidden
it's thing.
behind this alleged curvature. Except for on the clearest, driest days, we see even further. When there's absolutely no refraction, we see even further. So where are you at here, man? It seems like you're just
Okay, well,
like
let me get back to what I was
in
saying.
Coperville, man.
Okay. So, one, please link any of those studies that you were saying.
I'm sorry, say that
I'd love
again.
to
It
see them.
sounds like you're like
He
eating a
said,
fuck.
"Can
You just bring
Transit,
up
can
those
you mute,
studies. Can
please?
you link
Because
them?
your chewing is really annoying.
Somebody's eating something and it's hot micing.
And it's Transit. Yeah, you could just stay muted.
Yeah.
Yeah.
So I've laid this all out, and I
Okay,
got
well,
interrupted. I got interrupted a million fucking times on
alright, well,
what I was gonna say, because like I'm on a roll. I'm on a track here,
god
right?
damn, you are a yapper.
Yeah, am I? I
Hey,
mean,
don't
you
be
are
rude.
All
too.
I'm
You are
saying,
too.
link,
You are too.
Don't
It's
link
be
those
okay.
rude.
It's
studies.
okay. It's
Link the
okay.
studies. Link the
It's okay.
studies, please.
The
You bring up all
fact
those
that
things. Bring up the studies.
let's go back to the fact that Aristotle was like, oh,
Yeah,
Earth must
can I
be a
go back to
fucking
what? Like, you never even let me finish. Like, you
Aristotle.
cut me off, and you're still talking. You are the
Yeah,
definition
well,
of a
I'm
yapper.
gonna keep talking. So, Aristotle was like, "Oh, Earth must be a
Well,
globe because we see the
like
ships disappear.
it's fair. Like,
We see
you're
the
getting mad at me
why."
for cutting you off. But you cut me.
All right. So I'm gonna ask one question, and I'm gonna let you have the floor. So why is it that we think that fucking ships disappear over the horizon, and yet we can zoom in on them and we can see them further? Why is that? If the curvature is 8 inches per mile square with a 3959 radius, why the fuck are we seeing shit that's 10, 20, 30 miles out that we shouldn't be able to? It should be hidden by curvature. How is that? Why? Give me that
Can you show
explanation.
me the studies that we do this? Like, send the studies.
You mean like the regular people like you and me that have gone out and fucking tested it for themselves with cameras and
You're
telescopes and
bringing up like
lasers?
military experience, like experiments. Like,
No, I
that is not
never
like
mentioned
scientific
anything
spending.
military. Nope, no, sir. I never mentioned anything
Okay.
military. No, sir. I never mentioned
So then
anything military.
what are the
I
things that
want
you
to
were saying that you
know
seeing like
from
penetrate?
you,
Yeah.
why can we see things that should be hidden behind an alleged curvature? That's what I want to know from you. Why do we
So
see
give an
things that
example, because
should be?
I would say that that's wrong. I don't think we can. So give an example.
Yes, sir. We can, because the human eye should not be
What?
able to resolve. Hold on. According to, now I've done my research. According to the heliocentric model, we should not be allowed to see anything beyond 3.1 miles before the curvature starts. However, we are able to resolve things at 10 plus miles. Why is that? Why
Wrong. But Imputer, can you give me rolls, by the way?
from a 1 foot I don't care about your rolls. From a 1 foot
Nothing.
observer height.
Damn.
From a 1 foot observer height, why is it we can see out 10 miles? 10 miles from a 1 foot observer height. Do the math. Do the math on this real quick. You've got a curvature rate of 8 inches per mile
You're
squared. You've got
literally
a
just
radius.
referencing that black swan example, and I already said that I don't like that. Doesn't mean anything to me, because I think you can take a picture of an oil rig and then say that this is the observer height and whatnot.
Okay, I mean, here's the thing: is go out and do it for yourself. The fact is that many people have gone out and made these observations. Oh, that word! Oh, I love that word, observations. It's the very first step of the scientific method. You have to observe something, and then they have gone out and they have measured it. They have made the measurements. They have been like, oh, well, we can see 41 miles across the water. No curvature has interrupted us at all. We can see this laser. This laser goes 41 miles, whatever it is. Why?
Will you send the
Why
thing for
can
that laser? Because
I'm
that's
I'm
related to the military. That laser, right? Send that in.
no, it's not related to the military. It's related to some basic ass people like you and me that wanted to go out and test this shit.
Well,
Okay.
either way, if it's a scientific experiment, then they should have it documented, in which you should be able to send it to me, and I can read over it and look at it myself.
It's the FE core greatest laser experiment in history. Would you like? I'll send it
Please,
over. I'll put it in the chat right now. Give me
please
just a
do.
moment,
Please do.
and I will put the FE core. I've actually got it in a playlist that I titled "Testing the Tangent." Testing the tangent. It's so fun, so great, because every time we test the tangent, we can't find any fucking curvature at all, ever.
Jenna,
Not even in the
I have. Oh, I'm sorry. Go ahead.
No, go ahead. What were you saying? I'm gonna go find this. Go ahead.
Oh no, I was just gonna say. There was somebody was telling me today. I'm not sure if you agree with this or not, but star patterns are like um are a big thing, and he was basically saying if you were to stand at the North Pole, Polaris, like the North Star, would be like directly over your head. But on a flat Earth, Polaris would be visible no matter how far away you were from the North Pole. Like, what would you have to say to that? Is that like an irrelevant point? Like, because
I
I'm
would
new to this space,
say
by the way. Like, I just joined not too long ago, and I'm kind of interested in this whole thing. So,
I would say that I have never been far enough away from Polaris to know whether or not that's the case. I can tell you that I travel the country in the United States, and I can tell you that from place to place to place to place that I go, state to state, Polaris is always in the same place. Polaris never moves, ever. Ever. The constellations are always going around Polaris. I have no reason to believe that the Earth that I stand on is moving. I have every reason to believe that the sky above me is in a rotation. The zodiac wheel. The zodiac wheel. There are constellations in the zodiac. This wheel, the ages. It's like they are like time. They're like timekeepers. They're like hands on a clock over the clock face. A clock face is flat. Okay.
Oh, that's yeah. I see what you're saying.
So you see, the sun is the sun keeps the hour every hour of day until the moon comes out. It moves over us hour by hour by hour like a clock. The sky is our calendar, it is our clock, it is our seasons, it is our zodiac, it is our ages, it is all of that over the face of the earth. Guess the one shape that doesn't have a face? A sphere. A sphere is the only shape that doesn't have a face.
Yo, because it has no sides. Yo, this is crazy.
It has no actual sides, right? Exactly. We live in a realm, man. How can anybody look at a terrarium, right? A terrarium, a closed system where life exists infinitely, and think, oh, I live on a spinning wet ball? The fuck? Where the fuck is... Go ahead.
Would the point then be... So would the point then be like, if Earth is flat, then would that mean every single other planet besides this planet would be flat? And if that's not the case, then would it be fair to say that all the other planets could be different shapes and we just so happen to be living on a flat one?
Not necessarily. I would say that all of these other planets are not terra firma. That means firm land. They are not like Earth. Even NASA tells us that they are balls of gases, right? They are gaseous.
What about Venus? Venus is solid. So is Mercury.
Do you know that for sure? Have you been there? Do you know that for sure? No, neither have I, so I don't know that for sure, and you can't say that for sure. Honestly, intellectually, you can't say that for sure. Because you haven't been there, and neither have I. So you can't honestly look at these...
What about Mars?
Mars? Oh, you guys are going to love this, buddy. Hold on. You guys are going to love this. I'm going to blow the lid off of this one. I need you guys to go and look up... You can actually go and visit my channel on YouTube. It's my name. It's just me. You know, you got fucking nothing to dox. It's just me. There's Mars is Greenland. Okay, NASA has a camp. And I'm not bullshitting you. You can go look this up. You don't have to believe me. NASA has a camp in Greenland. And ironically, coincidentally, the terrain in Greenland looks identical to the terrain on quote unquote Mars. When we look at Mars from Earth, from where you stand, if you can find Mars in the sky, it looks like a light to you. Yes?
What about which you have I've looked at Mars through a telescope and it looks like Mars.
Like a light. Like a
not only
light.
that, but then
Right?
we sent like a drone there to like see
No,
if
we
it's
didn't.
solid, and it was solid.
No, we didn't. I'm sorry, but we didn't. That's an illusion,
We didn't
and that
send
didn't happen.
Curiosity the drone to Mars.
No, we didn't send anything to Mars.
So Mark Rober, that really famous YouTuber,
Greenland.
he's faking it all.
Greenland and Devon Island. You don't have to believe me. Don't take my word for
Greenland. Here,
it.
I'll
And
look up. Does
Devon
Greenland look
Island
like
in
Mars?
Canada. Greenland and Devon Island in Canada have the identical terrain as Mars. Don't
They
take my
have
word for it.
so they're red deserts. They're red sanded deserts in Greenland.
Yes, they are very red and sandy. Go look at the terrain in Greenland. You can use Google Maps. You can use Google Earth. You can get in and look at the terrain on Greenland and in Devon Island on Canada. off the coast of Canada. It all looks the same. It's very red. It's very rocky. It's identical. Identical. The hills, the mountains, the same. It's the same stuff. So what I'm telling you is if you actually know how to do your research and get in and do reverse image searches and all of that stuff, you'll find that all of these NASA images from quote unquote Mars actually come from fucking Greenland, dude. And Devon Island. I'm not,
So
don't
hang
take my
on.
word.
So like the YouTuber
Don't
Mark
take my word
Rober,
for it.
he's lying.
I don't want you to believe me. I just want you to do the research, okay?
I'm
Because
asking you,
this is
like,
the
so
shit that
Mark
I found out.
Rober, the guy who's worked on the Curiosity drone, he's lying.
Yeah, he gets paid to lie. How much money do you think he gets paid? He gets paid fucking 5-10 times more than you do, bro. Yeah, how much
I
money would you
imagine.
take to lie? But how much money
Why
would you
would if
take to lie?
if he made all that money, why would he publicize himself? And then not
How
only
much
that, but why
money?
would he why would he make a curiosity box, which is his business to sell things?
Are you kidding me? Dude, it's the same fucking reason that fucking drug dealers in the fucking cartel make up a business to hide the fact that they're fucking doing the fucking trafficking drugs. It's no fucking different. It's no different. How much money
I
would
don't know. I feel
you,
like those things are a little different.
I would say, how much money would you take to lie?
Because in one example, the drug business, the business is the cover-up business. But with Mark Rober, he's doing it so he can get money. He
Yeah,
kind of
how
needs
much?
it.
Okay,
But if he
again,
was
I
paying,
go
if he
back
was
to
just
my
being paid off by the
question.
government, he wouldn't need it.
I go back to my question. How much money would you take to lie? Like,
Hang on,
you'd
let me
get,
ask you this: do you think like the
you
NFL is
would you
rigged?
take money? Would you take money like that? Like, he gets paid hella good. Like, hella good. You would take that money to lie too. No bullshit. You would. You just would. You would take that money to lie. Anybody would.
Okay, well, either way, like, do you think like the NFL is rigged?
Yep.
The
Hello.
National
Hold
Football
on.
League.
Time out. Give them bread and give them circus, and they shall not revolt. Yeah, it's fucking rigged, dude. It's no fucking different. There's nothing new under the sun. Absolutely
So
nothing
all the
new
players are
under the sun.
in on it, is what you're claiming.
They're playing for money. They don't give a fuck. They're making
Because
money.
they
Oh,
definitely
NFL is
care a little
nonprofit
bit.
fucking organization.
Because
Who
they
gives a
probably
fuck?
want to win a Super Bowl. Like that's
Who
like
gives?
probably like some of the most important shit to them. So like I can't like it would literally be impossible for the NFL to function if all the players were in on it being rigged. Like something would come out by now.
You think so? You think so? You think that this huge group of people would let you in on what they're doing?
Well, I'm saying that like
They don't need to
think
be
about it.
all
The
in on it.
NFL would have to keep every single player like checked in on this lie, and not a single one of them could ever like leak it out. And that's really hard to do, and it wouldn't happen because something
I
would
think
come out by now.
I think the screwed up part of it is that the NFL players themselves are innocent in that aspect, that they don't exactly know what the fuck they're doing. But they are
What do you mean they
playing
don't know
these
what they're doing?
games. Hold on, they are playing these games and they're playing these sports and they get their fucking money, and then some other big company gets even more money. It's all for your entertainment. It's to keep you docile. It's to
When
keep
Joe
you
Burrow
fucking
throws a football to
complacent.
Jamar Chase, he's not actually throwing the football.
I
He's
just
just thinking he does it.
I just want you to stay stupid, and I want you to watch sports and porn and play video games, and I want you to not question anything because I own the fucking world. Like, it's this there's this huge deep fucking thing to
Well,
it, dude.
like you see, like you have to in order for your belief system, like you have to go against so many things. Like even for like you have to go against NFL players, like
Yeah,
being in
fuck
on
the
the fact that
NFL.
it's rigged.
Fuck the NFL. Fuck the NBA,
Well,
NBA.
that's when you're
Fuck
getting like
all the
really
fucking
absurd.
the national baseball. I don't give
It's
a
really
fuck about
obvious that the
sports.
NFL can't be rigged because then some player would leak it by now.
You think so? I bet they get paid
Yeah,
really good
like
to not fucking leak it, bro. I bet they get paid
what do
real
you mean
good
they
to
already get
not
paid
fucking
really
leak
good?
it.
There'd be no like if like they get paid just to play the sport. So like and like they really want to win. Like that's a
It's
big part of it.
no
Like that's why they get
fucking
paid a lot just
different.
to win.
my God, how lost are you, man? It's no different than give them bread and give them circus, and they shall not revolt so long as you have something to fucking entertain your silly ass. You're not gonna
What if, like,
revolt.
but you have to think about it like
But
this: is
what?
like, what if
But
their
what if?
bread?
But
What if the
what if?
bread to them is
But what
winning a
if?
Super Bowl? They can't all win
I'm
Super Bowls.
really fucking
So
tired of hearing. But
somebody's
what
gonna
if?
revolt because they would want to win a Super Bowl. They all of them want to be that guy that gets, because
It doesn't
all of them
matter.
wants to be
They
the
all
Patrick
get paid.
Mahomes, but they can't.
It,
So
no,
that's the problem. If they all want to be Patrick Mahomes, but they can't, then somebody's gonna be like, well, I don't care for getting paid. I
nope,
want to be the Patrick Mahomes.
nope. It doesn't matter. They're all getting paid. They got nothing to fucking complain about.
Some of them definitely do.
Like fucking UFC and MMA, all that shit. That shit's fucking rigged too.
You think the UFC is rigged?
Yup.
Oh, Conor McGregor versus Khabib. You think those guys were just like, they were like, Khabib? You really think Khabib Nurmagomedov is in on a scheme that with the UFC to make it rigged?
I mean, everything's rigged, dude. The whole system is rigged. It's all fucking bread and circus. Do you understand
Like,
what I'm telling?
do you
Hold
not
on,
see like
hold on,
how like
hold
crazy it
on,
sounds?
hold on, hold on, hold on. Do you understand what I'm telling you when I say that it's all bread and circus? Do you understand what I'm saying when I say it's all bread and circus?
I mean, I get what you're alluding to. I'm just saying I don't think that
Oh,
actually like
so you get what I'm alluding
applies.
to. No, you don't understand. You get what I'm alluding to, but you don't even understand. It's not that you don't understand. You don't even understand how this is bread and circus, how this is all meant to distract you, keep you entertained, keep you fucking complacent.
So what benefit do they have by making the Earth like round? Like, what is the benefit of the government lying to us?
So
What do
what
they gain?
if I told you it was to eliminate God? It's no different than the Tower of Babel. When they built the Tower of Babel to go
Oh,
up against God,
it's because you think that they're trying to get rid of like religion?
I think they are trying, not that they're trying to get rid of religion, but that they're trying to hide this creative force in general.
But you wouldn't happen to be a Republican, would you?
I don't claim either side.
But okay, well, I'm gonna
I claim no.
assume that
Let me make myself clear.
you advocate for the Second Amendment. You don't like abortions. Would you say that these fit?
I believe that abortion is okay in medical necessity. Other than that, it's not okay. And that yes, I want my fucking guns. I need to hunt, and I need to be able to defend myself and my home and my family.
So defend yourself from like obviously like you want to defend yourself from like robbers and stuff, but would you also
Well,
say that so you can defend yourself from the government?
well, let me tell you something real quick. Let me just sum this up real quick. I work for an Israeli family. Do you know what's going on in Israel right now?
Yes, I'm aware.
Okay,
Your
so
job, like what do you
I've
mean like you work for them?
it doesn't matter. I work for this Israeli family. They were able to fly their son out of Israel literally a couple hours before the airport shut down. There's a lot of this shit going on right now, and it doesn't fucking matter. Okay, but you want to know about the shape of the fucking Earth and all this shit? Like, dude, I got off track with my own thought, but you can't deny that water is level, that water seeks its own level. That's physical science. And you can't deny that you see the sun and the moon in motion over this earth.
Well, the moon does move, but the Earth does as well.
So, like sunset, sunrise, set, and rise are verbs. This would indicate that the moon or the sun is doing something. The moon is doing something. They are moving over the face of this earth, like the face of a
The
clock.
sun moves, but the sun technically doesn't. Well, the sun is moving, but not in a direction that we could like measure.
So the sun is moving, even though they say that they teach us that we are moving around the sun.
We are moving. We're moving around the sun, and then like
And
the
the
whole
sun is
solar
moving to the
system is
galaxy.
moving around.
Yep.
The whole solar system is moving around the galaxy.
So the whole solar system is moving. Solar sun. The whole thing is moving around the sun as the sun is traversing Mach 88 into the infinite expanse of fucking nothing.
It's not in the expanse of nothing. We're in the Milky Way galaxy, and we're rotating around it, like the big black hole in the center
Are
of
you
the
sure
Milky
we're
Way
in the Milky Way?
galaxy.
Like I see, I'm actually sitting outside and I'm looking at the Milky Way right now, and I can identify multiple constellations, but I don't think that we're in the Milky Way galaxy. I think the Milky Way is something.
What?
No. Yeah, what? I know it sounds so crazy. All the shit that you've
I
been
see that we're in the
indoctrinated to
Milky Way, but I
believe.
don't think we're in the Milky Way.
I can see it. No, I can see the Milky Way, right? But I don't think that we are in the Milky Way galaxy. These words,
You wouldn't
right?
happen to
These
play
words.
Poker Stars VR, would you?
I'm sorry, what?
You play Poker Stars VR. It's like a VR game, but it's poker.
No, I stay the fuck away from virtual anything.
Pretty cool, actually.
Well, simulations and virtual reality are not reality to me. I
Well,
fucking
yeah,
spend a lot
obviously they're
of
not.
time
That's why they have
outside.
virtual in the
I
name.
spend
No
a
one's
lot of
claiming that it's
time.
real. It's a virtual
DCS.
reality. That's like
Yeah,
on F-18.
I can make all kinds of different fucking fucked up simulations and make it into a virtual reality video game, but it doesn't make it fucking real, dude. Like that's the whole
I
point.
never said it was real. I was literally agreeing with you that it's not real, but I'm saying that it doesn't mean that it's not a virtual reality. It's just a reality in a virtual area.
The fact
DCS.
the fact
Plane
is that
models are 95% accurate to reality.
water takes the shape of the container that it's put into. We all know this. We learned this shit in like 4th fucking grade. Water seeks level
And
on its surface. We all learned this shit in 5th grade. What?
It's a sphere. People that told you that water sits in its takes the shape of its container, they would tell you that the Earth is a ball.
Ironically, right? Like weirdly enough, right? They probably would. No, I agree with you. I agree. They probably would. I agree.
You don't know that from people saying it to you, though. That's just through observation. You experience it yourself. You see water taking the shape of its container. You don't need someone to fucking tell you that.
Yep. You can observe level water, like, I don't know. So, like, the fact that according to the heliocentric model, we shouldn't be able to see beyond 3.1 miles before the curvature starts. That would mean that even with a camera, we should not be able to resolve anything beyond 3.1 miles before the curvature starts. However,
So hang on. You guys say
hold
that you
on,
guys
I'm
don't
not
believe in
done
a piece
fucking
of this,
talking. I'm
though.
not done fucking
Well, you're gonna say the
talking.
things that you time. Like I
I'm
don't
not
care
done
about this point.
talking.
Like I already know
Go
what
ahead.
you're
You
gonna
can
say.
assume what I'm going to say, but
I
I'm
already
not
know
done
what you're gonna say.
talking.
I don't know why
You
you
hold
need
your
to repeat it.
fucking thoughts. Hold your
You gotta
thoughts like
keep
an
yapping.
intellectual for just a moment. Okay. But with
You're just
these
gonna yap on
cameras,
something I already heard. Like you can the
so
curvature of the
how
Earth
does that
doesn't allow you
explain
to
that?
see this far, but
So
yet
how
we
the
can
fuck?
see this far. I heard you the first
Yeah.
15 fucking times.
So how the fuck do you validate a globe if that's the case?
Because you still need to send the sources for that claim.
What?
You need to send the sources that prove what you're saying is true. Like you never sent it.
Oh my god! I gotta go into the chat and I gotta be like, look. From a fucking 1 foot observer height, we can fucking see way fucking further than we should be able to
Yeah,
see
you're
with this
gonna
fucking
bring up
camera.
the black swan thing with the oil rigs. I literally already know that.
Yeah, that doesn't work for you. So why doesn't that work
No,
for
it
you?
does not.
That's what why doesn't
Because
that?
I can look up
Let me
on
just
Google
know.
oil rig, and then I can take Photoshop and I can add in text boxes and say observer height 1 foot, and then I can put the distances. Even though I never actually measured it, I just took a picture of an oil rig off of Google and then said those things.
No. Those are
No, you
known
couldn't do
distances.
that?
Those are known distances. That's not what happened. Do you know where that video comes from?
Ding ding ding.
Do you know anything about it at all, or do you just think it was a random image that was just Googled up and then somebody put all that text on it? Like, what are you saying here?
Well, send the video then. Like, the video.
Yeah,
buddy.
I will. Yeah, buddy, I will. 1 second. Check.
Are you even in live stream
Got
voice
it.
text? Like, what the hell?
There
Hold
it
up,
is.
I got it.
This guy took the video. You can see that when he starts the video, he's got the camera right down near the water, so he's only about a foot off the surface, and it wouldn't matter anyway, even if he were 6 feet, 10 feet. It wouldn't make any difference to the observation, really, or to the impact of it on the globe, because you would still geometrically not be able to have a horizon that distant if the surface was curving like it would on the globe. You'd have to be about 60 feet elevation to get it anywhere near 10 miles.
So that's so cap. That's so.
Oh, really? Oh, really? How so?
Oh, really?
Yes.
So tell me how high you
oil
have.
rig is tall, bro. It depends on the two. It depends on how tall the observer is, and it depends
No, it
on
doesn't.
how tall the object is.
No, it doesn't. No, it doesn't. Give me the argument. No, it doesn't. No, it doesn't. Give me the black swan argument, because you obviously don't know what you're talking about. What is the argument? You tell me what my argument
You shouldn't
is.
be able to see the oil rig.
No, you stupid fuck. That's not the argument. How many times have we talked about this today? It's about the distance of the horizon. The oil rig is just a mile marker. It's a demarcator. It's just there to go, hey, this is an object of known distance at X distance, and we see the horizon beyond it. Therefore, it's further than that distance. Has nothing to do with the oil rigs being hidden or any of that. They're simply mile markers. So tell me again why what I just said was cap.
So, what are you trying to prove? Like, I don't even. If it's not the
Okay,
fact that,
well,
that you can
maybe
see
it's because you have a
what is it?
potato for a brain, but I just told you exactly what I'm trying to prove, which is that the
Heretic.
ocean is
Dude,
not
that's
curving.
awesome. You
It's just because
bro.
the
That's
ocean
awesome.
is not curving, because if it was, it would have a geometric horizon at 1.2 miles based on that rate of
Okay,
curvature.
the best part
That's
about it is
why
like you
it's
think you're
called
right.
sea
Like
level,
it's
motherfucker.
hilarious. It's so funny here, Tick. Like you're a dumbass, but you don't even know it.
Okay, so
No,
where was I wrong?
you're the dumbass and you don't know it. It's called sea level for a fucking reason, bro.
So that's your rebuttal. I'm a
Albert
dumbass.
Einstein, Neil
Okay,
deGrasse Tyson, all the scientists in the
so
world.
your rebuttal is I'm a dumbass and I don't even know it. That's what you have to say in response to what I just said to you? Sounds like a dumbass to me.
Sounds like a dumbass to me too, man. Because only a fucking dumbass would be
Hey, man,
like,
I'm down to
oh,
talk to Jenna. This here kid is a fucking retard, dude.
So that's your rebuttal to what I gave you. This kid is a fucking retard. Sounds pretty retarded. Are you some kind of retard?
Hey, man.
Hey, man, it says here on your chart,
Bro,
not trying to be a
fuck up,
dick
bro.
or
Just sit down.
anything, but it says here on your chart that you're all fucked up and shit.
It's on my chart.
Oh, you've never seen the movie Idiocracy? Anyway.
No, I've not seen that movie.
You should watch that fucking movie, Idiocracy. Fucking great movie. Says here on your, I'm not trying to be a dick or nothing, man, but it says here on your chart that you're all like fucked up and shit.
Okay, well, either way, yeah, y'all are some fucking idiots.
Yeah, you got nothing.
You got nothing, bro. You've got nothing to rebuttal the fact that we can see.
I'll be here. I'll come back.
Maybe you should take a look at that infrared footage.
Well, yeah, we're fucking idiots, but you don't even know what we're talking about after, what, 6, 7 hours? How long have you been here coping for? Yeah, we're the idiots. You tell yourself that.
Bing, bang, bang, the past 4 hours.
Hey, here, go email Neil deGrasse Tyson. See if he'll talk to you.
What for?
He can probably explain things better than I can, man.
Oh, you need to outsource your thinking to somebody else. I see. You need me to talk to him because you're not smart enough to have this conversation. Well, why don't you just get the hell out of here then?
Okay, well let's just establish this because I'm gonna look into this the oil rig, the Black Swan. So tell me what you're trying to prove with it.
That you can see way further. The point with the Black Swan is that you can see way fucking further than you should be able to see if Earth were Earth had curvature at an 8 inches per mile square with a 3959 radius. That's what we're trying to show, is that the fucking math for the globe that you so fucking adamantly believe in is wrong. It's wrong.
No, I don't believe in it. It's like a fact. a scientific fact.
That's what I'm saying. You think it's a fact because you believe in it. And we're trying to show you right here that we can see much further than that would allow. So we can see much further than the curvature calculation would allow? What?
Man, you can't even prove
Why?
God exists. So.
You want to divert, and you can't even prove God
Yep.
exists. I don't give a fuck. We're
Yeah, I
not
do.
fucking
So,
talking
well,
about
hang on.
God. We're not fucking
No,
talking about
I'm
God.
gonna be answering,
You're
and I'll
coping.
be looking into it. I'll be back.
Cope-harder.
Be ready.
Cope-harder.
Ready, Jenna.
Grab your fucking nuts and cope harder, bro. Grab your fucking dick and cope harder, because we can see way
Tell you,
fucking
but I'd rather
further
not.
Yeah, be
than that
ready.
fucking curvature calculation allows. I don't give a fuck what you think. You're trying to
I'll be
cope.
back.
Oh
It was
God.
fun.
You want to bring God into
Sorry for
it. You want
anything
to bring
rude I said
God
to you,
into it?
Jenna. I
That's
don't
cool.
have
You
any
can
problems
bring
with it.
God
Your
into
tick
it. You can
was
keep
dumbass,
talking
bro.
over me, talking over you. It's fine. It's wonderful. It's fine. But the fact is, we
Hey,
can
Jenna.
see way
Just
fucking
telling you what I'm
further
hitting out here.
than that curvature calculation would allow. And you want to be like, oh, well, God, dude, prove that God exists. Seriously? That's
I'm
where
just
you went
fucking
with
with you
that?
at this point. You know that, right?
We
Come
can
on,
see
Jenna.
we can see a lot further than the curvature calculation would allow, and you want to be like, oh, prove God exists. That's your fucking argument, you weak motherfucker. I'm sorry,
Okay,
but
well,
you have nothing. You have nothing. You're a disgrace. You're coping really hard. I've been there. I've been there. I've been there. And so I feel your pain. It's okay. Just try to get through it,
hey,
dude. Try to get
I'll
through
be
it,
back.
because
Don't you worry.
we can see a lot
I'll try to
further.
get through it. It's gonna be a tough ride. I know it.
Yeah, it's going to be a
And then
tough
when I
ride
end
for
up on
you,
the
because we can see a
same
lot
street that I started at,
further.
I'll be like, damn, that was so
Be,
pointless.
yeah,
Hey,
because
Jack, can I just ask him
we
real
can.
quick? Yeah, go ahead. Finish your thought. I just want to ask him something.
I was going to say, because we can see a lot further than the curvature calculation would allow, but you want to be like, tell me why God exists. All right, that's your argument. Go ahead.
Yeah, I get it. I diverted it.
So
What do you
how
say,
do you
man?
how do you feel Prof. Phil set you up for this conversation? You think he did any good for you?
What do you say? What are you
Yeah.
saying?
Do you think
I don't
Prof.
know what you mean.
Do you think Prof. Phil set you up for this? You think you know like how to navigate this conversation? Did he do a good job for you or nah?
Phil, I don't even know what you're talking about.
Oh sure. Well, check the live stream voice text. I know who's talking to you.
Last stream voice text. Phil, why are you lying? Show him this photo and explain the difference. You won't because you are a liar. What? I don't even. That means nothing to me. I don't know what you're trying to prove.
Oh, this clown just showed up in my DMs, and you've suddenly been getting these little spurts of knowledge out of nowhere that you can't really explain properly. So it just looked like someone was. It just looked like someone was DMing you all night, is all.
But like, if let's just say that somebody was like, what's the big deal behind that? Like, I honestly, like, I don't even see like why it doesn't matter. Like, does it really matter who presents the argument? Like, I don't know like what that means.
Yeah, we just don't really. I mean, it's kind of pointless to talk to someone's puppet, you know.
Well, I mean, like it makes no like that's like such a dumb argument. It doesn't matter who presents the argument, and I'm sure Professor Phil would rather just talk to you himself.
No, he would rather use you as a puppet because that's all he can do. It's as close as he can get.
Well, like that, but that makes no sense. Like that's just dumb. Like that's just a really weird thing to do.
Yeah, he does it all the time. You guys are fucking weird.
Here, go to like a party and say you're a flat earther, and I bet you they're gonna be like, you know, this guy's awesome. This guy's completely normal.
Oh, okay, so social reasons to stay with the globe. All right, I get you. You don't actually have any geometrical. You don't have any geometric argument.
Dude, you're
Yeah,
so
but who
weird.
cares?
And
Yeah, but
what's
who
funny
cares?
is that,
Listen, the problem with you is that you can't seem to focus on the subject matter. You tend to get sidetracked by trivial things like people, us. You want to talk about flat earthers. You want to talk about anything basically but the subject at hand because you're not equipped for it.
whenever I like bring stuff up, y'all are like, "No, that's not real."
Well, you don't even know what you're arguing with.
Like this loop.
You don't even know what you're arguing with.
Ultimately, at the end of the day,
You don't even know what you're arguing with. We've been giving you the Black Swan argument for I don't know how many hours in here. You still don't know what it is. So, like, what do you think you're going to do to rebut it? like, you know that you have to learn the argument first before you can make any sort of coherent argument against it, right?
Yeah.
You don't know. So you haven't done that
The
yet.
arguments
So
like never really make sense anyway, so it's kind of hard to rebuttal against them.
that's a failure on your part. It's not that it doesn't make sense, it's that your sense-making skills are out of order. So you can't find the sense in it, because you're senseless.
Alrighty. Well, I'm gonna head out of here.
Why?
I'm gonna do some research. I'll be back.
Yeah, see if you can learn the argument we've been repeating to you for like the last 4 hours.
Bro,
See
be
if you
like,
can
yo,
figure it
Flat
out.
Earth gang. Go to those.
Shut up, dude. See you later.
Dude, fuck that guy. He doesn't believe in our cause.
Sorry, Jenna. Just had to have Adam.
We had to move on. I mean, come on. It was long enough on that guy.
It's
Yeah,
okay.
he's a fucking dickhead.
Like, he just goes in circles and like I don't know. That was just circular as fuck.
Yeah, dude, he's such an asshole.
I'm not even sure. I'm not even sure if he's looking at the information you're showing him. Yeah, it don't sound like it.
Well, it's been 4 hours of giving him these arguments. He still doesn't even know what they are. Then he complains that, like, you know, we don't just, like, suddenly jump back on the globe.
Alright.
I think the best part is I'm drunk and I could still shut him down.
He did that skit from.
Crazy.
You're just special.
He did that. He basically his argument for the globe was that skit from Mad TV where it's like church lady. They're all gonna laugh at you. That was it.
Oh no, that was from fucking Stephen King's Carrie. They're all gonna laugh at you.
Okay, yeah.
But yeah, you notice how I caught him in that shit where he's like, oh, but tell me how God is real. I'm like, that's a total fucking divert from what the topic was. Like, well, yeah, all right, okay. So nobody has an answer, so they want to fucking divert the topic every fucking time. Every time.
He went straight to blaming God and attacking God.
Like,
he don't believe in him anyways. He don't believe in it anyway. So why you even?
that ended with so tell me why in the fuck we can see a lot further than what the curvature calculation could allow. Well, tell me how God is real. Bro, really? What, that's the angle you took?
Yeah, it's
I'd have to really, really think about it, but I'm pretty sure that even when I was an unbeliever, or thought I was, I never even would utter those words. Not once. You have to be some psycho to just go to that.
Yeah.
Mm-hmm.
Crazy. What about? Oh wow, actually, Jedi. Nice to see you. What about like just to say like what if the Earth is just really big? What about that?
What if the Earth is bigger than any of us actually know? And what if none of us know the ends of this Earth? What if that?
I tend to agree that there's ends to everything.
What if we can
And
figure
new
out
beginnings.
that? Yeah, and what if we can figure out that water does in fact find its level across 71% of this known Earth, but the Earth is a lot bigger than what we know?
Allegedly. We just use their own.
71%. Why did you use that?
I use 71. I say 71% because 71% of the known Earth, the surface of the Earth, is water. And we all know that water seeks a horizontal equilibrium on the surface. That's why. Of the
Well,
known.
Horizontal equilibrium.
yeah,
Okay.
that's why the Glober claim is so incoherent, because they're basically claiming a 71% flat ball. Do they know what the surface properties of a ball are?
Ah, Heretic, I love you, bro. That's awesome.
Thanks.
Yep.
Don't know if they've actually seen a ball before. They seem to think it's some sort of flat object. They look out and see a flat horizon and go, yep, that's a ball.
I fucking wonder. Like I said earlier, I'm like, how the fucking people like look at a terrarium? Like a terrarium that's been going for 20 plus years, closed, never been opened, and life is still sustaining in this terrarium. And they're like, I'm part ape and I live on a spinning wet ball. Like, how the
I
fuck?
said we all go
Jesus,
inside the
dude,
terrarium and we all
I
light up.
really tried to just like buy into what you guys are talking about, but I don't understand. So wait, hold on. So you're saying that using math, 71% is water, but it's only the known world, and then you deny that, but then you use that mathematics to use this percentage. I'm confused.
When did I know? When was it denied?
So
When was it?
you believe that it's flat with the same percentage?
How is that impossible? I'm saying that.
I'm not saying it's impossible. That's really not what I'm saying.
Well, here's the
Okay.
thing. If
I guess
if your claim is that 71% of the globe is water,
That's not my claim.
no,
Someone else
that's
said that.
okay. You all right? Hold on.
a
If
Glober
you're,
claim.
if you are going to align with the globe is supposedly 71% water. So that means that your ball in space, the convexity of the water needs to translate down to reality, and we don't see that.
Right. Yep.
So you don't see it personally?
No
What
one
was?
sees it. None.
No one sees it? Wait, what do you mean no one sees it? Of course no one
But no
sees
one, because
Okay, are
everyone,
you fucking God?
no one
Nope.
has ever observed
And look,
water
here comes
curving.
Jedi. But go ahead, what were you saying?
I didn't say anything, mate.
Go Flatsy. This is flat. It's on Flatsy. Go Flatsy.
I'm saying that if no one has ever observed water curving, because we all observe large bodies of water resting flat on their surface, and the globe claims that 71% of the earth is water, that's a lot of water that everyone observes to be flat and level.
It means that the
Correct.
claim in and of itself is contradictory.
Fallacious.
Falls apart on its face.
Yep.
Okay, wait, how does it fall? I know this is ladies' night, but how does it fall apart?
Okay, because
I'm not a
fill your
Jeff,
bath.
by the way.
Okay. I'm gonna explain this like I'm explaining it to a 5-year-old. Okay. If you can't explain it to a 5-year-old, then you've got nothing. If I fill the bathtub up with water and I let it sit, it's gonna be level, right? The water's gonna be flat and level in the surface in the bathtub, right? Have you experienced anything other than that?
No.
Okay. Now, if I go out to a big puddle or a pond and it's perfectly still, it's pretty flat and level, isn't it? Right? In a pond,
Hey,
right?
Dustin, can you stop? Can you
This
mute
is
yourself? You're hot micing. I hate hearing your disgusting throat. You smoke too much. Can you mute yourself?
whoever
It's
spoke.
Dustin.
Oh,
He has a
I
disgusting
didn't
throat.
even realize I was unmuted.
Yeah, bro. Just
Sorry.
smoke to yourself.
I don't
So,
smoke at all, by the way, but okay.
Yeah,
all right. So let's bring it all around back. When you fill your bathtub up, you notice that it has no curvature. It's level, right?
And then we
You
went
agree
to
with that?
lake.
And let's go to a pond. Let's go to an even bigger body of water. This pond is level and it's flat on its surface. You've got no reason to believe otherwise than that it's curving. You can see with your own eyes, observation, that this pond is flat and level. Let's go to a lake. A lake is even bigger than a pond. And you can observe mirror perfect reflections in this lake. And then we go to the ocean. When the oceans are calm, they are also the same way. They are flat, they are level. 71% of this Earth's surface is water. All of that water on the surface seeks a level, flat, horizontal equilibrium. Period. That's a 71% flat fucking Earth. Level Earth.
Can I say something? I don't want to cut you off, but can I say something? I'm curious. I mean, I'm very much on the fence. I literally just joined the server from Rumble about 25 minutes ago. How? I mean, what do you think our existence is then? If we're not on a globe, if we are on a flat plane, are we the center of the universe? Obviously, it's a romantic idea because it proves the existence of a creator, right? If we are not a globe and we are in fact on a flat plane, then we have to be the center of whatever this is. What do you theorize our existence is?
Well, if we live within a created system, then we are created for the pleasure of God.
And are you guys of all the same affiliated religion here? Are we all?
No.
No.
We've got Christians, we've got Jews, we've got Muslims, we've got spiritual people.
So we haven't
got
agreed
all
on
kinds
we
of-
haven't agreed on what God we believe in. Then is that's
Yeah.
I mean,
that's
It's not the
accurate?
topic. It's flat Earth.
No, but I think that the romantic idea, or the romanticized idea of us being on a flat plane, obviously, is significantly wrapped around us being created, right? So therefore,
Indeed, yes.
right? I mean, that's what this is all. This is